Hi, I'm Dan, and I'm excited to welcome you to the Ultimate CSS Full Course. This course is designed for complete beginners with no coding experience, and by the end, you'll be able to write CSS at a professional level. It's by far the most comprehensive and high-quality course you'll find online, and goes well beyond the standard tutorials you'll see elsewhere on YouTube. My teaching style is not to just talk over code, but instead, I've carefully crafted this course to be a visual masterpiece, with interactive animations, beautiful graphics, and professional editing, making it fun to watch to ensure you remain engaged in order to maximize your learning. I also use the most effective teaching techniques for visual learners, where the course is jam-packed with diagrams, analogies, code annotations, tables, and much more. By far the most useful feature is that every topic ends with a summary card, so that by the end of the course you have a full set of cards consolidating everything you need to know for CSS. Now this course is a direct follow-on from my full HTML course, so if you don't know anything about HTML, you'll need to watch that first. It's appearing in the top right now. If you haven't done my full HTML course, but are confident in the basics and know about HTML tags for text, hyperlinks, images, containers, and semantic elements, you'll be able to follow along just fine. So let's look at the CSS course program. We'll be covering the following topics: an introduction to CSS, CSS Text, CSS Selectors, the CSS Box Model, CSS Units, CSS Functions, Flexbox, CSS Grid, Responsive Design, Positioning, Shadows and Transitions, and CSS Frameworks. Each of these topics contains many subtopics, which comprehensively cover everything you need to know to get a solid foundation that will enable you to code CSS at a professional level. Throughout the course, we will continue to work on Quill, the major full-stack project we started in the HTML full course. As a reminder, here is where we got up to at the end of the HTML course, and by the end of this course, we will end up with our design looking like this. And I'm sure you can agree with me, CSS is able to bring our web pages to life. Now, if you didn't join me in my HTML full course, you can download the completed HTML file in the description below, so you can pick up where we left off. You can also learn more about all the features of the Quill project by clicking on the video appearing in the top right now. In addition to the starter HTML file, all the complete HTML and CSS coding files, presentation slides, and summary cards from this video can be downloaded from the description below. So let's kick off the course nice and slow with an introduction to CSS. We'll be discussing what is CSS, the CSS box model, CSS properties, and CSS rules. So first up, what is CSS? CSS stands for Cascading Style Sheets. Cascading is how to style an element when several rules apply. There's a bit of theory to get through to fully understand what this means, which we'll be looking at in a later topic. Style is about the various styles that can be applied to HTML elements. And finally, we have sheets that refer to their own documents which can be linked to HTML files. So what does CSS do? CSS is used to control the presentation and layout of HTML. We've looked at HTML already, which is all about content. CSS is all about the visual styling of the content. And the next section we'll spend a lot of time on is JavaScript. These three languages, HTML, CSS, and JavaScript, are the foundation of front-end web development. Let's take a look at the power of CSS by looking at our Quill application with just HTML. For those of you joining me for the first time, Quill is the major project we are working on inside the bootcamp, and this is where we got up to at the end of the HTML section. You can see it is just the content. At the end of this CSS topic, the Quill homepage will look like this. I'm sure that you can agree with me, it's chalk and cheese, comparing the web page with CSS and without it. Now, an important concept we need to discuss straight away is the CSS box model. CSS views every HTML element as if it has its own invisible box around it. Let's take a look at our Quill application and fill in all of these invisible boxes around the content, starting with the logo in the top left corner. Although if I were to trace the perimeter of the icon and text, it wouldn't be straight. All CSS sees is a box around the edges of the content, in this case the image tag. We then have boxes around the navigation links, which are anchor tags. There is a box around the main heading, which is an H1 element. There is a box around the paragraph text, which is a paragraph element. And then again, we have boxes around these links, which are anchor tags. In addition to content elements, structural elements also have boxes around them, like the navigation semantic element and the section semantic element, as well as the span element. We can easily see these boxes whenever we use DevTools. I'm going to right-click, Inspect. I'm going to click the Inspection tool and go and click on some boxes. Let's start with this heading, the H1. You can see a blue box appears around the content. Same with the paragraph and all the anchor tags. This blue box is the CSS Box Model in action. Now these invisible boxes will either be block or inline. We have already covered this concept in the HTML section, but it's worth recapping because it is critical to understand it when working with CSS, and it can be a bit confusing when first starting out. All HTML elements are by default either a block or inline element. Let's first look at block elements. Block elements always start on a new line. We can represent block elements like this. Block elements always take up the full width of a page. Some examples of block elements are headings, paragraphs, unordered lists, and list tags. Now let's look at inline elements. Inline elements do not start on a new line, unless they're after a block element. This is because the block element extends the full width, so it pushes the inline element onto a new line. We can represent inline elements like this. Inline elements only occupy the width of their content. Some examples of inline elements we've seen include anchor tags, images, a line break, and input tags. Knowing whether an HTML element is a block or inline element is crucial, as it significantly influences CSS styling and layout. Let's go and update this image and distinguish between the inline elements and the block elements. I'll keep the block elements in red and update the inline elements to be green. The logo is an image tag, which is an inline element, so we need to update that. The anchor tags in the navigation bar are also inline, so we'll update that to green. We also have a set of anchor tags in the hero section, so those also need to be updated. Finally, the span, which is a container element used to style text, is also inline, so that needs to be updated. From the outset of CSS, I want you to get comfortable with thinking in terms of block and inline elements. It will make your CSS journey a lot easier. Let's go and check out some block and inline elements. I'm going to open up DevTools, and I'm going to click the inspector icon. Looking at this paragraph first, we can see the blue box extends the full width of the page, and the paragraph text starts on a new line. This is typical behavior of a block element. If we look at the image over here, you can see the blue box is only extending the width of the content. This is also typical behavior of an inline element. Now looking at these anchor tags here, again, the content of the anchor tag is only extending the width it needs, because it's an inline element. So why then is this learn more appearing on its own line? Shouldn't it be appearing next to get started? We discussed this in the HTML section, and the reason this is happening is because the anchor tags are wrapped by list items, which are block elements. You can see the list item is extending the full width of the page, which is then pushing down the next list item, which extends the full width of the page. And the anchor tag is inside that list item. You can see that in the markup here. We have an anchor tag inside the list element. So just be aware that nesting can influence the behavior you'd expect. You might remember at the start of the HTML section, I used this PowerPoint slide of my top 5 best things on the internet as an analogy to explain HTML. I now want to extend this analogy to show you how CSS can influence styling. The first thing we'll do is identify the block and inline elements. I'll have this key at the top with block elements in red and inline elements in green. The heading is an H1, so it's a block element. The paragraph is also a block element. Over here we have an ordered list, which is a block element, and each list item within the list is also a block element. And finally, the image on the left is an inline element. Now let's add some structural elements. I'm going to convert this to gray because I'm going to be adding more layers on, and it's going to be a bit much to leave it all in color. First, we'll add a div to group together the heading and the paragraph text. And then I'll add a section to group the image and list. Both are block elements, so are in red. You could, of course, use other suitable structural tags. I've just chosen these two to show you can mix the generic div container with semantic elements. I'm going to then add the final element, a span, to wrap the text the funniest things, as we will be styling that text differently to the others in the paragraph. A span is an inline container, so it is in green. So next up, we're going to look at CSS properties. This is how we actually style our HTML. I'm going to split what CSS does for us into 3 overarching categories. The first category is styling we can do to content. This is stuff inside the box. This includes properties like font size, font weight, and background color. It's all stuff within the box. Now, there are a lot more, but let's look at some common content-based properties. And we're going to see this in action on the PowerPoint slide. The first thing we can do is switch up the font family to change how the text looks. Then there's font styling, where we get to play with making text bold or adding an underline. Next, we'll change the font color. Watch as the headings turn blue and the funniest things in the paragraph switches to purple. Quick reminder, we are able to change the color of the funniest things because we have a span we added to wrap this text. We can also change the font size. I've applied this to the heading, so watch as it reduces in size. The final property I will be applying is background color, which I will add to the unordered list. So now that we've had a look at the content, next up is the box. These properties are to do with the box itself. By this, we mean CSS allows you to style box properties with things like width and height, border of the box, and margin, which creates space around the box. Let's see these in action inside PowerPoint. Here's where we left off before. Let's add some borders around the image. You can see it here in green. Next, I'll apply margin below the paragraph text, which creates extra space between the paragraph and the list and image below it. We can also play with the box size, which allows us to modify how much space the box takes up. Watch as the image shrinks in size and the width of the list reduces. The last major category is layout. Layout is about where the boxes go on the page. Properties controlling layout include Flexbox, which allows us to place elements in one dimension, along a row or column. Grid, which allows us to place elements in 2 dimensions, in rows and columns. And Position, which allows us to specify the precise location of elements. Continuing on from where we left off, watch how we can totally transform the layout with Grid. We've essentially created 2 columns. Now, this layout looks fairly terrible, but it showcases the power of CSS to move and rearrange boxes. So let's now look at CSS rules, which is how we go about writing CSS. It all starts with what's known as a selector. Selectors is a topic in itself, which we will be looking at a lot of detail later on. For now, a selector does what it sounds like. It selects the HTML we want to target to apply styling to with CSS. The most simple selector is what we call the element selector, where we just reference the element we want to select and style. In this example, I am selecting all H1s on the web page. Next, we add curly brackets, like this, which will enclose the styling rules. I'm going to add 2 styles that hopefully will be fairly intuitive to understand. But seriously, don't worry about the actual styles for now. We will be covering them all in great detail throughout the CSS section. I'm first going to add a style to change the size of the font, which has the notation font-size. This is known as a CSS property. The property is always followed by a colon. We then give the font size property what size we want it to be. In this case, I want it to be 20 pixels, which I write as 20px. This is called the value, and it always ends with a semicolon. We can apply multiple properties inside these curly brackets. Another example would be changing the color of the H1 element to blue, which I would do like this. It follows the same structure as font size above. The property is color, and the value is blue. Let's now zoom out and get a grasp of some of the terminology we are going to be using in CSS. The combination of a property and its value is called a declaration. Multiple declarations inside the curly brackets is called a declaration block. And this whole setup forms what we call a CSS rule for the h1 element. Before we finish up, I want to set some expectations with CSS. The first point to consider is the size of CSS. There are a lot of properties and values, but CSS is many, many times larger than HTML. You don't need to worry about learning them all. I honestly don't know all of them myself. It's fairly common to always be looking these up on a resource like MDN to remember exactly what the property is and how it works. The second aspect is theory. Mastering CSS theory is key to understanding why elements are styled the way they are. Compared to HTML, CSS requires you to have a deeper theoretical understanding of how things work. The third expectation is that CSS can be fiddly. I say that because getting layouts to look how you intend across all devices can be challenging. Although it may not seem so, it's actually fairly challenging to get a layout to look exactly how you want it to. Beyond just the complexity of how the rules work, you also have to have your CSS cope across different devices, which can be a bit of a pain. So let's finish up by starting to build the summary card for this topic. Introduction to CSS. We looked at CSS properties, which control the styling of HTML elements. We saw how each HTML element has an invisible box around it, and that the boxes are block or inline, which is incredibly important from a CSS perspective. We saw how there were three main categories of CSS styling. The first was the content, what is inside the box. The second was the box itself, like width and height. And the third was where the box goes, like a grid layout. We then spoke about CSS rules. Here is the rule we looked at. We saw a selector is what we use to target an HTML element. We then added curly brackets that contain the styles we are applying. The styling is set by a property, in this example color, and a value, in this case blue. A combination of property and value is called a declaration, and multiple declarations are called a declaration block. Next, we'll dive into how we add styles to our web page by different methods for including CSS. We'll be looking at inline CSS, internal CSS, and external CSS. So first up, let's look at the different methods for including CSS in our HTML document. There are three methods for including CSS. The first one is inline CSS. The second one is internal CSS. And the third one is external CSS. It's important to note that inline and internal CSS are generally not recommended. However, it's essential to go through them as they are methods you should know about. External CSS is considered best practice, and this is the method we'll be using in our Quill project. First, let's take a look at inline CSS. Inline CSS is when styling is applied directly to individual HTML elements. As an example, let's take a look at these h1 tags with the text "Welcome aboard." Inside the heading opening tag, we can introduce a style attribute, which is just an HTML attribute. The style attribute can contain a CSS property and value. In this example, color is the property and blue is the value. You can see that there's just one property here, but you can add multiple properties to the style attribute. Now, using the inline method means that styles have to be duplicated for each element, which is not considered a good practice. The reason is because there are going to be many HTML elements on the page that will have similar styling rules. For example, maybe we want all our text to be blue. That would mean every single text element would need to have this style attribute, with the color property set to blue. Now, first of all, that would be a huge pain to repeat that over and over again. And then imagine if we had to go and update our color, we would need to update the value in possibly hundreds of places. Now in this course, I'm using VS Code as my text editor to write code, and Google Chrome as the browser to render our code. You will need to download both of these tools to follow along with me, and I've posted links in the description below to download each of them. If this is your first time using a text editor like VS Code, and you want to learn a bit more about what it is, then you can check out the video appearing in the top right now, which gives a more detailed walkthrough. So let's jump into VS Code and see how inline CSS works. Alright, so I've gone ahead and set up two simple HTML documents. The first is index.html. It contains an h1, an h2, a paragraph, and an anchor tag. The anchor tag here is referencing this page, download.html, to download the summary cards from the bootcamp. You can see this page is over here, download.html, and for now it just contains an h1. Both of these HTML files are contained inside a folder called including CSS. So let's go ahead and add the style attribute that we just saw before. I'm going to go inside the h1 and grab the style attribute. Let's add the color property and set its value to blue. And then I'm going to add another property by just hitting space, and let's go get font size. Now, as I'm getting this, I want to show you that there's also smart built-in tools to VS Code for CSS. As I'm typing the property I want, you can see VS Code is suggesting some, and I don't even need to type it perfectly correct. I can continue typing SIZ without a hyphen, and VS Code still knows what I'm talking about. So let's grab this property and set a font size of 40 pixels. I'm going to hit save, and let's check this out in the browser. So you can see in the browser that the h1 is now blue and a fair bit larger because I made the font size 40 pixels. Now, as I mentioned before, if we wanted to apply this style to other elements, like say the h2, I'd have to copy and paste this and add it to the h2. Let's save and refresh. And you can see now the h2 has the exact same styles as the h1. So inline CSS is not a good option. Let's move on to the second method for including CSS, which is internal CSS. Internal CSS works by styling a single HTML document using the style element. Let's see how this works. Here you can see I have a set of head tags. If you recall, the head section contains information that is not displayed on the web page. Things like the title tag and meta tags. Inside the head tags, we can add style tags. And just to highlight, these are tags, not attributes, like we saw previously for the inline CSS. In the style tags, we can add a CSS rule, with the same notation we saw earlier, using a selector like h1, curly brackets, and then adding our declarations. Now, this is an improvement from inline CSS, because now styles can be defined once, and will apply throughout the document. The problem is, styles have to be duplicated for each page. This method is not recommended, because most projects will have many HTML files. So for example, if you had a project with 100 HTML documents, you would need to replicate the CSS rule for the h1 100 times. So we still have the same issue, where we need to create this rule 100 times across each page, and then if we wanted to update anything, we'd have to go and update it 100 times. Let's go and add internal CSS in VS Code. Alright, so I'm back in our index.html file. The first thing I'm going to do is just remove these styles we added before. So inside the head, I'm going to go grab the style tags. So let's first style the h1. I'll select it and add our curly brackets. And I'll give it the same style as before, color blue, and font size 40 pixels. While I'm here, I'm also going to go add another style for our paragraph. To do this, it's typical to add a line break, and then I'll select our tag like before. I'll grab the paragraph element by typing P and add our curly brackets. Let's give it a color of green and a font size of 25 pixels. Now before we jump in the browser, I'm going to go add another paragraph just so you can see how internal CSS works. I'll grab the paragraph tags and I'll just type the text, "The cards are great." So let's check this out in the browser. So you can see our h1 is still blue, being defined by this CSS rule here. And you can also see that every paragraph on the page is now green with a font size of 25 pixels, which is being defined by this CSS rule here. So that is good. We're defining the style we want for our paragraph once, instead of on every single paragraph element like you'd have to do with inline CSS. However, we have a small problem that when we go look at the other page inside our project, download.html, which has an h1, you'll see that no styling is applied. So you can see that this is a problem. The styling we're applying on our index page is not being carried across to other pages. And that's because the CSS rule is being defined only on the index.html page. The styling is not present on this page. Now, this is also not a good solution. It's because we want to be able to set our styles in one location for all our pages, so that it's easier to manage our styling rules. So let's now look at the third method, external CSS. Here, styles are in a separate CSS file and linked to the HTML documents. Let's see how this works by looking at an index.html page. Inside the head tags of the HTML file, we add a self-closing tag called link. The link has two attributes. The first is rel, which defines the role of the linked resource. It specifies the relationship between the HTML document and the linked resource. For CSS, we use the value of stylesheet. There are other values that can be used for rel. For example, the value of icon is used for a favicon, that little icon that appears in the tab of your browser next to the web application. Honestly, I just wanted you to know what they are in the context of CSS. There are other values, but stylesheet is by far the most used value you'll see and use. The other attribute is the href attribute, which we've met before when discussing hyperlinks. The purpose of the href attribute is to reference the location of the CSS file, which will be somewhere inside our working directory. So we will be using a relative URL path. Now it's common to call your CSS file app.css. So I will do the same here. And you can see our href is referencing this file. In this example, inside the app.css file, we are selecting the h1 element and applying the color property with the value blue. Now with external CSS, our styles are centrally managed from one file. This is good practice. All we need to do now is that whenever we add a new page is reference the same style sheet by including the link element in the head of the page. For example, the register.html page would have the same link. And so too with the login.html page. All these pages are referencing the same app.css file. So in this method, we create a single file that sets the style for elements, allowing multiple pages to reference a unified style sheet. So let's jump back into VS Code and add a style sheet to our project. I'm first going to go and remove the style tag. I'm then going to go inside our working directory, including CSS, and create a new file by right-clicking and clicking New File. And I'm going to call this app.css. Inside the app.css file, let's first go and add the h1 again. We'll do color blue and font size 50 pixels. I'll then add a paragraph. We'll give it a color of red and a font size of 30 pixels. Now, if we were to open up the HTML file in our browser, we wouldn't see any of these styles being applied. And that's because the app.css file is currently not linked to any pages. So let's go link them now. I'm going to jump into index.html. Now, I generally like my title element to come last in the head, so I'm just going to scoot this down. I'm then going to go grab the link element by typing link, and you'll see VS Code automatically gives me the rel attribute with the value of style sheet, and that's because it's the most commonly one used. Now for href, we need to go grab the app.css file. Now because app.css is on the same level inside this working directory, we can just grab it by typing app.css. So let's check this out in the browser. So you can see on our index page, our styles have been applied. Our h1 is blue and 50 pixels, and both our paragraphs are red and 30 pixels. If I head over to the download page, you can see none of the styles are being applied. And that's because we haven't yet linked our central style sheet to the download page. So all I'm going to do is copy this link line of code, head over to download.html, and paste it in the head. I'm also just going to quickly add a paragraph here, so you can see that those styles are also being applied. So let's refresh the page, and you can see the styles are being applied. The blue 50 pixel heading, and the red 30 pixel paragraph text. If I go back, you can see the same styles. So I now have one location where our CSS rules are being applied. So now let's say I wanted to update the color of my H1 from blue to green. I just come here and write green. And if I refresh the page, you can see our heading is now green on the index page and on the download page. So now, as you can imagine, if you had hundreds of pages, they're all going to be linking back to this central file. So that is why external CSS is the way to go. Let's now finish off the summary card for this topic in Introduction to CSS. We looked at the 3 different methods for including CSS. First, we looked at inline CSS, which was achieved using a style attribute inside an HTML tag. This wasn't good practice because you had to duplicate every single style for every single tag. The second method we looked at was internal CSS, where we used style tags inside the head of the HTML and defined a CSS rule. This was also not good practice because in this method we had to replicate the same style tags for multiple pages. We then looked at external CSS by introducing a link tag within the head section of an HTML page that referenced the style sheet. In this example file of index.html, the href attribute links to a CSS named app.css, where our styles are defined. In the app.css file, the color attribute for h1 is set to blue, allowing for consistent styling across the project and centralized management of styles. This method is considered best practice among the 3 discussed, as styles are defined in one central location. Great work! We've now finished an Introduction to CSS. Next up, it's time to look at CSS Text. In this topic, we'll cover the key aspects of text design, including text styling, spacing, size, font selection, and color, while also beginning to develop a style guide. Let's begin by exploring how to transform the appearance of text through various techniques of text styling. We'll be discussing font weight, text decoration, font style, text transform, and list style. Throughout this topic, we're going to be taking a look at a range of text properties. I've broken these down into 5 categories. The first is styling, the second is spacing, and both of these categories have a mix of a few properties. The third one is family, which is about fonts. The fourth one is color, and the fifth one is size. When it comes to color and size, there is a bit more theory involved that applies throughout CSS. So in this chapter, we're focusing on text styling. The first styling property we're going to look at is font weight. It sets the thickness of text characters. Over here, font-weight is the property, and bold is the value. For all the CSS properties I'm going to introduce, below it I'm going to show the values we can use with some notes. For font weight, although we can use name values like bold or normal, it's more common to use numerical values, which range from 100 to 900 in increments of hundreds. Looking at some important values, 400 is considered normal, 500 is medium thickness, and 700 is bold. Normal, which is 400, is the default weight for most text, whereas 700 is the default for headings. When I say default, what I mean is that if we didn't apply any font weight styling, the default for most text would be 400, and the default for headings is 700. As you increase the font weight value, you make your text look bolder. Let's jump into VS Code and play around with this. Inside VS Code, I'm going to go create a new HTML file. I'm going to click New File over here, select Text File, click Select the Language, search for HTML, and hit Enter. I'll straight away grab the boilerplate code by hitting !Enter, and then I'm going to save the file by hitting Command S. I'm going to go on my desktop, and I'm going to create a new folder called Text Styling. I'll save this HTML file in this folder, and I'll call the file text-styling. I'm going to grab some placeholder text from my favorite placeholder text generator, Hipster Ipsum. I'm just going to copy this first sentence. I'm just going to paste the text over here for now. I'm going to add an h1 element, cut this, and put it inside the h1. I'll then create an h2, and add this text inside the h2. And then finally, let's add a paragraph tag, and I'll pop that text in there. So without adding any CSS, let's go check out the default font weight. So you can see that our headings look more bold because they have a default weight of 700. And our paragraph has just a normal font weight of 400. So let's go change the font weights of these elements. So let's go and create a new CSS file and connect it to this HTML document. I'm going to hit Command-N on my Mac to open a new tab. I'm then going to select a language and search for CSS. I'm then going to immediately save it by hitting Command-S, and inside the same text styling folder, I'm going to call it app.css. Let's now go and connect the CSS file to the HTML file, like we saw in the introduction topic. All we do is we go get the link tag. The value style sheet for rel comes pre-populated and is correct for CSS style sheets. And the href is just app.css. Because app.css lives inside the same folder and is on the same level as text styling HTML, we just reference it like this. So let's go and style these now. For the h1, I'm going to give it a font weight of 400. This is actually the default weight for the paragraph, so it's going to look a lot thinner. I'm not going to style the h2 because I want to keep it there as a reference to compare it to the h1. For the paragraph, I'm going to give this a font weight of 700, which was the default weight for a heading. So I've actually swapped the weights for headings and paragraphs. Let's take a look at this in the browser. So you can see our h1 now looks a lot thinner. The default heading thickness was over here at 700. And the paragraph, which looked a lot thinner before, now has a font weight of 700. It's the same as the default h2 paragraph thickness. Now, throughout the CSS section, for any property I introduce, I'm going to provide design guidance. I am pretty proud of adding this to my CSS section, and trust me, it's been a lot of work. Most other courses I've seen don't do this. They'll just show you the properties and move on. But I think without any proper design guidance, it is so confusing to know how to actually use the properties effectively. So let's look at font weight guidance. Typically, headings should be between 500 to 900, while other text should range from 300 to 400. For instance, let's check out this web page. The font weight for the heading is set to 600, and for the paragraph, it's 300. You can see the bolder heading is able to draw your attention, which is the effect we want to see. Let's look at another example. On this web page, the heading font weight is set at 500, and for the paragraph, it's 400. You can see this is another approach with values closer together, but it still works and falls within my suggested range for font weight for heading and other text. In our final example, notice how bold this heading looks. Compared to the earlier examples, this one really stands out. That's because the font weight for the heading is 900, while the paragraph is at 400. The next property we'll look at is text decoration. This property sets decorative lines on text. Text-decoration is the property, and in this example, underline is the value. It's called the line value, as we're going to be adding other values soon, so we need to distinguish it from the other ones. Line values include line through, underline, overline, and none. The value none is the default for most elements, which means most elements do not have any text decoration. However, underline is the default for anchor elements. We've seen this already, where the hyperlinks we've created always have an underline by default. We can also give our text decoration a color. So for example, blue, which is the color value. This value is simply added by putting a space after the line value. Color values can be named, hex, or RGB. Named colors are ones we've worked with so far, like green, blue, and yellow. There are other formats of color, like hex and RGB. Don't worry about colors at all for now. We're going to be discussing this later on in this topic. And for now, we're just going to use the simple named colors. We can also add a style of the line, like dotted. And this is the style value. Other style values include double, dotted, wavy, solid, and dashed. If you don't specify a style value, and just made this example underline and blue, the default value will be solid. And we've seen this in anchor tags as well. Let's jump to VS Code and play around with this. I'm back in our text styling HTML file. For this demonstration, I also want to add an anchor tag. So I'm just going to copy some of this text and remove it from the paragraph and add an anchor tag with that text. For now, the href value really doesn't matter. I'm just going to point it to Google. Back in the app.css file, I'm going to remove these styles we added before. For the h1, let's go grab the text decoration property. We'll make the line value underline. Let's give it a color of red, and let's make it wavy. For the h2, I'll grab text decoration. Let's give it a line value of line through, a color of green, and a style of dashed. For the paragraph, we'll get text decoration again. We'll give it a line value of overline, a color of blue, and this time I'm actually going to leave off the style value to demonstrate that by default this line will be solid. That is, a blue overline will appear that isn't styled in any fancy way, like being dashed or wavy. For the anchor tag, I'm going to grab text decoration, and this time I'm just going to set the value to none. I want to remove the default underline that appears there. Let's take a look at this in the browser. Alright, we can see some fairly crazy stuff going on here. The h1 has an underline, so it's under the text. It's red, and you can see it's wavy. For the h2, the line is going through the text because of the line through value. It's green, and you can see the style of the line is dashed. For the paragraph, it's an overline, so it appears above the text, and it's blue. And because I left off the style value, it defaults to just a solid line. There's no particular styling, like being wavy or dashed. And for the anchor tag, you can see there's no longer an underline here. We removed it with the CSS rule text decoration none. If I delete this and save and refresh, you can see by default we've got the underline back on our anchor tag. So let's now take a look at some text decoration guidance. We should always remove underline from anchor tags and very rarely use text decoration. On this web page, you'll notice the anchor tags here have no text decoration. And I'd highly recommend that instead of using text decoration to style text, it's a much better idea to style your text like you see it here, where we're styling with weight and color instead. I generally recommend steering clear of using text decoration for styling purposes, except for removing it from anchor text. Text decoration reminds me a lot of Internet Explorer. There's a ton of memes about how the whole purpose of Internet Explorer is just to download Chrome, like this one over here. It's the same with text decoration. Its main purpose is just to remove itself. The next property we're looking at is font style. This property sets the style of a font. Over here, font-style is the property, and in this example, italic is the value. The values we can use are normal, italic, oblique, and oblique at a specific angle, like oblique 10 degrees. The default value for font style is normal, meaning by default, no special font styling is applied to our HTML elements. Let's go play around with this in VS Code. I'm back inside our textstyling.html file. I'm going to head over to the CSS file, and I'm going to delete all the styling from before. For the h1, we'll grab the font style property and set it to italic. For the h2, we'll grab the font style property and set that to oblique. And for the paragraph, I'll grab the font style property and I'll set this to oblique with an angle of 30 degrees. Let's check this out in the browser. So looking at the browser, you can see the h1 is now in italic. The text slants to the right. But the h2, which is set to oblique, and the paragraph, which is set to oblique with an angle, kind of looks the same. And the truth is, the visual differences between italic and oblique can be subtle and may not even be noticeable in many fonts. So what is the difference between italic and oblique? Italic is a purpose-built font. For example, in Microsoft Word, you can select your font to be italic, which is actually selecting a specific variation of the font. Whereas oblique will take the regular font and just slants it to the right. It's not a purpose-built font. It's applying rules to an existing regular font. And that's why these basically look the same. The differences can be subtle. And to be honest, I really wouldn't worry about any of this. The nuanced differences between them concerns the print industry a lot more than web developers. So if you ever want to use this property, I suggest just using italic. Let's now take a look at some font style guidance. Font style can sometimes be useful to draw attention. In this example, you can see the words "in half" is in italic, to emphasize the fact you can cut your publishing time in half. Once again, personally, I prefer using weight and color to draw attention, and I suggest you also do the same. Next up, we're going to look at text transform. This property sets the capitalization of text. Over here, we can see text-transform is the property, and uppercase is the value. The values for this property include none, uppercase, lowercase, and capitalize. None is the default value, which means text will just appear exactly how you typed it in your HTML document. Uppercase turns all letters into uppercase, lowercase turns all letters into lowercase, and capitalize means the first letter of each word is capitalized. Let's go play around with this in VS Code. I'm back inside our text styling HTML file and its corresponding style sheet. For the H1, I'm going to remove this, add text transform, and let's add the value uppercase. For the heading 2, I'll remove this and go grab the text transform property and set it to lowercase. And for the paragraph, let's remove this, grab the text transform property, and set the value to capitalize. Now, just before we look at this in the browser, I want to go put a capital in our H2, just so you can properly see the effect of setting it all to lowercase. So let's now check this out in the browser. You can see with our heading 1, every single letter is now in uppercase. With our H2, every single letter is now lowercase. And with the paragraph, the first letter of every word is capitalized. Let's look now at text transform guidance. It's best to stick with sentence case. Sentence case means the first letter of the first word in a sentence is uppercase. So this is just achieved by typing it that way in your HTML, instead of applying the text transform property. In this example, you can see sentence case being used for both the heading and paragraph, where the first letter of the first word in a sentence is capitalized. The T in the, for the recruitment software your candidates and team will love, and the J in join, where the rest of the letters in the paragraph are all lowercase. What you will see is bloggers, edgy brands, and studios will sometimes use uppercase to create a larger visual impact and appear more daring. Here's a studio example where everything in the heading is in uppercase, which creates a huge visual impact. However, for most applications you're likely going to be working on, sticking with sentence case is usually the safer choice. The last property we will look at is list style. As the name suggests, list style sets the style of a list. Here we can see list-style, which is the property, and in this example, disk is the value. The values we can have include none, disk, circle, square, and decimal. Disk is the default for unordered lists. As you've seen, the bullets are always a solid black fill, or disk. Decimal is the default for ordered lists, which are integers that increment by 1 for each list item. Let's go play around in VS Code. I'm back inside the text styling HTML file. Inside the body, I'm going to go create an unordered list. I'll add 3 list items by typing li times 3. And I'm just going to cut this text and remove the elements. And I'll also get rid of the anchor tag. We don't need it anymore. Let's head to app CSS. I'm going to delete all those CSS rules. Let's go and change the list style of the unordered list. I'll grab the unordered list by typing ul. We'll get the list style property by typing list style. We know by default it's disk, so let's change it to square. Let's check this out in the browser. So you can see now that our bullet points are no longer a circle fill, they're a black square. Let's change them to circle to see what that looks like. And now they become a circle with no fill and a black border. The last one I want to show you is changing it to none. This removes the bullet points entirely. So let's look at some list style guidance. We should always set list style to none when they are used for structural purposes. This is going to be the most common use case you are going to have for the list style property, simply using it to remove the default behavior, similar to how we use text decoration to remove the underline from anchor tags. In this example, this navigation bar is built with an unordered list with list styling removed. The unordered list is being used here for structural purposes, to nicely group the menu items together. So let's finish up by building a summary card for this chapter, text styling. We first looked at font weight. The CSS property looked like this, and the values ranged from 100 to 900 in increments of hundreds. The default values include 400 for most text and 700 for headings. And the design guidance is that headings should be 500 to 900 and other text 300 to 400. We looked at font style, where the CSS property looked like this, and the values include normal, italic, oblique, and oblique with an angle. And we saw that normal was the default property. The design guidance for font style was avoid using. For list style, the CSS property looks like this, and we saw there were 5 values: none, disk, circle, square, and decimal. Disk is the default value for unordered lists, and decimal is the default value for ordered lists. The design guidance we saw was that we should remove list styling. We also saw text decoration, where the CSS property looks like this, and there were 3 values. The first was the line value, then the color value, and then the style value. Line values include none, line through, underline, and overline, where none is the default property. For color values, you can use name colors, like we've done here with blue, or RGB or hex values, which we'll be talking about soon. And for the style value, values include double, solid, dotted, dashed, and wavy. For the design guidance, we saw we should remove underline from anchor tags. The last property we looked at was text transform, and it looks like this, where there are 4 values: none, uppercase, lowercase, and capitalize, where none was the default value. The design guidance was use sentence case in HTML. Okay, so it's time to start adding CSS to the major quill project we've been working on. Let's have a look at where we got up to at the end of the HTML section. I'm just going to scroll down the page so you can see all the content. By the end of the CSS section, our web page will look like this. And as you can see, CSS really adds visual identity to the page. So let's jump into VS Code and take a look where we got up to in the HTML section. So here's our quill project. We mainly worked on the index.html file, and this is the document we'll be styling with CSS. We also created a placeholder login page and a placeholder register page, as well as the create journal form. And then we also have a series of images, both PNGs and SVGs, that are being used on the index page. Now, if this is your first time joining me, I provided a link in the description below where you can download these files. And if you don't know anything about HTML, you're better off taking the HTML course first, because to properly work with CSS, you do need a solid understanding in HTML. You can take my full HTML course by clicking the link appearing in the top right now. Alright, so the first thing we need to do before we get started is add a style sheet and connect it to the index.html file. To do that, I'm going to come over here into our working directory, click New File, and create a new CSS file called app.css. Now, in order for the styles to apply to our index page, we need to link it. I generally like linking my style sheet above the title. I'll grab the link attribute. The rel style sheet becomes pre-populated, and the value style sheet is correct. And the href is going to point to our style sheet, which is in the same level as our working directory, so it's just app.css. So let's go and add some text styling properties we've just learnt about. We'll start by adding font weight to the homepage. We're going to be setting the headings to a font weight of 700, while other text content and paragraphs will be set to 400. Again, the headings over here will be set to 700, and the paragraph text 400. And at the bottom of the page, this heading will be 700, and the rest of the text will all be 400. So let's jump into VS Code and add this to our project. So let's go and add the font weight for our headings. We'll start with an H1, which will have a font weight of 700, the H2, We'll also have a font weight of 700. And same with the H3, a font weight of 700. We'll then set our paragraph to have a font weight of 400. And the final element we have on our page is an anchor tag. And we'll set the font weight of that to also be 400. Now, you may be thinking, why am I even setting these weights? The default value for all headings is already 700. And for other text, it's 400. This is just best practice to explicitly set the font weight. It could also be that later on in your project, you want to change this. So it's generally a good idea to always set the font weight, even if at the beginning it's the same as the default. Looking at this in the browser, we see no change, which makes sense because our font weight values, the headings and other text, is the same as the default values. The next property we'll be using is text decoration. All we're going to do is go to our anchor tag over here, grab the text decoration property, and put none as the value. Let's check this out in the browser. You can now see that the underlines on our hyperlinks have been removed. We can see that over here, over here, over here, and these ones over here. That's generally all we do with text decoration. Just remove them from the anchor tags. The next property we'll be discussing is text transform. As we discussed in the design guidance earlier, it's generally best practice to use sentence case. So in fact, we're not going to change anything because I've written my text in sentence case. For example, this paragraph, only the first letter of the first word is uppercase. I have noticed there are a few places that I haven't done this, so I want to correct those now so that everything is consistent. This get started, I'm going to put that in lowercase. The more, I'm going to put that in lowercase. The H2, get started now, I also want to put these letters in lowercase. And the anchor text here, the S in started, I also want to put in lowercase. So this should all be consistent now with everything in sentence case. I'm not going to be applying any text transform property. I've set it how I want to, just by how I've written the HTML. The last text styling property we will be using is list style, in order to remove the bullet points, which are acting as structural units. You can see we have these annoying bullet points, like next to our links over here. And also down the bottom here, with our social media icons, as well as these links. So let's go and remove those now. I'm back inside the Quill project. In the style sheet, I'm going to go grab the unordered list. I'm going to find the list style property, and I'm going to set it to none. So let's check this out in the browser. So you can see now those bullet points have been removed for these links, as well as down here on our social media icons. Next up, we'll learn how to control the spacing and alignment of text to improve readability with text spacing. We'll be looking at text align, line height, and letter spacing. So in the previous chapter, I introduced these 5 categories of text properties in CSS, including styling, spacing, family, color, and size. In this chapter, we're going to focus on text spacing, which, like styling, also has a few important properties we need to look at. The first property we're going to discuss is text align. This property specifies the horizontal alignment of text within an element. You can see here, text-align is the property, and in this case, center is the value. There are 4 text align values, which are left, right, center, and justify. The default value is left, meaning if we don't specify any text align property, our HTML elements will align left, which we've seen so far whenever we've written our HTML. It always starts at the left edge of the page. Left align is generally considered easier to read for paragraphs of text. For longer chunks of text, it's advisable to either use text align left or not specify it at all, since it aligns left by default. Center alignment is often used for headings and shorter pieces of text. If you set justify as the value, every line in a paragraph takes up the full width of a containing box. Now, before we go play around with this in VS Code, I want to dive into something incredibly important about text align, and that is the different behavior when applied to block and inline elements. Let's look at a block element first. As you know, with a block element, the box spans the entire width of the page, which allows text align to significantly affect the placement of text. For instance, I have the text here playing with CSS, which is an H1 element. and by default will initially be aligned to the left. As an h1 is a block element, its box will take up the full width of the page. If I apply text align as right, the text will move to the right inside the box. So you can see the text can move right because it is a block element. The box extends the full width of the page. Let's compare this to inline elements. As we know, inline elements only take up the horizontal space that they need. In this example, I have a hyperlink with the text link, which is an anchor element. And as we know, anchor elements only take up the space they need. Because of this, there is no space for the text to move, because the box is only as big as the content itself. So if I try to apply text align right to this element, it won't have any impact. When we first started the CSS topic, I mentioned the importance from the outset of being able to distinguish between block and inline elements in CSS, as styling can be heavily influenced by whether an element you are styling is block or inline. And here is a perfect example of that. Let's now go play around in VS Code. Inside VS Code, I'm going to go create a new HTML and CSS file. I'll start with the HTML file by clicking New File, selecting Text File, click Select a Language, and search for HTML. I'll grab the boilerplate code by hitting !Enter. I'll straight away save the file. On my Mac, I'm clicking Command S. I'll go to the desktop, and I'll create a new folder called Text Spacing. And I'll call this HTML file text-spacing. Let's go add the CSS file. I'll hit Command N to open a new tab. I'll click Select a Language, search CSS, and hit Enter. I'll save this by hitting Command S, and inside the same text spacing folder, I'll save this as app.css. Let's now go and link the CSS file to the HTML file. Inside the head tag, I grab the link element, and as app.css is in the same directory as our HTML file on the same level, we can just reference it with app.css. Alright, for this example, I want to go grab 3 h2s, and I'm just copying in some placeholder text from my favorite tool, Hipster Ipsum. I'm also going to add a paragraph tag with a much chunkier piece of text, and the last element I want to add is an anchor tag. I'll just set the href value as the Google homepage. Now, a really helpful trick I want to show you, which makes working with HTML and CSS more productive, is splitting the visual code window into 2. And the way we do that is we grab the other file like this and move it to the right. This now gives us our HTML on the left and our CSS on the right. And we can see both of them at the same time. And sorry, just a minor error I picked up on. This should have been an H3 and this should have been an H4. So let's now go and style these with the text align property. For the H2, I'm going to set text align to be left, which is just the default value, so we shouldn't see any change there. For the H3, I'm going to set the text align value to be center. And for the H4, I'll set the text align value to be right. For the paragraph, I'm going to set the text align value to justify. And for the anchor tag, I'm going to set text align to center. So let's check these out in the browser. So you can see, as expected, our H2 is aligned left, which is just the default value, so there's no visible change here. The H3 has been centered on the page. The H4 is now on the right of the page. The paragraph text is justified, where every line takes up the full width of the page, which means that the spacing in the lines can be different. For example, on this line here, there's much fewer words than elsewhere, so the spacing is much larger. Compared to this line here, where there's a lot of words, the spacing is smaller. And finally, we can see no effect of applying text align center onto our anchor tag, and that's because it's an inline element. If I open up the DevTools by right-clicking Inspect, I can go and select the different elements. For the headings, you can see the invisible box and how it extends the full width of the page, allowing space for the content inside of it to center or move to the right. Whereas for the anchor tag, the box takes up the width of the content, so there is no space for the anchor tag to move. And as we know, an anchor tag is an inline element. Let's now take a look at some text align guidance. Don't justify text. Long blocks of text should be left aligned, and do not center large blocks of text. On this web page, we can see that both the heading and paragraphs are centered, which appears visually attractive. This kind of styling is a common practice, but note that these pieces of text are not long and typically only extend a couple of lines. Let's look at another example. In this case, both the heading and paragraph are aligned left. Aligning the heading and paragraph to the left also presents a neat appearance, and it is especially common to do this when there's an image on the right, like we see here. Centering text with an image beside it wouldn't look so good. However, it's important to note that just because we've aligned left this heading and paragraph doesn't mean we need to do that throughout the page. As you can see below, we have a heading over here that is centered. The next property we're going to look at is line height. Line height sets the height of text and is commonly used to set the distance between multiple lines of text. Here we can see line-height, which is the property. And in this example, it's set to 1.5, which is the value. We can use several types of values for the line height property, such as a unitless value, pixels, percentages, and ems. Unitless is just a number that multiplies the font size and is commonly used for line height. There are other units that you can use, but we will explore these in more detail later on, as units is a topic in itself. Don't worry about these for now, it isn't common to use them for line height anyway. So let's go play around with this in VS Code. So I'm back in our text spacing HTML file. I'll keep this h2 element, but I'm going to get rid of the h3 and h4, as well as the anchor tag. So we're just left with a heading 2 and paragraph. I'm going to pop the app CSS file on the right. I'll delete all these styles, and let's grab the h2 and give it a line height of 3. For the paragraph, we'll grab line height and give it a value of 4. So let's check this out in the browser. So let's look at the heading first. If I try select it, you can see the blue box vertically is quite a bit bigger, and that's the impact of line height. However, because it's just one line, we can't really see the effect of spacing between lines. With the paragraph we can. We can see how spaced out each line is. If I make this a smaller value, like 2, you'll see how the lines are much closer together. So the real impact of line height is when we have multiple lines of text. Let's discuss some line height guidance. Headings should always be less than 1.5 and regular text between 1.5 to 2 to improve readability. As you can see here, this heading is assigned a numerical value of 1.2 for line height, which is below 1.5. This creates space between each line, making the heading a bit more readable as it slightly separates the lines of text. However, for smaller text like a paragraph over here, it's recommended to use a line height value between 1.5 and 2. In this example, a numerical value of 1.6 is used to enhance readability. We typically use a larger value of line height for smaller text like paragraphs compared to headings, as paragraphs usually have smaller font size, so require more line height to improve readability on multiple lines. In this example, the line height value for this heading is set to 1.5, which in my opinion is pushing the line height to the limit. You might notice it starts to look a bit odd, as if the lines of text are somewhat disconnected. That's the reason why we shouldn't set the line height value above 1.5 for headings. This is just a demonstration of how text appears when it's on the edge cases, and the lines of text begin to appear excessively spaced out. Moving on to the last spacing property we will look at in this chapter, which is letter spacing. Letter spacing sets the horizontal space between characters. Letter-spacing is the property, and in this example, 8 pixels is the value. Values we can apply to the letter spacing property include pixels, percentages, and ems. Pixels are the most commonly used type of value for letter spacing. We're going to talk about what pixels are soon, but just for now, understand that a pixel is just a small unit, and it's likely something you've heard about before. Keep in mind we will discuss percentages and em values later on. Also note that for letter spacing, there is no unitless value, like there was for line height we saw previously, meaning we can't simply have a number multiplied by the text. Let's go play around with letter spacing in VS Code. I'm back inside our textspacing.html file and corresponding app.css file. I'm going to remove this styling. I'm going to go grab the H2 again. We'll get the letter spacing property, and I'm going to add a value of 10 pixels. Let's check this out in the browser. You can see this looks terrible. Because I've added a positive value, it's creating space between each letter, which makes it really hard to read, as letters are disconnected from one another. Let's now look at some letter spacing guidance. We often apply a small negative pixel value to headings to improve readability. This technique brings letters closer together and is known as tightening. In this example, the heading is set with a negative 3.6 pixel value, making the letters a bit closer to each other, which improves the readability, as larger text like headings will have their letters more spread out, which would look disconnected. So applying a slight negative pixel value tightens the heading and improves the readability. So let's finish out by starting to build the summary card, text spacing and size. We first looked at text align. The CSS property looked like this, and we saw there were 4 values: left, right, center, and justify, where left was the default value. The design guidance we saw was that you can use center, but left align should be used for blocks of text. We then looked at line height, where the CSS property looked like this. The units we can use for the value include unitless, pixels, percentages, and ems. We mentioned we're going to be talking about units in a later topic. And for line height, it's most common to use unitless values, like 1.5 shown above, which multiplies the font size by 1.5. The design guidance we saw was that headings should be less than 1.5, and regular text should have a line height value of 1.5 to 2. The final property we looked at was letter spacing, and it looked like this. Values we can use here include pixels, percentages, and ems. And we noted that you can't use unitless values like you can for line height. For letter spacing, the most common unit to use is pixels. And the design guidance we saw was that small negative values are applied to headings to tighten up the text. Okay, so let's go ahead and add some of the text spacing properties we've just learnt about to the Quill homepage. We'll start off with the CSS property text align. At the top of the page, we've aligned both our heading and paragraph text in the center, which makes sense to do because there's no surrounding assets like an image to cater for. Scrolling down the page, we've also center aligned this heading. However, you can see that for each feature, both the heading and paragraph are aligned left. This looks good because we need to cater for the image on the right. So let's now go and add text align on the Quill project in VS Code. So I'm back inside the Quill project. I have my HTML file here on the left and my CSS file here on the right. We know that for our H1, we want this to be centered. So I'm going to come over here in our CSS, type text align, and set that to center. The H2s are also centered, so I'm going to set text align to center. And the H3s were all aligned left, which is the default value, so I'm not going to touch those. Now, with our paragraph, we have a slight problem, because some of our paragraph text is centered, like in the main hero section below the main heading, where other times it's aligned left, like for each feature in the features section. Now, we're just at the beginning of our CSS journey, so there's not much we can do about this at this point. In the next topic, we're going to be learning about different selectors and the concept of inheritance. And once we've understood that, we'll be able to implement a solution. With the anchor tags, at this point, applying text align center would also have no effect, because an anchor tag is an inline element, so we're not going to apply anything here. So let's check this out in the browser. Okay, so this did have quite an impact on the visual styling. Our main heading is nicely centered now, and our H2s, which are the section headings, like this one over here, and this one over here, are also now centered. Now that we've applied the text align property, let's have a look at applying the line height property. For our headings, we're going to be applying a line height value of 1.2. And for the paragraph text, we're going to be setting a line height value of 1.5. The impact of line height won't be seen for this particular paragraph because it's a single line. However, we will see the effect for other paragraphs down the page. Scrolling down, both the section heading and the features heading will have the same line height of 1.2. And as we saw before, the paragraph text has a value of 1.5. The effect of applying line height on this paragraph will now be seen because there are multiple lines. Let's jump into VS Code and add line height to our project. In the CSS file, for the headings, we have a line height of 1.2. And I'm just going to copy this for the other headings because the value is the same. For the paragraph, we're using a line height with a value of 1.5. And I'm going to do the same for the anchor tag. Although it's not going to be common to have multiple lines on an anchor tag, so this effect won't really be seen. But I'm just adding it for the sake of completeness. So let's check this out in the browser. Alright, we can see for our headings, we have a very slight line height over here when we have multiple lines of text. It's more obvious on paragraphs that span multiple lines, like this one here. The distance between each line has been slightly increased. The final CSS property we're going to be adding in this chapter to the Quill homepage is letter spacing. Across all of our headings, we're going to add a -2 pixel letter spacing value. As a result, each individual letter in the headings will come closer together and improve the readability. Let's go add letter spacing into the project in VS Code. So I'm back inside our project. In the app.css file, in the h1, I'm going to go grab the letter spacing property, and I'm going to set the value to -2 pixels. I'm then going to copy and paste this for heading 2 and heading 3. So let's check this out in the browser. Now, as you can see, this looks fairly awful. The letters are now too close to each other. Later on in this topic, we're going to be changing the font. And when we update the font, this issue will auto-correct itself. So we're just going to have to live with it for now. Now it's time to dive into adjusting the size of text elements by looking at text size. We'll be discussing font size, pixels as a unit, and looking at what a type scale is. So again, here are all the text properties we will be looking at in this topic. So far we've covered text styling and spacing, and it's now time to look at size. It's important to understand that with sizing, there's a bit more theory involved that will apply throughout CSS. We're going to take a look at size in relation to text sizing, but keep in mind that the material we discuss is going to be applicable for other non-text properties we will look at later. So let's talk about font size. This property sets the size of the text. Over here, we can see we have font-size, which is the property, and in this example, 16 pixels, which is the value. Now, when it comes to size units, there are two groups, absolute units and relative units. We're going to be covering units in a lot more detail later on. But here's a quick overview. Let's first look at absolute units. For absolute units, the size is fixed and does not change in relation to parent elements. Examples include pixels, points, inches, centimeters, and millimeters. The pixel is an absolute unit that is commonly used in CSS, and the other units you see here are uncommon. We're not going to use them. Point is a unit that's often used in printing, and inches, centimeters, and millimeters are units used in the real world. Most of the time, except for a few properties, we typically avoid using absolute units because they're static. Web pages are all about dynamic and adaptable designs that can fit different screen sizes and resolutions. Therefore, having a fixed size isn't ideal. So on the flip side, we have relative units. Relative units are where sizes are based on the size of a parent element and adjust proportionally to changes in the parent element. Now, that sentence can seem pretty confusing. The best way I can explain what this means is with this balloon. This balloon has an elastic band wrapped around it. I'm going to call the balloon the parent. It's the thing we're going to inflate. And the elastic band is the child. The size of the elastic band is dependent on the size of the balloon. So if we blew this balloon up, not only does the balloon expand, but the elastic band expands as well. So we can think about this with sizing of HTML elements, that when a parent is a certain size, the child will be a proportion of that size. Just like the elastic band going around the balloon is directly influenced by the size of the balloon. Examples of relative units are percentages, ems, rems, vh, and vw. They're great for web development because they help elements resize according to the parent's container's dimensions, giving flexibility across layouts and screen sizes. This is just a very basic introduction. Don't worry at all about these right now. I just wanted to provide a very soft introduction to them, and as I mentioned, we're going to spend an entire topic discussing them. For now, we're just going to be using the pixel. So let's discuss pixels in more detail. A pixel is a single point of light on a digital display. Here is a screen showing a pixel. It's essentially a tiny dot of color on the screen. So how big is a pixel? A CSS pixel has a length of 1/96 inches, or 0.0104 inch. In a nutshell, a pixel is small. So our pixel over here has a length of 0.0104 inches. If we applied the CSS rule font size as 10 pixels, it would mean that the size of the font would be 10 times this 1 pixel, which would be 0.104 inch. Now I need to add a big disclaimer at this point. The concept of pixel size is actually a bit more complicated than this, because in reality, different devices have different screen sizes and resolutions. At this point, do not worry about this fact. It is something we're going to be discussing a lot more in a later topic, and going into detail now would honestly just confuse you and be counterproductive. So let's now talk about some font size guidance. It's recommended that regular text should be 16 to 32 pixels, and headings can be greater than 60 pixels. Let's look at this web page here. The main heading has a font size of 72 pixels. It stands out nicely from the rest of the text. The paragraph text here is 18 pixels, fitting nicely between the 16 to 32 pixel range. Then we've got an anchor tag, which is 16 pixels, and a smaller anchor tag up here, which is 14 pixels. Scrolling down the page, we have a smaller heading here, which is 48 pixels, and an even smaller heading here, which is 24 pixels. As you can see, while some headings can exceed 60 pixels and be quite large, there is also scope to use smaller values less than 60 for smaller headings. Over here we have some paragraph text, which is set at 16 pixels, slightly smaller than the other paragraph text we looked at before. Let's look at another example. The heading here has a font size of 75 pixels, which is really eye-catching and big. The paragraph text is 28 pixels. What I want to highlight is that you've got some flexibility when it comes to choosing font sizes. There is no hard and fast rule that a heading or paragraph must be a specific font size. However, they should fall within the ranges I've provided. So let's talk about how we can help narrow down our choices for font sizing. You should use a type scale, which provides a structured hierarchy of font sizes to create visual consistency and limit choices. This is a fantastic tool, typescale.com. I've put a link in the description below and I'm going to show you how it works. Over here on the left, we have criteria. The first is the body size. It's the base value that all our text sizes will be calculated from. Just leave this at 16. Scale is the factor we're multiplying our body size to give us a range of other sizes. You can see that there are a range of different scales we can select, like 1.2, 1.250, etc. These names, minor third, major third, perfect fourth, etc., actually come from music theory. You don't really need to worry about the names, focus more on the numbers. Just to play around, I'm going to go select perfect fourth. You can see over here, it outputs us a range of different sizes that scale according to this scale factor. There's other criteria we can play with, like the font. For example, we're going to be using poppers, so I can change that. I can change the weight, line weight, letter spacing, colors, etc. On the far right here, if I expand this window, you can see what a typical web page would look like using this body size with this scale factor. So you can also play around here. In our quill project, we're going to be using a major third, which is a scale factor of 1.25. We start with a base of 16 pixels. For each value, I'm going to put some sample text so you can see what it looks like. 16 pixels is our base unit. So we then multiply that by 1.25, which gives us a value of 20 pixels. This is then repeated several times, where we get 24 pixels, 32 pixels, 40 pixels, 48 pixels, and 62 pixels. Now I am slightly rounding these numbers to make them a bit more user-friendly. So if you were to use the type scale tool and apply major third, your numbers would look a little bit different. I can also get smaller values by dividing by 1.25, which gives me 12 pixels. Next, we assign these specific sizes to HTML text elements. Starting at the top, I'll assign 62 pixels to an H1, 48 pixels to an H2, 40 pixels to an H3, and if we do need them later, 32 pixels to an H4, and 24 pixels to an H5. I've skipped over H6 as we don't need to go down that far. I'll assign 20 pixels to our paragraph, and 16 pixels will be our anchor tags. I'm also going to introduce small, which will be used for even smaller text, setting it at 12 pixels. Now note, this is not an HTML element like the others above it, but it's our own defined class, which we will be discussing in the next topic. Now, we could make our paragraph and anchor tags the same size, but I've chosen to keep the anchor tags slightly smaller. Hopefully you can see using a type scale helps provide a structure for helping you select font size. Now, of course, you have complete freedom to choose whatever values you like, and it is sometimes helpful to use a type scale and adapt the values for your own specific needs. So let's finish building our summary card, text spacing and size. We looked at the font size property, which look like this. Values you can use include pixels and rems, where pixels are an absolute value and rems are a relative value. We'll just be using pixels for now, and we have a whole topic dedicated to units later on in the course. The design guidance we saw was that regular text should be 16 pixels to 32 pixels, and headings can be greater than 60 pixels. We also looked at what a type scale was, where we start with the base unit, like 16 pixels, and then apply a scaling factor like 1.25 to give us the next value up, in this case 20 pixels. We then continued this to get higher values. And then from these values, we attributed a particular HTML element. So let's go ahead and add some different font sizes to our Quill project. These are the different font sizes we defined earlier. We used the type scale to establish different font sizes for different elements. We're now going to be using these values inside our Quill project. Our heading 1 has a value of 62 pixels. Our paragraph, 20 pixels. And our anchor tags are all 16 pixels. Scrolling down the page, our H2 is sized at 48 pixels. Our H3 is set at 40 pixels. And just like before, the paragraph is 20 pixels. Moving down to the bottom of the page, this heading 2 also has a value of 48 pixels. The anchor tag has the same value as the other ones at 16 pixels. And the anchor tags down here is also 16 pixels. We also have this very small piece of text right at the bottom here. This is 12 pixels. It's that small value we saw, and we'll be defining later in the next topic. So let's jump into VS Code and add all our font sizing. So I'm back inside the Quill project. I'm going to head to the app.css file, and we can start adding our different font sizing. Starting with the H1, I'm going to go grab font size and add the value of 62 pixels. For the H2, the font size value was 48 pixels. For the H3, the font size value was 40 pixels. Now, although we don't have an H4 or H5 yet, I am going to add them in case we want to use them later. So I'll grab H4, and this had a font size of 32 pixels. I'm also going to apply the other properties we've consistently applied to our headings: the font weight, line height, and letter spacing. For the H5, the font size was 24 pixels, and I'm just going to paste above those same settings. For our paragraph element, the font size was 20 pixels, and for our anchor tag, the font size was 16 pixels. Let's go check this out in the browser. So you can see adding font size makes a huge difference to our design. The H1 is looking nice and big here. The paragraph text is more readable. And the feature section pops a bit more, with a larger heading here and larger heading here. Scrolling down to the call to action section, the Get Started Now is also nice and big. One major change that has also happened since we've now made our text a lot larger is that the letter spacing value of -2 pixels actually looks good, where the text is no longer too cramped. While the letters are still a bit on top of each other, it does look a lot better, and it will only improve when we add our own font to the Quill project soon. As you can see, font size is really important. It makes a huge visual difference to your webpage. In the next chapter, we'll explore how to change the overall look and feel of your text by looking at text font. We'll be looking at typefaces, font family, and Google Fonts. So far, we've looked at styling, spacing, and size. In this chapter, we will be discussing font family. Let's start by talking about a typeface. A typeface is just a fancy word for a specific font. A font features characters with consistent visual characteristics. Now, typefaces or fonts are organized into groups. The first group we have is serif. Serif fonts have extra details on the end of a stroke, which you can see on this font over here at the bottom of the T. A classic example of a serif font is Times. Next, we have sans serif. These fonts are known for their straight ends and are much cleaner. And they don't have those extra details like a serif font. Arial is an example of a sans serif font. Next up, we have monospace fonts. In this font, letters are the same width. This means each character takes up equal space, like you see over here. Courier New is a good example of a monospace font. The next group are cursive fonts. Cursive fonts have joining strokes or mimic handwriting. Comic Sans MS is an example of a cursive font. The final group are display fonts. They are designed to be attention-grabbing and more artistic. Impact is a popular display font. Let's now explore each of these typeface groups and see how they're used in design. We'll first start with the serif typeface. Serif fonts are all about a classic feel used by brands to communicate luxury and reliability. Here's a great example. Patch is a more high-end plant company. I've previously complained about this company, as they sell grossly overpriced plants because they have cute names like Susie and Big Ken. But I have to hand it to these guys, their branding is pretty slick. When you look at their heading, it's just got that vibe of being a bit more classy. Serif typefaces are a go-to for high-end products. Next up, we've got the sans serif typeface. It's a modern and clean feel used by brands to communicate simplicity and clarity. Take a look at this heading and paragraph text. It's clean and straightforward. Sans serif fonts are a favorite among tech companies. Next is the monospace typeface. Monospace typeface has a technical feel used by brands to communicate accuracy and precision. This is a good example of using a monospace font. It's typically picked for very technical products. This company is quite techy, so they've used monospace to really drive home the vibe of scientific precision and accuracy. Moving on to cursive typeface. This one's all about creating a personal feel, which is used to connect with people on a more emotional level. The text here is cursive, which is super popular for things like weddings and blogs. It brings that personal touch used to evoke heartfelt emotions for an event like a wedding. Finally, we have the display typeface. It's a creative feel used by brands to communicate playfulness and rule breaking. This company sells CBD gummies, so it's a bit more of an edgy product. So a display font is a good choice. Display fonts are commonly used by fun brands, bringing a bold and lively vibe to the table. Alright, so let's look at the font family CSS property. Font family in CSS sets a prioritized list of font names, typefaces, or font categories. Let's take a look at this. On the left, we have the CSS property, which is font-family. In our example, the value to Homer is used, which is a sans serif font. And this is our first choice. This is then followed by a font group, sans serif, which is our fallback option. So why do we need a fallback option? The reason behind this is that fonts will only display in your browser if they are installed on your machine. So for example, the font to Homer is installed on 99.9% of Windows machines. However, on Mac, it is installed on only 91.7%. There's a chance that if you're viewing a web page on a Mac and to Homer isn't installed, it won't show up. That's where our fallback comes into play. The fallback is set as a generic font group, like sans serif, which ensures a font group that you do want will be found and displayed. So what sans serif font will be applied? This also depends on your operating system. On a Mac, the default sans serif font is Helvetica, while on a Windows it's Arial. Let's look at an opposite example. Futura is on 1.3% of Windows and 94.4% on Mac. So you can see the fallback option is really important for ensuring font visibility across different platforms. Now you can add more fonts to the comma-separated prioritized list, but you should always end with a font group as opposed to a specific font to ensure a backup font from a group you prefer will always be selected. At this point, I also want you to note that when we provide a single font value, it's in commas, whereas a font group is not. So let's jump into VS Code and check this out. Alright, so I've set up a new folder called font-family, and inside it I have an index.html file where I've grabbed the boilerplate, and I've also linked a style sheet called app.css, which is currently empty. So inside index.html, I'm just going to go add an h1, and let's just give it the text, this is a heading. So let's head over to app.css. I'm going to select the h1, I'll grab the font family property, and make my first choice impact. Now, because I'm on a Mac, there's a 95% chance this font is installed on my device. I'll then go give a backup font of sans serif. And just a reminder, the specific fonts that you select should be in commas, whereas a font group is not. So let's check this out in the browser. So you can see that our heading is looking very different to how it usually looks. Just a reminder of what it usually looks like. I'm going to comment out this h1, save and refresh. And you can see this is the default font you're used to seeing. I'm just going to go back and uncomment this. So the impact font is being applied, and we can actually confirm this in DevTools. I'll right-click Inspect. Now in the HTML section of the course, we spent a lot of time on the Elements tab, specifically on the left here, where it showed us the full markup of the page. In the CSS section, we're going to be spending a lot of time on the right here, as this shows all the CSS rules that are applied to the page. If I grab the inspection tool and select the h1, you can see over here h1 with the font family impact being applied and the backup font sans serif. And in fact, I can turn this off like this by unticking this box, which will return the heading to its default font style. Now, if I head over to Computed, I'm going to scroll to the bottom and you can see under rendered fonts, it says family name impact, and this confirms the impact font is being applied. Let's check out what happens when I update the font to another family called Seagull UI. This font family has a 0% chance of being installed on my Mac. So I'll save this and refresh the page. So if we look again at rendered fonts, you can see the font family name is Helvetica, and that's being applied because my first preference font is not available in my system. So the font being applied is from the backup sans serif group, and the default backup font for sans serif on a Mac is Helvetica. Now this font isn't all that ugly, but if I go back to Styles and now remove this property and go back to Computed, now the font family being applied is Times, which is just the default font of the browser, which isn't great, so it's really important to have a backup font group to avoid this happening. So let's now look at some font guidance. The key takeaway is to play it safe and pick a popular sans serif font. Sans serif fonts are a popular choice, especially for tech-based applications that you're likely going to be working on. Let me show you some popular fonts that I would like to recommend. First up is Roboto, and on the right is a sample of how it looks. Open Sans is also very popular and looks super clean. Another classic option is Montserrat. Another option is Poppins, which is actually one of my favorite fonts, and we'll be using it in our Quill project. And finally, Inter is another popular option. These are just a few examples of some great sans serif fonts to consider. Now, in your projects, it's recommended to select 1 or 2 fonts, but no more. In this example, only one font is being used, which is Inter. The page looks nice, clean, and unified. Let's look at another example. Here the heading uses Poppins, and then for smaller elements like subheadings, the font Rubik is used. Mixing 2 fonts like this can really make your design pop with nice contrast. But remember, do not go more than 2. Any more, and your design starts to feel a bit overwhelming, and you lose that cohesiveness. We'll finish up by talking about Google Fonts. Google Fonts are fonts that are available online and do not rely on the fonts installed on an individual user's device. These fonts live on the web, meaning they are not tied to your device at all, but are in the cloud. Google Fonts are very easy to add to your project, and it is super straightforward. There are just 3 steps. First, you need to find the font you like. Next, you embed the font with a link tag in your HTML. And then the third step is you add the font into your CSS. So let's go see how this works. Alright, so here's Google Fonts. The URL is just fonts.google.com. On the homepage, you're shown a list of fonts that are currently sorted by trending. So you can always come here to get some inspiration of which fonts to choose. You can then sort by other filters like most popular or newest. There's also additional filters over here, where you can filter by serif or sans serif, and other classifications like display, handwriting, which is cursive, or monospace. So let's go search one of the popular sans serif fonts I recommended earlier. Let's look for Inter. So you can see it appears here. So we click on the font. In the top right, we click Get Font, and then Get Embed Code so we can add it to our CSS. Now before we embed it, there's a few criteria options we can select. At the moment, it's going to be importing all font weights from 100 to 900. If you wanted to, you could click one value and select a specific value you want to import. I'm just going to import them all. And you can also change the slant of the font. At the moment, the default is 0, which I'm just going to keep. So my font will just be normal without any slant. Now on the right over here, we have 2 windows. Embed code in the head of your HTML, and CSS class for a variable style. This top part here is what we're going to copy into the head section of our HTML to actually import the font. And this window over here is just showing us an example of how to use the font in CSS by declaring the font family property with the font family name Inter and backup sans serif font. So let's copy this code and add it to our HTML. Now it's best practice to add this snippet of code before the link to our own style sheet. So I'm just going to paste it over here. This order ensures that font styles are loaded before our own custom styles, so the fonts that we're importing will load in app.css without any issues. Now this does look a little bit intimidating, so let's just briefly talk about what these different lines are doing. These first 2 lines are just for optimization purposes, and in theory you don't actually need them, but it's best to leave them there just to ensure the fonts load in quickly. This third line is actually importing the font itself. You can see over here family equals Inter, and it's importing the weight 100 to 900. So let's go add this font in our CSS file. For the font family, I'm now going to replace this font we added earlier with Inter. I'm also just going to add an H2 below so we can have a point of comparison to the default font in the browser. I'll just type default font. So let's check this out in the browser. So you can see the Inter font has successfully been imported. And again, we can confirm that by opening up DevTools, selecting the element, going to the Computed tab, and seeing the family name Inter. And you can see this font is just way nicer than the default Times font that comes in our browser. So let's finish up by starting to build out the next summary card, font family and color. We looked at what a typeface is. We saw that there were 5 primary groups of fonts. The first was a serif font. The next was a sans serif font, then a monospace font, a cursive font, and a display font. We then looked at the CSS font family property, which looked like this. Font-family, with a comma-separated list of fonts, where descending values were backups. And we always ended with a font family group, like sans serif, which was the final backup. The font guidance we looked at was use a popular sans serif font. So let's go ahead and add Google Fonts to our Quill project. I've decided for this project, we're just going to be using a single font throughout the application. So our headings, paragraphs, anchor tags, and all other text will be in the font Poppins, which is one of my favorite sans serif typefaces. So let's head over to Google Fonts and grab the code to embed in our project. So I'm on the Google Fonts homepage, fonts.google.com. So I'm going to go into the search bar and look for Poppins. I'll click it over here. I'll click Get Font. I'll click Get Embed Code. I'm not going to play around with any of this criteria. I'm just going to import all the different fonts in case we decide later in our project we want to use any. On the right over here, I'm just going to copy all this code. Alright, so I'm back inside our Quill project on the index.html page. I'm going to go paste in the code we just copied earlier, and I'm going to make sure to do it before my own custom style sheet app.css. I'm now going to head over to app.css, and for each text element, I'm going to add the font family property, set the value to Poppins, and provide a backup font of sans serif. I'm just going to copy this line of code for all my headings, paragraph text, and anchor tag. Alright, so let's check this out in the browser. Alright, so this has made a massive difference. Using a popular sans serif font, like Poppins, really does start bringing the project to life. I also want you to notice how adding that -2 pixel letter spacing was the right decision. Now that we've added the font, you can see that our text has been tightened, and the headings look like a nice cohesive unit. Now, as I mentioned earlier, the huge benefit of using Google Fonts is that they're stored in the cloud, which means that the fonts will always load in, irrespective of what fonts are installed on the user's device. Let's continue by adding visual impact to our text through the use of color. We'll be discussing named colors, color systems, the color property, and color palettes. Alright, we're finally onto our last text property. Now it's time to look at my favorite CSS property, color. Just like size, color is used throughout CSS, so it's really important to get a good understanding of what it is and how it works. So let's first start with named colors. These are the colors we've been working with so far. CSS includes 147 named colors that browsers recognize. An example of a common color we've seen so far is red, and then there'll be some variation, like salmon. We've got yellow, and a variation called khaki. There's blue, with a variation called aquamarine, and we've got green, with a variation called olive. Now, although we have been using these colors so far, these should not be used as they are very limited and not suitable for professional projects. This website, HTML Color Codes, shows you all the HTML named colors. So if you are interested, you can come here and check it out. So before we start looking at the CSS color property, we need to have a look at color systems. Color systems are a structured method for creating different colors using a set of primary colors and rules for mixing them. There are two main color systems. They are subtractive and additive. Let's look at the subtractive color system first. It's commonly used in print and painting, something many of us would have learnt about in school. Let's take the CMY color system as an example. In this system, C stands for cyan, which is that blue color, M for magenta, which is that pinky color, and Y for yellow. This system starts with white, and we apply colored pigments that absorb light. We start with a white canvas and add different colored pigments. The canvas absorbs the light from these paints, and you get black when all the colors are mixed together. Now on the flip side, we have an additive color system. This is commonly used in electronic displays. The primary colors here are red, green, and blue, often abbreviated to RGB, a concept we'll look at soon. In additive color systems, we start with black and emit light at different intensities. Think about it, before your screen is on, it's black, and once it's on, it's emitting light at different intensities. When red, green, and blue are all combined at their maximum intensities, the result is white when all mixed. The additive color system is the complete opposite of the subtractive color system. Now, in the context of CSS, we use an additive color system. It's because our colors are on a digital screen. I now want to go back to pixels, but this time we're going to be talking about color and not size. A pixel on your digital display is made up of red, green, and blue lights with adjustable intensities, which means we can tweak how bright each one shines. Over here I have a digital display, and this square over here represents a pixel. Let's now zoom in on this pixel. what we would see are three panels of light: one red panel, one green panel, and one blue panel. These are the primary colors, red, green, and blue, we mentioned in the additive color system, and we call this RGB for short. RGB values range from 0, which is minimum intensity, to 255, which is maximum intensity. So for red, the intensity can go from 0 to 255, for green, 0 to 255, and for blue, 0 to 255. So for each color, there are 256 possible values, 0 being one of them. So let's go tinker with these values and have a look at an example. Imagine we set R to 152. It's a somewhat muted red. The green value to 116, and the blue value to 249, which is pretty close to the maximum. As a pixel is tiny, our eyes would mix these colors and would get purple. Looking at another example, setting R to 232, green to 202, and blue to 9, from a far distance these colors would mix to yellow. So playing around with different RGB values gives you a whole spectrum of colors. An easy way to see the RGB value of different colors is to go to Google and type in color picker, and you get this widget at the top here. You can use this slider to go across the spectrum of colors, and then you can use your mouse to click a different tint or shade. And each time you click, you get a different RGB value. Now you can see below here, the first listed color is this thing called hex. So what is that? So let's take a look at RGB and hexadecimal notation. Color values can be represented in either RGB or hexadecimal notation. As a disclaimer, there are other systems, but RGB and hexadecimal are by far the most common. So let's first look at RGB. In CSS, we'd represent an RGB value like this. We'd write RGB, and then inside the brackets, we'd have each value comma separated. The red value first, then the green, then the blue. This RGB value would produce this purple color. Let's now take a look at hexadecimal notation. This same RGB value can be written like this, which is in hexadecimal notation. We start with a hash, and then we have three sets of numbers and characters. In this case, 98, 74, and F9. This would produce the same color, purple. Defining a color using the hexadecimal notation is actually more common than using RGB, so we're going to be using it throughout this course. And this notation is used across CSS for specifying colors for text, backgrounds, borders, shadows, and more. Now, you might be thinking, what is this hexadecimal notation? RGB you may have heard of before, but hexadecimal might be completely new to you. So looking back on the Google color picker, you can see that we have our RGB value and a corresponding hex value, which starts with the hash symbol and has three sets of letters and numbers. In this case, A1, 6D, and B3. So before we look at the CSS color property, we need to talk about shades of gray. When all three channels of RGB are set to the same value, we get a shade of gray. Let's take a look at this gray color here. It would have an RGB value of 64, 64, 64, and a corresponding hexadecimal value of hash 40, 40, 40, which gives us a dark gray. This gray color here would have an RGB value of 136, 136, 136, with a corresponding hex value of 88, 88, 88. This lighter gray over here would have an RGB value of 192, 192, 192, and a corresponding hex value of C0, C0, C0. Let's have a look at the extremes now. To get black, we set all the RGB values to 0, and in hex notation, all the values are also 0. On the other extreme, we have white. This is when all the RGB values are 255. And in hex notation, all the values are F. So this means we have 256 values of gray to play with. I also just want to show you something you may see sometimes, which is the shorthand for hexadecimal values. You'll see this shorthand when each pair of values in a hex code are the same. Let's take a look at an example. If the first pair is 22, the second pair is AA, and the third pair is 66, this can be shortened to 2A6. So for some of our shades of gray, we can use the shorthand as another way to represent them. For example, for black, each of the 3 sets has the same character of 0, so we can shorten this to 000. For the hex value where there are all 8s, we can also shorten this to 888. And for white, where there's all Fs, we can shorten this to FFF. We can't shorten the 404040 or the C0C0C0 because for each pair, the character has to be the same. 4 and 0 is not the same, and C and 0 is not the same. It only worked for the others because within each pair, the characters were the same. Now the shorthand notation is a neat trick, but it's not something to stress over. Most of the time you'll be using full hexadecimal codes. It's just something I wanted to show you that existed, so that if you ever see 3 characters being used for a hexadecimal code instead of 6, you know why. Let's now take a look at the CSS color property. The color property is used for specifying the color of text. Over here, you can see color is the property, and in this example, the hex code #9874F9 is the value. The values that we can use for color include RGB, hex, RGBA, and HSL. And as I mentioned earlier, hex is by far the most commonly used color system, but I do want you to be aware there are others. Now, the color property is specifically used on text. There are other properties like background color we'll be looking at later in the course, which, as the name suggests, define background colors. And color values, like the hex code you see on screen, are often used throughout other CSS properties, like borders and shadows, CSS properties we will also look at later in the course. So for now, just know that the CSS property color is just for text. So let's jump into VS Code and play around with this. I've gone ahead and set up a new directory called color. Inside it, I have an index.html file where I've grabbed the boilerplate, and I've also linked a style sheet called app.css, which is currently empty. On index.html, let's grab an H1 and just give it the text heading 1. I will just grab a paragraph and give it the text paragraph text. Inside app.css, I'm going to select the H1. I'll grab the color property, and let's start off with an RGB color. I'm just going to pick some random numbers between 0 and 255. So let's make the R 55, the G value 189, and the B value 110. So one of the nice features of VS Code is that it actually gives you a little sample of the color on the left of the property. And if I click on it, I can move around to get different tints and shades, and I can use this swatch to grab different colors. What's also really nice is if I come to the top here and click this, it toggles between different color systems. So let's go grab the hex color code, and I'm just going to change it to a bright green. So let's check this out in the browser. So as you can see, that bright green color has been applied to our H1. And I've just got this paragraph texture as reference to see the default color. And once again, I just want to drive home the message that the color property is only for text. For example, if I go add an input in our HTML, and then try apply the color property to the input, I'll just pick the same color as before, you'll see nothing changes. And that's because this CSS property color only works for text. There are other properties we're going to be looking at later, where we can change the background color of this input and even the border color. And you can actually see when I come into this input and start typing, the input text is green. Let's now look at some color guidance. The guidance I'll be going through now doesn't only apply to text, but as the web application as a whole. Now the rule of thumb is to have at least 2 colors in your color palette, a primary color and a gray color. Let's have a look at an example of a typical color palette. We'll start with the primary color. The first thing we do is choose a base color. In this case, it's this orange. The next thing you'll want to do is add tints. These are lighter shades of our base color and will look something like this. We also want to add shades, which is a darker version of our base color and will look something like this. We then add a gray color. Now the term gray is a bit confusing because it doesn't have to be a gray color. It can be a darker version of a color. So for example, the base gray color could be this dark purple. And again, we go and add tints, which are lighter versions of the gray color, and shades, which are even darker versions of the base gray color. Let's take a look at this color palette in action. Primary colors are used to highlight important parts of a page, and tints and shades can be used to create contrast. Here is the color palette we saw before being used on this page. You can see the call to action here, as well as this review icon, are in the primary color. They're the more important components of this page. You'll also notice the background color of the page is a lighter orange. It's the primary tint being used, which creates a nice contrast, but still maintains that consistency with the color palette. Now the gray color, along with its tints and shades, is often used for fonts. You can see this main heading over here is in the gray base color, whereas a less important subheading, like the one over here, is in a gray tint. Also, color is used in images and illustrations for consistency. Taking a look at these company logos here, they're in gray tints and shades. And the main image over here is also in gray tints and shades. So color is used throughout the design for both components and sections. Scrolling down on the page, we have this section over here. You can see over here that the primary color is used in components, whereas the gray color is used in this section as a background. So you can see throughout the design, you can play around with the base primary and gray color, as well as their respective tints and shades to create a clean and unified design. Now, adding a secondary color introduces variety and contrast, often making designs more appealing. Let's go set up a new color palette. For our primary color, we're going to use this blue base color with respective tints and shades. I'm going to add a secondary color of this purple with respective tints and shades. And for the gray color, I'm going to use a more traditional gray with its respective tints and shades. Let's check this color palette out in action. As we've seen before, primary colors are typically used on dominant elements such as buttons, background colors, and more. You'll notice the primary color is being used on icons, section headings, and buttons. And a primary tint is being used as a background. Secondary colors are used to add variety. Scrolling down the page, we have a very similar section, but now they're in the secondary color. We have the section heading and imagery in the secondary color. And again, the background color is using a secondary tint. Now you can also add tertiary colors. Tertiary colors add further variety. Looking at the same page again, we have this orange tertiary color being used as a section heading and in the icon. So let's now take a look at helpful resources which help you select colors. The first resource, which is my favorite, is called Open Color. It's this first link in Google over here. It basically gives you a gray color, along with tints and shades, as well as common colors you'd use for primary, secondary, and tertiary colors, like red, pink, gray, violet, etc. From here, you can easily select your own base color, like blue 4 or 5, and corresponding tints, like blue 1 and 2, and shades, like blue 7 and 9. This is one of my favorite resources because it really helps limit down color choices for you. The colors chosen here really are spectacular and beautiful, and I would recommend using a resource like this so that you don't feel overwhelmed. Another popular resource is Tailwind Colors. So if I type Tailwind Colors and click on this link, I'm provided with a similar resource like Open Colors, but there's just a few more options. For example, you can see there's quite a few more options of gray colors, like slate, gray, zinc, neutral, etc. And there are a few more colors you can use for primary, secondary, tertiary, etc. It's basically Open Colors with a few more options. Tailwind is a very popular CSS framework we will be discussing later on in the course. If you want a bit more freedom to choose a color palette, a tool like Coolors is really popular. From the homepage, if I click Explore Trending Palettes, you can see that I'm given popular color palettes. So essentially, primary, secondary, tertiary, gray, etc. is selected for me. Now, if I wanted to use this color palette over here, I'd have to generate my own tints and shades. To do that, just head over to Google and search Tints and Shades Generator. I'll click on this first link over here, and all you do is copy the hex code, I'll grab this one, and paste it in here, and click Make Tints and Shades. You can see our base color over here, with shades becoming more intense as I move to the right, and this row is the tints, with the tint becoming more intense as I move to the right. So this is another option, finding a color palette you like and generating your own tints and shades. Now coming up soon, we're going to be adding colors to our Quill project. But before we do that, I'd like to quickly talk about brand guidelines. We'll be discussing this a lot more in the web design module of the Fullstack bootcamp. Essentially, every product will have brand guidelines. It's usually a very detailed document containing rules about colors, sizing, logos, etc. I'm on the Duolingo brand guidelines. If I go to Identity and Color, you can see the primary colors that Duolingo use. Over here, we have the core brand colors, which are like the primary colors. There's secondary colors, and then there's neutrals, which is like the gray. They've even got a color palette for Duo, which is Duolingo's little owl mascot. Something that Duolingo do, as well as other companies, is give their colors distinguishable names, like feather green. These are colors Duolingo has just made up so that it's easy to refer to them. So let's go define quill colors, where we'll set up the color palette we'll be using in our quill project. We'll first look at the primary color. I'll be adding a base color, a tint, and a shade. For the base primary color, I'm choosing this blue. I'm going to call this color sky blue, and it's got this hex code. All the tints and shades and all the other colors I'm going to be adding are from OpenColor. So for the tint, I'm going to call it Arctic, and it's got this hex code. For the shade, I'm going to call it Deep Sea, and it has this hex code. Looking at the secondary colors, the base secondary color I'm going to call Lavender with this hex code, and it's this purple color. For the tint, I'm going to call Moonlight Iris with this hex code, which is a lighter version of that purple. And for the shade, I'm going to call it Velvet Night, which has this hex code, and it's a darker version of the purple. I'm going to also introduce a tertiary color. I'm going to call it Pumpkin, which has this hex code, and it's an orange color. The tint I'm going to call Dawn with this hex code, which is a lighter version of this orange. And for the shade, I'm going to call it Lava with this hex code, and this is a darker version of the orange. For my gray color, I'm going to call it Slate, and it looks like this. For the tint, I'm going to call Pebble, which looks like this. And for the shade, I'm going to call Graphite, and it looks like this. So once again, I just got all these colors from OpenColor. I selected a base color and chose a lighter version as my tint and darker version as my shade. Now, of course, you can add more tints and shades, but I want to keep this simple, and right now we have more than enough colors to work with. So let's wrap up by completing the summary card, font family, and color. We looked at the CSS color property, which look like this. And we discussed different color values you can use, like RGB hex, RGBA, and HSL. And I mentioned that hex is by far the most common color value to use. We then defined a color palette. We started with a primary color, where we defined a base color, sky blue, a secondary base color, lavender, a tertiary base color, pumpkin, and a gray base color, slate. We then added a tint of each of these, as well as a shade of each of these. And I simply grabbed each of these color values from my favorite tool, OpenColor, where I picked a base color, and one tint and one shade. The guidance we saw was have at least two colors, a primary and a gray, with tints and shades of each. So a moment ago, we defined the color palette for our quill project. So let's now go ahead and apply this color palette for different text elements. So let's now look at our quill homepage and how we add these colors. The primary color is used in our logo, as well as our buttons. We have our secondary color being used as a highlight over here. The gray color is used for paragraph text, and the gray shade is being used for headings. Scrolling down the page, you can see the primary color is being used inside this illustration. We have the tertiary color being used as a highlight. The paragraph is in gray, and our headings are in a gray shade. Scrolling down to the bottom of the page, you can see our primary color is used as a background, and is being used again as the logo in the footer here. The secondary color is being used on the button, and it's being used for this little love heart down here. The gray color is being used for these hyperlinks and small piece of text at the bottom, and the gray shade is being used for the social media icons. Now, although we won't be coding this up in this section, I do want to show you the Quill's journal page. It's the dashboard that will list all our journals. The reason I want to show you this is because it uses other colors we've defined. For example, the background of the emoji is in a blue tint, and the border of each card is in a grey tint. So although we won't be using all the colors for the homepage, a lot of them will come into play later. So let's jump into VS Code and add colors to text where we can. Alright, so I'm back in the app.css file for our Quill project. So let's go add text color where we can. All of our headings use the grey shade, which I called graphite. I add this color by finding the color property and adding the hex value, which from my color palette was #212529. And you can see VS Code even gives us a sample of what that color looks like. I'm just going to copy this color for all of my headings. For my paragraph, the color I used was the grey base color, which I called slate, and had the hex code 495057. This same color is used for my anchor tags, so I'll copy it and paste it over here. So let's check this out in the browser. So you can see our headings have this nice shade of grey, whereas paragraphs and anchor text are using this base grey color. As this project progresses, and we learn more about the box model and different selectors, we will start adding in our primary, secondary, and tertiary colors. In the final chapter, we'll consolidate all the properties we've looked at by starting to build a style guide. So throughout this topic, we've looked at a lot of different text properties. I'd like to specifically look at the properties we're using inside our Quill project. For styling, we're using font weight. For spacing, we're using line height and letter spacing. For family, font family. For color, color. And for size, font size. Now for each of these properties, in many cases, we've defined a whole range of values we're using in our project. The problem is we don't have one place where all these properties and values are listed, for easy use as the project expands. Looking back at the Quill project in our app.css file, you can see our values are defined on different elements. But what we do need is a central location which just lists all the properties and values we've defined. For example, we've only set a handful of colors so far. We haven't even used our primary, secondary, or tertiary colors. So eventually, when we do need them, we should have them in a place that's easy to reach and not in some file at the back of a drawer. Now, many companies will have brand guidelines. In the previous chapter, we looked at Duolingo's brand guidelines. Just to show you another example, I have open here Slack's brand guidelines. Slack is a workplace messaging tool. Now, you can see it's very detailed. It's 50 pages long and covers items like brand values, persona, voice and tone, as well as important design elements, like how to use their logo, color guidance, typography, and more. In the web design section of the bootcamp, we'll be developing our own brand guidelines for the Quill project. But for now, what we need is a place just to list all our values and properties. So we're going to add this all at the top of our CSS file. I'm going to come to the top here and make some space. The first thing I'm going to do is add a comment in CSS. Like with HTML, the shortcut for this on a Mac is Command/, and on a PC, Control/. So I'm going to go ahead and hit Command/ on my Mac. And this is the syntax for a CSS comment. It starts with /* and ends with */. Just like an HTML comment, this won't appear anywhere in the browser, and is used internally for documentation and notes to self. I'm going to create a multi-line comment by just hitting enter a couple times. For now, I'm going to be adding two main categories of properties. The first is typography. I like to make main headings look like this. I add a few hyphens, put my heading all in caps, typography, and then end it with the same number of hyphens. The other main category we'll be adding is colors. So let's go through all the properties and values one by one and add them up here. On the right, I've selected slides from the last few chapters where I've listed the property and values we're using. Starting with font sizes, I'm going to add a heading all in caps like this. To keep this concise, I'm going to add all the font sizes on a single line separated by a /. The first value is 12 pixels, then 16 pixels, 20 pixels, 24 pixels, 32 pixels, 40 pixels, 48 pixels, and 62 pixels. The next property are different font weights. We're using 400 and 700. Next up, it's line heights. The values we've defined are 1.2 and 1.5. Next, it's letter spacing, and the values we have are 0 and -2 pixels. I'm putting 0 here as a value because this is just the default value. On an element like a paragraph, we're not adding any letter spacing, so this will just have the default value for letter spacing, which is 0. The final typography value is font family, and in our project we're using Poppins. Alright, moving on to colors. I'm going to now add our primary, secondary, tertiary, and gray colors. Starting with the primary. Our base primary color has a hex code of 339AF0, and we call this sky blue. Our primary tint has a hex code of D0EBFF, and we call this Arctic. And our primary shade has a hex code of 1C7ED6, and we call this Deep Sea. Now, to avoid boring you, I'm just going to go add the base tint and shades for our secondary, tertiary, and gray colors. Alright, you can see that they're in now. So what we've now ended up with is an easy to reach central location which has important properties and values that we can pull from anytime as the project expands. At the moment, we just have typography and colors. And as we move through the CSS section, we will be adding other headings containing more properties and values. You're smashing it. We've now finished CSS Text. It's now time to learn about CSS Selectors. In this topic, we'll cover essential CSS selectors like type, ID, class, and pseudo-classes, along with more advanced concepts such as specificity and inheritance, giving you complete control over how elements are targeted and styled. Let's begin by learning how to style elements directly based on their HTML tag with the Type Selector. We'll be discussing CSS Selectors and the Type Selector. So let's start off by taking a broad look at CSS Selectors. As we know by now, selectors allow us to select HTML elements to apply CSS rules. For example, on this H1, we're applying a font size and color. The H1 is the selector. This is the only type of selector we've seen so far in this course. But there are in fact a range of CSS selectors. There is a large range of CSS selectors that allow us to apply styles from broad styling to specific visual details. I've broken this down into 4 categories. The first are basic selectors. These include element selectors and things like IDs and classes, which we'll be talking about soon. Basic selectors are used a lot. They are the most common type of selector used. Next up, we have Combinator Selectors. This is where the selector is defined by combining 2 different types of selectors. We'll also be looking at this selector later on. Next up are pseudo-class selectors. These type of selectors apply when a different state or condition is met. For example, hovering over an anchor tag. They're really important and we will be discussing them soon. The last type of selector is a pseudo-element selector. These selectors can target a specific part of an element. As you can see, there's a wide range of different selectors, and we'll be going through each of them in great detail in this topic. Let's look at the most basic type of selector, the Type Selector, otherwise known as the Element Selector. The Type Selector selects elements based on their tag name. It's the selector we've been using so far. We target a specific HTML element like an H1. This is called the Type Selector. Let's now take a look at some Type Selector guidance. The Type Selector is useful for setting global styles to ensure consistency. The word global just means applies everywhere. For example, these are 2 different pages from the same web application. If we look at the main heading on the left here, this is an H1, and it's styled a specific way. If we look on the right, this H1 is also styled the exact same way. So the CSS styling is defined on the H1 using the Type Selector. We can see the same thing for the paragraph text. That has specific styling like color and line height. And the paragraph on the right also has these exact same styles. Finally, the button over here, which is an anchor tag, has specific styling, like a navy blue background color and rounded corners. And the button on the other page also has these same rules applied to it. So you can see that the type selector is particularly useful for setting global styles on elements which can be used throughout the project. Jumping into our Quill application, on the app.css file, we've in fact already done this. For example, the styling on our H3, which is used in several places on the homepage, is defined once, using the type selector. We've given it specific values for font weight, line height, letter spacing, etc. And if we check out this element in the browser, we'll see that it has consistent styling. The H3 is used down here for our different features. We have an H3 over here and an H3 over here. And you can see the styling is consistent because it's defined once on the H3 using the type selector. We can see the same thing for our paragraph. All the paragraphs on the homepage all look the same, with the same font weight, line height, color, etc. So the type selector is really useful for defining global styles on different HTML elements. And just remember, when we start adding more pages to the application, the same styles applied on our type selector will also apply on those new pages. So let's wrap up and start building the next summary card, basic selectors and the cascade. We looked at the type selector. The type selector selected an HTML element, like an H1. This is an example of the type selector. And in the guidance, we saw it was used for setting global styles. Next, we'll explore how CSS rules are applied and prioritized as a concept known as the cascade. We'll be discussing style priority and style sheet priority. So what is the cascade? The word cascade means flows from one stage to the next. When I grew up in Australia, I'd often go bushwalking, and there'd be a river system called a cascade, where pools of water would flow from one to the other. In the context of CSS, the cascade is about how styles declared later will take priority. Let's have a look at an example. In this piece of code, we're selecting the H1 twice. In the first declaration block, we're giving the H1 a color of blue, and in the second one, we're giving the H1 a color of green. This is what is known as conflicting selectors. Because of the cascade, the later style will take priority. So in this case, green overrides blue, and the H1 will appear as green on the web page. Let's take a look at this inside VS Code. I'm on the app.css file for our Quill project. In this declaration block, I've defined styles for my H1. I'm going to go and select the H1 again, and let's go add the same properties but with different values now. I'll give it a font size of 100 pixels, which is significantly larger than 62. And I'm going to give it the color of red, which is very different to the gray shade we defined here. So let's check this out in the browser. So look what's happened. Our H1 now is the color red with a font size of 100 pixels. These styles are overriding the styles here, specifically the color and the font size. All the other properties are still retained from the first declaration block. For example, the font weight is still 700, the letter spacing is still -2 pixels, etc. So the idea of the cascade is really important. You need to appreciate that a style sheet is kind of dynamic, where styles targeting the same element that are applied later will override those that are applied earlier. Now at this stage, it may not seem so obvious why we'd declare a second H1. It would make more sense just to define all your styles inside your first H1. Now doing this isn't so typical, but we're going to see soon how we can take advantage of the cascade to write more efficient CSS. Now, not only do styles declared later take priority, but also style sheets declared later will take priority. For example, let's say we had an index.html file, and we have these two style sheets, app.css and app2.css. In app.css, we have the CSS rule h1 has a font size of 12 pixels, and in app2.css, we have an h1 with a font size of 52 pixels. So because app2.css is declared after app.css, the font size 52 pixels overrides 12 pixels from the previous style sheet. Let's look at this in action inside VS Code. Okay, I'm first just going to remove this H1. We don't need it anymore. I'm then going to go add a new tab. On my Mac, I'm hitting Command N. I'll select a language, CSS, and I'll straight away save this inside our Quill directory as app2.css. I'm now going to head over to index.html and add this style sheet after our first one. I'll grab the link tag and set the href value to app2.css. So as you can see, our app2.css is defined after our app.css. So whatever styles we define in this style sheet that conflict with the first style sheet will override them. This time, let's target the H2 element. We'll give it a color of green, a font size of 10 pixels, so significantly smaller, and let's also give it a letter spacing of 4 pixels. Alright, let's check this out in the browser. So you can see our H2 down here. It's now green, has a much smaller font size, and the letters are more spread out. And as we've discussed, this is occurring because the styles in our second style sheet are overriding the first style sheet. And again, just to reiterate, the order here is really important. Because our app2.css is a later style sheet, styles declared here will take priority. I'm just going to go remove this file and delete it, and remove the link tag, because we don't need it moving forward. Now again, you may be thinking, when am I going to need a second style sheet? Why wouldn't I just define everything in my first style sheet? As we move through this CSS topic, the need for a second style sheet will become apparent, as we're going to start to compartmentalize our different styles, such as global styles, component styles, and then also styles for different screen sizes. So appreciating the fact that later style sheets take priority is going to be important. So let's finish off by adding to our summary card, basic selectors and the cascade. We looked at the cascade. We saw that when we have the same selector, both targeting the same property, is known as conflicting styles. And conflicting styles declared later take priority. So in this case, the color green will be applied to the H1. We also saw what happened when we had two different style sheets, which both have the same selector. We have app.css, targeting an H1 of a font size of 12 pixels, and app2.css, which targets an H1 to have a font size of 52 pixels. In this case, we saw that style sheets defined later take priority. So in this case, the font size of the H1 will be 52 pixels, because conflicting styles in later style sheets take priority. Now we'll see how to apply styles to multiple elements at once by grouping selectors. We'll be discussing grouping shared styles, and grouping selectors and cascading. So what is grouping selectors about? Selectors can be comma-separated to apply shared styles. For example, let's say we had an H1 with the color blue and an H2 with the color blue. We can rewrite this CSS more efficiently like this. We grab the H1 selector and the H2 selector, and we comma-separate them. And then we just define our rule once. This method avoids us repeating shared styles and makes our CSS code more concise. So let's jump into VS Code and see how this works. So I've gone ahead and set up a new directory called grouping. Inside it, I have an index.html file where I've grabbed the boilerplate and added 3 headings, an H1, H2, and H3. I've then linked a style sheet called app.css, which is currently empty. So let's go and grab the H1. We'll give it a color of blue, a font weight of 700, letter spacing of -2 pixels, and font size of 40 pixels. I'm then just going to copy this, change the H1 to an H2, copy it again, and change the H2 to an H3. So we're effectively applying the same 4 rules to the H1, H2, and H3 separately. Let's check this out in the browser. Alright, so as you'd expect, these same rules have been applied to our H1, H2, and H3. As we saw before, we can more efficiently write this as H1, H2, H3, and remove these styles. And refresh the browser, and you'll see there's been no change. So these rules defined once are applying to these 3 different selectors. Now, for most projects you work on, there'll be some styles and are applied to all headings, like font weight and letter spacing. But other styles, like font size, will vary between headings. So how do we deal with that? We want to be able to define shared styles, but we also want to be able to define unique styles for elements that are grouped together. To do this, we're going to be using grouping selectors and cascading. We can use the CSS Cascade to add new rules to previous rules. For example, the H1 and H2 here have the same color. The declaration is repeated, but the font size are unique. The H1 has a font size of 62 pixels, and the H2 has a font size of 48 pixels, where we have some shared styles and some unique styles. So this is how we handle it. We group together the shared styles. So here we have H1, H2 with the shared color property. And as a result, the property is defined once. We then add in the unique styling. So first, the H1, which has a font size of 62 pixels. And because of the nature of the cascade, this gray color is added to the H1. And we can do the same thing for the H2. We define the unique value for the font size. And again, because of the nature of the cascade, the gray color is effectively added to this H2. So we're using the cascade to our advantage here. We're adding new rules to previous rules. So the combination of grouping selectors and effectively using the cascade helps us write much cleaner and concise CSS. So let's jump back into VS Code and check this out in action. Alright, so I'm back in the app.css file we were working on before. In most projects, the heading font size is different. So let's remove that from our group styles. We'll add an H1. Let's give it a font size of 50 pixels. We'll add an H2. We'll give that a font size of 40 pixels. And finally the H3, which will give a font size of 30 pixels. I'll save the file and refresh the browser. So now you can see that these shared styles are being applied to our heading 1, 2, and 3, and we're using the cascade to handle the unique nature of the font size for each heading. This technique is very common and very effective for writing cleaner and simpler CSS.
Let's finish off this chapter by adding to our summary card basic selectors and the cascade.
We looked at grouping selectors. We saw that selectors are grouped when there's shared styles, like color for this H1 and H2. We would then add custom styling to our type selectors, like a font size for the H1, where we'd be using the cascade to add new styles to previous ones.
So let's go and add grouping selectors to our Quill project.
I'm inside our app.css of our Quill project. And the first thing I'm going to do is group our headings at the top here as they have a lot of shared styles. I'm then going to go grab all the shared styles between all the headings. Font weight's one of them. Line height. Letter spacing. Font family. And color. I'm now going to go delete these shared styles from each heading. So I can remove the font weight, the line height, letter spacing, font family, and color. And what I'm left with is the unique styling rules for the H1. And again, the way this works is we're using the cascade to our advantage, where the H1 will initially have all these styles, and then as we move down the sheet, these styles are added. Now to avoid boring you, I'm just going to go ahead and remove all the shared styles from all the headings. Alright, so let's see what we're left with. We're left with all our shared styles here, and then only a few rules defined on each heading. So all the repetitive properties have been removed, leaving us with much more concise and clean CSS code. I'm going to do the same thing for our paragraph and anchor tags, because there are a few shared styles there as well. The font weight is the same, the line height is the same, the font family is the same, and the color is also the same. So in the paragraph, I can remove those shared styles, and I'm just left with the font size of 20 pixels. In the anchor tag, I'm going to remove the font weight. We're going to keep text decoration because that is unique to the anchor tag. The line height I'll remove because that's shared. Font size is unique to the anchor tag, and these two properties are shared, so I can remove those. So once again, we've cleaned up our code. We have removed repeated styles, and our CSS code is more concise and clean. Now, something you may be wondering is that even within our group selectors for paragraph and anchor tags, and all our headings, there are still shared styles here. For example, the font family is the same in our headings and our paragraph and anchor tags. Essentially, we want to apply the font family to every element.
And soon we will see how we can achieve that,
making our CSS code even more concise.
Moving on, we'll learn how to target specific elements more precisely using ID and class selectors.
We'll be discussing limitations with the Type Selector, the ID Selector, and the Class Selector. So first up, let's discuss some limitations with Type Selectors. Sometimes we want to apply specific styles to a single element. For example, let's look at this homepage. You can see the paragraph text here is in white. And in this design, white paragraph text is only used on the hero section. Looking at a section of the page lower down, you can see over here that grey paragraph text is used everywhere else. So simply styling a paragraph grey wouldn't work. We need a method to style a specific element. And to do that, we use the ID selector. The ID selector selects an element based on a unique ID attribute and can only be used once. We've actually met the ID selector already. Back in the HTML section, we learnt about a method called anchor linking, where we put an ID selector on a specific element, and we then reference that in a hyperlink, so that when you click the hyperlink, you are taken to that section of the page. Let's now look at an example using the ID attribute in CSS. Let's say we have an index.html page, and we have this body with this paragraph text. You can see here the ID attribute. It has the value red-text. In the app.css file, we would have styles like this, where the color of all paragraphs is grey, but the paragraph with the ID value red text is set to red. The ID selector has this hash symbol in front of the value of the ID attribute in the HTML. So all we do is add an ID attribute to the element we want to target in our HTML, and then reference that value in CSS with the hash symbol followed by the value. Let's play around with this in VS Code. I'm back inside the index.html file for the Quill project we've been working on. I'm going to scroll down to the hero section, and let's go target this paragraph over here. We'll add an ID attribute, and let's make it green, so I'm going to give it the value of green text. Over in app.css, I'm just going to scroll down to the bottom. I'll grab the hash symbol. I'll then reference the ID attribute value, which is green text. Grab our curly brackets, and let's give it the color of green. Let's check this out in the browser. So you can see now that this paragraph is green, whereas all the other paragraphs still remain the grey color. By using the ID attribute, we're only targeting this paragraph here in the hero section. Let's now continue our discussion with limitations of the type selector. Sometimes we want to apply specific styles to multiple elements. So the ID selector can't help us here,
because the ID selector can only be used once on an element.
For example, looking at this page here, you can see that there's grey text on the feature section. Scrolling down on the page, we can see here there's also grey text on the testimonial section. However, in other feature sections, we can see here that white text is used on the feature section. And on this section of the page, we have white text on the hero section. So in multiple places we have grey text, and in multiple places we have white text. So to help with this, we have the class selector. The class selector selects one or more elements based on a class attribute that can be used multiple times. Let's look at an example of this. Looking at the same index.html file we saw before, over here you can see I have the class attribute. I've given it the value blue-text, and I've used it twice. This is what makes the class attribute different to the ID attribute. It can be used multiple times. Having a look now at the app.css file, we select the class attribute with a full stop, or a period. And just like the ID attribute, we then provide the value that was used for the class attribute in our HTML, in this case blue-text. Let's have a play around with this in VS Code. I'm back in the index.html file, and I'm now going to select an element that I want to apply the style to in multiple places. Let's go do it on this h3 that we're using 3 times inside our features section. I'll add a class by typing class and hitting enter, and let's make this text orange, so we'll call it orange-text. I'm then going to copy the class and just paste it in this h3 and this h3. In app.css, to use the class selector, we type full stop or period, and use the value of the class attribute, which we called orange-text. I'll grab our curly brackets, type color, and give it the value of orange. So let's check this out in the browser. So you can now see that our 3 h3s are all orange. We've targeted multiple elements and applied the same style, using the class selector, whereas the ID selector only selected one element. So let's now discuss some selector guidance. Classes are often preferred over IDs because they offer greater flexibility and reusability. Let's have a look at an example. Let's say we had this index.html file, and we had this app.css file, targeting all paragraphs as grey, and then having a class called redText, which makes the text red. Initially in the project, we may just start with one. However, as the project grows, later on we can add another class of redText. So we can easily add styles as the project scales. So because classes can be applied once or multiple times, they offer a lot more flexibility. Let's now look at the next piece of guidance. It is common to use type selectors for global styles and class selectors for more specific visual styles. Taking a look at this page here, this heading would be styled using the type selector. It's a global style, meaning that all H1s throughout the application would be white, with this font size, etc. Whereas for more specific styles, we would use a class selector. For example, this gradient text here could be using the class gradient. So type selectors are useful for global styles, which are used throughout the application, whereas class selectors are useful for styling specific elements or components. So let's jump into Visual Code and check this out. So we've in fact already done this earlier. I created this class called orange-text, and I applied this to the heading 3s on the page. This orange text is essentially overriding the default text applied to all headings, which we can see up here. But we have our grouped headings with this grey color being applied. So this style sets the default base color of all our headings. And then we can create a class like this called orange text and apply it to specific text elements we want to style. In this case, we added it to the h3 elements. And like in the example we saw just before, we could also style just a portion of text. So let's make a class called popText. Let's give it a color of red. Let's give it a font weight of 900. And let's add some text decoration of red, solid, and underline. Let's apply this popText to the word simplicity over here. I'll head to index.html. To do this, I need to add a span. I'll cut the word simplicity, pop it inside the span, and give this the class popText. Let's refresh the browser. And you can see, once again, this class popText is overriding the default text styling applied to our paragraphs, which we can see over here. We're adding a much thicker font weight of 900 versus 400. The color is being overridden to red, and we're also adding an underline. Now this next piece of guidance is a little bit more tricky, but we will go through it step by step, so just stick with me. Classes for components are designed to be combined on a single HTML element for a more modular approach to styling. Alright, so what does this all mean? First of all, the word components. This is something we're going to be using a lot throughout this course. A component is a piece of reusable UI, or user interface. It's a piece of UI we continue to use throughout the application. So let's take a look at an example of a classic piece of UI. Buttons. Buttons are used throughout the application, on the home page, login page, and within the application itself. Buttons are an example of a component or a piece of reusable UI that is used throughout the application. Now, as you can see here, we actually have 2 different kinds of buttons. We have this green button, which would likely be a primary button, and this white button, which would likely be a secondary button. The colors are different, but the core structure of the button is the same. It has the same rounding. It has the same font size. There's a lot of structural properties here that are the same. So let's now look at the best approach to creating this component in CSS with class selectors. We'd first define a class like this, which sets the button structure. Now, don't worry at all about any of the properties here. The only ones we've covered so far are text decoration and font size. Border radius, padding, and display are properties we're going to look at in the next topic. Just know you need them to create the structure of the button. We would then add this button class to our anchor tag by using the HTML attribute class and giving it the value button btn. This would create the structure of our button. What we would then do is make a new class called button-primary. You can see it has this blue background color and white text. So the aim of this class is it sets a particular button style rule. We would then add this class in addition to the previous class to our anchor tag. So the styles are combined and our class attribute is button btn and button primary. This would then give us our blue button with white text. And again, the structure of the button is from the btn class, whereas the specific styling of the background color and white text is from our btn-primary class. So this all seems a bit confusing just to give us a button. So let's now look at why this method is so powerful. Let's say in our application, like our quill application, we have a purple button. What we would then do is define a second class, which I'm calling button-secondary. I'm giving it a purple background color and the font color of white. For a hyperlink I want to be a purple button, I would then use this button secondary class. So I'm still referencing the button class to get the structure, but now I'm using the button secondary class to apply the specific styling I want of purple and white. And this would give me a button that looks like this. This method of combining styles like this is incredibly common, and it gives us a modular approach to styling, where we define the structure in one class and then specific styling rules in other classes that we simply add on inside the class attribute.
What we've just seen here is what we'll be implementing in our Quill project.
This is in fact the approach many CSS frameworks like Bootstrap take. A lot of coding bootcamps will teach Bootstrap, but I specifically don't because I find it a bit of a cop-out, and I much prefer you to get a solid understanding of CSS. I'm going to be talking about CSS frameworks like Bootstrap towards the end of the CSS module, but I just wanted to show you that this is exactly how these frameworks do it. If I head over to Docs and scroll down to Components and go to Buttons, you can see that there's this base class, btn, and you can get all these different variants, which are simply added to the base class. For example, button primary, button secondary, etc. The reason I'm not teaching Bootstrap is because we in fact are going to be building our own mini Bootstrap. We're going to be writing our CSS using this modular approach. Don't worry about Bootstrap right now, I just wanted to show you that this method of combining classes like this is incredibly popular and is foundational to a lot of CSS frameworks. Long story short, I'm teaching you CSS properly and not distracting you with these frameworks, which are helpful, but only once you understand the foundations of CSS.
So let's wrap up by finishing the summary card, basic selectors, and the cascade.
We looked at ID and class selectors. Inside the HTML, we can add the ID attribute, like ID red text, and the class attribute, like blue text. In CSS, we select the ID selector, like this, where we use the hash symbol followed by the same ID text used in the HTML attribute. And this would apply the color red to the text copper mug. And we saw that the ID attribute can only be used once. For the class selector, it looks like this, where we use a full stop or period followed by the value that's used in the HTML attribute. In this case, on the text biodiesel tattooed and coloring book. We saw that the class selector can be used multiple times. And because of this, it's more commonly used, as it allows our project to scale when we want to apply the same style across different HTML elements in the project.
So let's go ahead and apply some of the class guidance we just covered earlier.
So I'm starting off in our app.css file. I'm then going to create a new class with a full stop or period and call it small-text. I want to give it a font size of 12 pixels. Now the small text also has the same properties as the paragraph and anchor tag. A font weight of 400, line height of 1.5, Poppins family, and this grey color. So I'm just going to go group it up here as well. I'm going to type comma, and then add the class small text. So in summary, I've created a small text class, which has a font size of 12 pixels, and also shares the same styles with our paragraph and anchor tags. I now want to go add this class inside our HTML. I'll pop our CSS on the right here, so we can see the HTML on the left. I'm going to scroll down to the button, and inside this paragraph here, I'm going to add the class small text. So this text, made with love in London, will now be 12 pixels. So let's check this out in the browser. So if I scroll down to the bottom of the page, you can see this text, made with love in London, is now a lot smaller. It's 12 pixels. Let's start creating our button components. I'm going to create a new class called btn. And like we saw earlier, this will be the structure of the button. There's only so much we can do for now, as we need to learn a little bit more about the box model in the next topic to fully flesh out this button. But let's start adding the text properties we can. We'll give it a font weight of 400. The font family will be Poppins, with a backup of sans serif. We'll give it a font size of 16 pixels. And because this is used on an anchor tag, we're going to give it text decoration none. Let's now add the styles for the primary and secondary button. I'm going to define a new class, btn-primary, and we're going to give it our primary color, which I can easily grab from up the top here, the sky blue base primary color. We'll create the button secondary, btn-secondary, grab our curly brackets, grab the color property, and grab the base secondary color, which we called lavender. Now in the actual design, the font color is actually white, and the background color are these colors. We will update that a bit later, when we talk more about the CSS box model in the next topic. But for now this is good, because we've set up a good modular structure using classes. So next up, let's go and apply these classes inside our HTML.
So I need to apply the primary button in a few locations. The first is in the register anchor tag. So I'll grab class, I'll type btn to grab the button structure, and then btn primary to grab the specific styling for the primary button. This same primary button is also used on the get started anchor link in the hero section. So I'll copy this class and paste it over here. We're then going to apply our secondary button in the call to action section on this hyperlink over here. So again, I'll grab the class attribute, I'll type btn to get the button structure, and then for the secondary button, to apply that style, we type btn-secondary. So let's check this out in the browser. So you can see nothing crazy has happened. All we have so far is the register and get started hyperlink in blue, and at the bottom of the page, in the call to action section, the get started hyperlink over here has purple text. We'll be adding in different styling to our button structure, like padding, etc., to make these hyperlinks look a lot more like buttons.
Now, you may be wondering, why didn't I just get rid of this anchor tag? If I'm going to be applying the btn style to all our buttons, what's the point of still having this? Well, at the bottom of the page, we have these links here, home, login, and register. And these aren't styled like buttons. They're just navigation text, so we still need to keep this anchor style for navigation items like this. Whereas all the other anchor tags on our homepage, like get started here, learn more and get started, and login and register, will be styled like buttons. So we'll be using these styles here. But at the end of the day, we are still applying them to an anchor tag, which is why we need properties like text decoration none, and font size 16 pixels, which we decided in our style guide would be applied to anchor tags. So in a nutshell, these classes are styling anchor tags, which will look like buttons, and this type element is also styling an anchor tag.
Now in theory, all these styles are actually defined in our CSS, because at the end of the day, the button class is being applied to an anchor tag. If we look at our anchor tag styling, we have text decoration none, font size 16 pixels, font size 16 pixels, and then up the top in our group selectors for our anchor tag, font weight 400, and font family Poppins and sans serif, which are these two over here. So at the moment, this class isn't actually doing anything new. However, for a component like a button, it is good practice to explicitly define these properties so you have easy reference in your CSS. And secondly, in the box model topic, we will be adding new properties in here which don't currently exist in the CSS. So we definitely do need this btn structural class. But I did just want to highlight that currently it is actually doing nothing new, because all of these properties are already defined on our anchor tag over here and over here. All we're doing is using a class, btn, to override the default anchor tag styling. But it's just a bit funny at the moment because we're overriding it with its existing styles. But as I mentioned, we will be adding new styles in the box model topic.
Next up, we'll dive into styling elements based on their state by using pseudo-classes.
We'll be discussing what are pseudo-classes, state pseudo-classes, and conditional pseudo-classes.
So what are pseudo-classes? Pseudo-classes define styles for a specific state or condition of an HTML element. So what do we mean by state or condition? Let's look at state first. An example of a state of an HTML element would be something like a button. At the moment, the button is green, but if I were to hover over this button, it turns purple. This is an example of state, where we can define styles for different states. Like we saw the button was green when our cursor was not hovering over it, whereas it turned purple when we did hover over it. Let's now look at condition. This would be something like in a table. We could style every odd row to be purple, like rows 1 and 3 here, and every even row to be white, like rows 2 and 4 here. We're using a condition of odd and even numbers to style the table. So let's now have a look at how we write pseudo-classes in CSS. A pseudo-class is a keyword with a colon added to the end of a selector. Let's have a look at an example of an anchor tag. We're using the Type Selector here to select all anchor tags. We then add a colon and add the specific pseudo-class name, in this case hover. This combination of colon and pseudo-class name gives us a pseudo-class. So let's first take a look at the state pseudo-classes. These pseudo-classes are very important. So state pseudo-classes are about dynamic styling based on user interaction and commonly used for hyperlinks. Now I know the term pseudo-class can seem intimidating, but honestly, the most common use case for them is for hyperlinks, and we're going to be spending some time on it now. So don't freak out, just stick with me. There are 4 different pseudo-classes we can apply to our hyperlinks. The first is the link pseudo-class. This targets anchor tags that have not yet been visited. So in other words, it's simply an anchor tag you haven't clicked yet. The next pseudo-class is the visited pseudo-class. This targets anchor tags that have been visited. You've probably had an experience with this already, where oftentimes a link you've previously clicked on that you revisit will now be purple. This happens in Google searches all the time. So the visited pseudo-class will target anchor tags that you have visited, and the link pseudo-class targets anchor tags that haven't yet been clicked. Now these 2 pseudo-classes are specific to anchor tags. You can't use them anywhere else. The next pseudo-class is the hover pseudo-class. This targets an element when the cursor is placed over it. It's like what we saw in the start, how the button turned from green to purple. That would be using a hover pseudo-class. The last pseudo-class is the active pseudo-class. This targets an element when it is being clicked. So this pseudo-class is specifically targeting when the element is actually being clicked. Oftentimes, you won't even notice the active pseudo-class, because clicking an element might only last a few milliseconds. These 2 pseudo-classes are not specific to anchor tags. You can use them on other elements. So let's go play around with these in VS Code. So in VS Code, I've created a new folder called pseudo-class. I've added an index.html with the HTML boilerplate, and I've linked a style sheet called app.css. In the index.html, let's go add an anchor tag. We'll give it the anchor text, click here. And for the href attribute, I'm just going to point it to Google's homepage. Jumping into the app.css file, we're going to style the anchor tag with those 4 different pseudo-classes. Let's first do the link pseudo-class.
This pseudo class was about when the anchor tag had not yet been visited. Let's give this a color of blue. Next up, we'll do the visited pseudo class. This styles the anchor tag once it has been visited. Let's give it a color of red. The next pseudo class was the hover pseudo class. This will style the anchor tag when the cursor is placed over it. Let's give it a color of green. And the final pseudo class was the active pseudo class, and this targets the element when it is being clicked. Let's give this a color of yellow. Alright, let's go play around with this in the browser. Alright, I'm on the index.html file and I've zoomed in quite a bit, just so we can see what's going on. You can see straight away the hyperlink is blue. That's this style here. It's an anchor tag we have not yet clicked. If I now hover over it, you can see it turns green, and that's the hover pseudo class coming into play. I'm now going to click on it, but I'm not going to let go of my mouse, because I want you to see the active pseudo class in play. So right now I'm holding my mouse down, but I'm not letting go. And you can see the active pseudo class, yellow, is coming into play. I'm now going to let go, so it clicks the link. Okay, so we've now clicked the link. Let's head back to the page. So now you can see the link is no longer blue, it's red. And that's because I've clicked the link. So this pseudo class is coming into play, visited. So let's now look at some state pseudo class guidance. It is best practice to style the pseudo classes of anchor tags instead of styling the anchor element directly. So let's have a look at what I mean by first looking at what is considered bad practice. Bad practice is simply using the type selector to select the anchor tag and apply styles directly. This is considered bad practice because we're not styling the different states the anchor tags can be. On the other hand, good practice is styling all the different pseudo classes for the anchor tag. This approach covers all states. So our CSS would look something like this. We'd first style the linked and visited pseudo class, for example, with the color blue. And you'll note these are actually grouped together, which is very common. It's because it isn't that common to separately style your visited pseudo class. You usually want it to adopt the same styling as just the regular link. So that's why we group these together. We then add styling rules for the hover and active pseudo classes. For example, we'll give it the color dark blue. And again, you'll notice these are grouped. And that's because we often don't really care about the subtlety of the active state, because in practice, you only see it for a few milliseconds when you click the link. So we just want to style it the same as the hover state, and that's why we group them together. This structure of styling the link and visited pseudo classes together and the hover and active pseudo classes together is incredibly common. And we take this same approach when styling a button class. For example, this would be considered bad practice, just styling the button, whereas this would be considered good practice, styling the button class pseudo class of link, visited, hover, and active. Now that can seem like a bit of a mouthful. We're targeting the pseudo class of a class, but it is common and don't let it intimidate you. At the end of the day, our BTN class is targeting an anchor tag. So don't let the pseudo class on a class thing throw you off. We're just targeting an anchor tag with the class name BTN.
We will be implementing this approach to pseudo classes on our buttons in the Quill project. So stick with me and we'll soon see this in practice.
Let's have a quick look at conditional pseudo classes. Conditional pseudo classes are generally less important. I'm not really going to be using them at all in the bootcamp, but I just want to show you that they exist and how they work. Conditional pseudo classes are styling based on an element's position in relation to other elements. For example, we could have the pseudo class firstChild, which targets the first child element in a list. We have the lastChild pseudo class, which targets the last child element. And there's also the nth child pseudo class, which targets child elements based on their position. In this case, every nth child. Now, some common places you may see conditional pseudo classes include on lists, like I've done here, or in tables, where you'd be targeting the TR element, the table row. For example, to get alternating colors for table rows, which helps with table readability. Let's jump into VS Code and play around with these conditional pseudo classes. I'm back in the pseudo class folder over here, and I've cleared out the index.html file and our app.css file from when we were playing around with state pseudo classes.
In index.html, I'm going to go add an unordered list. I'm going to create 6 list items by typing li times 6. And I'm just going to give each list item a number. 1, 2, 3, 4, 5, and 6. Jumping over to our app.css file, let's grab a list item and select the first child pseudo class. And let's make it the color red. So this will style our first list item red. Let's then grab the list element again and add the last child pseudo class. Let's give this a color of blue. Let's check this out in the browser. Okay, I'm just going to zoom in a bit so we can see this more clearly. You can see that our first list item is now red and our last list item is blue. So if I now were to go add another list item, let's say the number 7, you'll see that the blue color is now applied to 7. It's always targeting the last child of the list. And the same thing here, if I go add the number 0 and refresh, you'll see that the first child is always targeting the first list item, which is now 0. I'm going to remove these styles. Let's now play around with the nth child pseudo class. The way this works is we need to specify something inside these brackets. For now, I'm just going to pick the number 3, and this will simply target the third element. Let's go and give that a color of green, and I'll refresh the browser, and you'll see the third list item, which is now number 2, is green. But we can use this as a bit of a formula, where, for example, I can put 2n, which will target every second list item as green. So if I refresh, you'll see 1, 3, 5, and 7, which is every second list item is now green. In other words, I'm targeting even list items. I can target odd elements by simply adding a +1 here, so that when n is 0, 2 times 0 is 0 plus 1, so the first item will be green. When n is 1, 2 times 1 is 2, plus 1 is 3, so every third item will be green. When n is 2, 2 times 2 is 4, plus 1 is 5, so every fifth item will be green, etc. So if I refresh,
So you'll now see that every odd list item,
starting here, is styled green. And not that you'd ever need to do this, but you can start making up your own linear equations in here. For example, I could do 3n plus 2. So if I refresh, when n is 0, we get 3 times 0 plus 2, so the second list item is styled. When n is 1, 3 times 1 is 3, plus 2 is 5, so the fifth list item is green. Anyways, I just wanted to show you these conditional pseudo classes. Don't let them freak you out. We're not really going to be using them at all. The state pseudo classes on our anchor tags are way more important. So let's finish off by starting to build the next summary card, pseudo classes and specificity.
we looked at pseudo-classes. A pseudo-class works by having a selector, like the anchor tag, and following it with a colon and a pseudo-class name, like hover. This gives us a pseudo-class. We saw that there were two different types of pseudo-classes. There was a state pseudo-class, which is very important, and this is where styling is based on user interaction. And we saw a common use case was targeting anchor tags, like buttons, where we would often group the link and visited pseudo-classes, as well as group the hover and active pseudo-classes. We then also looked at conditional pseudo-classes, and these were less important, as we don't use them as often as state pseudo-classes. Conditional pseudo-classes is when styling is based on an element's relative position. And we saw an example of an nth child pseudo-class, and can be used to target every odd or even list row.
So let's go and add pseudo-classes to our Quill project. Now, the first thing we need to talk about is where exactly are we going to add these pseudo-classes? We actually don't need to add the pseudo-classes onto this button class here. And that's because it's setting up the overall structure of the button. We only really care about the state changes of the button, like when you're hovering or when it's visited, for the actual specific button styles. So button primary and button secondary. So let's do the first group of pseudo-classes. We'll do button primary and add the pseudo-class link, which again targets anchor tags that have not yet been visited. And we're going to be grouping that with button primary and the pseudo-class visited, which, as a reminder, targets anchor tags that have been visited. We'll grab our curly bracket and we'll just give this the same color as before. And I'm now going to get rid of this style here, as we don't need it anymore, as we're now implementing better practice, targeting all 4 states of our button. We'll then add the next group of pseudo-classes. So we'll grab our class, btn-primary, and the pseudo-class hover, which as a reminder, targets the anchor tag when the cursor is hovering over it. And we'll group this with button primary and the active pseudo-class, which as a reminder, targets an element when it is being clicked. We'll grab our curly brackets, and let's now add a darker color of this blue. We'll scroll up to the UI guide we created at the top. And let's add our primary shade, this deep sea color here. And we'll go ahead and implement this exact same method for our secondary button. We'll grab our secondary button, add the link pseudo-class, grab the secondary button and add the visited pseudo-class, grab curly brackets, and we'll use the same color here. We'll then get rid of this as we no longer need it. We'll then add the other group of pseudo-classes. We'll grab button secondary, add the hover pseudo-class, get button secondary again, and grab the active pseudo-class. For the color here, let's go grab a shade of this purple. Scrolling up to the top, this purple is lavender, it's our secondary base color. For the shade, we called it Velvet Night. And it has this hex code here, so I'll simply copy that and paste it here as the color value. So let's now check this out in the browser. So our get started anchor tag here has the btn primary style applied to it. Just as a reminder, if I head to index.html, you can see here, this anchor tag has the class btn and btn primary. So with our pseudo classes, we've now targeted this primary button and considered all the different states. At the moment, the get started button is this blue here, because it's a link which hasn't yet been clicked. If I hover over it, you'll notice that it goes a darker blue. And that's this pseudo class coming into play. The hover pseudo class is making it this slightly darker blue. I'm now going to click on it but hold my mouse to show you the active pseudo class. I am holding my mouse and you won't actually notice a change in color, and that's because the hover pseudo class is grouped together with our active pseudo class. It's the same darker blue. I'm now going to let go of my mouse so that the anchor tag is clicked, which takes me to the register page. I'm just going to head back, and the get started hyperlink is still our primary base blue. That is this blue over here. It hasn't changed color because the visited pseudo class is the same as the link pseudo class. And the exact same thing would happen down here on this get started button here. As a reminder, we've added the btn secondary class there. Looking in the index.html, scrolling down to the CTA section, you can see btn and btn secondary. So the exact same thing is going to happen now. The hyperlink text is our base purple, whether it's been visited or not. And when I hover and click, it's going to go to that darker shade of purple, which you can see now. Now, just to clarify again, why we're adding our pseudo classes over here and not to the btn class over here, is that because the state changes that we're going to be coding are only happening on our primary and secondary. There are no changes in state to any of these properties. It's not like when I hover over the button, I'm changing the font or changing the font size. These properties are static. They remain constant no matter what the state is. However, for the specific styling like primary and secondary buttons, we do want to consider state. We want to make our buttons one color in this state and another color in this state. And in the CSS Box Model topic coming up soon, we're going to be adding even more properties in here. Things like background color, which will really make these two groups of pseudo classes even more prominent. Now, one last thing I want to show you before we finish up is I could take a similar approach with this anchor tag here. I could add in pseudo classes just like we did for the link and visited state, as well as the hover and active state. Those styles would be visible down here in this mini navigation bar in our footer. So for example, we could style the anchor tag that when I hover on it, it goes a little bit darker. Now, I'm not going to do that because I want to keep this a bit simpler for now. That style really is not critical for the visual aesthetic of this web page. But for buttons, it is. You always want to be using pseudo classes on your buttons like I've done here. Let's continue by exploring to select elements based on their relationship with other elements using Combinator Selectors.
We'll be talking about the descendant selector, the direct descendant selector, the adjacent sibling selector, and the general sibling selector. So what are Combinator Selectors? Combinator Selectors combines two or more selectors to target elements based on their position relative to each other. Now, I do want to give a bit of a heads up at this point. The Combinator Selectors we're going to look at are just not that commonly used in CSS.
This chapter may seem overwhelming going through each of these selectors,
but I honestly wouldn't worry about it too much. It's something you just need to know about and probably aren't going to be using them that much in practice. There's four main types of Combinator Selectors. The first is called the descendant or child selector and looks like this. And this selector I do sometimes use. It's definitely the more commonly used one compared to the others we'll look at. The next Combinator Selector is the direct descendant or child selector and looks like this. The next one is the adjacent sibling selector, which looks like this. And the last one is the general sibling selector, which looks like this. Now, these three I don't really use, and they're not overly common. So as you can see, each of these selectors is combining two selectors, and we're going to go through each one now to see how they work. We'll start off with the descendant selector. This targets all children elements of a parent. We have a selector, then a space, followed by another selector. In this case, div space p. Let's have a look at a snippet of HTML to see how this works. This HTML is a short article of my favorite Will Smith movies. We've got a containing div element with the class of article, and inside the div we have an h1, 2 paragraphs, and then another div which contains an unordered list and a paragraph. So let's look at a CSS rule and see the descendant selector in action. This first class, article, we would call the parent, and the paragraph type selector is the child. So inside our HTML, the class article is on this div, which is the parent, and the paragraph here and here are what we call direct children. They're direct children of the parent. We also have a paragraph down the bottom here inside the nested div. This would be considered a grandchild. Now the descendant selector targets all children element of the parent. So all three paragraphs here would be blue. Now just a small note, we can use any type of selectors. In the example I showed you, we used a class selector, which was the parent, followed by a type selector, which was the child. But we can use any selectors. For example, we could achieve the same thing by two type selectives, div, which would be the parent, and the paragraph type selector, which again would be the child. So you can use any selector types. The important thing to note is that the first selector you choose is the parent, followed by a space, followed by the second selector, which will be the child. So let's have a play around with this in VS Code. I've prepared a new file, index.html, which contains the HTML snippet we just saw before, an article containing my favorite Will Smith movies. I've also linked a style sheet, which is currently empty. So let's go use the descendant selector. I'll first use the class article, which is the parent element, space, and then paragraph for my child element. Let's give it the color green and a font size of 30 pixels. Let's check this out in the browser. So you can see that all paragraphs, whether they're a child, grandchild, etc., of the parent container are all green. We know that these two paragraphs were direct children, which are over here in our HTML, and this paragraph was a grandchild. It's the child of a child, but the descendant selector selects all children. Next up is the direct descendant selector. This targets only direct children elements of a parent, and the syntax looks like this, where instead of a space, we have a right angle bracket. So looking at some CSS now, we'd write a rule very similar to before, but instead of a space, we now have a right angle bracket. The class article, again, is the parent, and the paragraph type selector is the child. Now the direct descendant selector, like its name suggests, only targets direct descendants. So this paragraph down here is a grandchild, which is not selected. So only the direct children, shown in green, would be colored blue. Let's play around with this in VS Code. Back inside our app.css file, I'm going to change the descendant selector to a direct descendant selector by using the right angle bracket. And I'll just keep these styles the same. Let's check this out in the browser. So now you can see only these two paragraphs are being styled. And this paragraph down here is not being styled because it's not a direct descendant. It's what we would call a grandchild. Next up is the adjacent sibling selector. Adjacent is just a fancy word for next to. The adjacent sibling selector targets an element directly after another element, both nested within the same parent. The syntax looks like this, where the parent and child are now separated by a plus symbol. Now the sentence I read out before is a bit of a mouthful, so let's see what this actually means. Inside our CSS, we could have a rule like this, where we have two selectors separated by a plus. The first selector we call the preceding sibling, i.e. the sibling before. And the second selector we call the adjacent sibling, that is, the sibling next to. So I'm going to read out the sentence again. Targets an element directly after another element both nested within the same parent. Let's start with both nested within the same parent. That would be something like this div element here. It's a shared parent of nested elements. Now in our CSS, the first selector is the h1, which is the preceding selector. In our markup, the h1 is over here. So this is the preceding sibling. And the adjacent sibling is the element directly after the preceding sibling. So it's just this paragraph here. It's the adjacent sibling. So the important part here is that the two elements we're selecting, the h1 and paragraph, need to be nested within the same parent, in this case the div. And because they're on the same level, they're considered siblings. Where we first select the preceding sibling, it's kind of like the root sibling. It's our reference point. And the next selector is the adjacent sibling, and it's specifically targeting the element directly after the preceding sibling. So that's why only the first paragraph is selected, and not the paragraph below it. Let's play around with this in VS Code. So I'm going to get rid of the style from before. I'll grab the h1 plus the paragraph and our curly brackets. And for this style, let's just give it a color of red. Let's check this out in the browser. So you can see here, the adjacent sibling, which is the paragraph, has been colored red. Like I mentioned, see the h1 as like a reference point, which is over here in our markup. The adjacent sibling selector targets the element directly after this reference point, this paragraph here. And again, for this to work, they have to be considered siblings, which means they need a shared parent, which in this case is this div over here. The last combinator selector we're going to look at is the general sibling selector. This targets multiple elements directly after another element, both nested within the same parent. And the syntax looks like this, where we have two selectors separated by a tilde symbol. So let's have a look at this inside CSS. I'm going to define this rule here. The h1 is again considered the preceding sibling, and the paragraph is now referred to as subsequent siblings. The general sibling selector is pretty similar to the adjacent sibling selector. In addition to selecting direct siblings, it will select multiple siblings that are nested within the same parent. So this paragraph over here is also selected. The first and second paragraph are both subsequent siblings of the heading. The paragraph down here is not a sibling of the heading, so won't be selected. Let's look at this inside VS Code. So all I'm going to do is remove the plus symbol and replace it with a tilde, and I'll keep the style the same. So let's check it out in the browser. So you can see now, both this paragraph and this paragraph are styled red, whereas before, with the adjacent sibling selector, only this paragraph was styled red. And we can also see that this paragraph is not styled. Now, all these combinator selectors are pretty intimidating. As I mentioned, don't really worry about them. And besides the descendant selector, which is definitely the easiest one to understand, I'm not really going to be using these throughout the bootcamp. But I just want you to know about them in case you see them out there in the wild.
So let's wrap up by adding to our summary card pseudo-classes and specificity.
We looked at combinator selectors. We saw there were 4 different kinds of combinator selectors. We had the descendant selector, where we used 2 selectors separated by a space. We had the direct descendant selector, where we have 2 selectors separated by a right angle bracket. We have the adjacent sibling selector, where we have 2 selectors separated by a plus symbol.
And we had the general sibling selector,
where we have two selectors separated by a tilde symbol. As I've mentioned a few times now, I know these combinator selectors are quite overwhelming, and the good news is we don't really use them. So I wouldn't worry too much about them. I would just remember what the descendant selector does, as you will sometimes want to use that.
Now it's time to look at how CSS determines which styles take precedence through the concept of specificity. We'll be discussing the Cascade and conflicting selectors, specificity, and specificity calculations. Before we look at specificity, let's do a quick recap of the Cascade. The Cascade is about how styles declared later will take priority when the selectors are the same. For example, looking at this snippet of HTML, we have an H1. In CSS, we could style the selector by using the Type Selector to grab the H1 and then give it a color of blue. Later on in the sheet, we can grab the H1 again using the Type Selector. So in this example, we're using the same selector, the H1 Type Selector. And we know because of the cascading nature of CSS, styles declared later will take priority. So in this case, green overrides blue. So the H1 will no longer be styled blue, it will be styled green. Let's now talk about what happens when we have conflicting selectors. When styles are applied to the same element using a different type of selector, the outcome is determined by specificity. So what do we mean by this? Let's say we had the same HTML we saw before, but now we've added a class attribute with the value heading. Now in the CSS, we're going to style this heading in two different ways. The first is using the class heading, where we have the notation period or full stop, followed by heading. And the second is using the type selector H1. So now in this case, we have different selectors, a class selector and a type selector, but they're both targeting the same H1 element. And not only are they targeting the same element, they're applying conflicting styles. The class selector is styling the heading to be blue, whereas the type selector is styling the heading to be green. Now up until this point, you would say to me that because the type selector H1 with the color green is declared after the class selector, the color of the heading will be green, because we know the nature of the cascade is that styles declared later will take priority. However, this is not the case. The green does not override the blue, and this is where specificity comes into play. Now, to understand specificity, we're going to be looking at sports tables. In a sports table, team rankings are determined using a system of priority. I'm going to be looking at the English Premier League. Currently, Arsenal is in first place, Man City in second place, and Liverpool in third place. The rankings of the teams are determined by things like wins, draws, and goal difference, where as we move from the left to the right, the numbers have a lower priority, where as we know a win is more substantial than a draw, and a draw is more substantial than goal difference. We can see Arsenal has 7 wins. This puts them in first place as they have the most wins. Looking now at Man City and Liverpool, they both have the same number of wins, 5 each, and they also have the same number of draws, 4 each. So the place in the table is determined by goal difference. Man City has 20 and Liverpool has 8. So Man City is in second place as they're ahead on goal difference. Now if you were to just look at the numbers on this table, 20 is the largest. It's the value of Man City's goal difference. Now this is the largest number, but it's also the lowest priority. As I mentioned at the start, a win is much more substantial than a goal difference. So as a team in the EPL, it's a lot more important to have 1 win over, say, 100 goal difference. The category of win, draw, and goal difference is really important and have a lower priority as we move from left to right. This same principle applies to specificity. So what is specificity? Specificity determines the priority of a CSS rule when multiple rules apply to the same element. Let's have a look at this snippet of HTML. We have an H1 nested inside a div, which is then nested inside another div. In our CSS, we have 4 different ways of selecting the same element. The first rule is using the ID Selector. The second rule is using the Descendant Selector, where the class Textbox is the parent and the class Large is the child. The third rule is also using the Descendant Selector, where we're first selecting the div as the parent using the Type Selector. then selecting the next div down as the child using the type selector, and then using the class large, which is the grandchild, to select the heading. And the fourth rule again uses the descendant selector, but instead of using the class large to select the heading, we're using the type selector h1. So all these CSS rules are selecting the same element, the h1, but they're using a mix of different selectors, and they're all trying to apply a different color. So which color ends up being applied? To do that, we need to do a specificity calculation. A specificity calculation is very similar in nature to the sports table, where instead of wins, draws, and goal differences, we have the type of selector, ID, class and pseudo-class, and type. Where as we move from left to right, these selectors have a lower priority. So an ID selector is like a win, a class and pseudo-class selector is like a draw, and a type selector is like a goal difference. So let's now go through all 4 CSS rules we just saw earlier and tally this up. The first selector was the ID selector heading. There's just one ID selector here, so this gets 1 point. There's no class or pseudo-class selector, and there's no type selector. The next rule we saw was the descendant selector using 2 classes. There are no IDs here, so this gets 0, and there are 2 class selectors here, text box and large, so this gets 2 points. And there are no type selectors, so we get 0 points. The next CSS rule looked like this. There are no ID selectors, so this gets 0 points. There is 1 class selector being used, large, so this gets 1 point. And there are 2 type selectors, the 2 divs, so this gets 2 points. The last rule looked like this. In this case, there are no IDs being used, so the ID column gets 0. There are no class and pseudo-classes being used, so we give 0 here. And there are 3 type selectors being used, div, div, and h1. So the type column gets 3 points. So the ID selector heading is at the top of the table. Back to the football analogy, it's like it has 1 win, whereas all the other selector combinations don't have any wins. And we say that this selector has the highest specificity. In other words, it's the most specific selector used. And you can see each row is ordered correctly in terms of its specificity. For example, the next row down, where we have the 2 classes text box and large, this uses 2 classes, which is like 2 draws. So that's a higher specificity of the combination below it, the div, div, and large class, where that only has 1 class and 2 type selectors. And once again, if you look at this table, the largest number on it is 3, which are 3 type selectors on the div, div, and h1. But the biggest number doesn't matter, because the type is like goal difference. It isn't such an important number compared to an ID, which is like a win. So let's finish up by talking about some specificity guidance. Long story short, don't worry too much about it. The concept of specificity and the calculations behind it can seem a bit confusing. I can assure you, you're not going to be sitting there with a calculator trying to work out its specificity value whenever you're applying a CSS rule. Specificity is just something you need to know about so that you understand when you're applying conflicting selectors, which one is winning and why. The reason I don't want you to worry too much about it is because it is common to use the type selector for global styles and the class selector to override this for specific styling. For example, on this page, the heading 2 over here would be a global style with a specific font weight, color, font size, etc. So by default, within our application, all H2s will be styled this way. Within the application, there may be specific circumstances we want to override that default global styling. For example, this H2 over here, we could create a class called white, where we would override the H2 color property with a white color using the class. And the reason this works is because a class selector is more specific than a type selector. So long story short, don't stress about specificity. We're generally going to be styling global styles using type selectors and using class selectors to override this style for specific cases. It is also important to understand the concept of specificity so that when you write your own CSS and rules aren't being applied as you'd expect, you can start thinking about the specificity of conflicting selectors. So let's complete the summary card, pseudo-classes and specificity. We looked at specificity. We saw that specificity determines priority of a CSS rule when multiple conflicting rules are applied to the same element. We looked at an example of HTML like this. where we were targeting the H1 in 4 different ways. We saw that we could calculate the specificity of each selector, where ID, class and pseudo-class, and type selectors had a lower priority from left to right. In the example, we looked at 4 different cases, where filling in the table, the heading was 1, 0, 0, the 2 class selectors was 0, 2, 0, the 2 type selectors and class was 0, 1, 2, and the 3 type selectors was 0, 0, 3. And therefore the heading, which is an ID class, had the highest specificity, as any ID selectors were much more specific than a class or pseudo-class or type selector, just like a goal was more important than a draw. The guidance we saw was that we use the type selector for global styles and class selector to override for specific styling. It's now time to learn a fundamental concept in CSS, where certain styles can be passed down from parent element to child elements through inheritance.
We'll be discussing what is inheritance and specificity, what gets inherited, and inheritance and text align.
So this chapter is getting my more difficult stamp,
The concepts we're going to be exploring are just a little bit more challenging.
especially towards the end of the chapter when we talk about inheritance and text align.
So what is CSS inheritance? It's when properties set on parent elements are passed down to their children by default. Let's take a look at an example to see what I mean. We have this snippet of HTML where we have a div container element with the class hero section, and it contains a heading 1 and paragraph element. Looking now at the CSS, we've added the CSS rule color blue to the hero section. Now this rule is set on a parent. So what happens here is the parent element passes down this styling to its children. So the H1 and paragraph get this blue color. And we say the blue color is inherited. So that's the basic idea of inheritance. Properties set on parent elements will be passed down to their children. And now quickly want to touch on inheritance and specificity. Specific selectors will override inherited styles, as inherited styles have a very low specificity. I'm going to update our CSS to now include this rule, where we're styling our paragraph red. We're using the Type Selector here, which has a higher specificity compared to inherited styles, meaning our rule above, where we're adding the color blue to the container and it's being passed down to the heading, is a very low specificity. So almost any time we're using a specific selector, like a type, class, or ID selector, to target a specific element, it will always override inherited styles. So in our paragraph, the red color is applied, as it's overriding the blue color applied on the div, which is being inherited by the paragraph. Let's see this in action inside DevTools on the monday.com homepage. I'm going to right-click, Inspect to open up the DevTools, and I'm just going to select this text over here. We can see the styles that have been applied directly to this element here. It's got a font weight of 600, font size 60 pixels, and a line height of 100%. If we scroll down, we can see over here inherited from. This color is being inherited from somewhere else. If I scroll down more, you can see that the text align center is also being inherited. Now I want to show you an example of what I was talking about earlier. How applying styles directly on the element will always override conflicting inherited styles. You can see here, for example, the font size is being set to 60 pixels directly on the element. If I scroll down here and have a look at inherited from body, which is the body tag, the font size 16 pixels has been crossed out. It's because, as I mentioned earlier, applying styles with inheritance has a very low specificity. So when we have conflicting styles, one which is being inherited versus one which is being applied directly, the one which is being applied directly will always win out. And that's why we end up with a font size of 60 pixels. So the next question I want to answer is what gets inherited? It is mainly text properties that are inherited from parent to child.
So properties like these.
I'm not going to read them out, but feel free to pause to have a look at them. This is really important to remember. It's mainly text properties that are inherited. So try your best to remember that fact, because it can sometimes be confusing when you're applying a property to a parent and you're wondering why it isn't being inherited. More often than not, you're applying a non-text property. So by way of example, let's say we have the same HTML snippet we saw before, and we now apply these two styles to the div, a color blue and a border that's 5 pixels solid and black. Now I know we haven't looked at the border property yet. We'll be discussing it at great length in the next topic, but unfortunately at this stage, we haven't really covered many non-text properties, so I have to put something there, and hopefully border is somewhat intuitive. Because border is a non-text property, it's not going to be inherited by the children. So only the color blue will be passed down to the heading and paragraph. So let's go play around with inheritance inside VS Code. I've created a new mini project where I have an index.html file with the boilerplate ready. I've added in a link element, which links to an empty style sheet app.css. Alright, inside the body, let's go add a container element with some div tags. I'm then going to add in an h1, a paragraph, and an anchor tag. I'm just going to give this div a class of hero-section. Heading over to app.css, let's select this class, and we'll give it a few text properties. Font size of 30 pixels, the color blue, and let's make it all uppercase with text transform uppercase. Let's check this out in the browser. So let's look at what we see here. I'm going to start with the paragraph. This element has inherited everything from the container. The color is blue and it's all uppercase. Now for the anchor tag, the font size is 30 pixels and it's all uppercase, but it isn't blue. And the reason is because the browser has built-in styles that are applied directly to the element.
We saw this in the Pseudo-classes chapter where we can style the pseudo-class visited.
Because I have visited google.com, the default styling of the visited pseudo-class in the browser is purple. So that default style will override the inherited style, which we know has a very low specificity. And the same thing's happening on the heading here. The heading is inheriting the blue color and text transform uppercase, but the font size is bigger than 30 pixels. And we can actually see this default browser styling inside DevTools. If I go to inspect and click on the heading, you can see over here the H1 have these default styles that are set directly on it inside the browser. One of them is font size 2M. And you can see my styling, which I'm setting on the parent and is being inherited, is being crossed out. And because there's no default styling for color or text transform, they are being applied. But we have conflicting rules for font size set directly on the H1 for the default styling in the browser, and for the font size I'm setting on the parent, which is being inherited. And as we know, inheritance has a very low specificity, so the default font size of 2Ms will win. Now in practice, don't let this freak you out too much, because it's very rare we're actually going to be using the default styles inside the browser. Like we've seen in our Quill project already, we are explicitly styling the H1 in our CSS. So in almost all cases, we're always going to override the default browser styling with our own styles. And this brings me to the important topic of inheritance guidance. Make sure you marry a rich partner. That's good advice for the real world. But in CSS, global font styles are set on the body element so that all child text elements inherit styles by default. Let's have a look at an example of what I mean with this snippet of HTML. I've got a section container, which has inside a heading and paragraph, and then I've got a footer with a single paragraph. Inside the CSS, we would select the body element, which we know is the main wrapper element inside the HTML file for all content displayed on the page. We would set default text properties here, like the color, font weight, and font family. All these text properties are then inherited. Now, a property like font size would not be set here, because usually every text element, like a heading 1, heading 2, paragraph, etc., has its own distinct font size. Whereas setting something like a color is a good idea. It gives us a base color for all our text elements, and then anytime we need a specific color, we can just override it with specific styling rules.
We will be using this method in our Quill project.
Once we've done that, we next want to set global font styles on type selectors, which will override inherited properties. I'm going to make some more space in our CSS file here, and I'm going to add this H1. The properties defined in the body are still being inherited, and any newly defined conflicting styles, like color and font weight, will override the inherited styles. So the H1 will now have a color of blue, a font weight of 700. The font family will still be Arial, which is inherited from the body, as there's no conflicting style there. And the font size, which is a newly defined property, will be 52 pixels. Setting default text properties on the body element is very, very common, but inheritance is also often utilized for a container that requires specific text styling. In the HTML snippet we have on the left here, I'm going to simply add a class to the section with the value hero section. I'm then going to update our CSS, where I'm targeting the hero section and adding a text transform property. So this style is applied on the container. So we end up with our heading 1, which will result in uppercase on both heading and paragraph elements. So it's very common to use inheritance both to set default text styles on the body, as well as use inheritance within particular sections of the page. So the last thing I want to focus on is inheritance and the text align property, as this can cause a lot of confusion. We've already seen text align affects block level elements, but has no impact on inline level elements. We spent a fair bit of time with this in the previous topic when we were looking at text elements. But just as a quick recap, let's say I have a page with a heading 1 and a paragraph. Headings and paragraphs are block elements, which means they take up the full width of the page. If we were to apply text align center onto the heading and paragraph, the content inside the box gets centered. So our text will display like this. And this is because there's space to move within the box of the heading and paragraph. Let's compare this behavior to the anchor tag. An anchor tag is an inline element, which means it only takes up the width of the content and doesn't extend the full width of the page. So if we were to apply text align to the anchor tag, there is no space to center the text. So the anchor tag doesn't move. Jumping back into VS Code with the file we were playing around with earlier, I've got a heading 1, a paragraph, and an anchor tag. I'm going to head over to app.css and just remove these styles. The heading 1, I'll grab text align and set the value to center. For the paragraph, I'll do the same thing. And for the anchor tag, I'm also going to set text align to center. So let's check this out in the browser. So as expected, our block level elements, the heading and paragraph, get centered, whereas there's no impact on the anchor tag. And we can see why visually when I go to DevTools. When I click on the heading, you can see the blue box, which is the space the heading can move. The same for the paragraph tag. Whereas when I hover over the anchor tag, the blue box is just the content itself. There's no space for it to move. So now I want to show you something which will blow your mind. I'm going to remove these styles. And now I'm going to add text align onto the parent container, this div here. I'll add the class hero section, and I'll put text align as center. I'm going to refresh the page and watch what happens. Both the block and inline elements are being centered. So what is happening here? So we've just seen that when applying the text align property to a block level parent containing inline elements, all children will be impacted. So in the example we just looked at, we had a block level parent, which is a div. And as a quick reminder, a div is a blockline element. And we applied text align center to this, which ended up centering the block elements and the inline elements. So there's actually two things going on here. The first is that child elements are centered, where the child elements here are the heading 1, paragraph, and anchor tag. To really highlight this point, I kind of want to move away from these elements. I'm going to fill in the block elements like this, and I'm going to fill in the inline element like this. Now for the block elements, there is no impact on block elements as the element is already full width. I want us to view these elements as children rather than specific H1, paragraph, etc. elements. Just view it as a red box. Because the red box is a block element, it takes up the full width. So this child cannot move anywhere inside the div. In contrast, the inline element is centered as it has space to move. Again, just view it as a green box inside this div element. And because text align center is set on the div, which means all child elements of the div are centered, the inline element will be centered. And it has space to move because the inline element only takes up the width of the content itself. So that's the first thing going on. Child elements are centered, and the major impact here is on inline elements, which end up being centered. and there's actually no impact on block elements. Now, something else I want to quickly mention before we move on is that this in fact can be any inline element. For example, if we had an image that was this size, it would also be centered. So that's why I took this approach of coloring it in green. I just want you to see it as a green box. It doesn't really matter what inline element it is. From the div's perspective, it just sees it as a general child. So let's now have a look at the second thing going on. The second thing happening is that child elements inherit the text-align property. And again, inheritance is when we're passing on the property from parent to child. It's like the H1 and paragraph now have text-align applied directly to them through inheritance. And this is just now the standard behavior we've seen before, where text is centered inside block elements as there's space to move. So the second thing that would happen is our text inside our block elements, H1 and paragraph, will center. And there's no impact on inline elements as text has no space to move. Again, this is just a regular behavior we've always seen. When you try to apply text-align center onto an anchor tag, it won't move. And in this case, the text-align center property has been inherited from the parent div. So the net effect from these two different things going on is that both the block elements and the inline element are centered. Now, at the end of the day, you just need to remember that when you apply the text-align property onto a block-level container like a div, everything inside it will get centered. I spent a bit of time explaining what's going on behind the scenes because I think it is useful you have a basic understanding. So let's finish off by building our next summary card, Inheritance and the Universal Selector. We looked at Inheritance, which is where properties set on parent elements are passed to child elements by default. And we saw this was mainly for text properties. We saw an example with a snippet of HTML like this, and we applied CSS styling rules onto the body. And we saw that all the text properties were inherited by all the HTML elements wrapped by the body tag. For inheritance guidance, we said global font styles are set on the body element. We also looked at inheritance and text-align. We saw that when applying text-align to a block-level parent, both block and inline elements are impacted. We looked at an example where we had a div, and we applied the text-align property to this div container. We had an H1 and paragraph, which are both block elements, and block elements inherit the text-align property. This causes them to center inside their box. We saw an anchor tag, which is an inline element, and inline elements have space to move inside the block container, which results in the anchor tag being centered. So applying text-align to a container results in both block and inline elements being centered, just through different mechanisms. So let's now go and use inheritance inside our Quill project. I'm going to go grab the body, add our curly brackets, and let's start adding in our global font styles. The first one I'm going to put in here is the font family. I'm just going to copy it from here and paste it in the body. Now, because I'm defining it on the body, which means that all child text elements will inherit this, I'm now actually going to remove it from any other location we're defining this to avoid duplicate declarations. So I'm going to remove it from here, and we also have it on our paragraph anchor and small text. And I also have it down here on our BTN class. So I'm going to go remove it over here as well. Now, previously in this topic, I did speak about explicitly defining some properties on the BTN class, so it's clear the properties being used in our buttons. However, now that we've learnt about inheritance, the best practice is we define our global base font styles on the body. So something like font family is just applied to every single property. So there's no need to explicitly define font family on the button as well. So in doing this, we've now consolidated our font family property onto the body, which is being applied to all text properties through inheritance. The other properties I'm going to be adding, I'm going to go grab down here. I'm going to copy these and paste them inside our body. Now, the reason I'm selecting a font weight of 400, a line height of 1.5, and our base gray color is because those are the default text properties I want. As we've seen, they're used on elements like paragraphs, anchor tags, smaller text, etc. I kind of see these elements as a bit more commonly used throughout the application, whereas headings are a bit more specialist. So that's why I want to use these properties as my default properties. So I'm going to scroll back down here and simply remove this now. Now I could also remove the font weight of 400 in our button class, because that's now set on our body tag.
And through inheritance, our anchor tag will get applied the style. However, with a component like a button, it actually is still good practice to keep the font weight explicitly defined here. That's because something like a font weight on a button could be different. You could have a 500, 600, or 700 value here. So it is always a good idea to explicitly define the font weight, even if it is the same as the font weight in your body tag. As I mentioned before, something like font family, you don't need to explicitly define in your button, because in this application, all the text elements have the same font family. So by default, all our text properties will now inherit these styles. If you remember from earlier on in this topic, once we define our base text properties on the body, we next go and set global font styles on Type Selectors. We've actually already done this. We have our default styling inside the body, and then we have specific styling on Type Selectors. For the font weight, we're setting it as 700, which will override this 400. The line height as 1.2, which will override this line height. This darker shade of gray, which will override this color. And we're also adding a new property on, the letter spacing of -2 pixels. And again, the reason these are overriding is because properties through inheritance have a very low specificity, and the type selector has a higher specificity. So these properties will override inherited properties. And then of course we're selecting each heading and applying its unique properties, like font size. Now if you remember, just earlier, we saw the power of applying text align on container elements, where it centers both inline and block elements. So let's now go and use this to our advantage inside the Quill project. With the hero section, it would be nice to center all of this content instead of just the H1. The feature section we're going to leave as it is, because that final layout has this content on the left with images on the right. The call to action section containing this heading and this anchor tag would also be nice to center, and the entire footer would also be great to center. So let's now code this up inside VS Code. I'm back inside the index.html file for our Quill project. I'm going to scroll down to the hero section and add in a class and give it the value hero section. I'm going to scroll down to the CTA section and give this a class of CTA section. And for the footer, I'm going to give this a class of footer. Now, of course, I could use the type selector in CSS and not add a class, but this is generally considered better practice. So heading over to app.css, I'm going to add the hero section class, grab the curly brackets, and add the property text align center. I'll do the same thing with the CTA section, and the same thing with the footer. So let's check this out in the browser. So you can see now that our hero section is all nice and centered. Same thing with our call to action section, and same thing with our footer. Now, just a few comments at this point. The first is, this does work, using text align center on a parent element to center all the children. And once again, like we've discussed, even the inline elements are centered, like the anchor tag over here, or images over here. Later on, we'll be talking about Flexbox, which is the more modern way of handling alignment. So while this does work, later on in the CSS module, we will be exploring new modern and advanced methods. The next thing I want to comment is that these links over here and these images are actually a little bit off center. If you compare it to this text over here, you can see that the center line kind of comes down here to the right. If I go to DevTools and hover over this paragraph text here, you can see the blue box extends the full width of the page. Whereas over here, the list item has a little bit of space on the left here, which when I hover over it goes green. This has to do with the CSS box model, and we'll be correcting this in the next topic. But I just wanted to point that out now, in case you were wondering why this looks a bit funny down here. Before we finish up, I just want to tidy up our CSS file a bit. The first thing I want to do is remove text align where we no longer need it. I'm going to scroll up, and I'm going to remove text align on our H1, as we're now handling that with inheritance on the parent element. We had also previously defined text align center on our H2. In our HTML, the H2 is used as a heading for each section. For example, the feature section has an H2, and the call to action section has an H2. The H2 over here is now being centered through inheritance that we defined over here.
So if I remove text align center from this H2, the H2 in the call to action section will still be centered, but the H2 in the feature section will no longer be centered. It generally isn't a good idea to have a text align center set as a global style like this on an H2, because not all H2s will be aligned center, whereas all H2s will be 48 pixels. So to correct this, I'm going to delete the text align property here, and I'm going to add a new class to this H2. We'll call it features main heading. Scrolling down in the CSS file, we'll add the class features main heading, and we'll give it the text align property of center. So this is much better. I'm now just centering this heading for this particular instance, instead of globally using the H2 type selector. Let's check this out in the browser. So as expected, there's no actual net change. The heading 2 is still centered here, which is being controlled by this. And the heading 2 over here is also being centered, which is being controlled by inheritance over here. Okay, the last thing I want to do is just tidy the CSS document itself up a bit. You may be noticing things are now getting a little bit out of hand. We need some better structure to organize this. So what I'm going to do is split up the CSS document into 3 main sections. I'm going to add a comment by hitting Command/ on my Mac, add a whole bunch of dashes, and give this the title Global Styles. I'll copy these dashes on the other end as well. I'm just going to copy this entire comment as well, as I'll be using this syntax as a title below. So all these styles below are global styles. They're setting things like the font size of all H1s, or all the text properties on the body that are being inherited. The next series of styles I'm going to call components. These are pieces of reusable UI we're going to be using throughout the application. The button is a great example of a component. The next section is going to be called sections. These are different sections of our web page. And I'm going to put it in order as it appears on the page. I'm going to add a comment, and this time I'm only going to add a few dashes to make it appear as a subheading of sections. The first section with specific styling for is the hero section. I'll copy this for the next section, which is the features section. That's this piece of code over here. I'm going to cut that and pop it above over here. The next section we have is the CTA section, and the next section is the footer. So using comments to create headings like this helps better structure our CSS file. But we first have all our global styles, our different components, which we're going to be adding to as we move through the course, and different sections of the page, where we'll also be adding a whole bunch of new CSS rules.
Next, we'll see how to target all elements on a page with one simple rule using the Universal Selector.
We'll be discussing what is the Universal Selector and the Universal Selector versus body tag inheritance. So what is the Universal Selector? The Universal Selector applies styles to all elements. Let's take a look at this snippet of HTML. It contains a section and footer. In our CSS, I'm going to apply this style rule. The selector you see here is the Universal Selector. It's an asterisk symbol. The styles inside the declaration block applies to every single element. And when I say every element, I mean every element. Even structural elements like bodies, sections, and footers, as well as, of course, regular content elements like headings and paragraphs. So let's now play around with the Universal Selector inside VS Code. I've set up this simple HTML file where I've got a div container with the class of hero section, and inside it, I've got a heading 1, a paragraph, and a hyperlink. I've also linked a style sheet called app.css, which is currently empty. So let's go and add our Universal Selector, which is the asterisk symbol, grab our curly brackets, and let's add a few properties which will be applied to every single element. Let's make any text property with the color blue, and then I'm also going to add a border top, which is a CSS Box Model property we haven't spoken about yet, but I do want to use a non-text property so that this will apply to every element. We'll give the border top a width of 5 pixels, it will be solid, and let's make it red. So let's check this out in the browser. So you can see that every text element we have is now blue, and every HTML element has a red border top. The border thickness is 5 pixels, but you can see in some locations it's a bit thicker. So let's have a look in DevTools why this is happening. I'm going to grab the inspector tool. I'm going to click on this first element here. This is the root HTML element, which is getting a red border top. It's this element here in our HTML. The next element is the body element, which is also getting a red border top. If I move my mouse down slightly, you can see that this box is the div container, which is also getting a red border top. Because these are just container elements, the body and the div, without any content between it, it's like the border tops are being stacked on top of one another, which makes them appear thicker. So in a nutshell, any properties that are applied on the Universal Selector are applied on every single element in your HTML.
Now I do quickly want to contrast this to Inheritance, which we looked at earlier.
I'm going to just comment this out by highlighting it and hitting Command// on my Mac or Control/ on a Windows. I now want to apply these same styles but using Inheritance. I'll grab the body tag and I'll copy these styles in the curly brackets. I'm going to hit refresh, and what we can see is that only the blue color is being applied to our text, and the border top is only being applied once. It's only being applied to the body element, where this style is declared. And if you remember, it's because only text properties are inherited. So the color blue is inherited by all text children, whereas border top is a non-text property, so it's only being applied on the body.
Towards the end of this chapter, I will be doing a more comprehensive comparison
between what styles to put on a Universal Selector versus the body, as I know it can be a bit confusing, the subtlety between them. So let's now have a look at how we use the Universal Selector. So we'll now be going through the Universal Selector guidance. The Universal Selector is primarily used for resetting default properties and is not typically used for applying specific styling. It's like doing a factory reset on your computer or phone, completely clearing it out, making it how it was like when you first bought it. So what default properties are we actually resetting?
I'm back inside our Quill project where we got up to in the last chapter.
I'm going to open up DevTools. I'm going to grab the inspector and click on a few elements. We'll start with this heading. You can see on this heading, it's got some default margin, which is space between the element and other elements. You can see it in the orange. Same thing with the paragraph. It's got some built-in spacing called margin between the paragraph and the elements surrounding it. If I go up to our navigation bar, these list items, which are inside an unordered list, they've also got some default styling. If I hover over the left here to select the unordered list, you can see this green box, which is called padding. It's default styling rules applied to unordered lists, so that our lists get slightly indented. So we typically use the Universal Selector to remove this default styling of margin and padding. So the properties we put inside the Universal Selector have to do with CSS Box Model properties, which we will be looking at great length in the next topic. So we don't really have much use for it right now, but we will be using it to remove the default spacing on elements, specifically margin and padding. Don't even worry about what those terms mean right now. Just realize it's not used for setting any text properties. Back in our Quill project, at the top of the global styles, I just want to go make a comment, which will be add in Universal Selector later to remove default spacing properties. So we can't use the Universal Selector just yet, because we still need to understand more about the CSS box model. But once we do understand that, we will replace this comment with the Universal Selector and some box model properties that will remove the default spacing. And while we're here, I just want to remind you again that we use Inheritance on the body Type Selector to set all font properties. So just to drive the message home of the difference between the Universal Selector and body tag Inheritance, I've created this table to compare them side by side, as I personally found it quite confusing to know what is used where. So let's start with the body tag and Inheritance. The CSS properties we add inside the body only applies text properties to its children. So it's primarily used to set default text properties across our application. On the other hand, the Universal Selector applies all properties to all elements throughout the application, not just text properties. The Universal Selector is primarily used to reset default styles, which again, we need to learn about box model properties to implement this. In a one-sentence nutshell, the body tag and inheritance is used to apply styles, whereas the Universal Selector is used to remove styles. So that's probably the easiest way to think about it. Body tag and inheritance, adding text styles. Universal Selector, removing default styles.
So let's finish up by continuing to add to our summary card inheritance and the Universal Selector. We looked at the Universal Selector, which applies styles to all elements. The Universal Selector is an asterisk symbol, and in this example, the color blue and border top is applied to every single HTML element. We saw that the guidance was the Universal Selector is most commonly used for resetting default styles. Finally, in the last chapter of this topic, we'll explore how to style specific parts of an element using pseudo-elements. We'll be discussing what are pseudo-elements, the pseudo-elements for text styling, selection, and content insertion.
So what are pseudo-elements? Pseudo-elements are used to style a specific part of an element. They're not to be confused with pseudo-classes, which we saw was used to style a specific state of an element, like hovering over an anchor tag. Let's look at the syntax for a pseudo-element. We have a selector, like an H2, and then we add on our pseudo-element, which is made up of a double colon and the pseudo-element name.
Now, just a small note at this point, pseudo-elements are not overly common. I'm not going to be using them throughout the course, but I do just want you to know that they do exist in case you see them out there in the wild. When I first learned CSS, I felt very overwhelmed with all the selectors I'd learnt, and especially scary worded ones like pseudo-classes and pseudo-elements. Pseudo-classes are very, very important. You always use them on anchor tags. Pseudo-elements are not that common, so don't stress too much about them. So let's now take a look at different pseudo-elements. The first group of pseudo-elements have to do with text styling,
where they're used to enhance visual appearance of text. The first example of this is the first letter pseudo-element, which, as the name suggests, will target the first letter inside a text element, like a heading or paragraph. And this gives us something called a drop cap, which you can see in my image here, where the first letter will be larger than the rest. This kind of styling you'll often see in some publications like books or magazines. The other text styling pseudo-element is first line, which, as the name suggests, targets the first line of text. And often this will be a paragraph opening line, as a paragraph usually contains multiple lines of text. So let's play around with these in VS Code. I've prepared this index.html file ahead of time. It's got my boilerplate code and just an h1 and paragraph element. I've also linked an app.css style sheet, which is currently empty. So let's use the first letter pseudo-element to target this paragraph. I'll use the Type Selector, add 2 colons, and then add the pseudo-element name, first letter. I'll grab our curly brackets, and let's add some styles. A common one would be text transform to uppercase. This will give us that capital letter as the first letter. Let's make the font size 30 pixels, and let's give it a font weight of 700. Let's check this out in the browser. So you can see in our paragraph, the L over here, which is the first letter of the paragraph, is uppercase. It's got a larger font size of 30 pixels, and it's got a font weight of 700. And as I said before, this is called a drop cap. I'm going to comment out this style. Let's go add the other pseudo-element we saw. I'll again grab the paragraph, add 2 colons, and this time we're going to be using the first line pseudo-element. I'll grab our curly brackets, and let's just use the same styles here. I'll copy them and paste them here. Let me refresh the browser, and you can see now the first line is all uppercase, has a font size of 30 pixels, and has a font weight of 700. So text styling with pseudo-elements targets specific parts of the element. We saw first letter, and now first line. The next type of pseudo-element is selection. This is used to visually enhance the text a user selects. And as you guessed, the pseudo-element name is selection. Let's play around with this one in VS Code. I'm going to get rid of these styles. I'm going to grab the paragraph again, add my double colons, and add the pseudo-element name selection. Add curly brackets, and let's give this a color of red. Let's see what this does in the browser. So initially, it doesn't look like any change. To see the selection pseudo-element in action, we need to go and highlight the text. So I'm going to grab my cursor and select the text as if I'm going to copy it. And you can see it's turning red. So that's selection in action. The last pseudo-element type is content insertion. This is used for adding decorative elements without altering the HTML structure. There are two content insertion pseudo-elements. The first is before, and the second is after. As you could guess, using before adds the decorative elements before the HTML element you're targeting, and after adds the insertion after the element you're targeting. Let's have a look at this inside VS Code. Looking back on the HTML file, what I'd like to do is on my H1, I'd like to have a little beta symbol to signify that this application is in beta. Now, I don't really want that beta to be part of my HTML markup. It's kind of more like a little decorative element. It doesn't really make sense to have that inside my HTML structure. So I can use the before and after property to inject that element when the page renders. Heading over to app.css, I'm going to get rid of this style. I'm going to grab the H1, add 2 colons, and I'm going to use the after pseudo element. This will add the decorative element that I'm adding here after the H1. Now, a common property to use inside the before and after pseudo element is content. And we use quotation marks to write the content we want to appear. In this case, the word beta. And then we just use regular CSS text properties, like font size, which I'll make 12 pixels, and color, which I'll make purple. So let's see what this looks like in the browser. So you can see the word beta has been inserted into the page after my H1 heading. Now, usually you'd want to style this a bit more. You'd probably want to move it, say a little bit up and left, and also maybe give it a background color. Now, we can't do those things just yet because we need to learn more about positioning and the CSS box model, but you could imagine how this would look on a final page. And again, just to reiterate the subtlety of this beta is not actually an HTML element. It's being injected into the page when it renders. We can see this in DevTools as well. If I go into the heading, you can see welcome to the app, which is our heading text, and the pseudo element after, which has the properties we defined in our CSS.
So let's complete the summary card, Inheritance and the Universal Selector. We looked at pseudo-elements, which styles a specific part of an element. We had a selector, like an H2, which was then followed by 2 colons and the pseudo-element name, like first letter. This gave us a pseudo-element. Another topic done and dusted. We've now finished CSS Selectors. Let's now move on to one of the most important concepts in CSS, the CSS Box Model. The CSS Box Model is the foundation of layout design, determining how elements are sized and spaced on a web page. In this section, we'll break down its key components, content dimensions, padding, borders, and margins, and cover layout rules that control element sizing and behavior. Let's start off nice and slow with the CSS Box Model Introduction. We'll be discussing HTML element boxes and the CSS Box Model. Looking back at much earlier on in the CSS course, I introduced you to these 3 overarching concepts in CSS: content, box, and layout. We've already looked at content, the stuff about what's inside the box, and we looked at a whole variety of text properties like font size and font weight. Now it's time to have a look at the box itself. So we'll be taking a deep dive into the CSS Box Model. The CSS Box Model describes how all HTML elements are treated as rectangular boxes. So for example, every single HTML element on this page has an invisible box around it, whether it's a text element like a heading or paragraph, or an image. We've already seen this in DevTools. When we inspect an element, we get a blue box appearing around it, like this heading and paragraph over here. Now in the CSS Box Model, each box has its own set of properties. Let's look at this page as an example. We have an H2, paragraph, and some anchor tags. I've put the block elements in red, and the inline element, the anchor tag, in green. So if we were to look at these in DevTools, we'd see boxes that look like this, where the H2 and paragraph extend the full width of the page, or in this case, the full width of the container it's in, and the anchor tags just take up the width the content occupies, to just the anchor tag text. So let's now have a look at some of these box properties. The first obvious one we can see is this border. We then have some space between the content and the border, and we also have space between boxes. So you can see the CSS Box Model has a lot to do with spacing, both within elements and between elements. The CSS box model also applies to container elements, like divs and semantic elements. So for example, all of this content is inside a div. So in DevTools, we'd see a box that looks like this. Now looking at this box property, we can see that there's space between the content and border. And over here, we can see that there's space between boxes, between this box and the content above. Now in this case, there isn't actually a border. There's just been some background color applied to the space between the content and where the border would be to give an impression like there is a border there. So let's now look at the CSS box model properties in detail. We're going to be doing that by zooming in to the See Live Demo button. So the first thing we have is the content. This is just the text See Live Demo. The content has a width and a height. Now the content is any HTML element, like text, images, links, forms, etc. The next box model property we have is padding. Padding is the space between content and border and is still considered part of the element. So in our button, padding is the space between the See Live Demo text and the blue border that surrounds it. It's space between the content and the border. The next CSS box model property is border. Border is a line around the element and is still part of the element. So the content itself, the padding, and the border are all part of the element. The final property is called margin. Margin is the space outside of the element, separating it from other elements. It's kind of like a force field around the element. Now, because margin is the space outside the element, it is not technically considered part of the element. There are some properties we're going to look at later that, when applied to an HTML element, will impact the content, padding, and border, but won't impact the margin. Now, the best way to think of the CSS box model is by looking at paintings and posters. I've just grabbed a couple of these off Etsy. I've got this frame picture here by an awesome street artist called Banksy. The picture itself is the content. The rose gold frame is the border. Often in these kinds of framed artwork, you'll have this kind of like setting space between the picture and the frame, and this would be equivalent to padding. It's the space between the content and the border. Looking now at a regular wall poster, all we have here is content. There's no border, like a photo frame, and there's no padding. The last example is a framed poster, where we have the content, and in this case, there's no padding. The content is directly touching the frame. In the CSS box model, that would be the border. Now imagine these on your wall. It's unlikely you'd put them all next to each other. You'd want to space them out a bit. This space in the CSS box model is margin. We have some margin between the first and second artwork, specifically between the border of one and the content edge of another. And between the second and third, we have some margin between the content edge of the LeBron James poster and the border edge of the other framed poster. Throughout the CSS topic, I'm going to keep referring back to this diagram, because sometimes the subtleties of things like padding and margin can seem a bit confusing. So this is a fantastic real-world example to help you properly understand the CSS box model when talking about content, padding, border, and margin. So let's wrap up by starting to build the summary card, the CSS box model. In this chapter, we looked at the different components of the box model. We started with our content in purple, which has both a width and a height. The content can then be surrounded by some padding. This can then be enclosed by a border. And we saw that the content, padding, and border are all part of the element. We can then add some margin to create space between our element and other elements. Next up, we'll learn how to add visual style to our elements by setting the background color. We'll be discussing the background color property, background color guidance, and color versus background color.
So what does the background color property do? It sets the background color of an element and applies it to the content and padding. So let's have a look at this visually. Let's say we had some content, like a text element, and this content had some padding on it. Let's also apply a border. Now, if we were to apply background color on this HTML element, the background color would be applied to both the content and the padding, but not the border. So that's something really important to keep in mind. That background color both gets applied to the background of the content itself, as well as any padding present. So let's have a look at the background color property. Background-color is the property, and the value can be any color value. So typical values you'd see would be RGB, hex, RGBA, or HSL.
And we've already spoken in depth about color earlier on in the course.
Now in CSS, hex colors are the most commonly used, and we'll be using that color system throughout this course. So just to show you the background color property in action, I'm on this web page here. I'm going to jump into DevTools, and I'm going to click on this button here. You can see this blue background color here. The background color is being applied to the content, which in this case is anchor text book a call, and it's also being applied to the padding, the space between the content and its border. If I were to turn background color off, you can see the background color is removed from both the content and the padding. And if I were to turn the padding off over here, you can see the background color has only been applied to the content, the anchor text book a call. Now when making this video, I've been faced with a bit of a chicken and egg because we haven't looked at padding yet. And to explain background color, we need to know about padding, but also to better understand padding, it's helpful to know background color. So don't worry so much about the padding property itself right now, as long as you understand that padding is the space between the content and its border, and that background color gets applied to the padding and the content. So let's now take a look at some background color guidance. It's sometimes used to set the background color of an entire page. So for example here, this entire page has had a gray background color applied to it. A lot of times web pages will just be a default white, but you will see pages like this, with an actual background color applied. The background color property is commonly used to set the background color of page sections. So this page on the left here, the hero section is in this dark green. If we were to scroll down the page, you can see the nav bar is in this same dark green, whereas the testimonial section is in this very light purple. Background color is also commonly used in components. And if you remember, a component is a piece of reusable UI. That is, a piece of user interface that will appear in multiple places throughout the web application. For example, on this page, we have this component called a card, which has this grayy background color. And on the same application, we have buttons like this, where a turquoisey background color has been applied to this button. Now I want to quickly compare color and background color, because sometimes it can be a bit confusing. So starting off with color. Color applies to text elements, and the CSS property looks like this. Background color applies to the background of an element, and the syntax looks like this. So just keep in mind, color is for text, and background color is for the background of an element, and it's applied to the element and any padding if it's present.
So let's now add to our summary card the CSS box model. In this chapter, we started looking at some properties related to content. We looked at the background color, where the property is background-color, or we can add a color value like in hex notation shown here. We also said the background color applies to both content and padding.
So let's now go add background color to the Quill homepage. At the top of the page, we have this highlight, which uses our secondary background color. And some of our buttons are using our primary color as a background color. Further down the page, we have another highlight, where our tertiary color is being used as a background color. And at the bottom of the page, we have this big kind of card, where the background color is our primary color, and also a button, where the background color is our secondary color. So let's jump into VS Code and add background color. So I'm back inside the app.css file for the Quill project. The first thing I want to tackle is the background color for buttons. So I'm going to scroll down to the component section where our buttons live. Just as a quick reminder, the way we've set this up is we first created a btn class, which establishes the structure of the button, which is common to every single button, like the font size being 16 pixels and the text decoration being none. And as we move through the topic, the CSS box model, we will be adding some more properties here. We've then set up our different button styles, the primary button and the secondary button. And we have these pseudo-classes, link visited, which are grouped together, and hover active, which are grouped together. Now, this is not actually our design, where the text color is our primary color.
I just did this earlier on as we hadn't yet learnt about background color.
In fact, the way these buttons are set up is that the background color is the primary color for the primary button, and the background color for the secondary button is the secondary color. So I'm simply going to change this to background color, which is now correct, and the text color is just going to be white. Now, instead of doing it like this, what's more common is to actually explicitly define white in our style guide. So I'm going to scroll to the top, underneath our gray heading, I'm just going to go add the colors black and white. So white, which has the hex code FFF, FFF, 6Fs, and I'm just going to call this white, and black, which has the hex code 000000. Now this might seem a bit silly because they are obvious named colors, but it is good practice to explicitly define every single color inside your color palette. So let's scroll back down. I'm going to remove white and reference it by its hex code, which is 6Fs. Now for the hover and active state, I'm going to just get rid of this color, and the text color will be white also. But now when we hover, I want it to go a slightly darker blue. So we'll write background color, and we're now going to go get the shade of blue we have. The primary shade we call Deep Sea. So I'm going to copy that, and I'm going to pop it there. So now what will happen is that the background color of the button will turn a bit darker when we hover over it. Let's now go and do the same thing for our secondary button. The color is now actually the background color, and the text color is just white. For the hover and active state, I'm going to get rid of this, and the text color is white. And for the background color, let's go grab the shade of our secondary color. We called it Velvet Night, and it's this hex code over here. So I'll copy that and paste it as the value. And again, once we hover over this button, it's going to turn a darker shade of purple. So let's check this out in the browser. So you can see now this register button over here and the get started button over here, where the BTN primary class is added, has now got a blue background color and white text color. And when I hover over the button, you'll see the background color turns that shade of blue. And if I scroll down to our call to action section, the get started button over here has the secondary background color applied to it. And the same thing will happen when I hover over it. It turns that shade of purple. Now, one thing I do want to highlight at this point is that the background color has just been applied to the element background color.
Coming up soon, we will add padding to improve the readability of these buttons. And as we know, background color is applied to both the content and the padding.
All right, the next thing I want to handle are the different highlights we have in our design. If you can recall, we have a purple highlight running through Mindful Living, and an orange highlight running through Simple and Easy. So let's go add those now. Just to quickly explain how we're going to do this, back in the HTML section, we've actually already prepared for this. We added spans, which if you recall, are inline container elements, which are often used to group text. So we added a span already for Mindful Living, and we added a span over here for Simple and Easy. So now what we're going to do is go create a new class in our CSS and add the class to this span. So let's jump back to our CSS, and I'm going to create these highlight classes in our components. The reason is because these highlights are considered components as they are reusable pieces of UI. We're currently using them on the homepage, but they could easily feature in other locations of the application. For example, if we had an About Us page, we might want to use the highlights there, just like we're using buttons on all different pages throughout the application. I'm going to be taking the exact same approach as well when creating these highlights. I'm first going to create a highlight class, which just sets up the structure. And then I'm going to create different classes for the different colors. Now, fortunately, highlights will be a bit simpler compared to our buttons, because we don't need to worry about different states. The whole reason we have different states for our buttons was so that when you hover over it, it can change a different color.
So let's go down here and create a new class called Highlight. For now, all I'm going to put in here is the font color, which is just going to be our white. As we move through this topic, we will be adding other properties like padding and border radius, but this is all we can add for now.
I'm now going to go and create the different highlight colors. I'll first create a class called Highlight Primary, grab our curly brackets, and the background color here is the same background color as our primary button. So I'll just copy this declaration here. I'll then add our Highlight Secondary, and again, this is the same background color as the secondary button. So I'll just grab the declaration there. And then finally, I'll create Highlight Tertiary. And the background color here is going to be our tertiary color, which we called Pumpkin. And it's this hex code over here. So I'm going to copy it and paste it over there. So now we have our three different colored highlights, primary, secondary, and tertiary, as well as the CSS class, which sets the structure for the highlight. And as I mentioned, we will be adding more properties to this. So let's now go add these classes to our spans. Back in our HTML, the text Mindful Living had the purple background color. That is our secondary color. So we'll go grab a class we're first going to add the highlight class, which sets the structure, and then I'm going to add the specific color, which is highlight secondary. Moving down to the span over here, simple and easy, this had the orange background color. That is our tertiary color. So I'll get the class, again, add the structure of the highlight, which is the class highlight, and then add the specific color, which was highlight tertiary. So let's now check this out in the browser. All right, this has had a huge impact. You can see how great this is starting to look. We now have our purple background color applied to Mindful Living, and our tertiary orange color applied to Simple and Easy. The final thing we're going to do is add the primary blue background color to our call to action section. Now to do this, we actually will need to modify our HTML slightly. Let me show you why. In our CSS, I'm going to scroll down to the sections, and in the CTA section, we have this class CTA section. If you look at that in the HTML, that class is being applied to the semantic section element, which contains an H2, get started now, and the hyperlink. So let's add the primary blue background color inside this class. So I'll grab the background color property, and the value is just our base primary color, this one over here. So I'll copy that and paste it over here. So let's refresh, and this is looking good. But let me now show you the problem.
I'm now going to show you a new property we will be learning about in the next chapter.
However, I do need to add it now to show you the problem with our HTML. The property is height. So I'm going to add height, and I'm going to make the height of this element 300 pixels. And I'm going to refresh. So the problem that's happening is because the background color is being applied to the section, that is the entire section, it means the entire background color is going blue. And we don't actually want that. If you remember in our design, we have a card that is blue that is sitting on a white background. We don't want the entire section to be blue, just the card. So to handle this, what we need to do is go into our HTML and actually create a new div here to contain this content. So I'm going to cut the H2 and anchor tag and place them inside the div. And in the CSS, I'm now going to create a new class called CTA card and add the background color there. So I'll remove it from here and place it in CTA card. I'll then add this class to the div. So class CTA card. I'll save that and refresh. And this is what we want. We have our heading and hyperlink contained inside a card inside the section. Just to really highlight this, I'm going to open up DevTools. You can see the section is highlighted here, whereas the card is over here. Now, obviously, the card is positioned at the top, whereas in our design, it's centered, and we will be playing around with that later on. I'm just going to head back to app.css, and I'm going to remove the height, as I just added it there to show you the problem. So let's refresh, and we're actually back to where we started. However, we now have a div where the background color is being applied, so that when we do get to spacing this out, it will behave correctly, as we've contained the background color inside the card. Now, what we've just done is actually fairly common. When you start getting into the weeds of your CSS, you'll often need to go modify your HTML code to kind of further compartmentalize it and group content together more discreetly. So it's fairly common to have a base HTML file you're continually adding divs to make it work with your CSS. And we will be continuing to do this as we move through the CSS section.
Now, the last thing I wanted to mention before we finish this chapter is that in our design, we do have these outline buttons.
We will be styling those up in this topic. I just wanted to mention I haven't forgot about them,
and we will be handling them soon. Now we'll move on to explore how to control the dimensions of elements using width and height. We'll be discussing default block and inline element dimensions, the width and height property, and width and height design guidance. We'll start by talking about the CSS box model. Each rectangular box has height and width. For example, this image element over here has a width, in this case 630 pixels, and also a height, in this case 480 pixels. This heading has a width of 390 pixels and a height of 125 pixels. And the hyperlink down here has a width of 132 pixels and a height of 26 pixels. Inside DevTools, whenever you hover over an element, it shows you its dimensions. For example, this paragraph has a width of 483.9 pixels and a height of 90 pixels. You can see the dimensions are displayed on this pop-up in the top right corner. Now, block and inline elements have different default dimensions. Let's start by looking at the default block level element dimensions. By default, block level elements are just big enough to fit its contents vertically and stretches full width horizontally. Looking at some example markup, I have an H1 and paragraph. In the browser, these block elements will span the full width of the page. Irrespective of which block element it is, whether it's a heading or paragraph, it will span the full width of the page. So let's apply some CSS so we can look at the height. In this example, I'm applying a font size of 32 pixels to the H1 and a font size of 20 pixels to the paragraph. So these elements' height is set by the font size. So I've gone ahead and prepared this index.html file. It has the heading and paragraph we just saw previously. I've also added a style sheet where I've applied the font size of 32 pixels to the heading and the font size of 20 pixels to the paragraph. So let's check this out in the browser. Inside the browser, I'm going to go grab DevTools. I'm going to click on our heading, and you can see the blue box appears. For now, I just want to focus on the width. This heading has a width of 544 pixels, and the paragraph also has a width of 544 pixels. That is, they're both extending the full width of the page. The height of the heading is 37 pixels. So what's going on there? We would expect it to be 32 pixels. What's happening is that the browser has default line height properties. So if I go to our heading and just change the line height to 1 and refresh, you'll see that the height is now 32 pixels. And the same thing for the paragraph. It's currently got a height of 23 pixels. If I come and add line height of 1, its height, 20 pixels, now matches the font size. Continuing on our discussion of default block level element dimensions, I now want to look at container block level elements. I'm now going to wrap our H1 and paragraph with a div. So not only do individual elements span the full width of the page, but block element containers also span the full width of a page. And the height is the sum of font size and some margin. So jumping back into the index.html file, I'm going to go add a set of divs and nest the heading and paragraph inside of them. I'll then refresh the browser. I'll grab the inspector tool and grab the div. You can see the width, 518 pixels, extends the full width of the page, and the height, 73.44 pixels, is the sum of the font size of each element, as well as the space between the heading and the paragraph, which you can see in orange at the bottom. This is actually some default margin that has been applied to the heading and paragraph, which we'll be talking about later, and in fact removing. Let's now talk about the default inline level element dimensions. By default, inline level elements are just big enough to fit its contents both vertically and horizontally. Looking at some example HTML, in this case, I have an anchor tag and an image. I'll apply some font size to the anchor tag of 18 pixels. So for the anchor tag, the height and width are determined by the font size. And for the image, the height and width are determined by the image size itself. So like before, I've prepared this HTML file, which has an anchor tag, as well as an image, which I'm just grabbing off the web using an absolute URL. For the styles, I've just applied a font size of 16 pixels to the anchor tag. Let's check this out in the browser. So let's open up DevTools and check out these elements. The anchor tag has a width of 66.2 pixels and a height of 18.33 pixels. Again, there's just some default line height being applied to make it a bit larger than the font size we set. For the image, it has a width of 800 pixels and a height of 543 pixels. This is just the size of the image itself. It's an image which is 800 pixels by 543 pixels. So let's now talk about the width and height properties. The default box dimensions can be overridden by the width and height properties. Over here we have width set as 500 pixels. Width is the property, at 500 pixels is the value. Over here we have height set at 100 pixels. Height is the property, and 100 pixels is the value. So this is how they're used. They can override default dimensions or set dimensions where none exist. So let's first look at what I mean by overriding default dimensions. I'm going to pop the CSS file on the right here. I'm going to grab our image, and I'm going to give it a width of 100 pixels. This is a lot smaller than the default width we saw earlier. So what we'll see is the image will shrink. This is an example of overriding the default dimensions. That is, the default size of the image. To show you an example of setting dimensions when none exist, I'm going to go add a set of divs. Now, a div is a container element. It wraps other elements. Now, if there are no elements inside a div, the div won't have any height or width. The height or width is set by the elements inside it. So in other words, there are no dimensions currently on the div. However, we can add these. I'll grab the div, I'll give it a width of 300 pixels and a height of 200 pixels. Just so we can see this, I'm going to give it a background color of blue. So you can see now that our image is a lot smaller. We've set the width at 100 pixels. And this div has a width of 300 pixels and 200 pixels. We've explicitly defined dimensions on it, where ordinarily none would exist. So let's now take a look at some guidance about how to use the width and height property. We'll first take a look at block level sizing guidance, and looking first at individual elements, such as heading, paragraphs, and lists. For height, we usually do not set height, but let it be automatically determined. Instead, margins, paddings, and font size determines the height. We saw this earlier when we used font size on the heading and paragraph. That set the height, and it's very uncommon to set the height using the height property on individual block elements. For the width, we usually do not set width, which will stretch to fill the parent container. For container elements, like divs and sections, and other semantic container elements. For the height, again, we usually do not set the height, but let it be automatically determined. And again, this will be a combination of margins, padding, and font size, which will be both applied to the individual elements inside the container and the container itself. For the width, depending on the layout, it can be common to set a width. And in a moment, we'll be looking at an example of this. This approach ensures flexibility where content better adapts to different screen sizes. So although you can set the height and width on any individual element or container element, it is actually common not to do it that often, except for the width of container elements. So let's have a look at what I mean. Looking at this web page here, we have these 3 card elements. I'm going to zoom into one of them. In red, I'm going to be showing our individual elements, and in orange, I'll be showing the container elements. So starting with the individual elements, we have a heading over here and some paragraph text over here. Looking at the width of this, the content stretches the full width of the container. So on these individual block elements, no width is being set, it just stretches the full width. For the height is being determined by the font size. So again, height is not being explicitly set, it's just being automatically calculated based on the font size. Looking now at the container element, which I've outlined in orange, the height is the sum of child elements and some padding. In other words, the height is calculated from the font size of the individual elements and some spacing between them. For the container element, the width is set. The card on the page is not extending the full width of the page. A width is manually being set to achieve this layout. Let's now take a look at some inline level sizing guidance. Width and height can be set on some inline elements, but not others. Later on in this topic, we will be talking a bit more about this. But for now, let's look at inline elements we can apply width and height. They include images, inputs, select, text area, and button. Now I do want to quickly talk about the image, because it is an element we're often applying width and height to. Setting width or height will adjust the other dimension automatically to preserve the aspect ratio. The aspect ratio is just a ratio between the width and height. So if you do adjust one property, like the width, the height will scale automatically, so the image isn't distorted. Let's now look at inline elements where you can't apply width and height. These include spans, anchor tags, subscript, and superscript. I want to quickly focus on the anchor tag, as this is something we commonly style. Now, although we can't add width and height, it is common to use padding to create space around the anchor text. And we will be doing this later on in this topic. I want to quickly show you what I meant about applying the width and height property on images. In the file we were working on earlier, we have this image over here. I'm going to head to the CSS file, and for now just comment out this styling on the image, and refresh. So this over here is the default size of the image. I'm going to uncomment it, and just make the width 300 pixels. So you can see that the overall size of the image has been reduced. Not only the width, but also the height. And the image is not distorted at all. This is what I mean by aspect ratio, and that when you apply one property, the other property automatically scales. If, however, I set an explicit height, say 50 pixels, you'll see how this image completely distorts. So behind the scenes, if you don't apply height, it is actually automatically being calculated so that the image does not distort. Now, just to show you an example of how we can't apply width and height to some inline elements like anchor tags, on our anchor tag here, I'm going to go add a width of 500 pixels and a height of 500 pixels. I'll give it some background color just so we can see it. And let's choose yellow. I'll refresh, and you can see the background color has been applied, but no width or height has been applied onto our inline element. As I mentioned earlier, it's actually more common to style anchor tags with padding as opposed to setting explicit width and height. But later on in this topic, we'll be discussing this in a lot more detail, and we will see a method which will allow us to apply width and height properties onto all inline elements. So let's now go add to our summary card the CSS box model. In this chapter, we looked at the width and height properties. The width property looked like this, which sets a fixed width on our element, and the height property looks like this, which sets a fixed height on our element. So let's now take a look at applying dimensions on the Quill homepage. We're first going to apply a width of 100 pixels to our logo in the navigation bar. For the buttons, we will apply padding later, as we don't use the width and height property on anchor tags. Scrolling down the page, for the images, we're going to set a width of 400 pixels. And at the bottom of the page, we're going to set a width of 1000 pixels on our call to action container. You can see this is totally in line with the guidance I provided earlier, where it is sometimes common to apply a set width on a block level container, whereas the height is determined by the content and some padding. So we're not going to be explicitly setting height here. And again, for the button, we will apply padding later. In the footer, the Quill logo, we're going to give a width of 80 pixels. And for each social media icon, we're going to give a width of 20 pixels. And as we just saw earlier, the height will automatically scale. So let's now jump into VS Code and add this all. I'm in the index.html file for our Quill application. Now, the first thing I need to actually do is remove some width I added back in the HTML section. If you're joining me for the first time now, and as a quick refresher, back in the HTML section, I actually used the HTML attribute width to set the width of some images. For example, each of the images in our features section has an HTML attribute width. I did this just to make our HTML more manageable, because some of the images were just huge and were just getting in the way. Now, you can set width like this, but it really is not common and is not best practice at all. Setting width and height in CSS is the way to go. So I'm just going to go remove all the widths I set. I set them on these feature images, and down in the footer, I also set them on each social media icon, because these did appear massive. So I'm just going to go remove them all now. Okay, so now we have our images all in their original size. And just to remind you how big some of these were, let's go check this out in the browser. So you can see these feature images are absolutely massive in their original size, and the social media icons are also huge. So let's go now take care of these with CSS. So the first thing I want to do is go create a new logo component. So I'm going to scroll down to our component section, and at the bottom here, I'm going to create a new class called Logo MD, standing for medium. This will be the logo we'll use in the navigation bar. I'm going to set a width of 100 pixels. I'll also define another logo called Logo-SM for small, and this will have a width of 80 pixels, and we'll be using this in the navigation bar. The reason I want to make these as components is that the logo could appear in many other locations throughout the web application, so they're reusable pieces of UI which we'd consider components. Let's go add these classes to our HTML. I'll pop the CSS on the right here. I'll scroll to the top, and we have our image over here nested inside an anchor tag. Inside the image tag, right at the start, I'm going to go add a class, logo-md. I generally just like putting my classes right at the front. Let's also, while we're here, add the small logo class to the logo in the footer. So we have the image over here. I'll add a class, and this one is logo-sm for small. Next up, let's go handle the feature images. Now, those images aren't components, they're specific to the features section. So it's going to make more sense to add the styling rules in the features section. So I'm going to pop down here, add another class called feature-img for image, and we're going to set the width at 400 pixels. Let's go and add that class to our HTML. So for each image in the features section, I'm going to go add a class of feature-img, and I'll just copy and paste that for each image. The final item we need to handle are the social media icons. Now those icons are going to be specific to the footer and won't be reusable, so it makes sense to do that in the footer section down here. I'm going to add a new class, social-icons, and we're going to set the width as 20 pixels. Let's go add that in our HTML. So for each social media icon, I'm going to pop here, add a class, which was social icons. I'm just going to copy and paste that for each icon. The last thing we need to do is add the width on our call to action card. We already have a class defined here, CTA card. So inside that class, I'm just going to go add the width, which we said was 1000 pixels. All right, so that's our work done. Let's go check it out in the browser. So let's work our way down to see the changes. I'm going to open up DevTools and hover over the icon. You can see its width is now 100 pixels, and the height is being automatically calculated according to the aspect ratio of the image. Scrolling down, each of the feature images are now 400 pixels wide, and again, because they're an image, the height is being automatically calculated. I'm going to zoom out a bit, just so that you can see the call to action does actually have a set width of 1000 pixels, and you can see it's not extending the full width of the page. There's some space on the right here. And the wider I make the browser, the more space that appears. There's a fixed width of 1000 pixels on this card. Now later on, we will be improving this by centering it, adding padding, and rounding the corners. You can see that the logo in the footer has a width of 80 pixels, which we set, and each of the social media icons now has a width of 20 pixels. Now it's time to see how to create space between an element's content and its border by looking at padding. We'll be looking at what is padding, the longhand and shorthand padding properties, and padding design guidance. So what is padding? Padding is the space between the content of an element and its border to improve readability and visual design. Looking back at the artwork I introduced at the start of this topic, on the far left, we have a Banksy painting. In terms of the CSS box model, the artwork itself is the content. The rose gold frame is the border, and the space between the content and the border is the padding. For the LeBron James poster, there's just content. There's no border and no padding. And for the serial plant killer poster, we have the content, which is surrounded by a white frame, or in box model terms, the border. So there's no padding on this poster. The poster is touching the frame directly. In other words, the content is touching the border, with no padding between it. Let's now look at an example web page of where padding is used. Focusing on the 3 cards towards the bottom of the page. Each of them have content. There's a very thin grey border. And in between the content and the border, there's some padding. Looking at the navigation bar in the top right, inside our buttons, the hyperlinked text is the content, and the filled color space surrounding the content is some padding. In this case, there actually is no defined border, but there appears to be a border, which is just a contrast of the background white color to the filled color of the buttons. So let's now take a look at the padding properties. I'm going to zoom in on one of these cards. We'll first be talking about the longhand padding property. This sets the padding on individual sides. Again, we have the content over here, and a very light grey border running along the perimeter of the card. At the top, the space between the content and the border is 5 pixels, and this would be defined like this: padding -top 5 pixels. On the right, the space between the content and the border is 10 pixels, and in CSS, we'd write this as padding -right 10 pixels. At the bottom, between the content and the border, there's also 5 pixels of padding, and in CSS, we would define it as padding -bottom 5 pixels. And finally, on the left, between the content and the border, there's 10 pixels of padding, and this would be defined as padding -left 10 pixels. Now you have complete freedom to set whatever values you want. It just so happens that for this card, the top and bottom values are the same, and the left and right values are the same. Alright, so let's jump into VS Code and play around with padding. I've created an index.html file, and I've also linked an app.css file. Inside the HTML file, I'm just going to go add some divs. Heading over to the CSS file, I'll select these divs, grab our curly brackets, and I'm going to give this div some dimensions. Let's give it a width of 500 pixels and a height of 500 pixels. Just so we can see it, I'm going to give it a background color, and let's choose something a bit more funky, like khaki. So let's see what this looks like in the browser. So inside the browser, we can see our khaki colored box. Let's open up DevTools and inspect the element. You can see it has a width and height of 500 pixels. Let's now go and add some padding. Let's start with padding top, and let's give it a value of 50 pixels. I'll refresh the browser, and now when I hover over it, you can see this green box appearing at the top. That's the additional padding of 50 pixels. Now, something you're going to be using a lot in the DevTools is at the bottom down here. This is the CSS box model. In the center is the dimensions of the content, 500 pixels by 500 pixels. The next layer out is the dimensions of the padding. In this case, there's just a 50 pixel padding at the top. The next layer out is the border, which currently has no values, and then the margin, which also has no values. The colors are also really important. You can see that when I hover over the content, it's blue, which matches the blue 500 by 500 pixels. And you can see at the top, the padding there is green, which matches the color in this model down here. Now, this is incredibly common to use, because often in your CSS, you'll want to understand why things are displayed the way they are. And looking at this box model is a simple visual representation of what's going on. Let's go add the other values now. We'll add a padding right of 20 pixels, a padding bottom of 40 pixels, and a padding left of 10 pixels. I'll refresh, and when I hover over it now, you can see the green box, which is the padding, is surrounding our element. If we look at the box model down here, we can see the values as well, 50, 20, 40, and 10. So now that we've had a look at the longhand padding, let's take a look at shorthand padding, which is actually more common to use. Shorthand padding sets the padding on all sides at once. There are 4 ways to use it. You can set all sides at once, like this, where a padding of 20 pixels will be applied to all 4 sides, top, right, bottom, and left. This approach is very common. The second way of using it is setting vertical and horizontal padding. It would look like this, where the first value, 10 pixels, is the vertical padding, so the top and bottom, and the second value, 20 pixels, is the horizontal padding, left and right. This method is also very common. The third way of using shorthand padding is setting it on the top, horizontal, and bottom. It looks like this, where we have 3 values. The first value is the top padding, the second value is the horizontal padding, left and right, and the third value is the bottom padding. Now, this one is quite uncommon, and to be honest, I find it a bit confusing to use. The fourth way of using the shorthand padding is setting values on each side. It looks like this. The first value is the top padding, the second value is the right padding, the third value is the bottom padding, and the fourth value is the left padding. The way to remember this is you start at the top and you work clockwise around the box. So top, right, bottom, and left. This one is kind of common. The reason is because there will be times you need to use it. But the truth is, most of the time you're using padding, you're using consistent values. Whether that's a consistent value all around the elements or consistent values vertically and horizontally. So let's play around with these in VS Code. I'm back in the file we were working with earlier. Let's go and style 2 anchor tags, which will act like buttons. I'll add 2 anchor tags. For the first anchor text, I'll make it register. And for the second anchor text, I'll make it login. Let's head over to the app.css file. I'll select these anchor tags. And first of all, I just want to give them a background color. And again, I'm going to choose a bit more of a funky color like salmon. So let's check this out in the browser. So you can see down here, we have our 2 anchor tags. They appear next to each other because anchor tags are inline elements, and they only take up the width of the content. So you can see the background color has been applied to the content. Let's go and add some padding now. I'm going to use the shorthand padding, so just padding, and I'm going to set values vertically and horizontally. Let's give this a vertical padding of 20 pixels, which is the first value, and a horizontal padding of 40 pixels, which sets the left and right padding. So let's refresh. So you can see padding has been added, and the background color still applies to the padding. So let's check these out in the DevTools. I'm going to inspect the register button, and look at the CSS box model. You can see that the width and height are auto. The reason for this is that the anchor element is not given an explicit height or width, but are being automatically calculated. So they do actually have a width and height. If I hover here, we can see it's 133.32 by 58.33. But from the box model perspective, they're just automatically being calculated based on the size of the anchor tag. You can also see the padding is applied. We have 20 top and bottom and 40 left and right. Now, one thing I do want to comment on, which we'll be talking about in a lot more detail later, is how these elements are kind of overlapping the div. Now, I wouldn't expect this behavior. It's not something we've seen before. Usually elements kind of have this force field around them. This weird thing going on here has to do with the fact these are inline elements, and padding just applies a bit weirdly to inline elements. We'll be talking about this soon, so don't worry about it now. I did just want to point it out in case you were wondering why we're getting this overlapping behavior. It is something we will be learning about and correcting in a few chapters' time. So let's now have a look at some padding guidance. Padding is commonly used in buttons and text callouts to improve readability. Let's have a look at this example here. I'm going to zoom in on this blue text callout. I'm going to cover the content in purple, and you can see the surrounding space is padding. Let's zoom in on these buttons at the bottom, and in a similar way, we have the anchor tag text in purple, and the surrounding fill color is made up of padding. This is incredibly common, using padding to improve readability on callouts and buttons. Padding is also commonly used on cards. Having a look at this example here, I'm going to zoom in on these three cards. I'm going to cover the content in purple, which would be grouped together in a container element like a div. You can see that there's this gray outline border, and the space between the content and the border is the padding. Padding is also commonly used on inputs. Looking at this page over here, on the right you can see an input to subscribe for the newsletter. Let's zoom in on that and have a look. The placeholder text, enter your email, is the content, which I'll cover up in purple. There's a gray border going around the input, and the space between the content and the border is the padding. So padding is commonly used to improve readability across several elements, specifically text callouts, buttons, cards, and inputs. So let's wrap up by adding to our summary card the CSS box model. In this chapter, we looked at padding. We first looked at the longhand padding properties, where we can set the padding on each side of the element, with padding top, padding right, padding bottom, and padding left. We then looked at the shorthand padding property, and we saw there were four possible options. We can set a single padding value, which applies to all four sides. We can set two padding values, where the first 10 pixels applies top and bottom, and the second 20 pixels applies left and right. We then saw a third option, where there's three values. The first value of 10 pixels sets the padding at the top, the second value of 20 pixels sets the padding left and right, and the third value of 5 pixels sets the padding at the bottom. The fourth shorthand property, which has four values, sets the padding on each individual side at once, starting at the top and moving clockwise, right, bottom, and left. We also discussed the most commonly used shorthand property are these first two. So let's now go add padding on our Quill homepage. The first place we're going to add padding is on the text callout Mindful Living. The text Mindful Living is the content, and we have some additional space surrounding it, which is the padding. Looking now at the buttons in the center of the page, we have the text content Get Started and Learn More. You can see we also have a blue border going around this button, and the space around the content is the padding. Now we actually will be adding a blue border onto the main primary button. It's something we'll talk about a bit later, and we need to do it to ensure consistency between our buttons in different states. But I do just want to point out, we will actually be adding a border onto our primary button. Looking now at the buttons in the top right corner in the navigation bar, we have Login and Register, which is the content. Login has a border around it, and the Register button will also later have a border around it, and the space surrounding the content is the padding. Scrolling down the page, we're going to be adding padding to the text callout Simple and Easy. We have the text content, and the space surrounding it is the padding. Scrolling down to the bottom of the page, in the Call to Action section, we have the purple button Get Started. The Get Started text is the content, which is surrounded by some padding. The Get Started Now text and button are grouped together in a div, which we've previously given a width. So this is the content, And around the content, we've added some padding to improve readability. Now, before we code this up in our project, I do briefly want to talk about why on this call to action card, we're adding padding as opposed to just defining a specific width and height. If you looked at this element just like this, you may think the right approach is just explicitly defining a width and height of this card. But this is not the correct approach. The correct approach is applying width to the container element, which we've done, letting the height be automatically calculated based on the individual elements, in this case, the heading and the button, and then adding padding around the div. Let's play around in VS Code so I can show you why this is the case. All right, so I'm back in the file we were working with earlier. I'm just going to remove all this markup and add a new set of divs. Inside the div, I'm just going to put a heading 2 of welcome to the app, and I'm going to add some paragraph text. I'm going to grab the standard lorem ipsum text and get 3 lots of it. All right, jumping to the app.css file, I'm going to remove all these styles. I'm going to reselect the div. Let's give it a width of 800 pixels. I'm not going to touch the height, as we know best practice, as we discussed earlier. It's common not to add explicit height of a container element, but rather let it be automatically calculated based on the height of the individual elements inside of it. Let's add a background color of khaki. I'm then also just going to center the text. I'll use text align center, as this property is applied on the div and then inherited by the heading and paragraph. Let's jump into the browser and see what this looks like. All right, I'm just going to zoom out a bit so we can see what's going on. So let's first see what happens if I just add more width. Instead of 800 pixels, let's make it 1000 pixels. All that happens is the text stretches the full width now, and this doesn't look great. I'll change it back to 800 pixels. And as I mentioned before, it's very rare you want to set the height on a container element. You want the height to be determined by the individual elements of the heading and paragraph. So let's go add some padding. And as this is a card, it's common to set equal padding on every side. I'll set a padding value of 50 pixels. So you can see this massively improves the readability. There's now space going around the card. It's like height and width have been added, but the text remains in the center and there's space around it. The text isn't butting up against the edges. So this approach of adding padding to an element to increase its height and width is very common. All right, so I'm back inside our Quill project. Let's head over to app.css and go add padding to those 3 different locations. I'm going to scroll down to the components, and the first place we're going to add padding is on the button. I'm going to use the shorthand padding, and I'm going to use 2 values. The first value is for vertical padding, which I'm going to add 15 pixels. And the second value is for the horizontal padding, which will be applied left and right. Now, it is actually in fact quite common for padding on buttons to pick a vertical value and then double it horizontally. It's generally a good rule of thumb to do this. Now, just a comment, I'm adding padding to the button class because this is the class which sets up the structure of our buttons, whereas all these other versions are the different kinds of buttons, like primary and secondary, which mainly deal with colors. Let's scroll down to the highlight. And again, I'm going to apply the padding on our structural highlight class, because this padding is applied to every single highlight, irrespective of if it's a primary, secondary, or tertiary highlight. I'm going to grab the shorthand padding again, and again, I'll be setting 2 values. I'll set 5 pixels vertically, top and bottom, and I'll set 10 pixels horizontally, left and right. The last place we need to add padding is in our call to action section. We have this class CTA card, where currently with text aligning center, we've got the background color, and we've added a width of 1000 pixels. So let's go add our padding. And again, I'm going to be adding 2 separate values. I'll add 100 pixels vertically and 200 pixels horizontally. All right, so let's check this out in the browser. All right, this is starting to come to life now. You can see the padding has been added to the highlights, which has massively improved the readability. And also the padding has been applied to our primary buttons, also improving the readability. Don't worry for now that it's overlapping with the Learn More button. We're going to be styling this and taking care of it soon. Let's scroll down to the call to action section. So our CTA card is also looking great. The readability is improved and it really pops out a lot more by adding padding. And you can also see padding has been applied to the purple button, improving its readability. Now it's time to learn how to outline and define the edges of an element using the border property. We'll be discussing what is border, longhand and shorthand border properties, individual border properties, and border design guidance. So what is a border? A border creates a visible boundary around an HTML element and can enhance visual appearance and separation from other elements. We'll keep adding to the artwork analogy we've been using so far. On the frame picture on the left, the artwork itself is the content, the white space surrounding it is the padding, and then finally, the frame is the border. For the LeBron James poster, all we have is content. There's no padding or frame around it. For the artwork on the right, the poster is the content, and the frame directly touches the content. So we have a border surrounding the content. And in this case, there is no padding, so a border can touch the content directly, just like in this artwork. Let's look at how border is used on this web page. Over here, we have a border, which is separating the navigation from the main content of the page. On each of the cards, we also have a border, which is used to nicely contain the information of each card. So let's now look at longhand border properties. This sets the individual border properties and applies to all 4 borders. The first is width, which defines the border thickness. In CSS, it looks like this. The property is border-width, and the value in this example is 5 pixels. The default value of border width is 0 pixels, which means by default, every HTML element does not have a border because its width is 0 pixels. The values you can use include pixels, ems, and rems. Now don't worry about ems and rems, we'll be talking about them later. And in fact, pixels is the most common value to use in any case. The next border property is style. This defines the border line styles. In CSS, it looks like this. Border-style is the property, and in this example, the value is solid. The default value of border style is none, meaning that for every HTML element, not only is it 0 pixels, but there's no border style set. The possible values for border style include dotted, solid, dashed, and double. In just a bit, we'll be playing around in VS Code, so you can see how this all looks, but I'm sure you can imagine what a dotted line will look like. The final longhand border property is color, which as you can imagine sets the border color. In CSS, it looks like this. The property is border-color, and the value in this example is red. The default value is just the element color. So what I mean by this, if you were to set a border width and style but not a color, the color of the border will just be the same as the color of the element. So for example, if you had a green heading, the border would also be green. The values you can use for this are your typical color values like RGB and hex. So let's play around with this in VS Code. I've prepared an index.html file, as well as an empty style sheet called app.css. I'm going to add a div, and I'm just going to leave it empty. In app.css, I'm going to go select the div. Let's give it a width of 500 pixels, and a height of 500 pixels. Let's also give it a background color, just so we can see it, of khaki. Let's now add our border properties. We'll first add border width, and let's give it a value of 10 pixels. Next, we'll add border style, and let's give this the value dotted. And for border color, let's just give this a value of black. All right, let's check this out in the browser. So you can see our khaki box, and we have a 10 pixel dotted black border. Let's check this out in the dev tools. I'll select the element and scroll down to the CSS box model here. You can see that the width and height of the div is 500 by 500. There's no padding, and the border is 10 pixels all the way around. And as I mentioned, it's dotted and black. Let's play around with the style. I'm going to change this to double. I'll refresh, and you can now see we have a double-lined border, which kind of looks like a frame. Now that we've had a look at the longhand border property, let's have a look at the shorthand border property. This sets all the border properties in one go and applies to all 4 borders. And this is in fact the more common approach. It looks like this. We have the property border, and then there's 3 values you can set. The first is the width, the second is the style, and the third is the color. It's just the 3 different properties we saw before, all merged into one single property. And as I mentioned, using this property is very common. So let's play around with it in VS Code. So let's just merge these 3 properties into one, using the shorthand border property. I'll grab border, I'll give it a width of 10 pixels, a style of double, and a color of black. I'll remove these styles, I'll refresh, and you'll see there won't be any changes. I'm going to remove these, just so we can play around with some other values. Let's set a border of 30 pixels, a style of dashed, and the color red. And you can see how this looks now in the browser. Using this shorthand property is by far the most common way of setting borders. It's incredibly compact and easy to use. Now, there's one more way you can set borders, and that's using individual border properties. This sets all the border properties in one go and applies to one border at a time. So it's just like the shorthand border property we just looked at, however, it only applies to one border at a time as opposed to all four at once. It looks like this. We have the border-top property with the same three values as before, border width, style, and color, and this border would look something like this. We then have border-right, and in this case, 2 pixels dashed blue, which would look something like this. The next property is border-bottom, and in this example, it's 1 pixel dotted red, which would look something like this. And the final property is border-left, which is 10 pixels double and green, which would look something like this. So let's play around with these border properties in VS Code. So for now, I'm just going to comment this out. Let's go add a border top of 10 pixels, solid and green, a border right of 20 pixels dashed and blue, a border bottom of 5 pixels dotted and red, and a border left of 30 pixels, double and purple. So you can see now the different styled borders on the four sides. So in summary, there are a few ways of setting borders. However, this one we saw earlier is the most common. It's not really that common to set individual borders, as usually we have a consistent border style that's applied to all four sides. So we use the shorthand border property, which is also the most compact. So let's now take a look at some border guidance. Borders help with grouping related content. For example, on this page, a border is used around the card. This piece of content is a testimonial, and the border is effective in grouping all the different elements together, like the logo, text, and image. Individual borders help separate sections. Looking at this example here, we have a border between the logos at the top, which is a section used to build trust, and the heading and images below, which looks like a feature section. So the border here is effective in creating a clear division between these two different sections. Borders can create outline buttons, which are commonly used alongside solid filled buttons. For example, on this page, you can see next to the Book a Demo button, which has a gray solid fill, we have over here an outline button. This button is almost the reverse of the filled button. Now I want to talk more about how the outline button is actually implemented, because when we add an outline button to our design, we actually need to make some modifications to the fill button to make the design consistent. It is common to add a border on a fill button which matches its background color when used alongside an outline button. So what do I mean by all this? Let's say we have a fill button that looks like this. The anchor text is Get Started and there's a blue background color. In the case of the outline button, it would actually look like this. Now I've purposely made the thickness of this border very large to emphasize the problem. You can see the Get Started outline button actually will appear larger than the filled button. So to make our buttons more visually consistent, border with the same background color is added. So we end up with a filled button that looks like this. And now the buttons will be consistent in height and width. So let me show you this inside VS Code. I'm back inside our index.html file. I'm going to add 2 anchor tags. I'll give the first one the anchor text filled, and the second one the anchor text outline. I'm just going to leave the href value empty, as I don't actually need these to link anywhere for this demonstration. What I will do is add some classes here, as we are going to style them in a sec. I'll give the first one a class of button filled, and I'll give the second one a class of button outline. So let's jump into the app.css file. I'm going to select the button filled first. I'll remove the text decoration. Let's give it a background color of blue, a font color of white, and padding of 20 pixels vertically and 40 pixels horizontally. Now I'm not going to add the border just yet because I want to show you the problem. On the button outline, I'm just going to copy these properties. I'm going to change the background color though to white because it's the opposite of our filled button, and the color here to blue. The button outline, I am going to add the border. So let's add a border of 10 pixels, solid and blue. So let's check this out in the browser. So you can see here what I mean. The outline button has this blue border that goes around it and makes it appear much larger than the filled button. So to fix this, all we need to do is add the same border to the filled button. So I'm just going to copy this border and paste it here. Let's refresh, and you'll now see that our buttons are much more consistent in styling. Now again, just to point out, we do have that weird thing happening as we discussed earlier, where our buttons are kind of overlapping the div. Don't worry about that just yet, we will be talking about it soon. For now, I just want you to focus on this approach, where whenever you add an outline button, which is the opposite of the filled button, you have to go and add the same border onto it so that your buttons are consistent in their styles. So let's finish up by adding to our summary card the CSS box model. In this chapter, we looked at border. We first looked at the longhand border property, where we set the border width, border style, and border color independently. We then looked at the shorthand border property, where we're able to set the width, style, and color in one go. And we saw that this was the most commonly used border property. We also looked at setting individual borders, where we could set border top, border right, border bottom, and border left independently. So let's now go add border to the Quill homepage. We're going to be using border on our buttons. We're going to go define the outline button style, and then we're going to go add the same border to all our other buttons so that our buttons are consistent. So let's jump into VS Code. So I'm in our app.css file. I'm going to scroll down to the components section where we have our buttons. So just a reminder of how we're doing this. We're first defining a btn class, which just sets up the structure of every single button, where these styles are the same across every button, like the font size, text decoration, and padding. We've then defined two different buttons, the primary button and secondary button. And for each of those, we've grouped together two separate states, link and visited as one state, and hover and active as the other state. So what I want to do is now go define a primary outline button. And I'm first going to do the link and visited states. We'll give this a class name of btn, primary, and then outline. And the first pseudo class in this group is link. For the second class, I'm just going to copy this and change link to visited. I'll grab our curly brackets, and let's define the specific styles of this button. So let's first add the text color. The text color is going to be the exact opposite of the values we have inside the button primary link and button primary visited. So all I'm going to do is grab the value we're using here for the background color, which will be the text color of the outline button. For the background color, again, it's the opposite. So on our primary filled button, we have a background color of this blue and a text color of this white, which means that the background color of our outline button will now be this white. I'm then going to add a border using the shorthand border property. We'll give it a thickness of 2 pixels. It will be solid, and the color will be the same as the text color. So I'll just copy this value and paste it there. So that's the first group of pseudo-classes complete for our primary outline button, the link and visited pseudo-classes. Let's now go add the other group of pseudo-classes. I'm going to change link to hover and change visited to active. So just as a reminder, this is what happens when we hover over the button and click it. So for these colors, I'm now just going to do the opposite of what we have for our primary button for the hover and active pseudo-classes. So on our primary filled button, the background color is this darker shade of blue. So that value will now become the color of our outline button. The background color will keep white. We don't want that to change. And for the border, we should update its color to be the same as the text color here. So I'll copy this value and paste it here. So we now have 3 different styles of buttons. We have our primary filled button, a primary outline button, and a secondary filled button. So before we check this out in the browser, we need to go add these classes in our HTML. So I'm going to pop over to index.html. Inside the navigation bar, we have the button login. So I'm going to add a class here. I'll first grab the btn class, which sets up the structure of the button. And then I'll add the specific styling to the outline button, which is the class btn primary outline. We then also have the outline button on the button learn more. So I'll just copy this class and paste it over here. So let's check out our work so far in the browser. All right, so this is looking really cool. We've now got our outline buttons next to our filled buttons. Now ignore the fact they're overlapping each other and not looking great. We'll sort that out in a bit. 2 things I want to comment on. The first is how the pseudo classes are working. When I hover over the button, you'll see it changes to a darker shade of blue, both the text learn more and the border. So that's working really nicely. The second comment is you can see the problem I've been speaking about. because we're adding a border on this outline button, it's appearing visually inconsistent with the filled button. If I zoom in quite a bit, you can see it's just slightly wider, and that's because of the border being added onto the element. So let's go fix that now. To fix this, we need to add a border onto all our filled buttons. So let's start with the primary button. I'm just going to copy this border property here and paste it here. Now, we actually don't need to make any modifications to this. It's the same thickness and style as our outline button, and the color's also fine. The color needs to match the background color of our filled button. For the hover and active pseudo class of our primary button, I'm going to go copy this border here and paste it here. And again, we don't need to make any modifications. It's the same thickness and style as the outline hover and active pseudo class, and the background color matches the background color of the primary filled button. So all we're doing here is just adding on a little bit of border, which is the exact same as the background color of our primary filled button in its different pseudo classes, so that it appears visually consistent when next to the outline button. Now at the moment, we don't have a secondary outline button, so adding a border here is not totally necessary, but just to keep everything consistent, I am going to add the border, because we've done that on our primary filled button, and just in case we add a secondary outline button later on in the project. So let's go get the border property. It'll be the same thickness of 2 pixels, it will be solid, and the border color is just the same as the background color. For the hover and active pseudo class, we'll use the border property. It'll be the same thickness, the same style, and the color will be the same as the background color. So let's check this out in the browser. Alright, this is looking much better. You can see our Learn More outline button is looking a lot more visually consistent with our filled button. And even though you can't notice it, there is in fact a border that's been applied onto the Get Started secondary button down here. Let's open up DevTools to have a look. I'm going to go select the button, and I'm going to scroll down here to the box model. You can see the padding here and that 2-pixel border. But to the naked eye, it just looks like some background color that's been applied to the padding. But in fact, we have padding and a border which is the same color in both states. You can see the link in visited state, and when I hover over, you can see the hover and active state, where again we have some padding with the shade of purple, and a border as well with that same shade of purple. It's now time to dive deeper into border by learning how we can add rounding to it with border radius. We'll be discussing the border radius property, how border radius works, hills and circles, and border radius design guidance. So what is border radius? Border radius rounds the corners of an element's border. So let's look at an example. In the top right corner of the Get Started button, you can see that there are rounded corners. And for the image on the left, there are also rounded corners. The border radius CSS property sets the border radius value. So border-radius is the property, and in this case, 12 pixels is the value. Values you can use include pixels, ems, rems, and percentages. Now, so far, we've only looked at pixels, and we will be talking about ems, rems, and percentages in the next topic. But it turns out for border radius, pixels is actually the most commonly used. Now, one thing that was never really taught to me is how border radius actually works. So I'd like to give you the experience I didn't have of having it explained properly to you. The way it works is a quarter circle is placed in the corner of an element, and the cutout rounds the element's corner. So let's say we had this rectangular element, and we set a border radius of 10 pixels. What's happening is that in each corner, a circle is placed like this. We then focus on the quarter circle that is in the corner, like this. The border radius value of 10 pixels is the radius of this circle. So this distance here is 10 pixels. This wedge over here, the space between the quarter circle and the corner of the element, is then cut out. So we're left with an element that looks like this, where rounding has happened on the corners. As another example, let's say we had the same element, but now applied a border radius of 20 pixels. The same thing happens. Circles are placed in the corner. We focus on a quarter circle. The radius is 20 pixels. And then the space between the quarter circle and corner of the element is cut out. And again, we can see rounding over here, where because the border radius is larger, there's more rounding. Let's play around with this in VS Code. I've got an empty index.html file, and I've already linked a style sheet, which is also empty. In index.html, I'm just going to create an empty div. In app.css, I'm going to select this div with the type selector. I'll give it a width of 500 pixels and a height of 200 pixels. Let's also give it a background color, and let's choose a bit more of an interesting color like plum. So this div will currently have square corners. So let's go around the corners by adding the border radius property. Let's give it a value of 20 pixels. All right, let's check it out in the browser. So here you can see our div, and the corners are now rounded. I'm just going to comment it out to show you what it would look like without rounded corners. Okay, I'm going to add it back in, and let's now increase the value significantly to see how it impacts the element. Let's change it to a value of 50 pixels. So you can see that the corners are now more rounded. Now there are two specific cases I want to look at when rounding corners. The first is called pills. Pills have fully rounded corners that are created from rectangles by setting border radius equal to half the element's height. So let's have a look at what I mean here. Let's say we have a rectangular element like this. Its width is 200 pixels, and its height is 100 pixels. So half the element's height would be 50 pixels. So we then set the border radius to be 50 pixels. Now because we're setting the border radius as half the height of the element, there are in fact only two circles inside this element now, not a circle in each corner. And instead of looking at quarter circles, we're now looking at semicircles, because the radius of each circle is 50 pixels. And again, we look at the space between the semicircle and the corners of the element, which is then cut out. And this leaves us with a shape that looks like this, a pill. Just like the pill you would take if you had a headache. You can see a pill has fully rounded corners. It's like a semicircle on each end. So let's play around with this in VS Code. So let's work in the file we were in before. We have a height of 200 pixels, so I'm now going to set the border radius to half the height, which would be 100 pixels. And let's see what this looks like. You can see now we get fully rounded corners. Now, just a small note, if I try to increase this value further, like 120 pixels, you'll see that there's actually no effect. The border radius kind of has a cap, which is half the height or width of the element, depending which one is smaller. The next special case I want to look at is circles. Circular elements are created from squares by setting border radius equal to half the element's height. So for circles, the element we're working from is not a rectangle, but a square. It's got an equal height and width. Let's say it's 100 pixels. Half the element's height, or width, because it's the same thing, would be 50 pixels. So if we set a border radius of 50 pixels, what this would mean is that there's one circle in the middle, which has a radius of 50 pixels. And then the same thing happens. The space between the circle and the element's corners is cut out, which leaves us with a perfect circle, which is fully rounded. So let's see this in VS Code. In our CSS file, I'm going to change the width to be 200 pixels. So now we'll have a square with a width and height of 200 pixels. Half the width and height would be 100 pixels, so I'm going to set the border radius to 100 pixels. And as you can see, this gives us a perfect circle. So let's now discuss border radius guidance. Square corners are more formal. We've seen this page previously, which sells pot plants at a premium. Because they want to come across as a more luxury brand, you can see that the corners are square corners. There's no rounding happening. Rounding corners can be perceived as more friendly. For example, on this page here, you can see the buttons have rounded corners, and it appears a bit less formal and a bit more friendly. Fully rounding corners can be perceived as playful. Taking a look at this page here, you can see the buttons have fully rounded corners, which fits this design really nicely. This design is very playful and colorful, and fully rounding the corners fits in nicely with this design. Now it is important to have consistent rounding across all elements. So for example, you can see we have similar rounding on both the button and image. Now the values actually used on the image and button would be different. You can see the image is much larger, so it would require a larger border radius value. But proportionally, they do have a similar rounding when looking at the page. So let's wrap up by adding to our summary card the CSS box model. In this chapter, we looked at border radius. We saw the property, which was border-radius, with a unit value. We saw that applying a border radius creates rounding on our corners. And we saw that half an element's height gives us fully rounded corners. So let's go and add border radius on the Quill homepage. In our highlights, we have rounding in the corners, And on all our buttons, we also have rounding. Scrolling down the page, you can see again in our highlight, we have rounding. And at the bottom of the page, our call to action box has rounding in the corners. And again, there's rounding on our buttons. So let's jump into VS Code and add border radius. So I'm back inside the quill app.css file. I'm going to scroll down to the components, and I'm first going to add border radius to our btn class. I'll grab the border radius property, and I'm going to give it a value of 8 pixels. There's no exact science to this, you just need to play around with values until you find one that looks right. And for me, that was 8 pixels. And just to make it super obvious, the reason I'm adding border radius onto the btn class and not the specific buttons like primary, outline, or secondary is because border radius is part of the structure which will be seen on every single button. So it makes sense to add it here, along with the other properties like padding, etc. Let's scroll down to our highlight. And just like the btn structural class, I'm going to go add the border radius here, which will be applied to all our highlights. And because this is a smaller component, I'm going to give it a border radius of 4 pixels. Again, it's a value I played around with that I thought looked nice. The final place we need to add border radius is on the call to action card. So I'm going to scroll down to the call to action section, and inside the CTA card class, I'm going to go add border radius. And because this is quite a large element, I'm going to choose a larger border radius of around 20 pixels, which again, I played around with earlier and it looked nice. Now, before we go and look at this in the browser, border radius is one of those properties we want to keep note of in our style guide. So I'm going to scroll to the top, and inside our style guide here, I'm just going to copy this heading. I'm going to come below the colors, and I'm going to add the heading border radius. And the values so far we've used are 4 pixels, 8 pixels, and 20 pixels. As the project expands, these are values we might want to pull from, or we might want to add some other values. But it's a good idea to keep track of the different border radius values that we're using. All right, so let's check this out in the browser. For me personally, border radius makes a massive difference to the visual impact of a design. The highlight element really looks nice with this slight border radius, and the buttons are really starting to take shape as well. Scrolling down, the call to action section also looks a bit more friendly with the corners rounded. Now let's dive into controlling how the box model calculates the size of elements using box sizing. We'll be discussing default box dimensions, the box sizing property, border box, and box sizing design guidance. So to get an understanding of box sizing, we need to get an understanding of the total box dimensions. By default, the total width and height of a box will be the sum of the content width and height, padding, and border. So let's have a look at an example of what I mean here. Let's say we had an element that looked like this, and the CSS rules were defined like this. You can see this element has a width of 500 pixels, a height of 200 pixels, a padding of 50 pixels, and a 10 pixel border. I'm going to illustrate each of these on our element. In purple, we have the actual content. From our CSS rule, this has a width of 500 pixels, some padding either side of 50 pixels, and the border width is 10 pixels. So the total width of our element would equal 2 lots of 10 pixels from the border, 2 lots of 50 pixels from the padding, and then the content width itself, which is 500 pixels. If we were to add this all together, we would get a total width of 620 pixels. Now, if I were to do the exact same thing for the height, we would get a total height of 10 pixels plus 50 pixels plus 200 pixels, plus 50 pixels, plus 10 pixels, which would give us a total height of 320 pixels. I'm going to call the total width and total height calculated values. They're calculated because I had to sum up the width and height with the respective padding and border. It's not so obvious just looking at the CSS to see instantaneously what the width and height of the element will be. It involves a bit of calculation. Now, it's not the most complex maths, but you do need to add up some values. Let's have a look at this in VS Code. All right, I've got an empty index.html file, and I've already hooked up a style sheet called app.css, which is currently empty. Inside the body, I'm just going to go and add an empty div. I'm going to give it a class called box1. Heading over to app.css, I'm going to select the class box1. I'll give it a width of 800 pixels, a height of 400 pixels. Let's give it a padding all the way around of 50 pixels and a border, which will make 10 pixels solid and black. Let's also give it a background color of plum so that we can easily see it in the browser. All right, let's check it out. So here are our boxes. I'm going to open up DevTools and I'm going to inspect the box. Scrolling down to the box model, you can see that the properties have been applied. 800 by 400, a 50 pixel padding all the way around, and a 10 pixel border all the way around. You can see that when I click the HTML here, it's showing the total dimensions, 920 by 520. Now the 920 is coming from the width of 800 plus 2 lots of 50 pixels for the padding left and right, which gets us to 900, plus 2 lots of 10 pixels for the border left and right, which gets us to 920 pixels. And the same thing for the height. The 520 pixels is coming from the height of 400 pixels, plus 2 times padding of 50 pixels, plus 2 times border of 10 pixels. So the takeaway point here is that by default, the dimensions of an element will be the sum of the width or height plus padding plus border. Now this behavior is actually defined in the CSS box sizing property. The box sizing property modifies how the total width and height of an element are calculated. It looks like this. Box-sizing is the property, and in this example, border-box is the value. The values we can have are content box or border box, where content box is the default value. And this is what we've seen so far, where the dimensions are calculated by adding the width and height, plus any padding, plus any border width. However, border box is the more commonly used value. So let's have a look at these in more detail. We'll start with content box, which is the default value, and it's the behavior we've seen so far. If we set a width of 500 pixels, it means that the width of the content will be 500 pixels, and any padding and border is added on top of this. So the total dimensions is the sum of content, padding, and border. In this case, the set width and height will be smaller than the total width and height of the box. So what I mean by that is the width we're defining in our CSS property will always be smaller than the total width, because the total width will include the width as well as padding as well as border. I also want to highlight that the actual content dimensions are unchanged. The width of the content is always 500 pixels. So content box is the default behavior we've seen so far. Let's now talk about border box. For border box, if we set a width of 500 pixels, what this means, we'd actually end up getting something that looks like this, where now the total width is actually 500 pixels. That is, the content, padding, and border width all add up to 500 pixels. You can see when I add in these orange lines, the big difference between content box and border box. In content box, the width is just the width of the content. In border box, the width is the total width of the content, padding, and border. So in border box, the total dimensions include content, padding, and border. For border box, the set width and height will match the total width and height of the box. In border box, because the width includes content, padding, and border, it straight away is the total. So setting a width of 500 pixels in CSS will immediately give you the total width, which is very different to content box, which is being calculated, which is the sum of the content, padding, and border. Now, in order for border box to work, the content dimensions need to reduce. It's kind of like the content is getting squashed a bit because the width is now the total width, which needs to include the border width and the padding, which in a sense is kind of squashing the content so it all fits inside the set width. So now that we've compared content box and border box, let's look at the border box value in more detail. This is the setup we had at the start. Now I'm going to update the CSS to include the box sizing property with the value border box. Just as a reminder, the default value is content box, but I'm now changing this to border box. So by doing that, this is what will happen. The whole element will shrink. The width of 500 pixels, the set values of our width match the final box values. So the total width now is 500 pixels. So now we're going to work backwards. The total width is 500 pixels. The border is still 10 pixels, so we'll drag that up into our calculation. The padding is still 50 pixels, so we'll drag that up into our calculation. And for this to mathematically work, the width of the content has to be 380 pixels. So that when we sum this all up, we get a total width of 500 pixels. and I want to highlight that the content dimensions have reduced. Doing the same thing for the height, the calculation would look like this. Total height equals 10 pixels plus 50 pixels plus 80 pixels plus 50 pixels plus 10 pixels equals 200 pixels, where again, the content dimensions have reduced. So before, the total width and height were called calculated values. For the border box property, we can call them set values. Now when looking at the CSS properties, we have a width of 500 pixels, a height of 200 pixels. We can see straight away what the total width and height of our element will be. We don't need to do any calculations of the element in the browser. Let's play around with this in VS Code. In our index.html file, I'm just going to add another empty div, and I'm going to give it the class box2. In app.css, I'm just going to copy this rule. I'm going to paste it over here, and I'm going to update the selector to box2. I'm going to leave all the values, but just add in the box sizing property. And I'm going to set the value to border box. Now again, the default value is content box. So you could explicitly define it here, like that, but there really is no need. So I'm just going to remove it. All right, let's check this out in the browser. So as you may expect, our second box is now smaller than our first box. And that's because the width is actually the width we're defining over here. The total width of this box is 800 pixels. Whereas for box 1 above, the total width is the width of 800 pixels plus the padding either side plus the border either side. Let's check this out in DevTools. I'm going to select the second box, and you can see the little pop-up above the box in the browser is showing the total dimensions of 800 by 400 pixels. If I compare that to box 1, the total dimensions there are 920 by 520 pixels. Jumping back to box 2, let's go look at the box model. You can see the border is exactly the same as what we set. The padding is the same as what we set, but the width and height have both been reduced. So in a nutshell, by default, the total width and height will be the sum of the width and height values plus the padding plus the border. But when we set box sizing border box, the total width and height of the elements are immediately set with width and height. The padding will be the same, the border will be the same, and to make this mathematically work, the actual content will reduce. So let's now discuss box sizing guidance. In almost every single project, you'll want to set the border box property on the Universal Selector. As a reminder, the Universal Selector sets the border box on all boxes. So in other words, every single element will have border box applied to it. And in fact, this is usually one of the first things to do in a new CSS document. Now, the reason we want to do this is because it's much easier setting values in CSS and knowing that those will be the total values in the browser. If we didn't change the box sizing to border box, setting values in the CSS, it would actually be a lot more complicated to know how the final dimensions of your elements will look in the browser. So let's wrap up this chapter. Now I'm going to do something I really don't like doing, and that is starting the next summary card without finishing the one we've been working on, the CSS box model. So I'll now be starting the summary card, setting global rules with the CSS box model. Now the reason I'm doing this is because I don't want the material we discussed in this chapter on the CSS box model summary card. We're going to finish that off in the next chapter when we learn about margin. I've had to order the topic this way, that we discussed box sizing now, as it has to do with the content, padding, and border, which we've already covered. So in this chapter, we looked at box sizing. We first looked at the value content box, which in CSS looked like this, box sizing content box, and this is where the set width is the width of the content only, and content box is the default value. So let's say we applied a width of 500 pixels to our element. This would be the width of the content shown in purple. We could then apply padding and border, which would be added on top of this width of 500 pixels. So the total width and height of our element would now be more than 500 pixels, as it includes padding and border. The other value we looked at was border box. In CSS, it looks like this, box sizing border box. This is where the set width will be the sum of content, padding, and border. So having box sizing border box and a width of 500 pixels will look like this. Our content will shrink so that the content, padding, and border have a width of 500 pixels. And we can see the difference very clearly between the two by adding in these orange lines, where for content box, we can see the width of 500 pixels is just the content, where for border box, it's the content, padding, and any border. So let's now apply the box sizing property on the Quill homepage. Essentially, every single element is going to have the border box property. All right, let's jump into VS Code and add in the box sizing property. So inside our app.css file, I'm going to come right to the top, and we actually already have a comment about adding in the Universal Selector here. So I'm going to remove this. I'm going to add the Universal Selector, grab our curly brackets. I'll grab the box sizing property and add the value border box. Let's check this out in the browser. Now immediately, the difference won't really seem that significant. But let me just show you a place where something significant has changed. This call to action section will now have the width we actually set. If you remember earlier on, we're setting the CTA card with a width of 1000 pixels. So now the total width of this card will be 1000 pixels. Let's check this out in DevTools. I'm going to select this element. And you can see on the pop-up there, the width is 1000 pixels. Looking at the box model, you can see the padding is the padding we set in the CSS, 200 horizontally and 100 vertically. And you can see that the width is being reduced. It's 600 pixels. Now, just a small comment. You can see that the Get Started button is kind of cutting into the padding a bit. The source of this issue is the same we've seen earlier, where our buttons at the top are overlapping. We will be sorting this out soon. Now let's jump back to our Universal Selector, and I'm just going to comment it out to show you the impact it's had on the CTA section. I'll refresh, and now you can see the width of the CTA card is now a lot bigger. It's 1400 pixels wide. This is the default box sizing value of Content Box, where the width 1000 pixels is being summed up with two lots of 200 pixels for left and right, giving us a total width of 1400 pixels. So I hope you can see why we want to be using box sizing border box. It means that whatever values we're setting in our CSS will be the total values in the browser, making the size of elements much more predictable. Moving forward through this topic, we'll now learn how to create space between elements by adjusting the margin. We'll look at what is margin, the longhand and shorthand margin properties, and margin design guidance. So what is margin? Margin is the space outside of an element's border, creating distance between it and neighboring elements. Let's take a look at the artwork analogy we've been using throughout this topic. To recap what we've learned so far, we'll start with the Banksy artwork on the left. The painting itself is the content. The area surrounding the content is the padding. And the frame of the painting is the border. For the LeBron James poster, all we have is the poster, so the content. There's no padding and no border. And for the framed poster on the right, the poster itself is the content, and there's no padding. The frame is directly touching the poster, so we just have border. Now margin is the distance between each of these artworks. It's equivalent to how you would space the paintings on your wall in your home. So let's look at an example of margin being used on a web page. I'll first highlight the different containers of elements. We have a navigation menu, some big heading text, a paragraph, a button, and a small piece of text over here. Now margin is used to separate each of these elements. We have some margin between the navigation menu and the big heading text. We have margin between the heading text and the paragraph, and we have margin between the paragraph and button. There would also be some margin from the bottom of the small text all the way to the next element below the content we see on this page. So as you can see, margin helps create distance between elements. So let's check this out in DevTools. First up, I'm just going to zoom out a bit. I'm then going to open up DevTools. And let's start by looking at the big heading. In the CSS section, if I scroll down to the box model, you can see over here, this has a margin of 50 pixels at the top and 24 pixels at the bottom. Let's have a look at one more element to see how margin's being applied. If I hover over this paragraph, you can see an orange box below. So we have some margin below this paragraph, separating it from the button below. So let's now look at how we define margin in CSS. We'll be starting off with longhand margin. Just like with padding, where we had longhand and shorthand, longhand margin sets the margin on individual sides. If you remember from the padding chapter, it's the same thing, where we have a longhand version and a shorthand version, which we'll see soon. So let's take a look at this card to understand longhand margin. The area in purple is the content, the red line is the border, and the green area is the padding. So let's go add some margin to separate this from other elements. We'll start with the top by adding a margin of 5 pixels. In CSS, that would look like this: margin-top 5 pixels. On the right, we'll add some margin of 20 pixels. This would be margin right, 20 pixels. We'll add 5 pixels on the bottom, so this would be margin bottom, 5 pixels. And we'll add 20 pixels of margin on the left, and this would be margin left, 20 pixels. Adding each of these margin values creates a kind of force field around the element, so other elements would be positioned around this force field. So let's play around with margin in VS Code. I've got a blank index.html file, and I've linked up a CSS file, app.css, which is currently blank. In the HTML file, I'm going to add 2 divs, and I'm going to give it a class of box1, and the second one a class of box2. Inside the app.css file, I'm going to select box1. I'll give it a width of 500 pixels, a height of 500 pixels, and a background color of salmon. I'll copy this and paste it here, update this to box2. I'll leave the width and height properties, and let's give this a color of khaki. Alright, so let's check this out in the browser. Alright, so you can see, as expected, we just have 2 stacked boxes. Let's now go add margin to box 1. We'll start with margin top and give it a value of 40 pixels. I'll refresh the browser. You can see the box has visually moved down, as we've added 40 pixels to the top. Let's go add values to all the sides. We'll add margin right of 20 pixels, margin bottom of 50 pixels, and margin left of 30 pixels. Let's refresh, so you can see now this force field appearing around the box. Let's open up DevTools to see how this looks in the box model. I'll click on the element, and you can see in orange the margin all around the element. Now, just a quick note, for margin right, it isn't so obvious that there is a margin here because there's no element currently next to it. And actually, being able to place block elements next to each other is something we still need to learn about. So I just wanted to highlight that although it doesn't look like there is any margin, because there's no element next to it, there is margin being applied, which we can see in the box model in DevTools. So now that we've looked at longhand margin, let's take a look at shorthand margin. This sets the margin on all sides at once. There are 4 different cases. The first one is setting all sides in one go, and that looks like this: margin of 20 pixels. The 20 pixels is applied to all 4 sides at once. Using this is quite common. Next up, we have applying margin vertically and horizontally, and that looks like this, where the first value, 10 pixels, is applied vertically, that is margin top, margin bottom, and the 20 pixels is applied horizontally, that is margin left, margin right. Using this is also common. The next case is applying margin top, horizontal, and bottom, and it looks like this. The first value of 10 pixels is applied to the top. The second value of 20 pixels is applied horizontally, so margin left and margin right. And the third value, 5 pixels, is applied to the bottom. Using this is fairly uncommon, so don't worry too much about it. The fourth case is applying margin to each side in one go, and it looks like this. The first value is the top, the second value is the right, the third value is the bottom, and the fourth value is the left. So we're starting at the top and working our way around clockwise. Using this is kind of common, as there may be some use cases where you do want different margin values on each side. So let's jump back into VS Code and play around with this. I'm going to get rid of these longhand margin properties we played with earlier. So let's do the first case, where we use the margin property and define a single value which will apply to all sides. Let's do 50 pixels. So as you can see, 50 pixels has been applied to all sides of our element. The second case was where we had vertical and horizontal. So let's do 30 pixels for the top and bottom and 60 pixels for left and right. And you can see how 30 pixels has been applied top and bottom and 60 pixels left and right. The third case, which wasn't that common, was applying first margin to the top, which I'll do 20 pixels, then horizontally, so left and right, let's do 40 pixels, and then the third value was the bottom. Let's do 60 pixels. Checking it out in DevTools, we can see how these values have been applied: 20 to the top, 40 left and right, and 60 to the bottom. The last case was applying a value for each side. We start at the top with 10 pixels. Let's move to the right, 20 pixels. At the bottom, 30 pixels. And on the left, 40 pixels. Checking this out in DevTools, you can see 10, 20, 30, 40 have each been applied, starting at the top and working clockwise. So let's now look at some margin guidance. We use margin to apply white space between groups of elements. On this web page here, we have our main heading and paragraph text, where we have a small margin in order to keep the text close together. Whereas for the button and image over here, the different elements are further apart. So we use a larger margin value to apply white space between these elements. So in other words, some elements we want to keep close together, like a heading and paragraph, so we use a small margin value, whereas other elements we want further apart, so we'd use a larger margin value. We also use margin to apply white space between sections. On the same web page, we have a section over here, and we have another section down here. You can see that in this case, there's a lot of white space between sections. So it's very common to use much larger margin values between sections in order to keep them distinct. Now, it is common to control spacing between elements with margin and other more modern techniques. On this web page, we have our navigation and our main heading. And the spacing between these elements is handled by margin. Now, these cards down here also have spacing between them, but this is handled by other techniques we're going to learn about later. Okay, so let's jump back to our summary card, the CSS Box Model, and finish it off by adding in margin. We first looked at the longhand margin property, where we set the margin on each side of our element through margin top, margin right, margin bottom, and margin left. I also mentioned I like using margin bottom to create white space between different elements. We also looked at the shorthand margin property, where similar to padding, there are 4 possible options. The first is setting a single value, which adds the same value of margin on all 4 sides of our element. The second option is using 2 values, where the first value, 10 pixels, is margin top and bottom, and the second value, 20 pixels, is margin left and right. The third option is using 3 values, where the first value, 10 pixels, is margin top, the second value, 20 pixels, is margin left and right, and the third value, 5 pixels, is margin bottom. And the final option is using 4 values, which sets the margin on each side, starting at the top, moving right, bottom, and left. And we discussed the most common use of the shorthand margin property is the first 2. So let's go and apply margin to the Quill project. On the home page, we have the navigation menu over here and the main heading over here. Between these elements, we'll be applying margin. We have the paragraph element here, where between the heading and the paragraph, we'll also be applying some small margin. And between the paragraph element and the buttons, we'll also be applying some small margin. We'll then be using a large margin value between the bottom of the buttons to the next section of the page. Now in the navigation bar, the spacing between the logo and the buttons, and between the buttons themselves, will be handled by other techniques we'll be learning about later. For the features section of the page, we have the main heading, and as I mentioned before, we'll have some margin separating the bottom of the buttons above to this main heading. For the feature containers, we have 3 sets of these, 1 here and 2 below. We'll be applying some small margin between the heading and the top of the first feature container. And for spacing between all the elements inside the feature container, we'll be using other techniques we'll learn about later. For the bottom of the page, we have the Get Started call to action card. There'll be some margin between this and the bottom of the last feature container on the previous page. We'll have some small margin between the Get Started Now text and Get Started button. And we'll also have some margin between the bottom of the call to action card and the footer. For spacing inside the footer, we'll be using other techniques we'll learn about later. Now, before we jump into VS Code and add margin, we need to talk about the idea of a spacing system. This is where we define specific spacing values that are used throughout the project. We start with a base value, like 10 pixels. This is called our base unit. We then use multiples of this unit to define our spacing system. So we start off with increments of 5, like this, giving us the range from 5 to 30 pixels. We can then use increments of 10 pixels, giving us values from 40 to 100 pixels. We then increase the increment to 25 pixels to give us 125 pixels and 150 pixels. We then increment the value by 50 pixels to give us 200, 250, and 300 pixels. And then finally, we increment by 100 pixels to give us 400 pixels and 500 pixels. So this now gives us a predefined spacing system that simplifies the design process and ensures consistency. So when we're thinking of margin values when we're coding this up, we have a system we can refer to instead of trying to continually make them up. And it also ensures consistency, where similar values will be used throughout the project. Now, I've just defined this specific spacing system. This makes sense for me, but of course you have complete freedom to choose whatever values you like. As a general rule of thumb, you will have more of the smaller values, as this provides more control for smaller spaced elements, where generally larger margin values, you don't need such fine tuning. So let's go and code this up. So I'm back inside our Quill project, inside the app.css file. The first thing I want to do is add the spacing system in our design guidelines in this comment. I'm going to copy border radius, paste it down here, and change the heading to spacing system. I'm going to add in the values we just looked at previously, 5 pixels, 10 pixels, 15 pixels, and to avoid boring you, I'm just going to add them all now. Okay, so I've added in all the different pixel values for our spacing system, so we have an easy place to reference them up the top here. So let's start with the margin between the navigation and the main heading. Now, to make this easier to see when we make changes, I'm just going to open up the index page on the Quill homepage. So first, let's add the margin between the navigation and this heading. So I'm going to scroll down to that section, and I'm going to add a margin bottom to this navigation. Now, you could also add a margin top to this heading, but I prefer using margin bottom values when adding margins, and I'll be using that for every single element. Whichever approach you use, whether it's margin top or margin bottom, just be consistent. It makes your code a lot cleaner. Now, I don't yet have a section for the navigation menu, so I'm just going to copy this and call it navbar. In our HTML, the navigation menu is inside the semantic nav element. I'm just going to add a class to this and call it navbar. So the navbar class will select the entire navigation menu, including the logo and buttons. So let's go select that, navbar, and let's add a margin bottom of 200 pixels. Let's refresh, and you'll see now we get some nice spacing between the navigation bar and this major heading. And again, I'm using a value of 200 pixels, which is inside our spacing system. Let's now add some small margin between the heading and paragraph. You will notice that there actually is margin there already. If I open up DevTools and inspect the heading elements, you can see in orange some margin top and bottom. This has been applied by default and is something we're going to correct soon. But you can see for now, this heading text and paragraph text look a bit disconnected. So we want to apply a small margin value to group them better visually. Now to achieve this, I'm going to add a margin bottom to our heading over here. It'll be a small value that will bring this closer together. If we head to our index.html file, our heading currently doesn't have any class, so we won't be able to select it. So let's go add a class of hero heading. I'll copy this text, I'll select the class, and add a margin bottom of 10 pixels. So let's refresh, and you'll see that the paragraph now moves closer to the heading. Next up, let's create some space between the buttons and this paragraph. So to do that, I'm going to add some margin bottom to the paragraph. I first need to add a class to the paragraph in the HTML so that I can select it. Let's call it hero paragraph. I'll copy that, select the class, and let's add a margin bottom of 100 pixels. Let's refresh, and you'll see now some white space between the paragraph and the buttons. So this is looking good. We've added a small margin value between our main heading and paragraph, grouping that content together. We've created some distance between our navigation and heading text over here. We've also created a bit of distance between the paragraph and the buttons. The last thing we need to do is add some margin between our entire hero section and the start of the features section here. Back in the HTML, we have our hero section inside the semantic section element with the class hero section. with the next section being the features section over here, all inside the main semantic element. So what we're going to do is add margin bottom to the hero section. We have that class already selected over here. So let's just go add margin bottom. And because we're creating some white space between different sections, so I'm going to use quite a large value of 300 pixels. So you can see by doing that, we get large white space between the different sections. The hero section over here and the start of the features section over here. Now looking at this, I've noticed that I think these buttons are too far away from this paragraph text. So what I'm going to do is update the margin bottom on the paragraph text to something like 50 pixels. So let's refresh and see how it looks. Okay, that looks a lot better. The text is still grouped nicely, and we have a bit more distance between our buttons over here. Now, that iterative process I just went through is very common when applying margin. You'll just experiment with different values until it just looks right to you. So let's scroll down to our features section. All of the spacing for each of these containers, so this feature container here, this feature container here, and this feature container here, is going to be handled by other techniques we're going to look at later. So I'm not going to worry about spacing of any of these elements just yet. Let's just add some small margin to this heading over here so that we can create some space between it and the start of this container. Inside our HTML, we've already defined a class for this, features main heading, which we can see over here. So let's just go add some margin bottom, and let's give it a value of 80 pixels. Nice, so that creates just a bit more space between the primary heading and the first feature container. The last thing we need to do for the features section is add some margin between the entire features container and the call to action section. Jumping back to our index.html, we essentially need some margin between this section, the features section, and our call to action section. So we're going to be applying some margin bottom on the section element. Currently, we don't have a class for that, so let's go add one, and we'll call it class features section. I'll copy that text, head to app.css, and because I'm selecting the whole container, I usually put that right at the top. So I'm going to add it there, and we'll add a margin bottom, again of 300 pixels, just like we did between the hero section and the features section up here. So let's refresh, and you'll see we now have a good chunk of white space between the features section and the call to action section. Now the last thing we need to do is add some margin between the call to action section and the footer at the bottom. In our index.html, we have the call to action section, all contained within the HTML section semantic element, and we have the footer down here, all contained within the footer semantic HTML element. So all we're going to do is add some margin bottom to the entire call to action section. We already have a class for that, CTA section, which was actually commented out earlier on in the course. So I'm going to add that back in, and we're going to add margin bottom, and because we're trying to create a lot of white space, again, I'm going to use a large value of 300 pixels. And you can see that creates a nice amount of distance between the call to action section and the footer. So let's take a look at what we've done here. You can see adding margin to CSS makes a significant difference to how the web page looks. The use of white space helps group related elements together, as well as separate other elements. We have nice space between our navigation bar and our heading. We've grouped these nicely together. We've created a bit more space between the buttons and the paragraph. We've created a nice amount of white space between the hero section and features section. We've separated this heading from the first features container. We've created a nice amount of white space between the features section and call to action section. And we've also created a nice amount of space between the call to action section and the footer. Now, before we finish up, I just want to highlight something. Most of the work we did here was just adding margin vertically, where I used the margin bottom property. As I mentioned, you could have used margin top. I just prefer using margin bottom, and whatever you choose, just make sure you're consistent. Now, the process of just using margin vertically is actually fairly common. We're going to be using other techniques, which we'll be learning about in the Flexbox and CSS grid section, to help us with layout and spacing within different containers, like this feature container here. When we get up to that, there are other properties that help us with spacing. Margin is typically used to help us separate between major sections. And in fact, we're going to see later, we'll be using other techniques instead of margin to create space between different elements like our heading and our paragraph and buttons. That is, the smaller values of margin we used. margin is typically the most useful in creating lots of white space between different sections. So between the hero section and the features section, or the features section and the call to action section, and the call to action section and the footer. That is where margin is most commonly used. Now it's time to learn how to control the layout and visibility of elements with the display property. We'll be discussing how the box model applies to block and inline elements, the display property, the inline block value, and display design guidance. So before we start looking at the display property, I want to do a quick refresh on what are block and inline elements. All HTML elements are by default either a block or inline element. Looking at block elements first, their main feature is they always start on a new line, and we can represent them like this. They also take up the full width of a page. And here are some common block elements. For inline elements, these do not start on a new line, unless they come after a block element. And that's because the block element extends the full width of the page, so pushes the inline element onto a new line. And we can represent inline elements like this, where they're able to butt up against each other. Unlike block elements, they only occupy the width of their content. And common inline elements include these ones here. So now that we've recapped block and inline elements, let's talk about block elements and the box model. Block elements follow the box model rules, so applying any properties work as expected. So I'm going to represent a block element with this purple box here. It could be any block element, like a heading, paragraph, or div. We can apply width to the block element. We can apply height to the block element. We can apply padding to the block element. We can apply a border to the block element. And finally, we can apply margin to the block element. All these properties work as expected. Let's play around with this in VS Code. So I'm in a new index.html file. I've grabbed the boilerplate, and I've also linked up an app.css file, which is currently empty. I'm just going to go add a div, which we know is a block level element. In app.css, I'll select this div, and I'm just going to go add all the different box model properties. Let's give it a width of 500 pixels, a height of 500 pixels. We'll give it a background color so we can see it. Let's do light coral. We'll give it some padding of 50 pixels, a border, which will make 10 pixels solid black, and finally some margin all around it of 100 pixels. So let's check this out in the browser. So as expected, nothing crazy going on here. For block level elements, all the box model properties apply. Let's confirm this inside DevTools. I'll inspect the element. We'll go down to the box model. We'll see the width and height has been applied, padding's been applied, the border's been applied, and the margin's also been applied. So for block level elements, everything works as expected when applying box model properties. So now let's look at where things get a bit interesting. And that's inline elements and the box model. Inline elements do not follow the box model rules, so applying some properties do not work as expected. In purple here, I'm representing an inline element. This could be something like an anchor tag or a container element like a span. So for width and height, this cannot be set. The width and height of the inline element will just be the width and height of the content. We can't manually override the width and height with the width and height properties. For block elements, we can. If this was, for example, a heading and it had a width and height set by its own content, we could still then apply the width and height properties to override those values. But we can't do this for inline elements. Let's now take a look at padding. For padding, it applies but only pushes content away horizontally. We'll see exactly what this looks like inside VS Code soon. Let's now take a look at border. For border, just like padding, it applies but only pushes content away horizontally. And we'll see exactly what this looks like inside VS Code soon. Let's now take a look at margin. For margin, it only applies horizontally. So no margin is applied vertically. To get a better understanding of what this all means, let's jump into VS Code and play around. I'm back in the file we were working in before. I'm just going to get rid of this div and get rid of the styles here. I'm now going to add a chunk of paragraph text. I'll grab the p tag and I'll type lorem times 40 to get a whole bunch of paragraph text. I'm going to go towards the middle of this chunk of text, and I'm going to add some span tags, which we know are inline elements. I'll wrap this word in the span. And let's just give it a class of inline element to make it clear for us. I'm now going to head over to app.css. I'll select this element. It had the class inline element. And let's just start by giving it a background color. I'll choose light green. So let's check this in the browser, and we'll continue to add box model properties and see their impact. All right, so here's that stan element we've given a green background color. So let's go add a height and width. I'll give it a height of 400 pixels and a width of 400 pixels. I'll refresh, and you'll see absolutely nothing has happened. And that's because for inline elements, width and height don't work. Let's now give it some padding. I'm going to apply 100 pixels top and bottom, and 100 pixels left and right. I'll refresh, and as you can see, the padding has been applied. The green extends 100 pixels top and bottom and left and right. However, it's only pushed content horizontally. You can see this word here and this word here have been pushed away from our span, but the text below and above has not moved. Let me just comment out the background color, so you can better see now that the text above and below is still present. It's only left and right that the text being pushed away. And if I turn background color back on, you can see that the padding has still applied, but it's having a weird effect, only pushing content away horizontally. I'll now add a border. Let's do 20 pixels, solid, and red. I'll refresh, and again, the same thing is happening. The content horizontally, that is this word here and over here, have been pushed further horizontally, but there's been no impact on the content below or above. It's staying in place. The last property is margin. Let's apply 100 pixels top and bottom and 100 pixels left and right. I'll refresh, and look what's happened here. The margin has simply not applied top and bottom, but it has applied left and right of the content. You can see over here, there's 100 pixels between the edge of the border and the word over here. And there's also 100 pixels between the edge of the border and this full stop or period over here. So long story short, there's just some weird stuff going on with applying box model properties to inline elements. And we're going to see soon how we can correct this, as being able to apply box model properties to inline elements is important. So let's now take a look at the display property. This sets how the element is formatted and positioned. It looks like this, where display is the property, and in this case block is the value. The values can be block, inline block, flex, and grid. The value block is the default value for block elements, and inline is the default value for inline elements. So for example, a heading, which is a block element, by default has a display property of block, whereas an inline element, like an anchor tag, has by default display inline. Now, not that you would do this, but you could change the inherent behavior of these elements. So for example, a heading, which is a block element, I could add the CSS property display inline, and this changes the heading to an inline element now. The other value inline block we'll be talking about now, and the other values flex and grid form their own topics later on in the CSS section, as there's a lot to talk about with those display values. So let's now have a look at the value inline block. This combines features of block and inline elements, and it helps correct some of the issues we saw earlier, where box model properties were applying very weirdly to inline elements. To understand inline block, let's quickly recap how CSS box model properties apply to block and inline elements. For block elements, the CSS property is display block, which again is just default for block elements. Block elements start on a new line, and they take up the full width of the page. For the box model properties, width and height can be set, padding applies as expected, border applies as expected, and margin applies as expected. For inline elements, the display value is inline, and again is set by default on inline elements. Inline elements do not start on a new line, and they only occupy the width of their content. For the box model properties, width and height cannot be set, padding only pushes content away horizontally, border only pushes content away horizontally, and margin only applies horizontally. So let's now talk about inline block. The display value for this is inline block. Inline block takes the inherent display properties of inline. That is, it does not start on a new line, just like inline properties, and it only occupies the width of their content, just like inline properties. So an inline block element is exactly like an inline element. However, when applying CSS Box Model properties, inline block takes all the good stuff from block, in that width and height can be set, padding applies as expected, border applies as expected, and margin applies as expected. So the display value inline block helps solve the problems we saw when applying CSS Box Model properties to an inline element. Inline block gives us an inherent inline property, which we still need, but allows us to apply Box Model properties as expected. Let's take a look at this inside VS Code. So just as a reminder, this element over here is a span, which is an inline element. And by default, its display value is set as inline. Let's go explicitly set it though. Display inline. If I refresh the page, nothing will happen, because by default, this is an inline element. Let's now change it to block. I'll refresh, and you can see that this inline element, the span, has now been overridden and becomes a block element, where all these properties are applying as expected. That is, it has height and width set, padding set, border set, and margin set. So it's behaving exactly like a block level element. Also note that just like a block level element, the element starts on a new line. And because of this, we don't see any other text from the paragraph before it or after it. It's on its own line. Let's now change this to inline block. I'll refresh and watch what happens. So all the box model properties still apply as if it were a block element. That is, it has height and width, it has padding, it has border, and it has a margin. But the big difference now is that it's still inherently behaving like an inline element. That is, it is not starting on a new line. You can see we have text to the left and right of it, because with inline elements, they don't start on a new line. You can have other content surrounding it. So inline block fixes the issues we saw earlier. We're able to apply CSS Box Model properties, but the element still inherently behaves like an inline element, where other content can appear to the left and right of it, because it doesn't start on a new line. So let's now talk about how we use inline block elements by looking at some guidance. It is common to apply inline block to inline elements so they can flow inline, but all box properties can be applied. When I say flow inline, all I mean is that they can go next to each other. And for box properties, we're specifically talking about padding, border, and margin. Looking at this web page as an example, these buttons over here are anchor tags, which are inline because they're appearing next to each other, but also have box model properties applied, like padding and margin. Another example is this text over here in the heading. We'd use inline block on a span when applying padding and when margin is needed. So the word focus over here would be wrapped inside a span element, so that we could apply things like padding, background color, border, etc. So it's important that the span element remains inline so that it appears next to the word revenue, but we still need to apply those box model properties. So as a general rule of thumb, we're usually applying inline block to most inline elements on our web page. Now before we finish up, I want to talk about something called replaced inline elements. These are inline elements where the content is sourced externally and is not part of the HTML markup. To understand this, let's first talk about regular inline elements. As we know, they do not start on a new line. They only occupy the width of their content. Width and height cannot be set. And padding, borders, and margin do not apply as expected. Examples of regular inline elements include anchor tags, span, subscript, and superscript. Now let's talk about replaced inline elements. Just like regular inline elements, they do not start on a new line, and they also only occupy the width of their content. But with box model properties on replaced inline elements, they apply as expected. Width and height can be set, and padding, borders, and margin apply as expected. Replaced inline elements include the image tag, input, select, and text area. So replaced inline elements, as the name suggests, is when the browser is actually replacing the HTML element with something else. So for example, in the HTML markup, we put an image tag, but on the web page, we actually have a real image. It's being replaced. Same with the input tag. In the HTML markup, we have input, but then on the real web page, an actual input field renders. the input tag is being replaced by an input field, where I'm able to type something into the box. So replaced inline elements, in a nutshell, there's a subset of inline elements called replaced inline elements, and the most common ones we use are image and input, whereby the box model properties do apply just like a block element. So let's check this out in VS Code. I'm back in our app.css file, and I'm going to remove this display property. This will default back to a regular inline element. And as you know, we're going to have a whole bunch of issues when trying to apply the box model properties. In the index.html file, I'm going to add an input, which, as I said before, is a replaced inline element. You can see it down the bottom here. Now it's replaced because an actual input box is rendering on the page. The tag input is being replaced by something else. In this case, an input field. Let's give it the class replaced inline element. I'm going to head over to app.css and select it. Let's now go apply some box model properties. Let's give it a width of 400 pixels, a height of 50 pixels, padding 100 pixels top and bottom, and 100 pixels left and right, a border of 10 pixels solid green, and margin of 50 pixels top and bottom, and 50 pixels left and right. I'll refresh, and you can see all the box model properties have applied to this replaced inline element. Let's double check that in DevTools. So you can see over here, the width and height's been applied, padding's been applied, border's been applied, and margin's been applied. So long story short, just be aware that there's this thing called replaced inline elements where the box model properties do apply. And the most common replaced inline elements we're going to be working with are images and inputs. So for those, you don't actually need to apply inline block. Whereas for things like anchor tags and spans, we should be applying inline block so that they can behave like an inline element, but we're also able to apply the box model properties as we'd expect them to work. So let's finish off this chapter by adding to our summary card, setting global rules with the CSS box model. In this chapter, we looked at the display property. To summarize what we've learned, I've made this table where I have the different values as columns, block, inline, and inline block. And in the rows, in purple, I have behavior, and in orange, I have box model properties. So let's start with block elements. For block elements, they start on a new line. They take up the full width of the page. Width and height can apply. Padding applies as we'd expect. Border applies as we expect. And margin applies as we expect. For inline elements, they don't start on a new line. They don't take up the full width of the page or container. You can't set width and height. Padding doesn't apply as we'd expect. Border doesn't apply as we'd expect. And margin doesn't apply as we'd expect. Now, none of this should be new to you, but what is new is the new display value inline block, which retains the inherent behavior of an inline element, but allows us to apply box model properties. So for inline block, it doesn't start on a new line, and it doesn't take up the full width of the page or container, just the content of the inline element. So an inline block element keeps all the inherent characteristics of an inline element. But inline block now applies box model properties how we'd expect. We can set width and height, padding applies as we'd expect, border applies as we'd expect, and margin applies as we'd expect. So let's go and add the inline block element to our Quill project. So let's identify the different inline elements we need to do this for. The first are these buttons over here, which are anchor tags. By default, they're inline elements, so we're going to change them to inline block so that box model properties apply to these as expected. The text mindful living currently sits inside a span, which is also an inline element, so we're going to change that to an inline block. So again, box model properties will apply as expected. In the top left, we have our Quill logo, which is an image. For the image, there's no need to set to inline block, as it is a replaced inline element. If you remember from earlier, replaced inline elements, like images and inputs, are inline elements where the box model properties do apply as expected. Further down our page, we again have a span over here, so we need to update that to inline block. The image over here is a replaced inline element, so we don't need to update that because the box model properties will apply as expected. And at the bottom of the page, this button over here is an anchor tag, so we need to update that to inline block. So let's jump into VS Code and make these changes. So I'm back inside our app.css file. In our global styles over here, I'm going to scroll down to the anchor tag and change this to display inline block. Because this is using the type selector on the anchor tag, all anchor tags will now become inline block. I'm then also going to go select the span element using the type selector. And I'm going to change this to display inline block. And this will ensure any span element has the display property inline block. Now, I've applied these display properties globally. I want all my anchor tags and all my spans to display inline block. This ensures any future anchor tags or spans I add will have this applied. Now, I could have applied the display property inside these components. Our button class is being applied on the anchor tag. So I could have added display inline block over here. The only problem is that that only covers buttons. There could be other kinds of anchor elements I add later that I also want to be inline block. And the same thing with this highlight component. I could have added display inline block over here, but that would only cover this particular component. Whereas what I want is to globally apply inline block to my spans and anchor elements. So it covers me for all future cases, where I might add another specific span component later on. So let's check this out in the browser. Now, before I refresh to see the impact of changing to inline block, I want to highlight some of the issues we were having before. The most obvious one is because the box model properties do not apply to inline elements, that is, these anchor tags over here, they're kind of overlapping. So that's what this issue has been caused by, these being inline elements. And you can see the same thing over here. I'm going to refresh the browser now, where we'll see the impact of changing these to inline block. Beautiful. Finally, we've fixed this issue. The buttons no longer overlap. The box model properties are being applied as expected. Now, with the highlight, the change here is quite subtle, but something is happening. I'm going to comment this out to go back to this span being an inline element. Now, if you remember, for inline elements, box model properties apply quite funny, where for padding, it is applied, but only pushes content away horizontally. So the word to and a are pushed further away. But for top and bottom, any content is not pushed further away. I'm going to uncomment this and refresh. And I want you to pay close attention to the word app. So I'll save and refresh. And although subtle, the word app has now moved down slightly because the padding is now moving content away vertically. So long story short, it's just best practice to apply inline block to your regular inline elements so that box model properties can apply as expected. Now, one thing I want to clarify before we finish up, which may cause a bit of confusion, is why these buttons are appearing stacked like this. This is block level behavior, not inline element behavior. And by changing to inline block, if you remember, it preserves the inline nature of the element. So they should appear next to each other. Now, the reason is because of how it lives in our HTML. Inside our HTML, these anchor tags, the inline elements, are being wrapped by list items inside an unordered list. A list item is a block level element. So the block level element is what's causing the buttons to be on their own line. Whether the anchor tag is display inline block or its default of inline doesn't make a difference. The fact that it's in a list item is what's causing this to happen. I just wanted to highlight that changing it to inline block is not causing the behavior of its stacking. It's just how we've structured it in the HTML. And if I actually remove this from the list item, like this, from the unordered list, and place it there, and place this one below it, you'll see that they actually do go in line. So I just wanted to highlight that in case you were thinking about why that's happening. And really just emphasize that applying inline block keeps the inline nature of the element, but allows us to apply CSS box model properties as we'd expect them to apply. Let's now look at how to ensure consistent styling across different browsers by looking at CSS Reset. We'll be discussing browser default properties, CSS Global Reset, and Normalized CSS. So let's first discuss the browser default properties. Browsers have built-in CSS default rules that style HTML elements. For example, on the body tag, there's a default 8 pixels of margin. For a heading 1, it has 21 pixels of margin top and bottom, a 32 pixel font size, and 700 font weight. For a paragraph tag, it has 16 pixels margin top and bottom, 16 pixels font size, and 400 font weight. For the ordered and unordered list tags, there's 16 pixels margin top and bottom, and there's 40 pixels left padding. These are just some of the common HTML elements, but as you can see, the browser gives them default styling rules. So let's check this out in VS Code. So I've got a new index.html file, and I've already linked up an app.css style sheet, which is currently empty. Let's go add some elements. I'll add an h1 and give it the text heading 1. I'll add a paragraph and put in some placeholder lorem ipsum text. And let's add an unordered list. We'll add 3 list items and just say list item 1, list item 2, and list item 3. So let's check this out in the browser. So I'm straight away going to open up DevTools, and let's select the different elements. Let's start with the heading. You can see straight away in orange above and below the margin. On the box model, you can see that 21 pixels has been applied top and bottom, which is the default styling. You can also see the H1 has a default font size of 2 ems. We haven't actually covered em units yet, and we'll be doing that in the next topic. But for now, you just need to know an em is 16 pixels, so 2 times 16 is 32 pixels, which is the default font size for heading 1. And you can see the font weight over here is bold, which is a value of 700. Let's move on to the paragraph. So I'm going to go select it. And again, you can see there's orange above and below. And if we look at the box model, you can see 16 pixels has been applied top and bottom. And let's finally check out the unordered list. You can see there's orange top and bottom, which is the margin. And you can see green on the left, which is the padding. Let's check it out in the box model. You can see for padding, there's 40 pixels on the left. And a reason the unordered list and ordered list has padding left is to allow space for those bullets. And again, we can see 16 pixels of margin top and bottom. So as you can see, browsers apply default styling rules. So let's now talk about CSS Reset. It is very common to strip away the main default browser's styles to give us a blank canvas to work from. So the global reset looks like this. Using our Universal Selector, which selects every single HTML element, we apply a margin of 0 and a padding of 0. And doing this removes all default margin and padding. And we've already covered box sizing border box earlier. So doing this will strip away all the default margin and padding applied to every single HTML element. It gives us a blank canvas to work from. In addition to global resets, there are also element resets. And that would look something like this, where, for example, on our anchor tag, we remove that default underline by setting text decoration to none. And on our unordered and ordered lists, we remove the list style. That is, we remove those bullet points, as we're commonly using lists as a structural unit to build things like navigation bars. So let's jump into VS Code and apply the global resets. I'm back in index.html. I'm going to head over to app.css. I'm going to use the Universal Selector to select every single element, and I'm going to set margin to 0 and padding to 0. So let's check this out in the browser. So as you can see, it looks quite different. There's now no margin or padding applied to our elements. I'll just comment this out to remind you what it looked like before. So you can see here the default margin and padding applied. Let me just put it back. So doing this now gives us a blank canvas to work from. We can go now and add our specific styles. Now, something interesting I want to highlight is that it looks like those bullets have been removed, even though I didn't apply a list style none. Those bullets are actually still there. They're just kind of overflowing the document. Let me show you. If I grab the unordered list and put a margin left of 100 pixels, you'll see that those bullets are still there. So we do need to make sure to apply some element resets, like list style none, to remove the bullets. Now, another option, which takes a slightly different approach to a reset, is using Normalize CSS. Normalize CSS creates uniform default styles for HTML elements without removing all styles like a reset does. Normalize CSS is a large CSS file that's added to your project. We grab it online, which I'm going to show you in a second, but I do just want to highlight this approach is slightly different to a reset. Instead of completely removing default styles like margin and padding, Normalize CSS does have default styling, but its aim is to create a uniform experience across different browsers, because different browsers will sometimes have different default styling. So let's take a look at Normalize CSS. All you do is head to Google and type in Normalize CSS. Hit the first link, and we're taken to the normalized CSS page, where it says a modern HTML5 ready alternative to CSS resets. Normalized CSS makes browsers render all elements more consistently and in line with modern standards. So all we do is hit download, and it gives us this fairly large CSS file. I'm just going to hit Command A to select all of it, and then Command C to copy it to my clipboard. Let's head into VS Code now. So I'm back on the index.html file we were working in before. I've got our app.css file, which we did the reset. And now I just want to comment these out. I'm then going to go to the Explorer tab and create a new CSS file. We'll call it normalize.css. And then I'm just going to paste from my clipboard the normalized CSS file I copied before. And as you can see, it's quite a long file with 340 lines of code. Just to look at one line of it, I'm going to go Command F and search for an H1. You can see the font size is 2ms, which is 32 pixels. And you can see this comment above. Correct the font size and margin on H1 elements within section and article context in Chrome, Firefox, and Safari. So this is a good example of what normalized CSS is doing. It's setting a font size of 2ms, which is 32 pixels, across Chrome, Firefox, and Safari. So no matter which browser you're viewing your web page on, the H1 will always be the same size. To include normalized CSS in a project, you would come and add it just like you would any other style sheet. I'll grab the link tag by typing link, and normalized CSS is sitting inside our current working directory. So I'll just type norm to get normalized.css. Now it's important that this style sheet is included first. So any other styles that we add ourselves in app.css will override the styles set in normalized CSS. So let's check this out in the browser. So you can see normalized CSS has made a few changes to the document. To better see this, I'm just going to comment this out and refresh the browser. By doing this, we can see the default styles. And if I go on the body tag, you can see that there's a bit of margin of 8 pixels all the way around. And as we know from before, our headings and paragraph also have default margin. I'm going to turn back on normalized CSS and refresh. You'll see on the body tag, there's no longer any margin. But our heading and paragraph do still have some margin. If I turn off normalized CSS and go on comment, I'll reset styles in app.css, I'll refresh again, and you can see the difference where all margin and padding has been removed from every single element. So just to quickly summarize them, doing a CSS reset by setting margin and padding to 0 will strip margin and padding away from every single element. Whereas using normalized CSS does remove some default padding and margin, but its aim, instead of resetting everything, is to create consistent styles across different browsers. So some elements like the heading do still retain properties like margin. So let's wrap up by finishing off the summary card, setting global rules with the CSS box model. In this chapter, we learnt about CSS Reset. We saw that we use the Universal Selector to reset styling rules that come default in the browser. The first rule we add is box sizing border box, and this makes setting dimensions more predictable, and margin 0 and padding 0, which removes all default margin and padding in the browser. Alright, I'm back inside our Quill project in the app.css file. We're going to go down to the Universal Selector and add in the CSS resets. We'll give it a margin of 0 and a padding of 0. And just a reminder from earlier, setting a margin and padding of 0 on the Universal Selector will apply a margin and padding of 0 to every single HTML element. Another approach was using the normalized.css file. I'm specifically going with this approach at this stage because I generally don't like including files where you don't really know what's going on behind the scenes. When you're first starting out, it's really important to know exactly what you're doing. So I'm using the CSS Reset approach. But just be aware, the normalized CSS approach is pretty popular. So let's check this out in the browser. Alright, so it might not be so apparent exactly what's happened. So what I'm going to do is go comment this out, and we're going to look at each section of the web page. I'll save and refresh. So you can see by commenting this out, the first thing is that there's this margin on the entire body. Let's remove the comment, and you can see that all the content that's left aligned goes right to the edge of the page. That's the first thing this reset does. Now we've already applied some margin on our heading and margin on our paragraph to separate out these elements. You can see that down here in the hero section where we've applied margin bottom properties. So those margin properties will override the reset, so we're not going to see much change over here. However, scrolling down to here, there's now no margin between the heading and paragraphs. Just to show you that, I'll comment this out again and refresh. And you can see that there's a lot more spacing between this heading and this paragraph for each feature section. And that's because the heading has default margin. The same thing's happening down here in the CTA section. There's a gap here caused by the margin on this heading. So if I remove this comment, you'll see the reset is removing the margin on this heading, causing the button to move a lot closer to the heading. Let's take a look at the footer. I'm going to go and comment this out and refresh. And I want to focus on the unordered list element, which is structuring our different navigation menus down here. I'm going to go select the unordered list tag, and you can see we have some margin, top and bottom, and we also have this padding on the left. And the reason we have that is because in an unordered list, there would ordinarily be some bullets there. We've already removed those bullets with the list style none on the unordered list tag down here. And if you remember from earlier, I highlighted that our quill logo and this sentence here, made with love in London, is horizontally centered in the page, whereas these social media icons and this small navigation list is kind of offset a bit to the right. And that's because the unordered list has this default padding on the left. So when I add back in the reset, you'll see that these actually center much better because that padding left has been removed. They also move a lot closer to each other because of the margin being removed from the unordered list. Now, usually in a project, one of the first things you come and do in your CSS file is add this line of code to give you a blank canvas to work from. Now, we obviously couldn't do that when we started out our CSS journey because we didn't know anything about the box model. So what we need to do now is look through our page and see anything we want to tweak slightly. There's two things I'd like to do. The first is to add a bit of margin between each feature section heading and paragraph, just to create a bit of space, because that space has now been removed from the margin that was there by default. And the second thing I'd like to do is add a bit of space between the Get Started Now and the Get Started button. Now, as I mentioned before, because you would ordinarily add this first, you wouldn't really need to do this, because you would already do this when creating white space, moving through your page top to bottom. So I just wanted to highlight, we need to think about this specifically now because we're adding our reset at a later stage. So let's go and add those two styles I mentioned. So I'll head over to our HTML file and scroll down to the features section. The headings I'm interested in adding a class to are these H3s over here. So I'm going to add a class of feature headings. Now I've already called this heading over here features main heading. So I put the word main there to distinguish it from feature headings over here, which are used for our H3s. I'm just going to copy this class and add it to all the H3s. I'll copy this class just so it's easier to select it. In app.css, I'll select that class, add all curly brackets, and let's give it a margin bottom value of 20 pixels. Okay, so that's just created a bit more space between our heading and our paragraph. Now I put this class here because I generally like to have my classes match the order of my HTML. I have my section, main heading, feature heading, and then image, which corresponds to the order it appears in my HTML. But in principle, you could put these anywhere. Let's now go down to the call to action section, and I want to add some margin bottom onto this heading. Now again, we don't have any class for that, so let's go add that in our HTML. That's this H2 element here. I'll add a class of CTA heading. I'll copy that text, I'll head back to app.css, and under CTA card, I'll select the heading, and let's add a margin bottom of 30 pixels. Okay, nice. That's also created a bit more space between our heading and button. So by doing this reset, because we stripped away all the default styles, I've just gone ahead and tweaked a few things to just make it look a little bit better. But again, just to really hammer the point home, when you first create a CSS file, this is usually the first line of code you add. So the tinkering I just went through would just be part of the regular process of working with margin to create white space in your design. Now it's time to learn how to create a central layout structure for your web page by defining a main container. We'll be discussing the main wrapper container and the auto value. So what is a container? It is very common for a web page to have a wrapper which adds margin left and right as well as centers all the content. For example, on this web page here, you can see the main content is centered on the page. Behind the scenes, margin left and right applying to all of this content in order to center it, so that there's a bit of white space on the left and right. Now this would be considered a wide container. The content extends quite wide on the page. Let's have a look at another container. On this page here, you can see that this container is quite narrow. The content is a bit more contained within the center of the page, and there's a lot more white space left and right. So let's now talk about how we make a container. To create a container, a suitable width is chosen to prevent content from excessively stretching on larger screens. So let's say we have a screen which is 1600 pixels wide. What we would do is create a class called container and apply a width to it, say 1200 pixels. Because the container is going to wrap all the content, our web page would sit like this in the browser with the width of 1200 pixels, and all the content remains inside. So let's go play around with this in VS Code. Alright, so I've got a blank index.html file here, where I've already grabbed the boilerplate code. I've also linked up an app.css style sheet, which is currently empty. So the first thing I'm going to go do is add this container element. It's simply a div, which is going to wrap all our content. I'm going to give it a class of container. Let's go and give it a few elements. I'll give it an h1, which we can just call main heading, and I'll give it some paragraph text, and go grab some lorem ipsum times 3. Let's head over to the CSS. The first thing I want to do is just do our CSS resets, which we learnt about earlier. I'm going to add a margin of 0, a padding of 0, and just set box sizing to border box. Let's now go grab our container element. I'm going to give it a width of 800 pixels. I'm going to give it a background color so we can better see it. Let's give it a value of light blue. Alright, so let's check this out in the browser. So here's our container element. And you can see that all the content, the heading and the paragraph, is contained within this div, which I've made with the blue background. Now, one thing I want to show at this point is how we can better see page dimensions inside DevTools. I'm going to right-click Inspect to open up DevTools. This icon over here, you can see says Toggle Device Toolbar. I'm going to click on that. And what this now opens up is a window where I can play around with the dimensions of the page. You can see that I can go to the edge over here and drag left and right, and the dimensions are changing up here. Later on in the course, when we talk about media queries, we're also going to come play around with some actual devices. So this view allows us to better see width and height values of the viewport we're looking at. So if I go and extend my viewport to the absolute edge, you can see that the width value is 1244 pixels. Knowing this is going to help us when we want to come and center this container. So let's now talk about centering the container. To center the container, calculate the remaining width and distribute the space to margin left and margin right equally. So in the example we were looking at before, we have a viewport width of 1600 pixels and our container width of 1200 pixels. So to work out the amount of margin left and margin right, we would do 1600 pixels minus 1200 pixels divided by 2 to give us 200 pixels. We would then update our container code to look like this, applying margin left and margin right of 200 pixels. This would then nicely center our container, with 200 pixels of margin left and right. So let's jump back into VS Code and do it for our example. As a reminder of where we left off, our viewport width at full screen is 1244 pixels. Jumping back into VS Code, let's now go and add the margin left and margin right. So just like in the other example, we would take the viewport width of 1244 pixels, we would minus 800, and we would divide this by 2. This gives us a value of 222. So all we're going to do now is add margin left of 222 pixels and margin right of 222 pixels. So let's check this out in the browser. So as you can see, our container has nicely been centered, with 220 pixels of margin on the left and right. But I now want to show you a major problem with this approach. I'm going to open up DevTools, and I'm going to come grab the edge of the viewport here. As you can see, when I reduce the width, the container is no longer centered. It's because we've hard-coded these values, left and right. So obviously, if I were to apply the same equation of 1050 minus the container width of 800 pixels and divide that by 2, I'm not going to get the 222 pixels we applied left and right. So to fix this, we need to learn about an important value in CSS called auto. Auto is a value that enables the browser to automatically determine a property's size. It looks like this. We have a property like height and the value auto. We've actually already seen this value apply behind the scenes with images. The property auto automatically applies to the other dimension when setting width or height to preserve the aspect ratio of an image. So for example, we've written CSS code that looks like this, where we would apply a width of 400 pixels and height auto would be applied behind the scenes. So although we didn't explicitly set height to auto, it is being applied behind the scenes so that when the image reduces or increases to 400 pixels, its height will also increase or decrease by the same proportion, so the aspect ratio is preserved. That is, the image won't distort. And we can also use the auto value on margin. In this case, it automatically calculates the remaining space inside a parent and is used to center a child container. So the auto value is being used differently to images. Inside the CSS code, it would look something like this, where we have a container of 1200 pixels, and instead of hard coding a value for margin left and margin right, we're just applying auto. And doing this centers the container, no matter what the width of the parent or viewport is. So let's jump into VS Code and fix up the problem we had before. I'm back in app.css, and I'm just going to remove the value we hard-coded and update it to auto. And I'll do the same for margin right. So let's now check it out in the browser. So back on the page, I'm going to open up DevTools, and I'm still inside this toggle device view. I'm going to come over to the far right, and I'm going to reduce the width of the page. And you can see that as the page reduces, the container is still staying centered. There's equal margin left and margin right being applied because of that value auto. Now, one last thing before we finish up is that using the shorthand margin property is concise and more common. So this is the setup we have, and this is the code we looked at before. Now, instead of applying margin left and margin right as two separate properties, it's more common to do this, applying a margin of 0 for top and bottom and auto left and right. This is the exact same as applying auto to margin left and right. And obviously applying a margin 0 top and bottom will not apply any margin top and bottom. Doing this is a lot more common and a lot more concise than applying margin left and margin right separately. So let's quickly update this in VS Code. I'm going to get rid of these properties and just type the margin shorthand, 0 for top and bottom, and also for left and right. And let's just confirm that this works as expected. So I'm back in the browser, and as I reduce the width of the page, you can see that it's still nicely centered. So let's finish off by starting to build our next summary card, responsive design with the CSS box model. In this chapter, we looked at how we can set up a main container. We have our browser shown in green, which let's say has a current width of 1600 pixels. In our CSS, we would then create a container. In this container, the width is set at 1200 pixels, and we center the container by applying margin 0 top and bottom and auto left and right, where the auto value is able to automatically calculate any additional space. So we'd end up with a container looking like this. It would be centered and have a width of 1200 pixels. So let's go and now add a container to the Quill homepage. Our container is going to be applied like this. It's going to contain all the content, including the navbar. So let's jump into VS Code and apply this. So I'm back inside our Quill project on the index.html page. So the first thing we need to do is go add our container. Now it's best practice to actually make this its own element inside the HTML. So I'm going to add a new div just below the body tag. I'm going to give it a class of container. And then I'm going to move all the content from the body inside this main container element. So you can see now that this div with the class container is wrapping all the content. So let's jump into app.css. I'm going to scroll down just below the body and select the container. This is a common place to put it inside your CSS. Let's give it a width of 1200 pixels, and we're going to apply that neat trick of margin 0 for top and bottom and auto for left and right. So let's check this out in the browser. Okay, this is looking really good. You can see that all our content is now centered and we have some white space left and right. And let's also check this still works when I reduce the width of the page. I'm just going to come to the edge of the page here, and as I reduce the width, you can see that the content is still nicely remaining centered, with some white space left and right that's being automatically calculated. Now, one last thing I want to do just before we finish up is use this same trick to center this call to action card. Let's jump back into VS Code. In the index.html file, you can see we have this div with class CTA card, which is wrapping this content. So this div is acting as a container for the CTA card. Let's go down to that class, which is in our sections in our app.css page. Under CTA section, we have the CTA card. Now a width of 1000 pixels has already been applied. So all we're going to go do is add margin, 0 top and bottom, and auto left and right. And this will now center the card. So you can see now that this card has been centered with an equal margin left and right. And similarly, as I reduce the width of the page, the call to action card is staying centered because the auto value is automatically calculating the margin left and right to be applied to center the card. Now in a topic later on in the full course, I'll be doing a deep dive into centering elements and containers, because we will see later there are more modern and powerful methods with Flexbox, and I'll actually be updating how we center this card. Let's now take a look at how to restrict the maximum width of an element to ensure responsive design using max width. We'll be discussing the max width property, max width on block and inline elements, and max width design guidance.
So this video is getting my more difficult step. The actual property max width we're going to look at is not too complicated, but we are entering into what is called responsive design, and it can be a bit more tricky to understand the best case for using maximum width. So what is maximum width? Maximum width ensures elements are responsive for different screen sizes. To better understand max width, let's first look at the width property we've already seen. The property looks like this, where the width of the element here is 500 pixels, and this sets a fixed width. And in this case, the width is 500 pixels, and it's fixed at this 500 pixel value. It won't go above or it won't go below. Let's now look at max width. The property looks like this, max-width, with a dimension value like 500 pixels. Now this sets an element's width that it won't exceed. So the element could be 500 pixels, which would be the maximum width, and it won't go above 500 pixels. But the major difference now between max width and width is the fact that if your browser reduces in width, the element will shrink less than 500 pixels. So width stays at 500 pixels no matter what the size of the browser, and max width stays at a maximum width of 500 pixels, but if the browser reduces in width, so will the element. Let's take a look at this inside VS Code. So I've set up an index.html file and grabbed the boilerplate HTML. I've also linked a style sheet app.css, which is currently empty. So inside the HTML, I'm going to go add a div, and I'm going to give it the class of container. I'm going to head over to app.css. I'm first going to use the Universal Selector just to reset all the default styles. So I'm going to set padding to 0 and margin to 0 to clear the default styles. Then I'm going to select that container class. I'm first going to give it a width of 1000 pixels, and I'll give it a height of 500 pixels. Let's then give it a background color of light blue. So let's check this out in the browser. You can see we have our light blue container here. Now what I want to do is drag my browser so that the browser width is less than the container width of 1000 pixels. And what you'll notice is that I can actually scroll across. You can see my scroll down the bottom. So because this is a fixed width, even though the browser is less than the container, the width of the container stays at 1000 pixels, which means that we can now scroll to see the full thing. I'm now going to change width to max width of 1000 pixels. And let's see the behavior here. So again, when the browser is the full width of my screen, the width of this element is 1000 pixels, because when we set max width of 1000 pixels, the element won't exceed 1000 pixels, but can go up to it. But the major difference now is that when I reduce my browser width, there's no scroll here. The width of the element is the width of the browser. And we can actually see this inside DevTools. If I inspect and click on the element and look at the box model, you can see it now has a width of 716 pixels, which is less than the 1000 pixels we set. And as I reduce and increase my browser width, you can see the width of the element is changing. until we hit that 1000 pixels when it will stay fixed. Let's now talk about max width in the context of block and inline elements. Max width behaves differently depending on the display property of the HTML element. Let's talk about block elements first. For example, an h1 or a div. Block elements occupy the full width of their parent, and we know that width and height can be set. Looking now at regular inline elements, such as an anchor tag or span, they only occupy the width of their content. And we know for these, width and height cannot be set. And in order to set width or height, we need to change to inline block so we can apply min and max width. Now we've also previously looked at replaced inline elements. Those are inline elements like image and input, which don't wrap any content, but are replaced by something else, like an input field. Like regular inline elements, they only occupy the width of their content. And for these, width and height can be set, so we don't need to change them to inline block. Now block elements and regular inline and replaced inline elements are very different in terms of the width they occupy. And because of this, it's going to have a big effect on max width. So now we're going to go look at max width on each of these different kinds of elements. We'll start with max width on block elements. As we know, this sets the maximum width an element can be while it can still go narrower. We'll start by looking at the regular width property. On the left, this grey box represents a browser, which is currently at 1800 pixels. We're now going to set a block element with a width of 1200 pixels. The block element stays at 1200 pixels when the browser is wider. When we make the browser narrower, say 800 pixels, the element with a fixed width of 1200 pixels will now exceed the width of the browser. So block elements extends beyond the browser. Let's now compare this by looking at max width. We have our same browser initially at 1800 pixels. We set a block element with a max width of 1200 pixels. So the element will look like this. It will still be 1200 pixels, because block elements stay at 1200 pixels when the browser is wider, when using a max width property. Now the major difference between width and max width for block elements is when the browser is narrower, say 800 pixels. The element will adjust to the same width of the browser, 800 pixels. So the block element reduces when the browser is narrower. In the coding example we looked at earlier, we used a div to create our container. And we know that a div is a block level element. And because it's a block level element, when the browser is wider than the element, it stays fixed at the 1000 pixels we set. And when we reduce the width of the browser, the width of the block element also reduces. So let's now look at some max width block element guidance. Using max width on a main container ensures content does not go too wide on larger screens. Taking a look at this web page here, we can see the main container wrapping all the content in red. This container width stays at 1200 pixels when the browser is wider. So using max width on a main container ensures the content doesn't go too wide on huge screens. Now the primary benefit of using max width as opposed to width is that when on smaller screens, the container is able to scale down with the browser as it is not a fixed width. If this were a fixed width, the content would overflow and the user would have to scroll horizontally, which is not a good viewing experience. So let's check it out on this web page. I'm going to open up DevTools and I'm going to click on this div where it says container large. At the moment, this has a max width set at 80 rems. Now we haven't looked at units just yet. We'll be covering rems in the next topic. Now because I'm at full screen, the width of this container is fixed at 1280 pixels, so that the content doesn't go too wide on the screen. But as I start reducing the width of the browser, you can see at a certain point, the width of the content is starting to change, and is all contained within the browser. It doesn't overflow, and I can't scroll left and right. Now inside DevTools, we can actually change properties. I'm going to go change max width to a fixed width of 80 rems. So let's see what happens now when I start reducing the width of the browser. Because the container has a fixed width of 80 rems, or 1280 pixels, when I reduce the width of the browser, the container width is not scaling down. It's staying at 1280 pixels. And you can see what this causes is the content to overflow, where I now can scroll right. Now, as you can appreciate, this is not a good viewing experience. We want all our content to be inside our browser window. So that's the main use case of max width on block level elements. So let's now look at max width on inline elements. As we know, max width sets the maximum width an element can be while it won't go narrower. Let's again take a look at the width property first. We've got our browser, which currently has a width of 1800 pixels. We'll now define a width of 1200 pixels on an inline element. So for the fixed width property, the inline element width stays at 1200 pixels when the browser is wider. The exact same behavior as a block element. When the browser now goes narrower, say 800 pixels, the inline element remains at 1200 pixels, its fixed width value. So the inline element extends beyond the browser when it is narrower. And again, this is the exact same behavior so far that we've seen for a block element. Let's now compare this to the max width property on an inline element. We've got our same browser initially at 1800 pixels, and we apply a max width of 1200 pixels. So the inline element's width stays at 1200 pixels when the browser is wider. So far, the exact same behavior as a block level element. But here's where things get a bit interesting. When the browser reduces to a width less than the max width, say 800 pixels, the inline element actually remains at 1200 pixels. So the inline element extends beyond the browser when it is narrower. This did not happen for a block level element. The block level element reduced and matched the browser width. It's almost as if max width has no impact on an inline element. Let's go play around with this inside VS Code and discuss it a bit further. So I'm first going to go to unsplash.com to grab an image we can play with. I'm just going to go grab an image of a camel. I like this one over here. I'm going to click on it and copy the image address. Back inside VS Code, I'm just going to get rid of this div, and I'm going to grab the image tag. I'll paste in the link I just copied, and I'm going to go remove a whole bunch of stuff here we don't need after the question mark here. For the alt text, I'm just going to put camel. In app.css, I'm going to remove the container, and I'm now going to select the image, and let's first apply a width of 800 pixels. So let's check this out in the browser. So as you can see, the image of the camel is at 800 pixels, and as you'd expect, because this is a fixed width, when I reduce the browser width so that it's smaller than 800 pixels, the image cuts off, and I'm able to scroll to see the rest. Let's now change width to max width. So as you'd expect, the image is currently 800 pixels wide, as our browser is wider. When I go reduce the width of the browser, you'll see what I was talking about before. The image's width doesn't reduce like it did with the block element. It still extends beyond the browser, and you can see we can scroll. So what is going on here, and how do we fix this? So I'm first going to apply the fix, and then I'm briefly going to touch on it, as we're going to be talking about this a lot more in the next topic. I'm going to go add a width and set it to 100%. Now we haven't actually spoken yet about percentage values, and as I mentioned, we're going to be talking about this a lot more in the next topic. But I do just want to show you the fix and explain a little bit about why it fixes the issue. So let's check this out now. If I reduce the width of the browser, you'll see the image does reduce, exactly like the behavior of a block element. So what have I done and why is it working? In simple terms, inline elements do not naturally expand to fill the width of their container. So setting width 100% ensures they do take up the full width available, allowing max width to limit their size. This is very different to block elements, which will automatically expand the width of their container, making max width effective without needing to explicitly set the width to 100%. It's kind of like block elements by default have width 100% applied to them in the background. Now, don't worry too much about this right now. We're going to be talking about it a lot more in the percentages section in the next topic. But I did just want to highlight that by default, when applying max width to an inline element like an image, when you reduce the width of the browser, the inline element won't shrink. We have to go and apply width 100% to make this work. So let's now discuss max width inline element guidance. Using max width on images creates a responsive layout. So for this page here, we have this large image in the center of the page. Now using max width will ensure that the image width stays at 1000 pixels when the browser is wider. Very similar to the use case for the container we looked at earlier, but it's just being applied to an image. Using the max width property as opposed to the width property ensures that the image scales down with the browser as it is not a fixed width. And as we saw, We will get this working later with percentages. You can't apply max width without also applying a width of 100%.
Over the next few chapters, I'm going to be building up a width summary table,
just to help see these different properties in relation to one another. Let's start with the property width. This sets a fixed width. For block and inline elements, the elements remain fixed when the screen size narrows or expands. An example of where you would use the width property on a block level element might be a sidebar, one of those side navigation bars you sometimes see on web applications. An example of an inline element where you'd use a fixed width are small images and icons. For the max width property, this sets an element's width that it won't exceed, but as we know, it can reduce. For a block level element, this will shrink when the screen size narrows, and an example of a block level element we apply max width to is a container. And doing this is very common, because we want our container to be responsive, so that when the screen size reduces, all the content inside with it also does. For an inline element, we saw that by default it won't shrink when the screen size narrows, and we had to do some extra work by applying width 100% so that it did reduce as the screen size narrowed. An example of using max width on an inline element is images, and again we saw this needs more work to achieve. Now in our Quill project that we've been working on, we'll be using both width and max width inside our project.
So let's finish off by adding to our summary card responsive design with the CSS box model. In this chapter and in the next chapter, we're covering max and min width, and I'll be summarizing everything we learned in this table. In this chapter, we looked at the width property, which in CSS is defined like this, and this is when an element has a fixed width, and it's often used on small images and icons. We then looked at max width, which in CSS looks like this. Using this means an element won't exceed this width, but it can reduce. And max width is often used on containers and large images. So let's see how we can use max width on our Quill application to make the web page more responsive. I'm inside the app.css file, and I would like to highlight some areas we're currently using a fixed width, where we should replace it with a max width. If I scroll down, the first location is on the container. We're currently using a fixed width of 1200 pixels. So let's see what this is doing in the browser. So at the moment, that 1200 pixel width is nicely containing all the content. I'm going to open up DevTools just so we can see it. And as you can see, all the content is within the 1200 pixel container, which works well for larger screens like I'm on now. However, as we know from earlier on in this topic, is that when I reduce the width of the browser, the 1200 pixel container now exceeds the browser's width, which is causing the scroll over here. We don't want this behavior. We want everything inside the browser window. So let's go fix this by changing the container to have a max width of 1200 pixels. So looking at this now, when I reduce the width of the browser, you can see the container is also reducing in width. Before it was cutting off, now it's all within this window. But there is still a scroll here. This is actually being caused by another element. If I scroll down to the bottom, we've got this call to action card, and it also has a fixed width, which is ultimately setting the width of the entire web page. So let's go correct that in our markup. I'm going to scroll down to our different sections in the CSS file. In the call to action section, we have the CTA card, which currently has a fixed width of 1000 pixels. So let's update this to a max width of 1000 pixels. Let's go check out the impact. So I'm going to reduce the width of the browser, and as you can see, because the CTA card has changed from a fixed width to a max width, it's also reducing when the width of the browser reduces. So this is looking a lot nicer. Now shrinking the browser like this, I can only go to a certain limit. So what we're going to do to see much lower values is open up DevTools, and we're going to click on the toggle device toolbar over here. And this now allows us to reduce the width of the page to any value we want. So the main container is looking good. And the call to action down here is also looking good as we reduce the width. So the next issue we run into when I start reducing the browser's width to be a much smaller value is that this CTA card actually has some padding all the way around it. If I inspect the card, you can see we have this padding of 100 pixels top and bottom and 200 pixels left and right. So there's some left padding here of 200 pixels, which is now causing the total width of the page to be determined by the padding and the width of the card. You can see when I hover over the container, the card is overflowing. This padding issue we're going to solve later on in the course, when we start looking at responsive design. For now, I'm just going to turn it off because I want to highlight another issue. So the padding's now been turned off, but still there seems to be something causing our web page to overflow the container. I'm going to scroll up, and you can see it's now this image, and that's because our image has a fixed width. So let's go and fix that up. Back in VS Code, in the features section, we have a feature image with the width of 400 pixels. So let's go change this to a max width of 400 pixels. Let's see the impact of this. So nothing has happened, which seems a bit strange. If you remember from earlier on, the reason nothing has happened is because applying max width on an inline element, like an image, doesn't work. We also need to go apply a width of 100%, so that the image is able to scale down with its parent container. Now, this is something we're going to be talking a lot more about in the next topic, when we talk about percentages. So don't worry too much about the details right now, just know that we have to add this in. So let's go check it out again. Okay, great. So now we can see that the image is reducing as we reduce the width of the browser. If I inspect it, you'll see that the image is now 235 pixels. So by setting max width on our main container, on our call to action card, and just temporarily disabling the padding, and also setting max width on the image, ensures that the elements will reduce with width as the page reduces with width. Now I do also want to highlight some elements which have a fixed width which we are not going to change. And these tend to be small images and icons. For example, our logo over here has a width of 100 pixels. We don't need to start playing around with max width there, as 100 pixels is really small, and almost all viewing experiences, even if on a small smartphone, will never go below 100 pixels. The other area we have a fixed width is on these social media icons. They have a very small width of 20 pixels. There's no need to add max width here. So we've looked at max width in detail. Let's now explore how to set minimum width for elements with min width. We'll be discussing the min width property, min width on block and inline elements, and min width design guidance. So like the previous chapter, the min width topic is also getting my more difficult stamp. So in the previous chapter, we had this slide about maximum width, where we looked at the width property and the new max width property. Let's now update this to look at maximum and minimum width. So I'll scoot over width and max width to make some space, and let's add in min width. The min width property looks like this, min-width, where the property is min width, and the value is something like 500 pixels. Min width is the opposite of max width. It sets an element's width that it won't shrink below. So if we have an element with a min width set at 500 pixels, the element's width won't go below 500 pixels. However, if the window expands, the element's width can exceed 500 pixels. I also just want to bring up this slide we saw previously, where we saw max width behaves differently depending on the display property of the HTML element, that is, whether it's a block element or inline element, and it's the same thing for min width. So let's update this orange sentence to now say max width and min width behave differently depending on the display property of the HTML element. So let's first take a look at min width on block elements. As we just saw, setting min width sets the minimum width an element can be while it can still go wider. Let's first compare this with the regular width property. We have our browser, which currently has a width of 1800 pixels. We now go add a block element and set its width to 1200 pixels. And again, we're looking at the case for a block element. If we now reduce the width of the browser to 800 pixels, because this element has a fixed width of 1200 pixels, it will remain at 1200 pixels. So the block element extends beyond the browser. Let's now compare this to min width. We have our same browser with the current width of 1800 pixels. We now set the block element's min width to 1200 pixels. And because we're using min width, the block element is able to expand the full width of the browser, 1800 pixels, so it goes wider. As you can see, this is very different to the width of 1200 pixels on the left. If we now reduce our browser to 800 pixels, our block element still has a width of 1200 pixels, because the minimum width our element has to be is 1200 pixels. So over here, the block element also extends beyond the browser. Let's play around with this inside VS Code. So I've gone ahead and created a new index.html file, and I've added the boilerplate, and I've connected an app.css style sheet, which is currently empty. So inside the HTML, I'm going to go add a div, and I'm just going to give it a class of card. Inside app.css, the first thing I'm going to do is just grab the Universal Selector and set all the padding and margin to 0, just so we have a clean slate to work from. I'll then go grab our card element. I'll give it a height of 200 pixels. For now, I'll give it a width of 800 pixels. And let's give it a background color of salmon, just so we can see it in the browser. All right, let's check this out. All right, so as expected, we have our card with the height of 200 pixels and a width of 800 pixels. And as we've seen previously, if I come and reduce the width of the browser, this card, because it's using a fixed width, exceeds the width of the browser and overflows, which means I can now scroll right. So let's go compare this to min width. So I'm going to come update our code to change width to min width. So let's check this out again. So the major difference now is that because the width of our browser exceeds the width of 800 pixels, that is the min width we set, the element's width will go above the 800 pixels. Let's check this out in DevTools. I'll select our element, go down to the box model, and you can see its current width is 1280 pixels, which is more than the 800 pixels minimum width. And as I reduce the width of the browser, you'll see the width also reduces until we get to 800 pixels. So once again, the element's width will overflow, and I can scroll right on the page. So let's now look at some min width block element guidance. Min width is useful for maintaining a section width in a grid layout so it does not become too narrow. Grid layout is something we haven't covered yet. So this guidance won't seem so relevant now, but it is something you should keep in your back pocket. An example of this is used in Duolingo's courses. This middle section has a min width. This is an important section of the page, as it's where users interact with when going between different topics. When you reduce the width of the browser like this middle section won't go below a certain width to remain user-friendly. Now again, this is what we call a grid layout. There are 3 columns here. The middle column is what we're currently looking at, but there is a column left and right, and this is being achieved with CSS Grid. So you would use the min width property inside CSS Grid, something we'll be looking at in a later topic. So let's have a look at the Duolingo page in the browser. As I reduce the width of the page, you'll see the middle section does reduce its width as I reduce the width of the browser. However, when I hit a certain point, it stays fixed. So let's now take a look at min width on inline elements. So again, this sets the minimum width an element can be while it can still go wider. So for this example, we're going to be looking at a span with some text inside of it. As you know, a span is an inline element. We'll first be looking at the case where there's no width set on the span. Let's first look at an example of a span which has the text short text. And in this case, because there's no width set, the width is determined by the content itself, as it's an inline element. And if we have some longer text, again, the width is determined by the content. Let's now go and apply a fixed width of 300 pixels to the span. And to do this, you'd also need to change the display property to inline block. Because we've seen previously, you can't set width or height on an inline element. You have to change it to an inline block element. Because we've set a fixed width of 300 pixels, both the short text and the longer text have a width of 300 pixels. And in the case of the longer text, the text is now wrapping onto a second line. Let's now look at the min width property. So for the short text, it remains at 300 pixels. But for the longer text, because it's now the min width set at 300 pixels, it is allowed to go wider. So the min width sets a minimum width. Let's go play around with this inside VS Code. So I'm back inside our index.html file. I'm just going to go get rid of this div, and I'm going to grab the span tags. I'm going to give it the class no width. I'm going to add the text heated warm swimming pool. I'm going to copy this span and paste it below, and just change the text to something shorter, like Wi-Fi. Inside app.css, I'm going to remove the card. I'm going to select the spans, which was the class no width. I'm going to give it a background color of light coral. As I mentioned previously, we have to change the display property to inline block so that we can later go apply width properties. And just to make it look a bit nicer, I'm going to apply text align center. So as expected, the width of each of our spans is just the width of the content itself. All right, I'm going to jump back into index.html. I'm just going to copy these, paste them below, and change the class of both of these to width. I'm then just going to do something a bit hacky and put a BR tag between these two sets, so it'll force these new spans onto a new line. In app.css, I'm now going to copy this previous style, and I'm just going to update the class to just be width. I'll change the color to light green, and I'm now going to go add the width property and set its value to 100 pixels. So let's check this out. So you can see by setting a fixed width, the text inside this first span now wraps, so it fits within the width of 100 pixels. And because the width of Wi-Fi was less than 100 pixels, there's now additional space left and right of the word Wi-Fi. All right, so finally, let's go add our third case. I'll grab a line break tag just to separate the spans. I'll copy these, and I'm now going to change the class to be minWidth. In app.css, I'm going to copy this style. I'm going to update its name to minWidth. Let's change the background color to light sky blue. And now instead of width, let's set minWidth of 100 pixels. Let's check it out. All right, so let's open up DevTools to see what's happened. This first span over here has a width of 189 pixels. So the text content is setting the width here. The min width is set at 100 pixels, but remember, it can exceed this. And because the text content is longer, it's going up to how long the text content is. With the Wi-Fi example, we can see that if I click on this one above, the width of that is 27 pixels, which is just the width of the content. But because we've now set a min width of 100 pixels, the span now goes 100 pixels. Now, of course, we could also set a min width value larger than the min width value of the text content. It's currently at 189 pixels. Let's go change this to 200 pixels. So you can see now both of these spans have a minimum width of 200 pixels. So let's look at some min width inline element guidance. Min width is sometimes useful for spans as it ensures text does not become too narrow and improves visual consistency. I actually struggled to find a good example of this, so I'm going to show you an example where you could use it. This is from the Etsy webpage, where at the bottom of a product page, there are different tags for related products. The min width could be used on these tags, like this small GIF tag over here. Using the min width property would make these tags just look a bit more visually consistent, and not have these odd tags with smaller text looking a lot smaller compared to the rest. Now in the previous chapter, we had a width summary table. So let's now go and add to this with the min width property. For its description, it sets an element's width that it won't shrink below. Looking first at when it's a block element, for its browser size behavior, it will expand when the screen size widens. And we saw an example of this was inside a grid section, which we haven't covered yet. For inline elements, the content won't wrap onto another line. And a UI example of this we saw were tags, which to be honest are just less common, but I did want to provide some example. Now the width and max width property are just a bit more commonly used, and are what we will be using in our project, as you've seen in previous chapters. We won't actually be using the min width property. Now I know this is all a lot to take in with max width and min width. My general advice would be focus on max width. It's a lot more important and it's used a lot more. And don't worry too much about min width. Let's wrap up by continuing to add to our summary card responsive design with the CSS box model. In this chapter, we learnt about min width. So let's go add it to our summary table here. In CSS, the property looks like this, and min width means an element won't reduce in width, but it can exceed. And we saw it's often used for grids, which we haven't yet covered. On to the last chapter of this topic. We'll now learn how to control the maximum and minimum vertical size of an element using max and min height. We'll be looking at the max and min height property and max and min height design guidance. So just like the previous chapters on maximum and minimum width, I'm also going to be giving this chapter my more difficult stamp. So let's take a look at the maximum and minimum height properties. We'll first start with fixed height, which has the CSS property like this, and this sets a fixed height. So we have our element over here. It has a height of 500 pixels, and this is fixed at 500 pixels. Looking now at max height, the CSS property looks like this, max-height, and this sets an element's height that it won't exceed. Looking at our element, we have a height of 500 pixels, and the element will never go above 500 pixels. However, just like max width, it can reduce in height. Now we're going to see soon there's just a bit more going on with max height compared to max width. So this is a slight oversimplification, and we will be going into more detail soon. Next up is min height. The CSS property looks like this, min-height, and this sets an element's height that it won't shrink below. We have our element here at 500 pixels, and the element won't go below 500 pixels. However, the height can expand beyond 500 pixels. Now, before we specifically talk about maximum and minimum height, I want to discuss maximum and minimum properties in general. Max and min width are more commonly used compared to max and min height due to their role in creating responsive layouts. So if we look at all our maximum and minimum properties for width and height over here, on the far left, max height is least frequently used, whereas max width is the most frequently used. And that's because for responsive layouts, we're moving horizontally from browsers on desktop, tablets, and mobiles. Now with all these properties, all are more commonly applied to block elements, especially for min and max height. So in this chapter, I'm not going to be going through min and max height for block and inline elements. I'm just going to be focusing on block elements when using the max and min height property. I promise I'm not trying to cut corners, I just want to focus on what's important. Max and min height aren't that frequently used, and they're even less frequently used on inline elements. So in this chapter, I'm just focusing on max and min height on block elements. Now before we start talking about max height in detail, I need to flag the big difference between max width and max height. Max width and max height behave in fundamentally different ways. For max width, it's based on its container, so it applies even without content. In a previous chapter, inside VS Code, we created a div and applied the max width property, and we saw that when we reduced the width of the browser, the width of the div also reduced. This wouldn't work for max height. It's because max height only applies when content exceeds the limit. So let's jump into VS Code and I'll show you what I mean. Alright, so I've gone ahead and set up a new index.html file and grabbed the boilerplate and linked an empty style sheet app.css. Inside the body, I'm going to create two divs. I'm going to give the first div a class of box1 and the second div a class of box2. Moving on to app.css, I'm first going to grab the Universal Selector and just clear all the padding and margin. I'm then going to select box1. I'm going to apply a width of 1000 pixels, a height of 400 pixels, and a background color of light blue. I'll copy these styles, change box1 to box2, and I'll just give this a background color of light salmon. Alright, so let's check this out in the browser. Alright, so as expected, we have two boxes, both with 1000 pixels wide and 400 pixels high. I'm now going to go change box1 to be a max width of 1000 pixels, and box2 to have a max height of 400 pixels. I'll refresh and watch what happens. Box1 is still there and has a max width of 1000 pixels, and if I were to reduce the width of my browser, the width of the box would reduce. But box2 has entirely disappeared. And like I touched on earlier, we actually need content inside box2. At the moment, there is no content, it's entirely empty. If I go just add a paragraph, let's get lorem times 4, I'll refresh, and you'll now see that box2 is back, and the height is just being set by the height of the content. If I add some more content, so I'll just get rid of this lorem, and I'll now do lorem times 20, and refresh, you'll see what's happening now. The content is overflowing, but the max height is working. Box2 has a max height of 400 pixels, which you can see in the salmon color. So let's take a look at this in diagrams. I'm first going to start with a piece of content, shown in green here. Like we just saw, this could be something like paragraph text. The content's height is 500 pixels. Note, this is not me setting a height, it's just the height of the content itself. This content lives inside a container, like a div we just saw. And the height of the container is also 500 pixels. And that's because the container's height is set by the content height. Let's now go apply a max height of 300 pixels, which is less than the content height of 500 pixels. Our content remains the same at 500 pixels because we're applying the max height onto the container. So we end up with the container with a smaller height of 300 pixels than the content. And you can see the content overflows the container. So let's go play around with this again inside VS Code. I'm going to get rid of box1, and in the styles, I'm also going to get rid of box1 over here. So as we just discussed, we have our content, this paragraph text, and let's go check its height in DevTools. It currently has a height of 558 pixels, and this paragraph lives inside our div container, which we've set to have a max height of 400 pixels. We can confirm that in DevTools. If I grab the div, you can see it has a height of 400 pixels. So we're saying that the maximum height the div will go to is 400 pixels. Looking back at our paragraph, if I change the div to have a max height larger than 558 pixels, the div will then just be the same height as the paragraph. So let's go change this to something like 1000 pixels. I'll refresh, and you'll see now the div container is the same height as the content. Because again, the maximum height it can go to is 1000 pixels, but the actual content inside the div is currently at 558 pixels, so it won't exceed that. Changing this back to 400 pixels, you can see again the content is overflowing the container. So this brings us to a new CSS property, which can be used in circumstances like this called overflow. This controls what happens to content that overflows an element's box. It looks like this. Overflow is the property, and in this case, hidden is the value. There are 4 values for the overflow property: visible, hidden, scroll, and auto. Visible is just the default property. It just means that overflow can happen. Hidden clips the content, so any content overflowing will be cut out. Scroll introduces a scroll bar that will always be present, even if there is no overflow. And auto is a scroll bar only when necessary. That is, only when the content actually overflows. So let's go play around with these in VS Code. So let's go grab our overflow property. The first value, which is the default value, is just visible. I'll refresh and you'll see nothing happens. Let's change this to hidden, and you'll see now the content that overflowed is now just cut out. Let's change it to scroll. I'll refresh, and you'll see this introduces a scroll bar for the box, and I can scroll and see the rest of the content. I'll change it to auto, and this too will introduce a scroll bar on the right over here. Now, it is more common to use overflow auto as opposed to overflow scroll, as overflow auto is a bit more versatile for other circumstances. So let's now look at some max height guidance. Max height is used when you want to ensure elements do not exceed a certain height. A good example of this is on a modal window. A modal window has a max height, and you can use CSS to get a scroll. So in this example, this modal window, otherwise known as a pop-up, has over 1,000 reviews. Now, for a good viewing experience, we wouldn't want to show all those reviews on the pop-up. We want to ensure the pop-up doesn't exceed a maximum height, so it fits nicely inside our browser window, but then we also want to be able to scroll inside of it. So we could use the property overflow auto. If we didn't set a max height, this pop-up would have a massive height and cause our web page to also have a huge height. Let's now take a look at min height. I introduced this diagram not too long ago, where we had our content at 500 pixels and a container also at 500 pixels, as the container's height is being set by the content height. Let's now go and apply a min height of 800 pixels to the container. For the content, it's still at 500 pixels, but the container now has a minimum height of 800 pixels. So for minimum height, the container is now larger than the content. So let's go play around with this inside VS Code. I'm going to remove this max height value, and I'll refresh. So the height of our content is setting the height of our salmon-colored container. I'm also just going to get rid of the overflow property, as we don't need it anymore. Let's go add a min height, and we'll set it to a value of 800 pixels. So you'll see now, the minimum height of the container is set at 800 pixels, which is now larger than the height of the content here. Let's open up DevTools again. I just want to check the height of this paragraph one more time. So it's 558 pixels, which is less than the minimum height value we've set at 800 pixels. Let's now go set a value less than 558 pixels. I'll set a minimum height value of 400 pixels. Let's refresh, and you'll see the content still nicely fits inside the box. And that's because the minimum height of the container is 400 pixels, but it can expand beyond this. And in our case, the height of our content is 558 pixels, and that's now setting the height of the container. This is the complete opposite of max height. If I change this to max height and refresh, the maximum height the container will go to is 400 pixels. But because our content is at 558 pixels, it's overflowing. So that's the major difference between min and max height. So let's look at some minimum height guidance. Minimum height is used when you want to ensure elements maintain a minimum height regardless of the amount of content. A good example is this card over here. This will maintain a minimum height even if there is less content. This card is a component, and it's used throughout the application. Now, the amount of text in this card varies. The heading may only have 2 lines, and if you didn't set a minimum height, the height of the card elsewhere would be different. So if you wanted to ensure consistency of the height of this card, you would set a minimum height. Now, just like in the width chapter, I'm going to be providing a height summary. We have this table over here. The first property we looked at was height. This sets a fixed height for both block and inline elements. It remains fixed when screen size reduces or increases in height. An example of where we'd use a fixed height value on a block element is a navbar, and it's something we're going to be implementing in our project later. For inline elements, you could use a fixed height on small images and icons. In our project, we're just applying it to the width. The max height property sets an element's height that it won't exceed. In this chapter, we only looked at block elements. For the browser size behavior, max height limits the content height, and overflow occurs if content exceeds the value of max height. And an example of using max height is on a modal. For the minimum height property, This sets an element's height that it won't go below. We looked at block elements. For min height browser size behavior, the container can expand if content is more than the min height value. And an example is on section containers, like the card we just saw earlier. In our quill project, height and minimum height are the properties we will use in our quill project. Now we can't implement them just yet, as we still need to learn a few more things. But let me show you where we are going to add height. So we're going to be adding a fixed height to our navigation bar at the top here. Inside DevTools, this nav bar currently has a height of 162 pixels, and this is just being set by the content, which is the logo and the 2 buttons. In the Flexbox topic, we're going to be moving our buttons to be in line with the quill logo, and then we'll go add a fixed height. We just can't do it now because these buttons are currently under the logo. So for the nav bar, we'll be adding a fixed height. Now in the next topic, we're going to be learning about units, and we're going to be applying a special unit that ensures the height of this hero section is always above the fold. That is, it's always above the bottom of the browser. In addition to that, we're also going to be applying a min height value so that if the height of the browser window reduces very small, not all the content is pushed into a very small space. Rather, it will overflow. So I just wanted to give a bit of a taste of where we're going to be using height and min height in our project, but don't worry too much about it for now, as we do need to cover some other concepts first. Let's finish off by completing our summary card, responsive design with the CSS box model. In this chapter, we looked at max and min height. Just like max and min width, I'm going to be summarizing this all in this table. We started by looking at the simple height property. In CSS, it looks like this, and this is when an element has a fixed height. An example of where we can use this is on a nav bar. We then looked at max height. In CSS, it looks like this, and max height is when an element won't exceed the height, but it can reduce. A common use case we looked at were modals or pop-ups. We then looked at min height. In CSS, it looks like this. Min height means an element won't reduce height, but it can exceed. And we saw a common use case was on section containers. That was a big one and a lot to take in. So congratulations on finishing the CSS box model topic. Before we move on to the next topic, I'd really appreciate it if you could take 10 seconds to share your feedback on the course so far in the comments below. This course has taken nearly 12 months to create. Countless hours have been spent clearly structuring each concept so it's easy for you to understand, designing custom illustrations, handwriting each letter for that cool animation effect, and video editing hundreds of hours of footage to ensure you get a top quality learning experience. It's been a lot of work with a lot of late nights and early mornings. Here's some snaps of me at 5 AM with my son watching Thomas the Tank Engine while working on this video. Your feedback keeps me motivated. These amazing comments I've received on my HTML full course really help me to keep going. So please drop a comment below and subscribe to the channel. It would mean a lot to me. With that said, let's get back to it. It's time to take our CSS knowledge to the next level by learning about CSS units. CSS units are essential in web design, defining the sizing and spacing of elements on a page. We'll be taking a deep dive into the various units available to us, from absolute units like pixels to relative units like percentages and rems, and get a solid understanding of how to and when to use each unit type to build more responsive web pages. Let's start by exploring the basics of fixed and flexible measurements with absolute and relative units. We'll be discussing absolute versus relative units and the importance of relative units. So let's start off by talking about absolute and relative units. Relative units are essential for responsive web pages so elements can dynamically adjust for different screen sizes. Now, we briefly touched on absolute and relative units earlier on in the course in the CSS Text topic. So let's quickly recap what we discussed there. We first spoke about absolute units. This is when the size is fixed and does not change in relation to parent elements. Examples of absolute units include pixels, points, inches, centimeters, and millimeters. Points, inches, centimeters, and millimeters are uncommon in web development. Point is an absolute unit that's commonly used in the print industry, and inches, centimeters, millimeters are units that are used in the real world. Now, throughout this topic, we're going to be looking at a whole bunch of relative units. However, the pixel, which is an absolute unit, is still used for specific cases. We're not going to be totally throwing it away. We are still going to be using it. So what are relative units? Relative units is when the size is based on the size of a parent element and adjusts proportionally to changes in the parent element. Common relative units include percentages, ems, rems, vh, and vw, and we'll be looking at each of these throughout this topic. Relative units are commonly used in CSS because they dynamically adjust depending on the screen size, which is really important for responsive design. That is, design that caters for all different screen sizes, like desktop, tablets, and mobile. So just to highlight the difference between absolute and relative units, I'm going to use this analogy. What you see over here is a photograph of how I proposed to my wife. We went out for a nice Mexican dinner and came back to her parents' house, where I got her family to put a whole bunch of balloons with string coming off them and attach photographs of us during the time we were dating. Yes, I was a bit of a romantic. Anyways, the reason this is relevant is because it's actually a great way for me to show you the difference between absolute and relative units. So here's the balloon with the string dangling off it and attaches a photograph of me and my wife. We're going to say the balloon is the parent, which has this height, and the photograph is the child, which has this height. Now, if I increase the size of the balloon, we can say that the parent increases. Now, the balloon increasing in size has absolutely no effect on the photograph increasing in size. It remains the same size, so there's no change in the child. This is how absolute units work. We can adjust parent elements without having any direct effect on child elements. I now want to compare this to putting an elastic band around the balloon. The balloon is this height, and again we're going to call it the parent, and the elastic band is currently this width. And in this case, the elastic band is the child. Now when we blow up the balloon and increase its size, the parent increases. But also, the elastic band has now increased, so the child increases. This is an example of relative units. The size of the parent directly impacts the size of the child. So let's see relative units in action. On the left, I have a desktop design, and on the right, a mobile design. On the desktop view, you can see the main container with the text and buttons has a lot of space left and right. However, on the mobile design, you can see now there is no space left and right, so the main container widens. Another example of relative units is this space between the callout at the top, number 1 team building software, and the main heading. This would be something like padding. And while a little bit harder to see, on the mobile version, the padding reduces to tighten up the content on the mobile to improve its readability. And something very noticeable is on the desktop view, our main heading is very large, whereas on the mobile view, the font size reduces. So here are 3 really good examples of where we would use relative units: on containers, box model properties like margin and padding, and font size. And we'll be looking at how we apply relative units to each of these and more throughout this topic. So let's start building out the summary card for this topic, CSS units. Now we haven't actually looked at any relative units yet, so all I want to do is list out common places we continue to use pixels. Pixels are still used in the following areas: border radius, border, letter spacing, logos and icons, max width, and shadows, which we'll be looking at later on in this course. Besides the max width property, all of these properties tend to be much smaller values. For example, it's not common to have large border values, something like 5 or 6 pixels. Because these values are so small, we continue to use the pixel because using relative units really has no impact on them. Now, over the next few chapters, we'll continue to add to this summary card of common use cases of each CSS unit. Now, inside our Quill project, I just want to highlight some of the areas that absolute units are causing some issues. We're going to see this by opening up DevTools and clicking on this device toolbar over here. I'm just going to make some more space. And let's start with this text up here. If I reduce the width of the browser, so I'm moving towards a mobile view, you can see this text is just way too large. And that's because we're using an absolute value of pixels. We need our text size to reduce as the size of the browser reduces. Another issue is that the content is butting up right against this left edge. You can see that over here, and other headings and paragraphs over here. This doesn't look great. We need a little bit of space left and right. You can also see our images are not reducing with width. They're staying the same size. We need our design to reduce the image sizes as the width of the browser reduces. And the final issue, which we've seen before, is that our call to action over here is looking very weird because of the left padding over here. So we also need to fix some spacing issues like padding and margin. Now throughout this topic, we're going to be using relative units to make our homepage more responsive. Next up, let's take a look at our first relative unit, percentages. We'll be discussing what are percentages design guidance, and common percentage value use cases. So what are percentages? A percentage is a unit that is always relative to some other value. There are two main use cases in CSS. The first is relative to a parent, and these are commonly used on CSS properties like width, height, margin, and padding. Using percentages relative to a parent is very common. Looking at an example of this, in green I have a container. Its width is 1000 pixels, and its height is 600 pixels. If we were to place another container like a div inside of this container, the red container is now a child of the green container. We could then set the width and height of this red box relative to its parent dimensions. So we could do something like this. We could set the height of the box to 50%, which would be 300 pixels, 50% of 600 pixels. And we could set the width to something like 40%, which would be 400 pixels, 40% of the 1000 pixel width of the parent element. So we're using percentages for the width and height of our child element, where the final pixel value is being calculated based on the width and height of the parent element. Another use case of percentages is relative to the element itself. You can use this on a property like line height. I do just want to flag that there are very few elements you can do this with, so don't worry too much about it. Using percentages relative to a parent is way more common. But let's look at this. If we have some text, this text would have a height which is determined by its font size. Let's say it has a font size of 20 pixels. We could then apply line height as a percentage of the element itself. So let's say 200%, which would be 40 pixels. We're using the font size of 20 pixels and doubling it to apply line height of 40 pixels. Let's check these out inside VS Code. So I've got a blank index.html file, and I've gone ahead and connected a blank style sheet app.css. Inside the body, I'm going to create a div, and I'm going to nest another div inside of this. We'll give the parent div a class of parent, and we'll give the child div a class of child. In app.css, I'm going to select the parent, I'm going to give it a height of 500 pixels, and for now let's give it a width of 800 pixels. And let's give it a background color of light blue. Let's go and select the child, we'll give it the same height of 500 pixels. For now I'm going to give it a fixed width of 600 pixels, and let's give it a different background color of light salmon. Alright, let's check this out in the browser. Okay, so we have our blue parent over here, and our salmon-colored child over here. As we know from the HTML markup, the salmon-colored box is a child of the parent. Now I want to go change the width value of the parent. Let's make it 1000 pixels. I'm going to refresh. You can see that the parent width has increased, and as expected, nothing's happened to the child, because we're using absolute units. I'm going to change this back to 800 pixels, and now instead of width 600 pixels, let's go change this to 50%. I'll refresh, and now you can see what's happened. The child element is now 50% the width of the parent, which would be 400 pixels. Let's check this out inside DevTools. I'll select the child element, and on the box model, you can see it's 400 pixels wide. Now here's where the magic happens. If I come and change the parent width, let's now make it 1000 pixels, the width of the child will still be 50%. So let's refresh. So you can see now that the width of the child has gone to 500 pixels. That is, the child width is directly proportional to the parent width. Let's now have a look at the other case where we could use percentages relative to the element itself. And as I mentioned, this is less common, but I still want to show you. I'm going to go remove these divs, and I'm just going to add an h1 tag. Let me put some text. In app.css, I'm going to remove these styles, and I'm just going to select the h1. Let's give it a font size of 20 pixels. I'm going to give it some background color of light green, and let's apply a line height value of 200%. So we would now expect a line height value of 400 pixels. Let's check this out in the browser. So you can see over here is our text, and there's height above and below. And if we inspect this in DevTools, we can see that the height of the element is now 40 pixels. That is 200% or double 20 pixels. So let's now take a look at some percentages guidance. Percentages are used in conjunction with max width on main containers so that the web page is fully responsive. Let's have a look at this page over here. We can see the container in red, and this container would have a max width property where the value would still be in pixels, which is very common to do. When we reduce the width of the browser for a viewing experience on tablet or mobile, we want to ensure the content inside the container is not right up against the edge of the screen on the left and right. If you remember, the max width property just sets the maximum width, where the content can still reduce. So we need a way to ensure that there's still space left and right of the main container. We have our body over here in green, and you can see our container in red. So in addition to the max width property, which is mostly there to control maximum width on larger screen sizes, we apply a percentage of the body when the screen is smaller to prevent the content going right up to the edges. So you can see we have some spacing on the left and right of the main container. So let's see this in action. I'm currently on this home page on my desktop, and you can see there's a lot of space left and right, as all of this content is in a container. And this is being controlled by the max width property. Let's check it out in DevTools. Over here we have this div with the class container. So I'm going to click on that. The container has a max width of 75 rems. We're going to be talking about rems soon, which is a relative unit. Now I'm going to come turn this max width off, and you'll see that the content stretches much further. The max width is here to ensure that on larger screens like a desktop, the content inside the container doesn't stretch too far horizontally. I'm going to come and reduce the width of my browser, and you'll see that the container on the left and right reduces in space, because on smaller screen sizes like a mobile, we need our content to take up more space, as space is limited on smaller screen sizes. However, you will note that there is still a bit of space left and right, and that's there to avoid the content butting up left and right on the edge of the browser, because that would not be a good viewing experience. So max width has nothing to do with this now. This is now controlled by a percentage value. I'm going to go back to the full screen. On the container, if I turn width 95% off, you can see nothing happens on the desktop view. I'm going to turn it back on, and let's go toggle the device. I'm going to reduce the width, so we get to a device like a mobile. I'm also just going to remove some styles from this app media. This is called a media query, and it's something we'll be discussing later on in the course. I'm just going to scroll down on the page to this heading and paragraph here. Watch what happens when I turn the width off. You'll see the content moves a lot closer to the left and right of the screen. I'm just going to toggle it on and off so you can see it again. Now I'm going to turn the width back on, and I'm going to change it to another value, like 70%. And you can see now that there's a lot more space left and right. This is not something you would do, as this doesn't look great, but I just wanted to show you that for smaller screen sizes, we now introduce the width property, in addition to the max width property, but we use a percentage value on the width to ensure that there is still a container which has space left and right on smaller devices. Now this is something we're going to be implementing on our Quill project, and I'll be discussing it in more detail there. So don't worry too much about it now. I just wanted to show you that percentages are commonly used on a main container, and they're specifically used to ensure that there is still a container with spacing left and right when our page is on smaller devices like mobile. So let's look at some more percentage guidance. Percentages are used in conjunction with max width on standalone images so that the web page is fully responsive. Here's the Notion homepage, and you can see we have this large standalone image over here. To avoid the image stretching too wide on desktop screens, we apply the max width for larger screens. Now this works well on larger devices like a desktop computer, but there is some extra work we need to do for mobile. On the mobile device, we have our main container here in green, and for our image, in order for it to be responsive, we need to also set the width to 100% on smaller screens so the image scales to the full width of the container. So on this image, we'd have both the max width property, which is there to prevent the image stretching too wide on larger screens, and we would also apply width as 100%. And this ensures the image reduces in size as the width of the browser reduces. Now, just a quick reminder about why we need to do this. It's because an image is an inline element. So we're going to be looking at an inline element reminder. Inline elements will extend beyond the browser when it is narrower. So let's say, for example, we have our image with a max width of 1200 pixels. We have our browser, which is currently at 800 pixels, less than the max width of 1200 pixels. For an inline element like an image, it doesn't scale down like a block element would. It extends beyond the width of the browser, so it would remain at 1200 pixels. Now, one thing I want to highlight is that for standalone images, we're applying a width value of 100%. All that this is doing is ensuring that the width of the image scales at the same proportion as the width of the main container. Now, a block element would do this automatically, but for inline elements, we need to explicitly set width as 100% to ensure that it does scale down as the width of the browser reduces. I also just want to note that in the previous guidance, we were setting main container widths to a value less than 100%. That was to ensure that there was space left and right of the main container. In this case, we're setting the image to exactly 100%, so it scales in direct proportion with the main container. There are going to be quite a few percentage values flying around as we move through this guidance. Towards the end of this chapter, I am going to provide a summary of the different values we use in the different use cases, so just stick with me. So let's check out an example of this behavior. So I'm on this web page here, and if I scroll down, we have this large standalone image. As I reduce the width of the browser, you can see that the image scales down. I'm going to extend the browser back to the full width of my screen, and let's open up DevTools and see what's going on here. I'll select the image, and you'll see we have this max width property of 1012 pixels. I'm just going to turn that off, and you'll see the image goes quite a bit larger. So again, the max width property is there to ensure the image doesn't scale too large for bigger screen sizes like a desktop. I'm just going to pop it back on. You can also see over here the width property set to 100%. I'm going to turn that off, and let's see what happens as we reduce the width of the browser. You can see the image doesn't reduce in size now. And as I explained earlier, because an image is an inline element, it now overflows, and I can scroll right on the page to see the image. So that's what the width 100% is doing. It's ensuring that as you reduce the width of the browser, the image scales in the same proportion. So let's turn it back on, and you'll see now the image is scaled nicely. The next percentage guidance is that it is common to set images inside a grid or flex container to 100% so it fills the cell and adapts responsively. So far in this course, we haven't looked at grid or flex, and we still need to learn about it, but I did just want to provide this guidance now. On this page, we have a grid layout, shown by these two green boxes. The grid layout is 2 columns and 1 row. The image on the right is inside a grid cell, which acts as a container. And as you can see, the image nicely fills the container. And that's because we're setting a width on the image to 100%. 100% of the parent element, that is, its container. So let's go check out an example of this. So I'm on the Notion homepage towards the bottom. What we have over here is a grid layout. We have 2 columns and 1 row. Let's open up DevTools, and I'm going to select the image in here. You can see the width is currently set to 100%. I'm going to turn that off, and you'll see the images go huge. I'm going to open the image in a new tab, and you can see this is the actual size of the image. In order to scale it inside this grid cell, we need to set the width to 100%. Another example of this is using these icons over here. This is a much larger grid. It's got 7 columns and 3 rows. I'm going to go inspect the image. I'll click on this one here. And again, you can see we have width 100%. Let's go check out the actual size of this image. I'm going to right click and open the image in a new tab. You can see it's quite large. Coming back to this page, if I turn the width 100% off, and I'm also going to have to turn the height 100% off, you can see the image disappears. And that's just because it's gone huge inside that container, and all we're seeing is the top left of the image here. So it just looks like a white box. So again, setting width 100% ensures that the image nicely fits inside a grid cell. For the next piece of guidance, there are cases when you want to set a button width to 100% so it fills its container and adapts responsively. Let's check in this login page over here. This login form has a container shown in green around the headings, buttons, and inputs. We have buttons at the top over here and the blue button down here. And as you can see, the button stretches the width of the container. And in order to achieve this, we're applying a width of 100%. Again, the parent element here is the container, and we want our button to stretch the full width. So we apply width as 100%. That is 100% of the container width. Let's check this out in the browser. So I'm going to open up DevTools, and I'm going to grab this button element. You can see over here, width is set to 100%. Let's turn that off and see what happens. Now, because a button element is an inline element, we know that it'll just occupy the width of the content. And we can see that with this blue box. So to visually enhance this form, we want to stretch the button the full width of the container. You can see in blue over here. And again, that's done by setting a width as 100%. All right, the last piece of percentage guidance. Percentage values are used for fully rounded corners as pixels require manual calculation. I mentioned in the border radius chapter, we would later be changing our pixel values to percentages. Now we often want fully rounded corners on elements like buttons and images. Let's say we have an anchor tag over here. Its height is 120 pixels, and we set a border radius of 60 pixels. I'm setting it as 60 pixels, as that's half the height. The way this works is we get a radius of 60 pixels inside our circle, and the sections in red are effectively cut away, which leaves us with a pill shape like this. If we had an anchor tag, which was 40 pixels, in order to get fully rounded corners, we would set a border radius of 20 pixels, again half the height. And the same thing happens. We get a radius of 20 pixels, and the bits in red are cut away. So in order to get fully rounded corners, the border radius is half the height of the container. So as you can see for pixels, we manually have to calculate half the height in order to apply a border radius, which gives us fully rounded corners. But using percentages is a lot more effective. Let's say we have the same anchor tag over here, and we now apply a border radius of 50%. We also have the same smaller anchor tag here, and again, we apply a border radius of 50%. So now the border radius is calculated automatically as half of the container. We don't need to manually work out the border radius. And this gives us the same result, fully rounded corners. Alright, we've looked at quite a lot of guidance and had a lot of different percentage values flying around. As promised, I've created a table of common percentage use cases. Just to help summarize this. The first piece of guidance we looked at was for main container. This had a max width property to ensure the content in the container doesn't stretch too wide on larger screens. And we would also apply a width of a value less than 100% to ensure that on smaller devices, the container still had space left and right. We looked at a standalone image. This also had a max width, so the image didn't stretch too wide on larger screens. And we would also apply a width of exactly 100%, so the image scales proportionally as the width of the browser reduces. We looked at images in grids. This just had a width of 100% to ensure that the image filled the grid cell. We also looked at full width buttons, and we saw this used in a form to ensure the button stretched the width of the form. And to achieve that, we applied a width of 100%. And the final case we looked at was rounded corners. And to achieve this, we apply a width of 50%. So let's wrap up this chapter by continuing to add to our CSS units summary card. In this chapter, we looked at percentages. The common use cases for percentages was on main containers, images, and border radius. Now you can see border radius is used both in pixels and percentages. We use percentages specifically when we want fully rounded corners, and we use pixels for border radius when they're not fully rounded. So let's go and apply percentages on our Quill homepage. The first place we're going to apply them is on our main container, so that when our page reduces in width, there's space left and right. For us, the parent element is the body tag shown in green, and we have our main container here in red, where we will now go and set a width as a percentage value less than 100% to ensure that as the browser reduces in width, we have that space in white left and right. So let's jump into VS Code and add this to our CSS. So I'm back inside the index.html file, and you can see our main div here with the class container. This div is a child of the body tag. So applying width with a percentage value here will reduce its width in proportion to the body. And the body is just the full width of the page. Let's head over to app.css. I'm going to scroll down to my global styles. And over here we have our container. In a previous chapter, we already set the max width at 1200 pixels. And that's there to ensure that the container doesn't go wider than 1200 pixels on larger screens. I'm now going to go add a width of 90%. And again, this will ensure that when the width of the browser reduces, there's still some space left and right. So let's check this out in the browser. So to see the effect of this, I'm going to go reduce the width of the browser, And as I'm reducing the width, you can see we still have some space left and right. And this is being achieved by having the width set to 90%. I'm going to open up DevTools, and I'm just going to turn the width of 90% off, just to show you what happens. So now again, I'm going to reduce the width of the browser. And as you can see, the content is butting up right against the left edge, which just doesn't look great. So that's what that width 90% is doing. The entire container is 90% the full width of the page. You can see if I go on the body, the current width is 892 pixels. And when I click on the container, its current width is 802 pixels. 802 divided by 892 is 90%. So the remaining space, 892 minus 802, which is 90 pixels, divided by 2, 45 pixels, would be left and right of the main container you see now. And again, just to drive this home, the max width property is there just to ensure that on larger screens, like what I'm on now, the content doesn't extend too far. If I untick this, for larger pieces of content, like this paragraph over here, you can see it just doesn't look great. It's just too wide. Setting a max width on the container ensures all the content is nicely contained within 1200 pixels for larger screen sizes. Now the second thing we need to do is add a width 100% onto our images. We effectively want to reduce the width of the image so it's less than the max width and stretches to the container edges on smaller screens. I'm back in the app.css file, and I'm going to scroll down to the features section where we have our feature image. The image currently has a max width of 400 pixels, and not so long ago, we actually already added in the width property of 100%. I did this before we knew anything about percentages, but I had to do it back then in order for the image to scale down. But now you'll have an understanding of why we did this. It's because images are inline elements, and if we didn't add the width of 100%, the image's width would remain at 400 pixels, so that when the browser reduces less than 400 pixels, the image would overflow. Applying width 100% to an inline element is essential to ensure that it reduces proportionally as we reduce the width of the browser. So let's check this out. So I'm going to come and inspect the image, and you can see max width of 400 pixels and a width of 100%. Again, the max width is there just to ensure that the image's maximum width is 400 pixels. If I turn that off, the image goes huge. You can see if we look at the box model here, the image is currently 400 pixels. The browser width is 470 pixels. Watch what happens when I reduce the width of the browser. You can see the image is reducing in width. If I turn this property off, you'll see the image scales back to 400 pixels. And again, that's because it's an inline element. And an inline element, when you apply max width, will just be that width, when less than the max width you set. So because we're less than 400 pixels, the image is just set at 400 pixels. In order for it to scale down, we have to explicitly set width as 100%. Now it's time to dive deep into scalable units that help make text and layout more responsive with rems and ems. We'll be discussing what are rems and ems, and we'll be looking at rems and ems design guidance. So what are rems? Rems are a unit that is relative to the root element's font size and are the key ingredient for creating responsive web pages. Now, before we dive in, I just want to highlight rems are really important. They are the primary driving force of making our pages responsive. That is, scaling our content for different screen sizes. So this sentence may not be the clearest, so let's break it down. We'll be talking about the root element first. As a reminder, in our HTML document, we have this HTML tag, which we call the root element. Back in the HTML full course, I spent a chapter on document structure, and you can see over here are these HTML tags. This is the root HTML element which wraps all other elements. It's the same as a book cover wrapping all the pages. In HTML, it's the tags that wrap all the other content. Now the font size of the root element is 16 pixels. And what we're going to see now is that we can size different elements based on the root element's font size of 16 pixels. So let's look at an example of this. I've got over here an anchor tag with different properties. The first property is the font size of the anchor tag, which is currently set to 2 rems. So this font size would be 2 times 16 pixels, which equals 32 pixels. Again, the 16 pixels is coming from the root element's font size, which is 16 pixels. We can also use rems on non-font size properties. So for example, the padding of this anchor tag is currently 0.5 rems, which would be equal to 0.5 times 16 pixels times 8 pixels. Again, the 16 pixels is coming from the HTML root element, which has a default font size of 16 pixels. The last declaration, margin bottom, has a value of 3 rems. This is 3 times 16 pixels, which is 48 pixels. Alright, so you're probably thinking right now, this is just really confusing. What is all this extra work of using this rem value, which is dependent on the root element's font size, and then I've got to multiply numbers by it? Why can't I just put my values like 32 pixels, 8 pixels, and 48 pixels? And I agree with you, it does seem really confusing. But let's go play around in VS Code to get a taste of why rems is so powerful. Alright, I've gone ahead and created this index.html file. I've got an h1, a paragraph, and an anchor tag. I've also linked a style sheet, which is currently empty. So let's head over to app.css and add some rem values to our different properties. I'm going to select the h1. Let's apply a font size of 3 rems, which again is 3 times 16 pixels, which would be 48 pixels. Let's apply a margin bottom of 2 rems, which is 2 times 16 pixels, or 32 pixels. Let's grab our paragraph. We'll give it a font size of 1.5 rems, so 1.5 times 16 pixels, which would be 24 pixels. We'll give it a margin bottom of 1 rem, so 16 pixels. I will grab the anchor tag. We'll give it a padding of 2 rems, which is 32 pixels. Let's give it a background color of light blue. And just so that the padding applies correctly, we're going to change the display property to inline block. And just as a quick reminder, that's because an anchor tag is an inline element, and for box model properties like padding to apply properly, we need to change it to inline block. Alright, so let's check this out in the browser. So you can see the different elements over here. Let's open up DevTools, and let's inspect the heading. You can see it has a font size of 3 rems and a margin bottom of 2 rems. Looking at the box model down here, you can see the margin bottom is 32 pixels. 2 times 16 pixels. If I head over to Computed, you can see the font size is 48 pixels, which is 3 times 16 pixels. And again, just to really drive the point home, all of these values are being calculated off the root element's font size. The default font size of the root element over here is 16 pixels. Now 16 pixels is not the nicest value to work with, so we can actually change this value. Just to show you this, if I make some space here, select the root HTML element, and give it a font size of 16 pixels, I'll refresh and you'll see nothing happens. And that's because the default font size of the root element is 16 pixels. Now, as I mentioned earlier, I do want to give a bit of a taste of why rems is so powerful, because at the moment, it just seems like a lot of work. In a later topic, we're going to be learning about media queries, and what media queries allow you to do is apply styling for specific widths of your page, which can be used for specific screen sizes, like mobile, tablets, and desktops. So for different screen sizes, what we're going to do is actually change the font size of the HTML root element. So for example, on a mobile, we might want our root element's font size to actually be 8 pixels. If I refresh the page, our font size, margin, and padding all dynamically updates by changing a single value. That is, the font size of the root HTML element. And for larger screens, we might set it to a value like 20 pixels. I'll refresh, and you'll see all the values dynamically update, all based off the root font size. Alright, I'm just going to go change this back to the default font size of 16 pixels. Now the default root element font size of 16 pixels is not the nicest value to work with. But let's go and see how we can make our lives a bit easier. Working with a base 10 pixels for rem units makes it simpler when thinking about sizing elements. My advanced maths is pretty good, but my basic maths sucks. So when I'm thinking of values, to have 16 as my base unit to multiply with fries my brain a bit, but 10 pixels is much easier to work with. So what we can do is inside our CSS file, we can select the HTML root element, so it's fixed at 10 pixels, which means 1 rem now equals 10 pixels. So let's go add this in VS Code. So I'm back inside our app.css file, and I'm just going to go update the root HTML font size to 10 pixels. I'll refresh, and you can see straight away all these elements adjust. Now the font size is 3 times 10, which is 30 pixels. Just so that we can use this new value, let's go change the font size to be 5 rems, which would be 5 times 10 or 50 pixels. Let's go open up DevTools just to confirm this is the case. I'll select the heading. You can see a font size of 5 rems. Heading over to Computed, we can see a font size of 50 pixels. I can also confirm on the HTML root element, we can see the font size of 10 pixels. And if I go to Computed, the font size is 10 pixels. So that's now the base unit we're working with. Now working with 10 pixels is certainly a lot better, but we do need to account for one more thing. What I want to show you is that your browser has a default font size it's using. Inside Chrome, I'm going to click these 3 dots. I'm going to head over to Settings. I'm going to go to Appearance, and you can see over here font size. This is currently set to medium, which is recommended. Now medium is 16 pixels. Looking at some other values, very small is 9 pixels, small is 12 pixels, large is 18 pixels, and very large is 24 pixels. Now I just leave my screen at medium, but whenever I grab my mum's laptop or phone, the text is seriously massive. It takes about 10 times longer to scroll through a page when looking at something on her phone. So to make it easier for her to read, she's using large or very large as her font size. Now the problem with setting font size at 10 pixels overrides those font sizes in the browser, which means that if someone were to go adjust the font size in their browser, like my mum, it just wouldn't scale accordingly. So to fix this, we instead set a font size of 62.5%. So where does this number come from? Well, we want our font size to be 10 pixels. All I've done is divide 10 by 16, which is 62.5%. 10 pixels is the value we want for a medium screen, but in the browser, the medium screen is set at 16 pixels. So what I'm doing is I'm effectively taking 16 pixels, which is the browser's font size, and multiplying that by 62.5%, which then gives me 10 pixels. And using a percentage value like this means we can use the different font sizes and just apply 62.5% to each of them. So this will scale if the user updates their browser font size. Looking at some mathematical examples, for medium, 62.5% times 16 pixels is 10 pixels, which is the value we want. And for very large screens, 62.5% times 24 pixels is 15 pixels. Again, the 24 pixels comes from the very large font size. So by using 62.5% for the different font sizes in the browser, we're multiplying each of them so that if someone were to go change their browser font size, everything still scales nicely. So let's go and update that inside VS Code. I'm just going to change our 10 pixels to 62.5%. If I refresh, nothing will happen. But now we've ensured that if the font size of the browser changes, this will scale accordingly. And just to demonstrate this inside the browser, let's go to the settings. I'll go to Appearance. For the font size, let's change it to very large. You can see the text goes very large. It's taking the browser's very large font size, which is 24 pixels, and multiplying it by 62.5%. Let's go change it to very small, and you'll see everything goes much smaller. The very small font size value is 9 pixels, so it's taking 9 pixels and multiplying it by 62.5%. All right, I'm just going to change it back to medium, and I want to show you what happens if we left this at 10 pixels. As you can see, there's been no change because 10 pixels is the same as 62.5% times 16 pixels, which is the medium case. But watch what happens now. If I go change this to very large, there's no change. And if I change it to very small, there's also no change. And that's because doing this is overriding the font sizes you set in your browser. So that's why using a percentage value is a lot better. Let's now take a look at some rems guidance. Rems are commonly used on font size, margins, and paddings to create fully responsive web pages. I have this homepage on the left over here. We have some padding applied above the main heading, and you can see the font size is quite large. Looking now at the mobile version of this page, the padding over here reduces, and the font size also reduces. And as I've mentioned, when we learn about media queries later on in the course, all we're going to be doing is changing the font size of the root HTML element for different screen sizes, which will automatically adjust the font size, margin, and paddings for different screens. Let's now look at ems. Now, ems are not as frequently used as rems, but we do need to go through them, as you will see them out there in the wild, and you also may want to use them in your own project. Ems is a relative unit that is more context-specific compared to rems. When I say context-specific, I just mean closer. As you know by now, inside an HTML file, you can have many levels of nesting. Rems are relying on the root HTML element, which could be many nested layers above the element you're styling. Ems are not based on the root element. They're based on an element much closer to the specific element that you're now styling. Now, there are two main use cases of ems. The first is for typography, where the element you are styling is relative to the font size of the parent. Properties you would use include font size, line height, and letter spacing. And again, I really want to highlight that we're relative to a parent now, and not the root HTML element. Our reference point is much closer or context specific. So let's go play around with this inside VS Code. All right, so I've gone ahead and set up a new index.html file. I've created a div, which has a class feature1. I have an h1, which has a class feature heading. I have a paragraph, which has a class feature paragraph. And I have an anchor tag with the class feature button. So let's move across to app.css. I'm going to select feature1, which again is our parent element. And I'm going to set its font size as 10 pixels. I'm going to select the feature heading, and I'm going to give it a font size of 2ems, which is 2 times the 10 pixels. As we discussed earlier, ems is based on a parent element's font size. Because I'm setting this parent element font size to 10 pixels, the font size of the heading will be 2 times 10, or 20 pixels. Let's go set some other properties nested inside the div. We'll select the feature paragraph. Let's give it a font size of 1em, so 1 times 10, which is 10 pixels. And let's select the feature button, which is that anchor tag. We'll give it a font size of 0.5ems, 0.5 times 10, which is 5 pixels. Let's also just give it a background color of light blue. All right, let's check this out in the browser. So you can see our heading, paragraph, and anchor tag over here. Let's just go confirm their sizes. I'll open up DevTools. I'll select the heading. You can see its font size is 2ems. And if I go to computed, you'll see the font size is 20 pixels. That's 2 times 10 pixels we set on our parent element. Now, if I go change the font size of the parent element, so let's go make it 20 pixels, you'll see all the values will double. So now the font size is 40 pixels of the heading. Now, just to really highlight that ems are based on a parent as opposed to the root element, let's go back into index.html. I'm going to copy this and paste it here. And I'm going to update this class to feature2. Inside app.css, I'm just going to change this back to 10 pixels. And I'm going to go select feature2 and give it a font size of 20 pixels. And these styles are still being applied to the content inside both feature1 and feature2. So let's check this out in the browser. So what we can see here, because the feature1's container has a font size of 10 pixels, whereas our feature2 container has a font size of 20 pixels, the elements in here are effectively double the elements in here. Because feature's 1 font size is 10 pixels, whereas feature 2's font size is 20 pixels. Now, you just wouldn't be able to do this with rems. Just to demonstrate this, I'm going to remove these styles. I'm going to get our HTML root element. I'm going to set its font size to 10 pixels. And I'm just going to update these all to rems. If I refresh, you'll see both feature 1 and feature 2 are now the exact same. And that's because they're all being based off the single HTML root element. Whereas before, I was able to size the features differently based on the parent element's font size. Now, in addition to typography, we can apply ems to other properties. And these are relative to the font size of the element itself. Common properties include width, height, margin, and padding. That is, box model properties. Let's play around with these in VS Code. I'm back inside the index.html file we were just in earlier. I'm going to go remove all of this. I'm just going to add a single anchor tag. For now, I'll point it to Google. I'll just have the text, click me. Inside app.css, I'm going to remove all these styles. I'll select the anchor tag. Let's give it a font size of 50 pixels, padding of 20 pixels, top and bottom, 40 pixels left and right. Let's give it a border radius of 20 pixels. Let's give it a background color of light coral. And for the box model properties to display properly, we need to change this display property to inline block. All right, let's check this out in the browser. So as expected, we have a button component. Now this is obviously quite a large button. If I had a smaller button in the application, and I wanted the font size to be 10 pixels, if I only change the font size and refresh this, you'll see this just looks quite bad. There's way too much spacing around the element. So instead I can do this. So let me first just change this back to 50 pixels. So a better approach would be allowing us to scale the button based on the font size. So to do this, we can use the font size of the anchor tag set here and apply M properties to the padding and border radius. And that way, when we change the font size, these two properties will scale accordingly. So for the padding, we have a reference font size of 50 pixels. For 20 pixels, we would need to change this to 0.4 em. 0.4 times 50 gets us back to 20 pixels. For 40 pixels, this would be 0.8 em. 0.8 times 50 pixels gets us back to 40 pixels. And again, 20 pixels is 0.4 em. So if I refresh, there won't be any changes. But watch what happens as I change the font size now. Let's go to 20 pixels. I'll refresh, and you can see the button is scaling correctly with the font size. The padding and border radius has scaled nicely. So we can put any font size value we want here. Let's go make it huge at 100 pixels. You'll see again, the proportion of the border radius and the padding top and bottom is scaling with the font size. So let's now take a look at some EMS guidance. EMS provide a higher level of precision for styling smaller components, as sizing is based on font size of the element itself. So like we just saw, we can have button padding based on the font size of the button itself. Now EMS do provide a lot of precision, but the truth is, using rems will make very little visual difference. In our Quill project, we're only going to be using rems. And I suggest when you start out, you also just use rems. When you become a bit more advanced with CSS, and you really want precision styling, feel free to use EMS. And just to show you that using rems is totally fine, let's take a look at this application. I'll open up DevTools, and let's go click around on some different elements. We'll click on this heading, and you'll see its font size is set at 3.7 rems. If I go to a component like a button, which is a good candidate for using EMS, you'll see again, box model properties like border radius and padding are still set in rems. So here's an example of a professional working application that's just using rems everywhere. And as I said, we're going to be doing the same, and I wouldn't worry too much about EMS. So let's finish up by adding to our CSS unit summary card. In this chapter, we looked at rems. We saw common use cases for rems include text, margin, and padding. And again, the power of using rems is that when we get to the responsive design topic and learn about media queries, we can instantly change these values by changing the HTML root element's font size for different screen sizes. And this will automatically adjust the text margin and padding properties. Now, pixels, percentages, and rems are more commonly used, and we're going to be using these throughout our Quill application. There are also properties which are used for specific cases. EMS is an example of one of these. Applying EMS to margin and padding is a common use case. But again, rems are totally fine, and will make things a lot simpler as we start out. Alright, so let's go add rems to the Quill homepage. So we're going to go update anytime we're using pixels for fonts, margin, and padding. So all font sizes will be changed to rem, all paddings will be changed to rem, and all margin will be changed to rem. So all we're going to be doing now is updating a whole bunch of values, so we can use rems moving forward. So I'm back inside the app.css file of our project. We're going to scroll down, and the first thing I need to do is select the HTML root element. We always want the Universal Selector to come first, and we're going to pop the HTML root element underneath this. Like we saw earlier on, we're going to set the font size to 62.5%. This is basically the same as 10 pixels, and as we spoke about earlier, this is better practice because if someone updates the font size in their browser, like my mum, to something much larger, we're not overriding that value, with say a font size of 10 pixels. So that's the first thing we need to do. Now we need to go change a whole bunch of pixel values. I'm also going to be highlighting values we don't want to change. In the container, 1200 pixels, we don't want to touch that. We only want to be applying rems to things which we do want to scale. The reason we have max width at 1200 pixels is for much larger screens. As soon as we start moving down to smaller screens, we want to use rems. But for a large screen size, there's no need to apply rems because it's only being used for one case. and that's to ensure our content doesn't spread too wide on larger screens. Anytime we're using small values of pixels, like letter spacing, there's also no point in using rems, so we're going to leave this as -2 pixels. All the font sizes, we definitely want to update to rems. So I'm going to change 62 pixels to 6.2 rem. 48 pixels will now become 4.8 rem. 40 pixels will become 4 rem. 32 pixels, 3.2 rem. 24 pixels, 2.4 rem. Now for our paragraph, we're also going to update this to 2 rem. Our anchor tag will be 1.6 rem. Our small text also needs to change to 1.2 rem. So we've updated the global styles. Let's now go update our different components. The font size in the button, we want to change to 1.6 rem. The pattern we want to change from 15 pixels and 30 pixels to 1.5 rem and 3 rem. The border radius of 8 pixels, we're just going to leave. As we've seen earlier, border radius is a property we just keep in pixels. It's such a small value that rems has very little significance. For the different states of our button, we can see 2 pixels is being used on the border. And again, we're not going to go change that. It's such a small value. For the highlight, we're going to update the padding here to 0.5 rem and here to 1 rem. Again, border radius we're not going to touch. Now for small images, like our logo, medium and small, we're just going to leave those as fixed widths in pixels. As we saw in the guidance earlier, we continue to use pixels for logos and icons. Let's now go down to the different sections of our page, where we'll be changing a lot of margin properties. We'll change our 200 pixel value here to 20 rems. In the hero section, this will now become 30 rems. 10 pixels will become 1 rem, and 50 pixels becomes 5 rems. In the features section, 300 pixels will become 30 rem. The margin bottom here will now become 8 rem. 20 pixels will change to 2 rem. And again, the max width here, I'm just going to leave it 400 pixels. It's the exact same guidance with our container. When using max width, that's just ensuring an image doesn't go too big for a certain screen size. As soon as we reduce the width of the browser, that disappears anyway, and width 100% takes over. We don't need to apply rem values for max width. Going down to our CTA section, we're going to update 300 pixels to 30 rems. And for our CTA card, we're going to leave the max width at 1000 pixels, but we'll update the padding to 10 rem and over here to 20 rem. The border radius, again, we're just going to use pixels. Scrolling down, we're going to update 30 pixels to 3 rem. And in our footer, we're just going to leave the width of this social media icon at 20 pixels. So let's check this out in the browser. So there's been absolutely no change. All I've done is updated our pixel values to the equivalent rem value. If I open up DevTools, let's click on the heading. You can see its font size is 6.2 rems. If I go to computed and check the font size, it's 62 pixels, which was the original font size we set using pixels, but we've now changed to rems. So all we've done here is updated font sizes, paddings, and margins to rems, so that when we get to the responsive design topic, when we use media queries, all those properties will be updated when we update the font size of the root HTML element for different screen sizes. Now, just to give you a taste of this, currently the root element has a font size of 62.5%, or 10 pixels. If I update this to say 50 pixels, which would effectively be 50% times 16 pixels, or 8 pixels, watch what happens as I refresh the browser. All the font size, margin, and padding has now scaled. Let's change this to a much smaller value, like 20 pixels. Okay, again, you can see all the margin, padding, and font size has all scaled down. Now this obviously looks awful, but I just wanted to demonstrate that by just updating this single value now, the font size of the root element, it automatically updates all the padding, margin, and font size within the design. Okay, let's just change this back to 62.5%. Finally, we'll learn how to size elements relative to the viewport with VW and VH. We'll be discussing what are VW and VH, and we'll look at some VW and VH design guidance. So what are VH and VW? View height, VH, and view width, VW, are units that are a percentage of the browser's visible window. So they're kind of like percentages that we've seen earlier, but VH and VW are specifically a percentage of the browser, whereas percentages was based on some parent element. So let's say we have our browser, which currently has a height of 1800 pixels and a width of 3000 pixels. we could have an element shown in red, and we could define its height as 80VH, which would equal 1800 pixels, the height of the browser, times by 80%, which would give us a value of 1440 pixels. We could give the element a width of 50VW, which would be 3000 pixels, the browser width, times by 50%. This would equal 1500 pixels. So once again, we're defining the element's dimensions, its width and height, based on the browser's current width and height. Now, of course, the browser can change in both width and height. As a user, you can always go and change the dimensions of your browser. So let's say we now reduced our browser in both width and height. The browser now has a height of 1000 pixels and a width of 2200 pixels. The element's height was defined as 80VH, which is now 1000 pixels times by 80%, which would be 800 pixels. For the width, we defined it as 50VW, which would now be 2200 pixels times by 50%, which equals 1100 pixels. So you can see that as we change the width and height of our browser, the element is changing based on the VH and VW values. So let's play around with this in VS Code. I've got the boilerplate HTML, and I've gone ahead and linked a style sheet, which is currently empty. So all I'm going to do is add a single div. Let's head over to app.css. I'll select the div. Let's give it a width of 60VW and a height of 40VH. And just a reminder, VW stands for view width and VH stands for view height. And finally, let's just add some background color of light blue. I'm also just going to use the Universal Selector to remove all padding and all default margin. So let's check this out in the browser. So currently my browser is the full width and height of my screen. So let's open up DevTools. We'll select the div. I'm just going to scroll this up, and you'll even see as I'm scrolling this up, the height of the div is reducing. You can see in the top right corner, the width and height of my browser. So I'm just going to go land at a nice value like 300 pixels. So right now, my browser is 1280 pixels by 300 pixels. Let's go look at the box model. You'll see that the current width of the element is 768 pixels. We defined our width as 60 view widths. So it's going to be 60% of the width of the browser, which is 768 pixels. We defined a height of 40 view heights, which is 40% of the browser height, or 40% of 300, which would be 120 pixels. I'm going to now change the browser width, and you can see the width of the element is also reducing. So it's always 60% the width of the browser. I could also go to the bottom of my browser and reduce the height there. And you can see as I move around, the element is always scaling based on the view height and view width I defined. So let's now take a look at some VH and VW guidance. VH can be used on hero sections in conjunction with min height, so content is always above the fold. Now, above the fold just means it's the portion of the page you don't need to scroll for. Above the fold comes from the newspaper industry. When newspapers are folded, it's the top section of the newspaper. That is, the most important content you want your readers to see straight away. So what we could do is on our hero section, define a total height of 100 view heights. And what this would do is that ensure that this content is always above the fold, so that no matter the height of the browser, you'll always see this content. And this is one of the few instances we set height on a main section. For sections, we usually never set a height. The height of a section is usually defined by the content height and any padding and margin. It's very rare to actually set the height of an entire section, but this is one example where you might want to do it. So I'm on the Duolingo homepage here, and you can see above the fold we have our navigation, this main hero section, and this banner of different languages you can scroll. Now watch what happens when I reduce the height of the browser. All of the content, including that banner at the bottom, is remaining above the fold. There's no additional scroll that's being added hiding any of this content. Eventually I do get to a height where this breaks, and you can see now it's going below the fold, and I have to scroll. So view height is being used here to ensure that until a certain height, all the content is remaining above the fold, and that at a certain point, a minimum height is being set. Because if you were to make your browser height really small, you wouldn't want all the content being forced into this small section. So view height is being used in conjunction with min height. Just to contrast this with another homepage, this doesn't have view height defined, so that when I reduce the height, you'll see the content just goes below the fold. So let's look at some more guidance. VW can be useful for creating responsive text when it is a main standalone element and not confined within a container. Looking at this page over here, this text is fully responsive. It's not within a container, and as the browser width reduces, the text width also reduces. Let's check this out in the browser. So I've got the page up at full width, and as I reduce the width of the browser, you'll see the text also reduces in width. So let's finally finish off our CSS units summary card. VH and VW are both used for specific cases, so I'm putting it in the red box on the right. For VH, it can be used for defining a section height, which we saw on the Duolingo homepage, and this is totally design dependent. As I mentioned, it's much more common for your section height to be defined by the height of its content and any padding and margin. But you can use VH on an entire section to get the above the fold effect. For VW, we saw we could use it on text, but in all honesty, this is not very common. So I really wouldn't worry too much about it. I did just want to show you a use case. All right, so let's go add view height units to our Quill project. Like we saw earlier in the guidance, on our Quill project, I want our entire header, which includes the navigation bar and this hero section, to always be above the fold, so that when I scroll up, the content isn't cut like this. Now I'm going to give a bit of a heads up. We are going to go implement the view height units, but at this stage of the course, it isn't going to work because we need to master Flexbox first. But let's go set this up. So I'm back inside our index.html file. And as I mentioned, I want all this content inside the header to always be above the fold. So let's go add a class here called header. In app.css, I'm going to scroll down to the different sections. I'll copy this and make a new section called header, which is essentially our nav bar and hero section combined. I'll grab the class header we just defined, and I'll set its height to 100 VH. So let's check this out in the browser. So if I come and scroll up here, you'll see that the page is still being cut. That's because we've defined some margin bottom on our navigation and margin bottom on our hero. Looking back at the CSS file, you can see on our nav bar, we have margin bottom of 20 rems, and on our hero section, margin bottom of 30 rems. Now, adding a height of 100 VH doesn't override that. That margin is still there. For this to work, we need to learn about Flexbox, which is coming up in a few topics' time. Flexbox is the modern approach for laying out containers and elements on your page. And once we implement Flexbox, the height of 100 VH will work. Now, I do want to show you a problem that has been introduced now that we've added height of 100 VH. If I scroll down, you'll see the content from the section below is coming up here. It's kind of like floating above our hero section. Now, the reason this is happening is because we've now defined the height of our section as 100 VH, which is 100% of the current browser window. So all that this content below sees, from its perspective, is the current height of the browser. So it thinks just to start over here. And if I scroll up further, the section below now thinks the height of the header above is just this height. So it will now start immediately over there. So to fix this, we need to also go add a minimum height so that the header is able to always maintain a minimum height. And if you remember, I mentioned we would implement this towards the end of the previous topic. So let's go do that now. Back in our app.css file, I'm just going to go add a min height, and we'll set the value to 800 pixels. So this will now ensure that the minimum height of the header is always 800 pixels. So let's refresh. I'm going to reduce the height of the browser. And if I scroll down, you'll now see that this content is only starting here, which would be 800 pixels from the top of the browser to the start of this section. So I know I may seem a little bit disappointed that we've learnt all about VH and it's not working just yet, but we need our layout to be more fluid, and to achieve that, we need to implement Flexbox, which we will be doing soon. That's all for CSS units. Well done on nailing these crucial concepts. Let's now move on to a shorter but still important topic, CSS functions. CSS functions are a powerful tool for creating dynamic and maintainable styles in web design. In this topic, we'll explore how to establish CSS variables and perform dynamic calculations, which help us create more flexible and efficient CSS. Let's begin by learning how to define reusable values for your styles using CSS variables. We'll be discussing how to set CSS variables and the root pseudo class. So what are CSS variables? CSS variables allow us to store values to make it easier to maintain consistency and more easily make global style changes. CSS variables are also known as custom properties. So let's first look at defining a variable. We do it like this, where the variable is set using double dashes. We then have the variable name, in this case primary, which is for a primary color, and this text can be whatever you want. And then we have our stored value, in this case a hex code. So there's defining a variable, and we also need to know about how to use a variable in our code. It's very simple and it's done like this. We have our property, in this case background color, and then we use this variable function, which is the word var with an opening bracket and closing bracket. And inside the brackets, we put our variable, in this case primary. So CSS variables are first defined and then used inside the variable function. So let's go and see these variables being used on some popular web applications. I'm on the Notion homepage. I'm going to open up DevTools and I'll select the heading. You'll see over here we have color with the var function with the variable name black 800 being used. For another example, I'm going to click the button over here and we can see letter spacing again with the variable function and a variable inside of it. So these are examples of the variable being used with the property. But where are these variables being defined? If I scroll down, all these variables are being defined over here on this root pseudo class. You can see all the different variables and the properties. Over here, we can see a whole bunch of colors being defined, and over here, a bunch of different spacing. So what is this root pseudo class? So CSS variables are set on the root pseudo class. We just saw it looks like this, where in red, we have the root pseudo class. And then inside the root pseudo class, we define our variables. And as we've just seen, we then use our variables with the variable function. So the variable can be used in multiple locations. So what is the root pseudo class? It's a special pseudo class selector that matches the root element in a document's hierarchy. The root HTML element looks like this, where we select the HTML tag. And this is basically the same thing. That is the root pseudo class and the HTML type selector. But it is best practice to use the root pseudo class to define your variables. Now there is a slight technical difference which makes the root pseudo class more versatile, but won't make any practical difference in our project. So we're going to be using the root pseudo class, but you could use the HTML root element. It is just better practice to use the root pseudo class. I know when I first learned this, I was seriously thrown off by this new root pseudo class. Honestly, don't worry about it. Just think of it as the HTML root element, and for the purpose of defining variables, it just has a bit more versatility for more complicated projects. So let's go play around with variables inside VS Code. I've got this new index.html file, and I've linked a style sheet which is currently empty. I'm going to go add an anchor tag. For the href value, I'm just going to point it to Google, and I'm going to put the text back here. I'll give it a class of btn. I'm then going to add a div. I'm going to give it a class of card. And inside the div, I'm going to put an h1 and put the text welcome. In app.css, let's go select the button. I'm going to give it a teal background color with this hex code. I'm going to give it some padding of 20 pixels top and bottom and 40 pixels left and right. I'll give some margin bottom of 50 pixels. We'll change this display property to inline block. For the color, we'll give it this gray value. And for the font size, we'll give it 20 pixels. Let's then select the card. I'm going to give it the same background color as what we defined on the button. I'm going to give it a width of 800 pixels and a height of 400 pixels. Finally, I'll select the H1. Let's give it a font size of 50 pixels. And we'll make it the same gray color as used in our button. Okay, so let's check this out in the browser. So as you can see, we have our button. There's some margin at the bottom of 50 pixels. And we have our teal card with an H1 saying welcome. Now, as you can see, we have some repeated values here. For example, this teal color, as well as the gray color on the button and on the H1. As you can imagine, in a large working web application, some properties are going to be repeated a lot, like color. So let's go and use CSS variables to define them in one place. I'm going to come right to the top. I'm going to select the root element pseudo class, which we discussed earlier, and I'm going to define all my variables inside here. Let's define a primary color. So I'm doing -- primary, and I'm going to store this teal value. Let's define a gray color, -- gray, which will be this value over here. Now we can store any value we want. These are color values, but let's go store some CSS units. I'll create a new variable called text-lg to represent large text, and I'm going to give this a value of 50 pixels. It's what we're using in our H1 over here. Let's go do another pixel value. I'll do --, text sm for small, and this value will be 20 pixels. So here we've defined all our variables. Let's now go use them inside the CSS. I'm going to update every place I have this teal color with the variable function, open brackets, and then I'll put in the variable, --, primary. I'm just going to copy this and paste it on the card background color as well. For the color property, let's go use the CSS variable there, which is --, gray. I'll copy this, remove the color of the H1 here, and replace it with the variable. For the font size of 20 pixels, let's go add the variable function and put our text small variable. For the font size over here, let's go remove 50 pixels, put our variable function, and grab the text large variable. So I'm going to refresh, and you'll see there's no changes. But we're now using our variables inside our CSS. And the really magical thing about variables is that the values are defined once. So if I wanted to go update my primary color, instead of updating it twice, or as you can imagine in a much larger project, hundreds of times, I'd just come to the primary variable here and change the value. Let's make it this purple color. I'll refresh, and you'll see now, wherever that variable is being used, the color changes. Now I mentioned earlier that the root pseudo class is better practice over the HTML root element, but just to show you it does work, for a simple use case like this, if I save and refresh, you'll see there's no changes. However, as I've mentioned, it's just better practice to use the root pseudo class. So let's finish up by starting to build out the next summary card, CSS functions. We looked at CSS variables, where for defining a variable, it looked like this, where we use double dashes and a variable name which we choose. We then give it a stored value, in this case a color, but we saw you can put any kind of values, like units as well. For using a variable, we did it like this, where we have our CSS property, like background color, and then we use the variable function and put inside the brackets our variable. We also learnt about the root pseudo class, where CSS variables are set on the root pseudo class. The root pseudo class look like this, and it's where we define all our CSS variables. So let's jump into VS Code and add CSS variables to our project. The first thing I'd like to do is highlight some areas where it would be useful to have a variable because the value is being repeated several times. You can see, for example, on our button, we're using our primary blue background color. And on our secondary button, we're using the secondary purple background color. We're also using these colors in our highlights. And inside the CTA section, on our card, we're also using this primary color. So if we ever wanted to later update our primary color, we'd have to go to all these locations and update it. But with the power of CSS variables, we can just define it once and just update the value on the variable, which would change all these different color values we just looked at. So I'm going to scroll right to the top, and I'm going to essentially work through our style guide at the top here and pick different property values we should convert to variables. The first values I want to put as variables are our different font sizes. So we're going to scroll down, we're going to go add the root pseudo class, and I place this right at the top above all the other selectors, as we want our variables to always load in first. I'll add a comment and put font size, and I'm going to define my font sizes like this, -- text. For the small text, I'm going to go -sm for small and give it the value 12 pixels. The next value was 16 pixels. We're using this as our base unit, so I'm going to put that as base and put 16 pixels. The next value, 20 pixels, we're using for paragraphs. So for this project, I'm just going to put -- text paragraph 20 pixels. I'm then going to put the rest of these as each of our headings. So -- text h5 with the value of 24 pixels. And just to avoid boring you, I'm going to go put the others in now. Okay, so I've added in all our font sizes as variables. Now I'm defining it like this, but it's also common to define your font sizes with notation like this, where SM is small. You could leave this as base. You could put this as MD instead of paragraph, MD standing for medium. This would then be L for large. This would then be XL for extra large. And then you would do 2XL, 3XL, 4XL, etc. That is another notation system, which is quite popular. But just for the sake of this project, I want to keep our font size variable names very specific. just so it's clear exactly what they are. The next values I want to define are our font weights. So we'll pop down here, add a new comment, font weights. I'll do -- font weight normal, which is just 400, and then -- font weight bold, which is 700. The next value is line heights. So I'll add a new comment, line heights. I'll define the variable line height tight, which will be 1.2, and line height normal, which will be 1.5. The next values is letter spacing. So let's go add letter spacing as a comment. I'll add a variable letter spacing tight, which is -2 pixels. I'm not going to define a variable for 0 because we don't actually use it anywhere in our project. So there's no need to define a variable there. Next up is font family. So I'll add a comment, font family. I'll create a new variable, font-family. And I'm just going to grab the value we're using in our project down here. So I'll copy that and paste it there. All right, back to our style guide. So we've looked at these properties. Let's go add our colors now. So scrolling back down, I'll add a comment, colors. We'll start with our primary color. I'm just going to copy the comment for easy access. I'll define a variable primary base. I'll copy that value there. Next, I'll define primary tint, and I'll copy this value here. And for the last primary value, I'll define primary shade and copy this value here. All right, just to avoid boring you, I'm going to go add in all the different variables for all our different colors. All right, so I've gone and added in variables for our different secondary colors, our different tertiary colors, our different gray colors, and white and black. So let's see what else is left in the style guide. We have border radius and our spacing system. Now, you can go and add these as variables. So for example, you could define a variable space 5, space 10, space 15, space 20, etc. For the purpose of this project, it's a bit overkill, and I'd prefer just to work with the actual units inside the project. For things like margin, the value we're going to be using is specific to the design we wish to achieve, so it's not likely you'd ever want to update those variables. So you can define these variables like border radius and space sizing. I'm just not going to. What I will say though, is that we should still use the values defined in our style guide. So we should continue to use these spacing values, and we should continue to use these border radius values. And if we come and add any more border radius values later, we need to add them into the style guide. So we still have one place where we know all our values. All right, so let's go ahead and use these values in our project. So we're going to scroll from the top of our document to the bottom and just update any values that now need a variable. The first one over here is font family. We define the variable -- font family, and you can see VS Code is able to pick it up. We also define the font weight. So I'm going to grab the variable -- font weight normal. For the line height of 1.5, we define this as line height normal. So let's get the variable -- line height normal. And this gray color is our gray base color. So let's go grab a variable -- gray base. Scrolling down, we can update the font weight of all our headings. So grabbing the variable, this was font weight bold. The line height, we defined it as line weight tight. So we'll grab the variable -- line height tight. For letter spacing, we defined this as letter spacing tight. So variable -- letter spacing tight. And the color for our headings was the gray shade. So variable -- gray shade. All right, I just realized I've just misspelled this. So let me just go update that. So this should be shade. And just making sure to update this here, shade. Now for our headings, we're actually working in rems. So I don't want the variables to be in pixels. So let me just go update those to 1.2 rem, 1.6 rem. And just to avoid boring you, I'm going to do the rest. Okay, so these are updated from pixels to rems. Let's go use them now. So for the font size, I'm going to use the variable text h1. Over here, it's the variable text h2. And just to avoid boring you, I'm going to update the remaining headings and paragraph. Okay, so I've updated all our headings to now use variables. For the anchor tag, I also need to update this, the variable text base. Scrolling down, I also need to update the font size of our small text. This was the variable text small. The font size on our button, we need to update to text base. The padding and border radius we're going to leave. The colors we're now going to come and update. For the background color, we're using primary base, which is the same over here. For the color of the text, we can also update this to white. For the hover and active states, I'm going to update the white there. This blue is the primary shade. So variable, primary shade. And it's the same value being used in the border here. So let's update that to primary shade. For the outline button, this is our base primary color. So I'll update that. And I'll update the border color. We'll change this white to our variable. That's our primary blue color. So let's copy this variable here, add it there, and add it here. Let's also update the white. For the hover and active pseudo class, we're using the shade. So I'll cut this and paste in the variable, and cut this and paste in the variable, as well as update the white. For the secondary button, let's just straight away update the white over here and over here. This is our secondary base. So let's remove this, grab the variable, secondary base. I'll copy that and update this value here. On the hover and active pseudo class, this color value is our secondary shade. So let's remove that, grab variable, secondary shade. We'll copy that and update the value here. Scrolling down to our highlight, the color white will update with the variable. Padding and border rays we leave. And these are just the different base colors for primary, secondary, and tertiary. So let's remove that. Grab our primary base, remove this, add our secondary base, and remove this, and add our tertiary base. Scrolling down, so that covers us for all the components. Let's scroll down to the different sections. Now for most of the sections, there's not going to be that many variables to update, because a lot of this is dealing with box model properties, like widths, heights, padding, and margin, and we haven't defined any variables for those. So let's go and see what we need to update. So scrolling down, there's nothing here. It's all margins and widths. Scrolling down. Okay, so the only value we need to update is on the CTA card, the background color. So let's go remove this and grab our primary base color. All right, so I know that was a little bit boring, but our project is now in a much better state, where we're using variables which are defined once in our project. So let's check this out in the browser. Okay, so as you may expect, there's actually been no changes. And that's because all we've done is update the values that were used in the CSS to variables. But check this out now. If I go to our primary base, let's go change this to a totally different color, like this green. Let's update our secondary base color to also something totally different, like this pink. And let's update our tertiary base to this turquoisey color. So I'll save and refresh. And you can see now, with just a few updates, our entire color palette has changed. Now this obviously looks horrible, but I just wanted to show you the power of using variables. All right, let me just change those back. Next up, we'll explore how to perform dynamic computations directly in your styles with CSS Calculations. We'll be discussing how to perform calculations and calculations in variables. So what are CSS calculations? We can perform dynamic calculations when setting values. And it looks like this. We use a calc function, which has similar syntax to the variable function we saw earlier, but instead of var, it's calc for calc. And inside the parentheses, we can perform calculations. In this case, we're using mixed units. We're dividing 100% by 3 and minusing 50 pixels. So let's play around with this inside VS Code. So as always, I've got an index.html file with the boilerplate, and I've linked a style sheet which is currently empty. I'm going to go add an image tag, and I've just grabbed this image of the city of Sydney for the source attribute. For the alt text, I'll just put Sydney. So let's check this out in the browser. So as expected, we just have an image of Sydney Harbour. And as you can see, it's absolutely massive because its width and height is just the size of the source file of the image. Let's head over to app.css. I'm going to select the image, and I'm just going to add a width of 100%. I'll refresh, and because this is a standalone image, the parent container is the body, and setting width 100% causes the image to fit nicely inside the body and adjusts depending on the width of the browser. I'm going to head back to index.html. I'm going to copy this image tag, and I'm just going to paste it twice. I'll refresh, and now we have 3 images of Sydney Harbour. Now, what I'd like to do is have these images next to each other. So what I could do is update this width, use a calculation, add 100% divided by 3, and then just to show you the use of mixed units, I'm also just going to subtract 50 pixels of the width of each image. So let's refresh, and now you can see the width of the image is 100% divide 3, which essentially splits the current width of the browser divided by 3, and then we're subtracting 50 pixels. Now, just as a note, this is not how you actually want to put images next to each other. We'll be learning a lot more about layouts in the Flexbox and CSS grid topic. All I wanted to show you is how you can use CSS calculations to set properties like width, and how you can use mix units like percentages and pixels. So let's now move on to variables and calculations. It is common to use variable and calculations in combination. For example, we just saw earlier, we can set variables with the root pseudo class, and you can see here, we have the text h1 variable, which has a value of 50 pixels. Inside our CSS, we could then select the h1 and do something like this, where we use the calculation function, we put in our variable, in this case 50 pixels, and we can then perform a calculation like adding on 10 view widths. In this case, what this is essentially doing is setting an initial font size of 50 pixels, and then depending on the width of the browser, the font size will scale. So let's check this out inside VS Code. I've gone ahead and added an h1 to our markup with the text welcome, and in app.css, I've just added what we just saw. We're selecting the root pseudo class, we're defining a variable text h1, and setting it to 50 pixels. We're then selecting the h1, giving it a font size, and for the font size, we're using a calculation where we use the variable text h1, which is 50 pixels, and then we add on 10 view widths. So let's check this out in the browser. So you can see the text is pretty big, but as I reduce the width of the browser, you can see it's reducing, and that's because a calculation is being performed. 10VW is effectively reducing as I reduce the width of the browser. And if we open up DevTools, if I go to the Computed tab, I'll select the h1. You can see font size is currently 434 pixels. And as I reduce the width of the browser, you can see the font size is dynamically changing. So let's finish off our summary card, CSS functions. We looked at CSS calculations. A CSS calculation is a function that looks like this, where we use the word calc and parentheses to give us the calc function. We also saw we could use mix units, like percentages and pixels. Alright, so let's go and use CSS calculations inside our Quill project. So let's first discuss what we're going to be doing. I'm going to scroll down to our header section. Earlier on in the course, in the CSS units topic, we set our header, which includes the navbar and hero section. Looking at that in the HTML, you can see our header includes the nav and the hero section. We set that to a height of 100 view heights to ensure that content always remained above the fold. Now I mentioned at that point, we're not really going to see the effect of this until we get up to the Flexbox topic. But what I'd like to do now is use CSS calculations to improve how we've set this up so we can start to see the effect of using 100 view heights. What I'm going to do is go up to our variables. I'm going to add a new comment. I'm going to paste in miscellaneous. I'm terrible at spelling this word, so before this video, I had it in my clipboard to make sure to spell correctly. Under here, we can go add miscellaneous or other kinds of variables. I'm going to define a variable called nav height, and I'm going to set this value now at 300 pixels. Now this value, we are going to come and update later. It's going to be too big for now, and only when we get to the Flexbox topic will our navigation items, like the logo and anchor tags, be in a better layout. Now the reason we want to define a navigation height is because it's a value that will be used throughout the application, across many different pages. So defining a navigation height as a variable is a good idea. So let's now scroll down to our header section. What I'm going to do for now is just comment this out. We are soon going to remove it and do a better implementation of this. I do just want to keep these values here for now. Inside our navbar, I'm now going to go give this the height property, and I'm going to grab the variable nav height. So essentially, we're fixing our navigation height at 300 pixels, which is the value defined on our nav height variable. In our hero section, I'm now going to go set a height. I'm going to use our calculation function. I'm going to initially set this at 100 view heights. But if you think about it, because we've defined a fixed height on our navigation bar, we now need to deduct that from the height of our hero section. That way, both the navigation bar and the hero section will always be above the fold. So I'm going to go minus, grab our variable, and grab the nav height. So what I've effectively done is from the header over here, I've split this height into two. In the nav bar, I'm setting the height using the nav height variable, and in the hero section, I'm setting the height to 100 view heights, and then just deducting off the nav height. I also just need to add the min height onto our hero section. So now I'm going to completely remove this. And I'm just going to go remove the class inside the HTML, as we don't need that now. Now, before we check this out in the browser, just so we can really see what's going on here, I'm going to go add a background color of light blue. And on the hero section, I'll add a background color of light coral. I'm going to come and remove these later, but this will just help us see what's going on. So let's check this out in the browser. Okay, there's quite a bit going on here. First of all, you can see our navigation bar now has a height of 300 pixels. Let's confirm that in DevTools. You can see from the CSS Box model, the navigation height is 300 pixels. As I mentioned, I've just made it quite a bit bigger for now. We are going to come and change this value later in the Flexbox topic. We can see we have some white gap here, and that's being defined by this margin bottom. For now, I'm just going to remove it, as we don't really need it right now. I'll refresh, and you'll see now our hero section and navigation bar are touching. I'm going to slightly scroll up the height of the browser, and you can see this is not working how we want it to. It should be that when I scroll down, I no longer see hero section. You can see as I scroll down, the hero section goes on for quite a while. Now this is being caused by the minimum height of 800 pixels. It's currently just too big, so I'm going to come and reduce this down to 400 pixels. I'll refresh, and you'll see when I scroll now, it is behaving how we want it to. It's being cut right at the bottom of the browser, and when I scroll, you can see we're now moving below the fold. Just to confirm this works nicely, if I reduce the height of the browser, the hero section still has a minimum height of 400 pixels. So all the content is still within the hero section. Now the next problem we have is that when I scroll down, there's this big white space here. And that's being set by this large margin bottom of 30 rems. I'm just going to update this to 10 rems in order to reduce it. And you'll see this looks a lot better. So let me extend the browser the full height of my screen. I'll refresh. And if I scroll down now, you'll see this is behaving exactly how we want it to. All the content is above the fold. And as soon as I scroll down, we're on to the next section. I'm going to reduce the height of the browser slightly, and you'll see it's the same effect. I'll scroll down, and we move on to the next section. So just to recap what we've done, because I know it seems a bit confusing. We've effectively set a fixed height on our navigation bar, which at the moment I've set quite large, and we are going to change later. And then I'm using a CSS calculation to set the height of the hero section so that it always remains above the fold. We're using 100 view heights, and we're minusing off the navigation height. And this gives us a really nice effect, where the navigation bar and hero section are always above the fold. And just to reiterate, the minimum height ensures that even when the height goes too small, the hero section still has a minimum height, as you can see in the coral color. Now, this is kind of a halfway implementation. Hopefully you can see we're using the view height units and calculations pretty effectively. But I do just want to highlight that the full implementation will be covered in the Flexbox topic. Just to finish off, I'm going to remove these background colors, as they were there just for demonstration purposes. The last thing I want to do is just scroll up to our nav height variable. I'm just going to pop a comment next to it to remind myself to update the value in the Flexbox topic. That's CSS functions complete. Great work for sticking with me so far. Let's now move on to one of my favorite topics in CSS, Flexbox. Flexbox serves as the foundation for crafting the responsive and flexible layouts that define modern web design. It allows us to easily align and space elements, ensuring websites look great and function seamlessly across all screen sizes and devices. Let's begin by exploring the basics of this powerful layout system with an introduction to Flexbox. We'll be discussing what is Flexbox, Flex Container and Flex Items, Main and Cross Axis, and Flex Direction. So back in the introduction video to the CSS Full Course, I introduced this slide, where at a very high level, I broke down the three major components of CSS. We're now up to an exciting part in our journey, where we're starting to look at layout, which is all about how we place boxes on our page. And using the power of Flexbox, grid, and position, we can finally achieve beautifully looking pages that are also responsive for different screen sizes. So what is Flexbox? Flexbox is a one-dimensional layout model, making it simple to arrange items in rows or columns and distribute space. Looking at this page over here, in the navigation bar, we have the logo and some nav links. And on the right, we have a login and try for free. This is a typical layout you'll see for a navigation bar. You can see there's space between these grouped elements, and they're arranged in a row, going from left to right. Inside the hero section, you can see these buttons. Again, there's some space between them, and they're also in a row. Looking now at the hero section, we have a heading, some paragraph text, the grouped buttons, and some images. There's space between each of these, and this is arranged in a column. Now we've seen previously, we can kind of achieve this layout already using things like margin and applying text align to the container so that all block and inline elements center. But Flexbox is a much more modern approach that is far more versatile and far more powerful. So let's check out this page in the browser. All right, so I'm going to open up DevTools, and let's start by clicking on the navigation bar. When I click on this div element, the navigation bar, the word flex appears on the right here. This is signifying to us that Flexbox is being used to arrange items inside this container. You'll also note that the space between the group content is a hatched purple, which is a new color we haven't seen before. You'll also see surrounding the main container is a dashed purple line, and this is also signifying that this is a Flexbox container. Looking now at the hero section, if I select this div here, you can see once again we have that purple dashed line, but this time the content is being arranged down the page, that is, in a column. And you can also see the word flex inside the HTML markup. So let's start getting comfortable with some Flexbox terminology. We'll be looking at Flex Container and Flex Items. Flexbox has two main components. The first is called the Flex Container. This is the parent element. Inside the Flex Container, we have Flex Items. These green boxes are the Flex Items, which are the children of the Flex Container. So Flex Container is the main parent container, and the different elements inside the Flex Container are known as Flex Items, which are the children. So let's now look at how we activate Flexbox with Display Flex. The display property on a container element will activate Flexbox's layout features on children elements. We've seen the display property already, with properties like block and inline. For Flexbox, we use the display value flex, and very importantly, this is declared on the Flex Container, the parent. Just for reference, values for display can include block, inline block, flex, and grid. Earlier on in the course, we've already looked at great detail at block, inline, and inline block. In this topic, we're looking at flex, and in the next topic, we'll be looking at grid. Now, I want to really highlight the difference between when you have no Flexbox, otherwise known as normal flow, and when you do have Flexbox. Let's look at no Flexbox first. This would be a display property like block, which for block elements is just default. We have a container, which acts as the parent, and for elements in block, like headings and paragraphs, they just stack vertically by default. Very importantly, the display property like block is declared on the elements, and we would describe each of these elements as block elements. Let's now compare this with Flexbox. The display property is flex. This now gives us a container, which is known as a flex container. And very importantly, flex is declared on the container. So in normal flow, or when not using Flexbox, the display property is applied on the child element. We've seen this a lot already, where, for example, we would apply inline block onto an anchor tag. Inside our Flex container, we now have Flex Items. And by default, they're not going to stack like this. They're going to be arranged in a row. So we end up with a row of Flex Items. Now, what I want to try get across is that Flexbox essentially takes full control of the layout. So each of these green boxes could be a block element. Let's just say they're all paragraphs. By default, when there's no Flexbox, the paragraphs will stack one below each other. But with Flexbox, they're arranged in a row, and now Flexbox properties take full control of their alignment and spacing. In the next chapter, I'm going to be doing a much deeper dive into normal flow and Flexbox. And the reason I'm doing this is because when I started out, I found it really confusing entering the world of Flexbox and properly understanding how Flexbox completely takes control of the layout. So let's jump into VS Code and play around with this. Alright, so I've gone ahead and set up an index.html file with the boilerplate code and linked an empty app.css file. Inside the body, I'm going to add a div, and I'm going to give this the class of Flex Container. This will be the parent element. Inside the div, I'm going to come and add 4 more divs. These are now the children, and in Flexbox terminology, these will be the Flex Items. I'm just going to put a number on each side of them, 1, 2, 3, and 4, and I'm going to give them each a class of Flex Item, and in this case, 1. I'll copy this class, change this to 2, change this to 3, and change this to 4. So once again, we have our parent div, which is going to be the flex container, and we have 4 flex items, 1, 2, 3, and 4. Let's jump into app.css. We'll grab the flex container. I'm going to give it a width of 800 pixels and a height of 800 pixels. I'm just going to give this container a background color of light gray. Now, as I mentioned, it's really important to understand that the display property for Flexbox is applied on the container. So let's go add display flex. This line of code now activates Flexbox and will mean that the elements contained inside the flex container now become flex items. Now on the flex container, I'm also just going to put a color of white, which will mean that the font color of our flex items will also be white, as this will be inherited. And I'm also just going to give it a font size of 30 pixels, which once again will be inherited by the flex items. So let's go get flex item 1. I'm going to give it a width of 200 pixels, a height of 100 pixels, and let's give it a background color of blue. We'll grab flex item 2. We'll give it a width of 50 pixels, a height of 300 pixels, and a background color of purple. We'll grab flex item 3. Let's give it a width of 100 pixels, a height of 150 pixels, and a background color of red. And finally, flex item 4. Let's give it a width of 150 pixels, a height of 50 pixels, and a background color of green. Now, before we check this out in the browser, I want to comment out display flex, as I want to show you what normal flow looks like when Flexbox is not activated. So let's check this out in the browser. So as expected, because each of these divs, the blue one, the purple one, the red one, and the green one, are just block elements, they're going to stack vertically like this. But now watch what happens when I turn Flexbox on. I'll uncomment this and refresh. And you'll see straight away that these are now arranged in a row, going from left to right. So the important thing to note is that where our flex items are defined in the HTML is by default how they'll be positioned left to right. So flex item 1 is first, and flex item 4 is last. So from left to right, we're going 1, 2, 3, 4. So you can see how Flexbox totally takes control of the alignment of these elements. And as I mentioned in the next chapter, I'm going to be doing a much deeper dive into this idea. And we can also confirm Flexbox has been activated by opening DevTools. We can see on the main container div the word flex. And you can also see those purple dashed lines appearing. You can see purple dashed lines around the entire gray container. You can see purple dashed lines between each flex item. And you can also see on the right some purple hatched area, which is some unused space on the right. The next really important concept we need to talk about is main and cross axis. The main axis is the primary direction in which flexed items are laid out, and the cross axis determines distribution on the secondary axis. Okay, that was a lot to take in. Let's break it down. We have our flex container and our flex items. Now, as I'm sure you know by now, flex items by default appear in a row from left to right. This is what we call the main axis. It's the primary direction in which flex items are laid out. But there's also another axis called the cross axis. And we can also lay out flex items in relation to this axis. Coming up soon in this topic, we're going to be looking at the properties, justify content, and align items. And these are really important properties, which are used for aligning our flex items along the main axis and along the cross axis. So just sit tight with me. We will be seeing properties that help us set alignment of our flex items, both along the main axis and along the cross axis. But just in this introductory chapter, we need to get a good understanding of flex direction. Flex direction controls the orientation of the main axis. And very importantly, it's set on the flex container. There are 4 values this can be. The first is flex direction, row, and row is the default value. It's what we've already seen so far, where our flex items go from left to right in a row. So we have our flex item 1, flex item 2, flex item 3, and flex item 4. They're going from left to right in a row. The next property is flex direction row reverse. And as the name suggests, this essentially flips the main axis. So instead of going from left to right, it's now going from right to left, with the cross axis still going down. So now our flex items would be positioned like this: 1, 2, 3, and 4. The flex items are going from right to left. So row and row reverse are complete opposites of each other. The next value we can have is flex direction column. This now completely changes the orientation of the main axis. Instead of going left to right or right to left, it's now going top to bottom, which means that the cross axis is now going left to right. And our flex items would appear like this: 1, 2, 3, and 4. They're moving from top to bottom. The final value we can have for flex direction is flex direction column reverse. And as you could probably guess, this flips the direction of the main axis to now go from bottom to top, with the cross axis still going left to right. So our flex items would now appear like this: 1, 2, 3, and 4, going from the bottom to the top. Now, when I first learned about flex direction, I was so used to coming from a mathematical background with the X and Y axis, where they don't ever change orientation. The X axis is always horizontal, and the Y axis is always vertical. Flexbox is not like that. The main axis, which I've shown in red, can essentially be horizontal in a row, but it can also be vertical in a column. And as we've seen now, in a row, it can go from left to right or right to left. And in a column, it can go from top to bottom and bottom to top. You'll also notice the orientation of the cross axis doesn't really change. We're much more interested in the orientation of the main axis. So let's go play around with this inside VS Code. So I'm back inside the app.css file we worked on earlier. Inside the flex container, I'm now going to go add the property flex direction, and I'm going to initially set it to row. So let's check this out in the browser. So as you can see, there's been no changes from what we had before, and that's because the default value of flex direction is row. So if I remove this, our flex items are in a row from left to right: 1, 2, 3, and 4. Let me add it back in. Now let's go change row to row reverse, and watch what happens. The main axis is now moving from right to left. You'll also notice that these flex items completely shifted from the left side of the container to the right side. In a few chapters' time, we're going to be talking about the important property justify content, is defining how these items are distributed along the main axis. Let's now change flex direction to column. By doing that, we've shifted the main axis from bottom to top, which means that our flex items are now essentially stacked on top of each other vertically. The final value we saw was column reverse. You can see this results in the main axis now moving from bottom to top, where our flex items now start at the bottom of the container and move up the column. And again, you would have noticed how the flex items have now moved from the top of the container to the bottom of the container. Now, one thing I really would like to highlight, because it can be confusing, is that both the display property for flex and flex direction property are defined on the container. They're not defined on the flex items themselves, but on the container. So let's now take a look at some flex direction guidance. In most cases, flex direction is set to row or column. So let's look at some examples of flex direction row first. And as I've mentioned, you do not explicitly need to set flex direction row, as it is the default value. So looking back at this web page here, the two buttons in the hero section, we could use Flexbox to arrange. The buttons are in a row, so the main axis is moving from left to right. We have our cross axis, we have our flex container, and each of the buttons are a flex item. So it's very common to have your main axis going from left to right, that is flex direction row. And again, you don't explicitly need to set this because that is the default value of Flexbox. Looking now at our navigation bar, again, we have items going from left to right. So our main axis is moving from left to right. We have our cross axis, our flex container containing all the items. We have a group of elements on the left, which is our first flex item. And we have a group of elements on the right, which is our second flex item. Let's now look at a case where we use flex direction column. Earlier on in this chapter, we looked at this web page, and the main hero section is in a column. The content is moving from top to bottom. So our main axis looks like this. The cross axis looks like this. we have our flex container and 4 different flex items, which are arranged in a column, moving from top to bottom. So again, flex direction row, which is the default value, and flex direction column are by far the most common values you are going to use. So let's start building a summary card, an introduction to Flexbox. In this chapter, we looked at flex container and items. We saw that we activate Flexbox by using the display property and setting its value to flex. This then gives us a flex container, which is the parent, and inside it, we have flex items, which are the children. We have a main axis, which by default is in row and moves from left to right, and we have a cross axis, which is the secondary axis. We also looked at flex direction. We saw that there were 4 possible values. Flex direction row, where we have our main axis moving from left to right, and our cross axis moving from top to bottom. Flex direction row places our flex items in a row from left to right. So it would look like this: 1, 2, 3, and 4. We saw flex direction row reverse, where our main axis now moves from right to left. The cross axis still from top to bottom. So our flex items are arranged like this: 1, 2, 3, and 4. We then saw flex direction column, where the main axis now moves from top to bottom. The cross axis left to right. Because our main axis now moves top to bottom, our flex items are arranged like this: 1, 2, 3, and 4. The final value we saw was flex direction column reverse, where the main axis now moves from bottom to top, and the cross axis still left to right. This then arranges our flex items like this: 1, 2, 3, and 4. Now, as I mentioned, this can seem very overwhelming with all these different directions flying around. By far, you're going to be using flex direction row, which is just the default value, and flex direction column. So don't worry too much about this. Just understand that the main axis can shift from a horizontal row position to a vertical column position. Now, I know we haven't really spoken about the secondary axis that much, and it may just seem like it's kind of floating there for now, not doing much. In a few chapters' time, we are going to see the importance of the secondary axis, because we can align our flex items both along the main axis as well as the cross axis. So just sit tight, we will see a use for it soon. Next, we'll get a solid understanding of how Flexbox takes full control of the layout of elements by taking a look at normal flow versus Flexbox. We'll be discussing normal flow, Flexbox, and comparing normal flow and Flexbox. Now, this chapter is getting my more difficult stand. When I was starting out, it just took me a bit of time to really understand how Flexbox now fully takes control of child elements inside a Flex container. Now, I'm going to spend a lot of time in this chapter diving deep into the difference between normal flow and Flexbox, so hopefully it will be a bit easier for you starting out. But there is just a little bit of a jump in understanding. So let's start out by looking at the difference between normal flow and Flexbox. When Flexbox is applied to a container, it takes control of the alignment of the children. So looking at normal flow first, spacing and alignment are determined by inherent properties of block and inline elements. So let's say we have a container. Inside the container, we have block elements and an inline element. So this is normal flow with no Flexbox. And all the spacing and alignment properties are inherent in the block and inline element properties. For example, the inline element just takes up the width of the content. Comparing this now to Flexbox. Flexbox overrides default behavior of block and inline elements, with spacing and alignment now controlled by Flexbox properties. So in Flexbox, we have our flex container, and now for the children, we need to think of these not as block and inline elements, but just as flex items. So let's take a deep dive into normal flow. Block and inline elements behave differently in normal flow. Let's say we have a div container. We know that the width of the parent container sets the width of the block elements. So let's say we had a block element, which is an h1, and another block element being a paragraph. The block elements stretch the full width of their container and stack vertically. Comparing this to inline elements, where we have an image and 2 anchor tags, inline elements have a width equal to their content and sit next to each other. Now, because inline elements don't take up the full width of the page, There's space between the inline element and the edge of the container, and at the bottom as well. So let's go check this out inside VS Code. All right, I've prepared this index.html file. I have a div with the class container, which is containing these elements: an image, which is a logo from our Quill project, a heading, a paragraph, and 2 anchor tags. Inside app.css, I'm just going to select the container, and I'm going to give it a background color of light gray. So let's check this out in the browser. So I'm going to open up DevTools, and I'm just going to select the different block and inline elements. As we know by now, a block element like an H1 extends the full width of the page, and will always start on a new line, like this paragraph over here. For the inline elements, they just occupy the width of their content. In this case, 187 pixels. And for the anchor tags, the length of the text results in the width being 69.75 pixels. And we know inline elements can sit next to each other. Now, with normal flow, when applying box model properties, we've seen in the box model topic, they apply kind of weirdly to inline elements. For example, if I select the anchor tag and try out a height of 50 pixels, and I'll just give it a background color so we can see this, I'll refresh, and you can see the background color has been applied, but the height has not been applied. Just to confirm that, I'll make it a much bigger value, and you'll see height is just not being applied to an inline element. This is not the case for a block element. If I select the H1, give it a height of 100 pixels, and a background color of blue, you'll see that the height is being applied. In the box model, we can see the content is 100 pixels high. With inline elements like anchor tag, properties like padding also apply quite weirdly. I'll remove the height, and I'll add a padding of 50 pixels. I'll refresh, and if you remember from the box model topic, we get this weird behavior where the anchor tag is almost overlapping other content. This doesn't happen with block elements. I'll remove the height on the heading, and I'll give it some padding of 100 pixels. I'll refresh, and you'll see the padding is applied and the content surrounding it is pushed down. Now, we did fix this by changing the display property on the anchor tag to inline block. So if I do this, this will now result in box model properties applying correctly to inline elements. Now, the main idea from this demonstration I just went through is that in normal flow, the positioning and size is heavily determined by whether an element is a block and inline element. And furthermore, box model properties apply a bit weirdly by default to inline elements. The next thing to discuss with normal flow is normal flow and alignment. Applying text align to a block level parent will impact both block and inline children through different mechanisms. I've got the same diagram we just looked at before, and I'm now going to apply text align center to the parent block element, the div. By doing this, two things happen at the same time. The first is that the text inside the block elements will center, and this is being achieved through inheritance. The text align center property is being passed down to the H1 and the paragraph, which effectively applies text align center to each of those elements, which then centers the text. The second thing happening is that the image and anchor tags, the inline elements, have space to move. So applying text align center will center these elements. So the inline elements are being centered because they are a direct child of the div. Now, we've seen in previous topics that applying text align center directly to an inline element won't center it. But when text align center is applied to a parent, like a div, all elements, whether they're block or inline, will center inside the container. So let's go play around with this inside VS Code. All right, so I'm just going to go remove a few things. I'm going to remove all our styles on the anchor tag in H1. I'll refresh, and now I'm going to go apply text align center onto the container. And you'll see that all elements are centered. And just to highlight what I was talking about before, if I remove text align center from the container and put everything back to where it was, and apply text align center to an inline element like our anchor tag, you'll see that nothing happens, whereas it does work for a block like the H1. So once again, applying text align center to a container will center both block and inline elements. So hopefully that was a good recap of normal flow behavior of block and inline elements. Let's now look at how this all changes with Flexbox. Flexbox overrides display behavior of block and inline elements. By applying the property display flex to the parent container, it totally overrides block and inline elements. We have our flex container, and the elements are now flex items, overriding the inherent nature of block and inline elements. You can see all elements now start on their own line and by default stretch the full width of the container. So we no longer view our elements now as block and inline when inside a flex container. They're flex items. What were inline elements like images and anchor tags now each appear on their own line and also stretch the full width of the page. Let's play around with this inside VS Code. So I'm back inside our app.css file, and I've removed a bunch of styles. I just have the container element with the background color being applied. And just to reinforce normal flow, by opening up DevTools, we can see that our block elements extend the full width of the page, and our inline elements are just the width of their content and do not start on a new line. So let's now convert this to a flex container. I'll add display flex, and just so we can keep the orientation the same, I'm going to add flex direction column. I'll refresh, and you'll now see, when I open up DevTools, that all elements extend the full width of the page. The image has been fully stretched. You can also see the anchor tags stretch the full width of the page, and now appear on separate lines. They're no longer next to each other. You can see as well, when I select the container, we get those purple lines appearing, separating each element. And these are our flex items. Now, the other interesting thing that happens is because we no longer view these as block and inline elements, applying box model properties to inline elements works. For example, if I select the anchor tag, give it a height of 100 pixels, and a background color of red, I'll refresh, and you'll see the height is being applied to the anchor tag. I'll confirm this in DevTools. I'll select the element, and you'll see it has a height of 100 pixels. If you recall when I did this earlier in normal flow, height didn't apply. I'm also going to show you what happens with padding. I'll remove height and add a padding of 50 pixels. I'll refresh, and you'll see padding is also being applied. We're getting 50 pixels of padding all the way around the element. And if you remember in normal flow with inline elements, we had that weird effect where the inline element kind of hovered over some of the other content. So in a nutshell, when our container becomes a flex container, our children now become flex items. Don't think of them as block and inline, because they just don't behave like that anymore. The inline elements appear on a new line, and they stretch the full width of the page. And we can also apply box model properties to them as if they were block elements. I'm just going to go remove this anchor tag, and I'm going to go in on the image and add a width of 100 pixels. So this would be something fairly common to do. We can still add a width to our image to keep it the size we actually want. Opening up DevTools, we can see that our image is now 100 pixels, but you can see it's inside the flex item, which still stretches the full width of the page. So I did just want to show you, in a design like our Quill project, we still have things like fixed width on an image. Now the final thing I want to discuss is comparing alignment in normal flow and Flexbox. In normal flow, we have a setup like this, where applying text align to the parent container centers everything. We discussed earlier, for the block elements, the heading and the paragraph, inheritance results in text centering inside the element. And for the inline elements, in normal flow, text align centered the image and links, as they're just children of the parent container with space to move. Now with Flexbox, we have a setup like this. The top box is the image, where I've applied a fixed width, like we just did a second ago in VS Code. And our headings, paragraphs, and anchor tags all appear on separate lines and stretch the full width of the page. If I were to now apply text align center onto the flex container, inheritance is still at play. It's being passed down inside each flex item. So it's kind of like text align is now being applied to the heading, paragraph, and anchor tags. And because we no longer view these as block and inline elements, but now flex items, text align center will center this text inside the flex item. Again, we can't view our anchor tags as inline elements anymore. They're just flex items. However, even with space available, text align no longer moves the image as it doesn't control alignment. This image won't center like it will in normal flow. And that's because Flexbox properties now control alignment, which we're going to be seeing in the next few chapters. Text align will not move a child like it did in normal flow. Let's check this out in VS Code. Alright, so I'm back in the app.css file we were working on earlier. I'm going to come and apply text align center inside our flex container. I'll refresh and watch what happens. The heading, paragraph, and anchor tags are all centered. Text align center is being inherited by each of these. If I open up DevTools, you can see each flex item surrounded by the purple dashed lines. You can see there's a lot of space horizontally for these items to move. Because they're all text items, a heading, which is text, a paragraph, which is text, and an anchor tag, which is also text, the text align is being inherited. So it's kind of the same thing as this. If I remove text align center here, I select the heading, paragraph, and the anchor tag, and directly apply text align center to them, you'll see that there's no change. It's all still centered. Now the big thing to realize is that in normal flow, if I were to apply text align center to an anchor tag, it wouldn't center it. Whereas in Flexbox, it does, because we no longer view it as an inline element. I'm going to add text align center back here. I'll refresh. And as I've mentioned, the image is not being centered because text align center no longer controls alignment like it does in normal flow. We need a specific Flexbox property to center this, which we'll be looking at soon. Just to remind you again of normal flow, I'll comment out the Flexbox properties, I'll refresh, and you'll see the image is now centered. And that's because in normal flow, when applying text align center onto a container, inline elements are just seen as boxes, that is, children, and they will center because there's space. That works on the inline elements like the images and the anchor tags, whereas in normal flow for block elements, when applying text align center onto a container, these are centered through inheritance. All right, so let's finish off the introduction to Flexbox summary card. In this chapter, we looked at normal flow versus Flexbox. We saw that Flexbox overrides block and inline behavior. Inside normal flow, we have a parent container with a block element and an inline element. These elements have inherent behavior, like an inline element taking up the width of its content. And we also saw applying text align center to a block element container like a div will center both the text inside the block element and move the inline element to the middle. For Flexbox, we now have a flex container and flex items. Flexbox completely overrides block and inline behavior, where now inline elements stretch the full width of the page. And also, we can apply box model properties to what were inline elements without any problem. We also saw that text align center doesn't always work and won't move something like an image with a fixed width, because text align center is no longer responsible for alignment inside a flex container. Now, I know this was a lot to take in, and that's why I gave it my more difficult stamp at the start. If you can just walk away from this chapter appreciating that when you apply Flexbox to the container, it will completely override block and inline behavior. And we now also need to use additional properties to align our flex items. Then you're doing great. Now it's time to learn about how to control alignment and spacing of elements along the main axis using justified content. We'll be looking at flex container size, the justify content property, justify content values, and justify content and shifting the main axis. So we're now up to an exciting part of our Flexbox journey, where we can start looking at aligning and spacing flex items. Flexbox offers a powerful way to space and align content. Looking at this web page over here, the nav bar, which is a flex container shown in purple, has two flex items in green. Flexbox makes it simple to align and create space between these flex items. Now, before we look at justify content, we need to talk about the flex container size. Understanding a flex container's dimensions is essential for visualizing how flex items will be positioned. When thinking about the size of a flex container, there are two categories. The first is a general block container. We have our browser window and our flex container, which in this case is just a block element like a div. And by default, the block element extends the full width of the container. Let's pop in our main axis and add in some flex items. So along the main axis, there's quite a lot of space. There's space between the last flex item in yellow and the edge of the browser window. Another important note is that the height of the flex container is being determined by the flex items. In this case, the height of the green flex item is setting the height of the entire flex container. This means that there's no space between the largest flex item and the flex container. The other category of flex container is a container with a set height or width. Again, we have our browser, but we now have a flex container that looks like this. In this case, the width is set, and the height is also set. Let's pop in our main axis, add in our flex items. We can see the amount of horizontal space here, which you can see is now smaller than the general block container. And in this case, because we've got a height set larger than the height of the biggest flex item, there is now vertical space. Now, the reason I want to get you thinking about where space is inside flex containers is that because in this chapter and the next chapter, we're going to be moving our flex items around. And it's really, really important to understand how much space there is vertically and horizontally to appreciate how our flex items are going to move. Inside VS Code, we had set up this example earlier. We have 4 flex items inside a flex container. This flex container is an example of where width and height has been set. And if I zoom out a bit, you can see that there's space horizontally from the edge of the green flex item to the edge of the flex container, and there's also space vertically from the top edge of the purple flex item here to the edge of the flex container here. Let's comment out those width and height properties. You'll see now that the horizontal space has now expanded and goes all the way up to the edge of the browser window, and that there is no vertical space between the largest flex item and the container. The largest flex item is setting the height of the container. So now that we've got a good understanding of spacing within our flex container, let's finally talk about justify content. Justify content sets how flex items are positioned along the main axis. It looks like this, where justify content is the property, and flex start is an example of one of the values. So we have our flex container, and what's really important is that justify content is set on the container. A lot of the next few properties we're going to be looking at are all set on the container and not the flex items themselves. We then have our main axis and our different flex items. So justify content sets how these flex items are positioned along the main axis. In this case, the value is flex start, so they're all at the start of the main axis, that is, on the left. So let's now take a look at all the justify content values. The one we've just seen is justify content flex start. We have our flex container, our main axis, and our flex items. The flex start value has all the flex items starting on the left of the main axis. And this is the default value. It's where our flex items are positioned by default, and what we've already seen in all the examples we've done so far. The next value we'll look at is flex end. And as the name suggests, this now positions all our flex items at the end of the main axis. The next value we'll look at is center. We have our flex container, our main axis, and as you'd guessed, the value center centers all our flex items along the main axis. The next value is space between. We have our flex container, our main axis. The first and last flex items are placed right at the edge of the container, and the remaining flex items are then inserted so that there's equal space between all the flex items. The next value is space around. We have our flex container, our main axis. Now this one works slightly different to space between. For space around, we divide our flex container into equal spacing along the main axis, and then our flex items are centered inside each of these blocks. So what we end up with is that the spacing between the orange, green, blue, and yellow flex items will be double the spacing between the orange flex item and the edge of the flex container, and the yellow flex item and the edge of the flex container. The last value is space evenly. With our flex container, our main axis. In this case, our flex items are all just spaced evenly between each other and the edge of the flex container. So there's equal spacing between all our flex items. This is different to space around, where there isn't equal spacing between all the flex items and the edge of the container. So these are all the 6 possible values for justify content. And just to hammer the point home, justify content is all about spacing our flex items along the main axis. Now I know this can seem a little bit overwhelming, especially the 3 values on the right, space between, space around, and space evenly, as the differences are quite subtle. Honestly, don't worry too much about them. We use some of them a lot more than others. So let's go play around with these inside VS Code. So I'm back inside our app.css file. On the flex container, let's go add justify content, and we'll start with the first value, flex start. I'll refresh, and you'll see nothing changes. And that's just because flex start is the default value. Our flex items are always aligned left by default. Let's change this to flex end. I'll refresh, and you'll see our flex items now shift to the right. The next value we looked at was center. This nicely centers our flex items. We then looked at space between. This places our first and last flex items right at the edge of the flex container, and then inserts the remaining flex items with equal spacing between all the flex items. The next value was space around, and if you remember, this divided the flex container into 4 equal blocks and inserted the flex items in the center of them. And this left us with double the spacing between the flex item and the edge of the container. And we can better see this in DevTools. If I select the flex container, you can see the spacing of the hatched purple on the far left and far right is half the horizontal spacing between all the other flex items. The last value we looked at was space evenly, and this simply spaces our flex items evenly between each other and the edge of the flex container. Now thinking back to those 2 categories of flex container, where we had a general block container, just like this, where it extends the full width of the page, versus a container with set width and height. Let's uncomment this and refresh. Now the reason I want to show you this is that now the flex container has a set width, so it's not extending the full width of the page. Now because the flex container now has a set width, which is lower than the width of the browser, the spacing between our items will just be smaller. So let's run through them one more time. So we'll do flex start, and just to highlight this a bit more, I'm going to come and change the width to 600 pixels. So as expected, our flex items are on the left. Let's change this to flex end. You can see our flex items have moved to the right, but compared to before, it's not like it moved all the way to the right. It has moved right, but because the container has a fixed width, which is smaller than the browser width, the amount it's moved doesn't look like much. Let's go center them, and you can see again, the spacing between all the flex items and the edge of the container is a lot smaller. We'll do space between, and again, the spacing values are a lot smaller. Space around, and once again, the spacing values are a lot smaller. And finally, space evenly. And again, the spacing values are a lot smaller. So the point of me doing this was really to highlight that the amount of spacing of flex items along the main axis is heavily influenced on the size of the flex container. And we've seen it can either be a general block container or a container with fixed width and height. I now want to spend some time discussing spacing on the shifted main axis when we move it from row to column. That is, our main axis is now going vertically instead of horizontally. Let's again look at our 2 different cases. The general block container will set a flex direction of column. This now results in our main axis going from top to bottom with our flex items, and the flex items is what's actually setting the height of the flex container now. That is, the height of each flex item adds up to give the height of the flex container. And this results in no space between the flex items and the container. So if we come and set a value like justify content center, different values will have no effect on placement of flex items as there is no space. So because there is no space along the main axis inside the flex container, setting any value on justify content will have no effect. Let's now compare this with a container with a set height. Again, we'll set flex direction column. This will result in our main axis going from top to bottom. Our flex container has a defined fixed height. We'll pop in our flex items. And now there is space between our flex items and the edge of the flex container. So we can set a value like center for justify content. And different values will have an effect on placement of flex items as there is now space. So let's play around with this inside VS Code. So I'm back inside the file we were working on earlier. Let's go first through the case when the flex container has no width and height. I'll comment that out. The next thing I need to do is shift the main axis. So we'll go flex direction column. I'll refresh, and you can see that the height of the container is being determined by the height of each flex item. If I open up DevTools and inspect, you'll see by looking at the box model, the height of the flex container is 600 pixels, which is the sum of 100, 300, 150, and 50. So again, for a general block container with no set height, the height is being set by the height of each flex item. And because there is no space, any justify content value will have no impact. And that's because there's no space along the main axis for our flex items to shift. So let's go set this to a value like center. You'll see there's no change. We'll change it to space between, and again, no change. Let's now compare this to a container with a set height. I'm going to uncomment these values. I'll zoom out a bit. And because our flex container now has a fixed height of 800 pixels, and the sum of each of the heights of the flex items was 600 pixels, there's 200 pixels of space for our flex items to move. So setting different values on justify content will have an impact. So let's now take a look at some justify content guidance. Justify content is often used to align and space navigation bars. You can see on this web page here, a navigation bar will all be inside a flex container. We have our main axis going from left to right. We have a logo on the far left and anchor tags on the far right. These would be our flex items. And we're using justify content to space these flex items along the main axis. Let's check this page out. So I'll open up DevTools. I'll go select the navigation bar, and you can see this is a flex container. If we look at the CSS properties, we can see that justify content is being used with the value space between. Space between is essentially inserting space between the two flex items, pushing the flex items to the left and right. This is a common value you'd be using on a navigation bar. Looking at some more guidance, it can be used to align entire sections. Looking at this page over here, this entire section content would be inside a flex container. We have our main axis in row going from left to right. We have a flex item on the left and a flex item on the right. Now, one thing to note is that Flexbox gives us a simple way to place elements next to each other horizontally. Without Flexbox, this isn't so easy to do. So let's check this out in the browser. So I'm going to open up DevTools, and I'm going to select this flex container. Now, in actual fact, the justify content value is actually not doing anything here. If I turn it off, you'll see there's no change. And that's because we're just using Flexbox as a way to get these elements next to each other. There is no need for a justify content value. This actually can be fairly common, where we're just using Flexbox to position items next to each other, and we don't actually need to specify a justify content value. Here's another example of how Flexbox can be used to align entire sections. All of this content is in a flex container. We have our main axis now in column, going from top to bottom. Inside the flex container, we have a section of content here and a section of content here. And these are our flex items. So let's check this page out. So I'm first going to zoom out quite a lot. I'm going to open up DevTools. I'll select the entire section. You can see flex over here and the flex container with those dashed purple lines. You can see flex direction is in column. And if I turn that off, you'll see it all moves to row. And you'll see justify content is set to center. But if I turn that off, nothing really happens. And once again, that's just because we're using Flexbox as a way to align these items vertically. For this particular layout, there's no need to provide a specific value. Moving on to the next piece of guidance, it's often used for spacing and alignment of simple one-dimensional components. Looking at this web page over here, I'm going to zoom in to the icon and projects. All of this would be inside a flex container. Our main axis is in row, running from left to right. We have our icon and text, and these would be our flex items. So again, we're just using Flexbox to easily position items horizontally. So let's check this out in the browser. So I'm going to open up DevTools. I'll grab the container. You can see this is a flex container. As you'd expect, we have display set to flex. Our flex direction is row. This is there even though it's not totally necessary, as row is the default value. And you'll see that justify content is set to flex start. And technically, this is not needed either, because flex start is just the default value. But you can see the power of Flexbox. It easily allows us to position these items next to each other. Now, one question you may have is we do have spacing between the icon and the word projects. So if justify content is not being used there, what is being used? We will be discussing this in a few chapters' time, but there's this property called gap you can see over here, currently set to 16 pixels. And as the name suggests, you can use this to define a specific gap value between your flex items. So if I turn this off, you'll see that projects butts right up against the icon. While we're on this page, I want to show you some other places we're using Flexbox for simple one-dimensional layouts. I'm going to scroll right to the top, and I'm going to click the container of these buttons. You can see this is also Flexbox. Flexbox is being used to nicely position these buttons next to each other. The last example I want to show you is that if I scroll down, we have these different tabs over here. If I select one of these tabs, you can see the Flexbox is also being used here to place the icon next to the text. And like we've seen in other cases, the Flex container actually has no space for our Flex items to move. This small space in purple here is created by this gap value. If I turn that off, you'll see that we're just using Flexbox to position our elements next to each other. And because there's no space, we can't even use justify content, because we need space inside our Flex container for justify content to work. So again, I just wanted to really highlight, oftentimes we don't even need to set a justify content value to position items along our main axis, because in a lot of circumstances, there actually won't be any space. The last example of a simple one-dimensional layout I want to look at is this page over here. We have all these logos inside a Flex container. We have our main axis in row running from left to right, and each of these logos would be a Flex item. In this case, a value for justify content is being used because there is space inside this container to space our items along the main axis. Let's check this out in the browser. So I'll open up DevTools. We'll grab the Flex container. I'll go check out the properties. You'll see we have display Flex as expected, and over here, justify content space between. If I turn this off, you'll see all the icons inside the Flex items butt up against each other. And you can see over here, on the right, the amount of available space inside this Flex container. I'll turn justify content space between back on, and you'll see that using this property nicely aligns our logos along the row with equal space between them all. So let's start building out the next summary card, justify content and align items. In this chapter, we looked at justify content, which positions items along the main axis. We saw there were 6 possible values. Flex start, which is the default value I'm going to put in red. For Flex start, we have our Flex container, our main axis going from left to right, and our Flex items positioned along the main axis at the start of the main axis. That is, in this case, on the left. The next value is Flex end. We have our Flex container, our main axis going from left to right. This means that Flex end is on the right of our main axis. So our Flex items are positioned like this. The next value we saw was center. We have our Flex container, our main axis going from left to right, and our Flex items will be centered along the main axis. The next value was space between. We have our Flex container, our main axis. The Flex items on the far left and far right are pushed right up against the Flex container, and then any remaining Flex items are positioned with equal spacing between each of the Flex items. The next value was space around. We have our Flex container, our main axis. The space is then divided equally, and our Flex items are placed in the center of each of these blocks. And if you recall, this means that the space between each Flex item is double the space between the edge of the Flex container and the Flex items on the left and right. The last value was space evenly. We have our Flex container, our main axis, and this simply just spaces the Flex items evenly with equal spacing between the Flex items and the edges of the container. So we're up to a really exciting part of the Quill project. We're now going to start adding Flexbox onto our homepage. Now we're going to be using Flexbox a lot on the homepage, but just to start off with, I'm only going to be using it in 2 circumstances. And as we move through this topic, I will be adding more instances of Flexbox. The first place I want to use Flexbox is on the navigation bar. We're going to convert our entire nav bar into a Flex container. Our main axis will be in row, running from left to right. Our Quill logo will be a Flex item, and our 2 anchor tags will also be a Flex item. We're then going to use the justify content space between property to create space between the Flex items, just like we saw in some of the previous guidance. So let's jump into VS Code and code this up. So I'm inside index.html of our Quill project. As you can see, we have the nav bar inside the semantic nav element, and this already has a class nav bar. We're going to go now convert this nav into a Flex container. So we'll jump into app.css. I'm going to scroll down to the different sections, and you can see our navbar class over here. Now, before I add anything, I want you to note that the current layout by default in normal flow is we have our Quill logo and then our login and register anchor tags, which are one below another because they're inside list items. So let's go add display flex onto the navbar. I'll refresh and watch what happens. the login and register anchor tags now appear next to the quill logo. Now you might be wondering, why didn't register appear next to login? Why are these kind of grouped together? If we jump into the index.html file, because we applied a flex container onto our navbar, the flex items are direct children of the navbar. That is this anchor tag, which is wrapping our image. So it's effectively just our image, which is over here, and our unordered list, which has the login and register anchor tags. So it's really important to understand that when you add display flex onto a flex container, like our nav, the flex items are just the direct children, not grandchildren like these list items. So in our case, the image is one flex item, and the entire unordered list is another flex item. We are later on in this topic going to be talking about nested Flexbox. That is, Flexbox inside of Flexbox. And we're going to be using that to pop our registered anchor tag next to our login. But it's really, really important to understand that flex items are direct children of the flex container. And that is why the login and register are grouped together like this and still appear one below another, because they're inside our unordered list tags, and the unordered list tag is the flex item. Jumping back to app.css, to be explicit, we could put flex direction as row. If I refresh, you'll see no changes. I'm not going to do this because it's not necessary. I'll remove it, but let's now go add justify content and space between. I'll refresh and check that out. With 2 lines of code, we've now beautifully positioned our image on the left and our buttons on the right. All right, the next place I want to use Flexbox is inside our footer. We're going to convert the entire footer into a flex container. In this case, our main axis will now be in column, running from top to bottom. Now, flex items will be the logo, the social media icons, the navigation text, and the small text at the bottom. In the guidance, we spoke about using Flexbox to align and space entire sections, and that's what we're going to be doing inside the footer. And just to note, importantly, there is no space along the main axis. As you'll recall, justify content is about aligning and spacing flex items along the main axis. Our main axis is now in column, and there actually is no space, which means we won't be using justify content. But we are going to be using Flexbox as a new and more versatile way to set up our footer. So let's jump into VS Code and code this up. So our footer currently looks like this. And in actual fact, after we've done the work with Flexbox in this chapter, there's going to be no visual change. But the benefit of using Flexbox is that we're able to unlock some more powerful features, which we'll be seeing later on with values like gap. So even though for now we're going to be doing some work which won't really achieve anything new, using Flexbox is a powerful way to structure layout for entire sections, like this footer over here. Let's take a second to look at the index.html file. We're going to be converting our footer into a flex container. So let's now identify the different flex items. The direct children, which will be the flex items, is this anchor tag, which is wrapping an image, which is the quill logo. It's this unordered list, which is the group of social media icons. It's this unordered list, which is a mini navigation with the home, login, and register anchor tags. And the final flex item is this paragraph, made with love in London. So again, it's really important to be able to identify your flex items. And just to really hammer the point home, these list items are not flex items of the footer. It's only the direct children which are flex items. So let's jump back into app.css. Let's go add display flex to convert the footer container into a flex container. Let's just refresh to see what happens. So by default, our main axis is running from left to right in a row, and that's why the flex items appear next to each other like this. We want this to appear in a column, so we're going to add flex direction and add the value column. Let's refresh, and you'll see we're actually back to where we started. But now this is a flex container. Now, one thing I do want to highlight, which we spoke about in an earlier chapter, is how we shouldn't really be using text align to space and align items in a flex container, because it doesn't really work. But in this case, it kind of is working. If I comment this out, you'll see that our flex items all appear on the left here. Now, our main axis is running from top to bottom. And as we mentioned earlier, there's no space over there, so justify content won't have any effect. But there is space now along the cross axis. If I open up DevTools, you can see there's a lot of space horizontally. And we're going to be talking in the next chapter about aligning and spacing items along the cross axis. If I turn text align center back on, it does center everything. This seems contradictory to what I spoke about earlier, where I said text-align center doesn't really work in Flex containers. Just to remind you of that, in the Flexbox versus normal flow chapter, I set up this, where we had our Flex container, an image, an h1, paragraph, and anchor tags. In app.css, we have display flex, our flex direction is column, and applying text-align center centers the headings, paragraphs, and anchor tags. If I open up DevTools, if I click the anchor tag, you'll see the anchor tag stretches the full width of the page, which is not typical behavior of inline elements. But by converting it to a flex container, this now becomes a flex item, and the idea of inline elements doesn't really apply. This is different to the logo, which has a fixed width of 100 pixels. If I try click away from this, I'm taken straight to the purple dashes of the flex container. This is different to the anchor tag, where you can see by default, the blue box extends the full width of the container. The image doesn't, it's just the width of the image. So trying to apply text-align center onto an element with a fixed width like this image simply doesn't work. And that's because text-align is no longer taking control of alignment. The only reason the heading and anchor tags are being text-align centered is because they're being inherited. So they are centering. So why then is the image centering here? That is completely contradictory to what I spoke about here. Now the reason this is happening is because in our markup, our image is actually inside anchor tags. You can see that over here. The image is wrapped in anchor tags. So the anchor tags are in fact inheriting text-align center. Just to really show you this, if I copy this image and paste it over here, I'll refresh, and you'll see this image is behaving exactly like I said here. It's not centering. If I open up DevTools, you'll see this image is inside an anchor tag, and you can see the blue box highlights the space it can move. Whereas this image just has a fixed width, and as soon as I move away, I'm just showing the entire flex container. All right, I'm just going to go remove this image and refresh. Now, this may all seem very confusing, but what I really want to highlight is that text-align center isn't really the best way to center items like this. We're going to be seeing in the next chapter a new property which is better used for centering flex items along the cross-axis. So for now, I'm actually just going to go remove this. This will then place all our items on the left by default, and in the next chapter, we will be correcting this. I really wouldn't overthink this too much, as I know it can seem confusing, but the main point I want you to walk away with is that inside a flex container, we're learning about Flexbox properties like justify content and align items in the next chapter, which is the correct way to properly align and space your flex items. Text align is not the correct way to space items inside flex containers. The last thing I just want to show you is that, as I mentioned, justify content will have no effect because there is no space along our flex container along the main axis, that is, going from top to bottom. I'll open up DevTools. I'll grab our flex container. You can see I've added justify content center. I'll refresh, there's no change. I'll add space between, and you'll see once again there is no change. And that's because there is no space inside our flex container along the main axis. But you can see there is a lot of space horizontally, that is, along the cross-axis. And in the next chapter, we're going to be using that to center our flex items. So as I've just shown, justify content has no effect, so I'm going to go just remove it from our footer. So we've learned about alignment and spacing along the main axis. Now it's time to learn about alignment and spacing along the cross-axis with align items. We'll be discussing the align items property, align items values, and align items and shifting the main axis. So what is align items? Align items sets how flex items are positioned along the cross-axis. The CSS property looks like this, align-items, with a value like stretch. Just like justify content, align items is also set on the flex container, and the value stretch is the default value. And we'll be looking at all the values soon. So let's take a look at our Flexbox diagram. We have our flex container, which is the parent. We have our main axis, which in this case has a flex direction of road, which means it's running from left to right. We then have our different flex items, which we know are the children. And we have our cross axis, which runs perpendicular to our main axis. And align items is all about the positioning along the cross axis. So justify content, which we looked at previously, is about spacing and alignment along the main axis. And align items, which we're going to be looking at now, is about positioning and spacing along the cross axis. So let's take a look at the different align items values. Just like I detailed in the justify content chapter, situations where the container has height and situations where the container does not have height, I'm going to be doing the same thing for aligned items. So when no height is set on the container, its height is set by the height of the tallest flex item. So let's take a look at all the values. The first one we have is align item stretch, and this is the default value. It looks like this. We have our flex container, our main axis running from left to right, our cross axis running from top to bottom, and by default, our flex items will stretch, so they'll look like this. Now just a small note, this occurs when our flex items also don't have a fixed height, so just content. And we'll be looking at this soon inside VS Code. But let's continue running through all the values. The next value is flex start. We have our flex container, our main axis, our cross axis, and our flex items are now at the start of the cross axis. So this is at the top of the cross axis. Now in justify content, flex start would also look like this, but that's because our main axis is running from left to right. So flex start in terms of justify content positions the flex items on the left of the main axis. Now align items is positioning along the cross axis. So in this case, flex start means at the top of the cross axis. We then have align items flex end. We have our flex container, our main axis, our cross axis, and our flex items will look like this. That is at the end of the cross axis. You can see it's the complete opposite of align items flex start. The next value is align items center, with our flex container, our main axis, our cross axis, and our flex items will now be centered on the cross axis. So it'll look like this. The final value is align items baseline. So for this one, we have our flex container, our main axis, our cross axis. Now to show you how this works, I'm going to add text inside our flex items. We have a flex item with the letter A inside. I then have a flex item with the letter B, which I've made a lot larger, and flex items with the letter C and D, the same font size as A. Now the way baseline works is that the flex items are aligned along the cross axis so that the text baselines of each item line up based on the largest letter, causing the smaller flex items to adjust upward or downward to match the baseline. Now honestly, this one is a little bit niche and may seem a bit confusing, but we're going to run through all of these now inside VS Code. Alright, so I'm back inside the file we were working on in the previous chapter. I'm just going to come and update these numbers to actual text. I'll write the word banjo, I, hi, and party. I'll refresh, and you can see the text appearing here now. Inside app.css, I'm going to go remove these width and height properties for now, as I want to just work with a regular container. And I'm going to remove flex direction column to get our flex items back in a row. And I'm also just going to remove justify content center for now. So by default, we know that our flex items will be positioned on the left. That is justify content flex start, which is the default value. Now what I want to do to really show you how align items works is for each flex item, I'm going to comment out the width and height, and I'm going to give each item a different font size. I'll give flex item 1 a font size of 90 pixels. For flex item 2, I'll comment out the width and height, and I'll give it a font size of 200 pixels. For flex item 3, comment out the width and height. Let's give it a font size of 150 pixels. And for flex item 4, comment out the width and height, and let's give it a font size of 120 pixels. So I'll refresh, and you'll see some crazy stuff going on. So what we can see is the align items default value, which is stretch, coming into play. Because our flex container has no height, the height of the flex container is being set by the tallest flex item, which in this case is this letter I. Then for the other flex items, they're being stretched the height of the flex container. So if I go add align items, stretch, you'll see nothing changes because this is the default value. Let's now have a look at the next value, flex start. Watch what happens when I refresh. The height of the flex items now only occupy the height they need, and the flex items are now positioned at the start of the cross axis. In this case, we know our row axis runs from left to right, which means that our cross axis is running from top to bottom. So the start of our cross axis is at the top. And once again, the height of the entire container is being set by this letter I, because it is the tallest flex item. If we now change this value to flex end, watch what happens. our flex items move to the bottom, that is the end of the cross axis, because the cross axis is running from top to bottom. The next value we looked at was center, and these now center our flex items along the cross axis, that is in this case vertically. And the final one we looked at was baseline. Now I want you to keep your eye just under the letter I here, and watch how these other flex items will move downwards as if there was an invisible line running under the letter I. So I hope you saw that those letters move down slightly to be baseline with the letter I. Now the beauty with Flexbox is that it's very common to use both justify content and align items together. So let's go play around with this. I'm going to go add the justify content property, and I'm going to set it to center. But now I'm just going to comment align items out. So we know justify content will center our flex items along the main axis, that is in this case horizontally. Let's now also add align item center. I'll refresh, and you can see our flex items are also now centered along the cross axis. So our items are perfectly centered both vertically and horizontally. And of course you can use whatever values you want. Let's change this to flex end. So now our flex items are on the right of our main axis and centered vertically. Let's change align items to flex start. So now our items are aligned on the right along the main axis and at the start of our cross axis, that is at the top over here. So you can see using justify content and align items together allows a lot of flexibility to position your flex items almost anywhere you want inside your flex container. Now before we move on, I do just want to show you why I removed the fixed heights and widths from each flex item and rather let the content set the dimensions. I'm just going to remove justify content flex end. This will put our flex items back on the left. And I'm also just going to comment out align items flex start. And as we know, the default value of align items is stretch. So the content inside the flex items are stretched. Now I'm going to go change our text back to 1, 2, 3, and 4, and I'll refresh. And then I'm going to go uncomment the width and height, and then comment the font size. So now the width and height of each flex item is going to be set by the width and height I'm defining and not the content inside of it. Just to avoid boring you, I'm going to go do the other two. So now our flex items have a set width and height. I'll refresh and watch what happens. You'll notice that the flex items are no longer stretching. And that's because when you set a specific height on a flex item, it isn't possible for it to stretch. You can think of it as the height is kind of overriding the stretch value. And just to show you, if I were to uncomment this and change the value to stretch, which we know is just the default value, I'll refresh and you'll see there's no changes. But the other align items values still work. For example, if I change this to flex end, you'll see our flex items will move to the bottom. That is the end of our cross axis, which is moving from top to bottom. I can also set this to center, and you'll see that our flex items also center. And of course, just like before, we can also go add justify content and values like flex end. So I just wanted to show you that if our flex items do have a set height, you're not going to see the effect of the default value stretch on align items. And that's because the height is kind of overriding the ability for the flex item to stretch. But as you can see, other values like align item center still work. And this is the reason at the very start of this demonstration, I let the font size set the height of the containers, as I wanted to show you all the values. And if I used a fixed width and height, I wouldn't be able to do this. I know this can be a lot to take in, but honestly, don't overthink it. Most of the time, we're going to be using simple values like align item center, and for values like that, it doesn't matter whether the content is setting the height of the flex item or there is a set height. I did just want to show you this detail so you really do understand what's happening. So we've just been looking at align items when the flex container has no height. So let's now look at when the flex container does have height. When height is set on the container, there is additional space for items to move. So let's look at our 5 different values now. Align item stretch. The flex items are able just to stretch a bit more. Flex start. The flex items are at the start of the container, but compared to the diagram before, there's just a bit more space between the flex items and the bottom of the flex container. It's the same with flex end. There's now just more space vertically between the flex items and the top of the flex container. We have center, and once again, there's now more space vertically and horizontally between the flex items and the flex container, and baseline, where once again, there's just more space vertically. So let's check this out in VS Code to really see the effect. All right, so I'm going to pick up where we left off. On the flex container, I'm going to go give it some height of 800 pixels. And watch what happens to the flex items. Because our line items value is center, and our flex container now has a fixed height larger than the largest flex items height of 300 pixels, our flex items really do look centered inside this container. Let's play with the other values. We know that stretch isn't going to work because these flex items have a fixed height. Let me quickly remove that and add the font size back in for each flex item. And to avoid boring you, I'm going to go do it for the others. Okay, I've updated all of those. I'll refresh and watch how much more these stretch because our flex container now has quite a large height on it. Let's change our line items value to flex end. You can see they now go to the bottom of the flex container. That is the end of the cross axis running from top to bottom. And the last value was baseline. I'll refresh. And once again, the numbers 1, 3, and 4 are aligning themselves on the baseline of number 2. Now, when you have a fixed height like this, using justify content and align items can give you some really cool effects. For example, let's go center both. I'll center justify content. This will center our flex items along the main axis. And let's go center align items. And as we know, this will center our flex items along the cross axis. That is from top to bottom. So you can see our flex items are perfectly centered inside this container. So let's now look at align items and shifting the main axis. When no height is set on the container, its height is the sum of flex items' heights, and justify content will have no impact. So I want to look at align items and justify content at the same time when we've shifted the main axis. If we have align item stretch, we have our flex container, our main axis, which is now running from top to bottom because we've shifted the main axis, which means that our cross axis is now moving from left to right. This means that our flex items will look like this. The default value stretch means that our flex items will now stretch the entire length of the cross axis. But because the cross axis is now running from left to right, they're being stretched horizontally. And because the height of the flex items is setting the height of the entire container, there is no space vertically, which means justify content will have no effect. For align items flex start or baseline, it'll look like this. We have our flex container, which once again has no set height. The main axis is running from top to bottom. The cross axis is running from left to right. And our flex items will look like this. They're at the start of our cross axis, that is on the left. And again, there is no vertical space. So any value of justify content simply will not work. Let's now look at align items flex end. We have our flex container, again with no set height. The main axis is running from top to bottom, the cross axis from left to right, and our flex items will be positioned like this, where they're at the end of the cross axis, that is on the right of the container. And once again, because the height of the flex items is setting the height of the entire container, there is no vertical space. So applying any value of justify content will have no effect. The last value is align item center. Once again, we have our flex container, our main axis running from top to bottom, our cross axis running from left to right, and our flex items will be positioned like this. That is, they're centered along the cross axis, and in this case, centered horizontally. And once again, because our flex container's height is being defined by the sum of the flex item's height, there is no vertical space. So justify content will not work. Let's play around with this inside VS Code. So I'm back inside the file we were working on earlier. The first thing I'm going to do is comment out the height. I'll refresh. I'm then just going to remove temporarily our justify content and align items values. And then I'm going to shift the main axis by adding in the property flex direction column. So let's talk about the setup. Our flex container no longer has any fixed height. So the height of the flex container is being defined by the height of the flex items, which is the height of the different numbers. We've also shifted our main axis. So instead of running from left to right, our main axis now runs from top to bottom, which means that our cross axis is running from left to right. The default value of align items is stretch. So our flex items are stretching horizontally now along the cross axis. If I go add align items stretch, you'll see there'll be no change because stretch is the default value. Let's change this to flex start. you'll see now our flex items are on the left. That is the start of the cross axis, which is now running from left to right. For baseline, there's also no change. It's the same as flex start. Let's go change this to flex end. You'll see our flex items now move to the right because that's the end of our cross axis, which is running from left to right. And the final value we'll add is center. And this now centers our flex items along the cross axis, running from left to right. And like we discussed, any justify content value simply won't work because our main axis is running from top and bottom. Justify content spaces and aligns items along the main axis, which in this case is running top to bottom. And because there is no additional space along the main axis, none of these values will work. Let's try flex start, and you'll see there is no change. Okay, I'm just going to remove this one for now. Now, when height is set on the container, there can be additional space, so justify content will have an impact. Looking at our different cases, align item stretch, we have our flex container, which we have set a height on. We've shifted the main axis, so it's running from top to bottom. Our cross axis is running from left to right, and our flex items will look like this. They're being stretched along the cross axis. But because we've defined a height on our flex container, there now is vertical space, so justify content will have an impact. Looking at the values flex start and baseline, our flex container has a defined height. We have our main axis running top to bottom, our cross axis running left to right, and our flex items will appear at the start of the cross axis, that is, on the left over here. And once again, because we've set a height on our flex container, there is now space for justify content to have an effect. The next value, flex end, we have our flex container, which has a height, our main axis top to bottom, our cross axis left to right, and our flex items will be positioned on the right, that is, the end of the cross axis. And because our container has height, there's once again space for justify content to work. Looking at the last value, align item center, we have our flex container, our main axis running from top to bottom, our cross axis running from left to right, and our flex items are centered along the cross axis, that is, in this case, horizontally. And once again, because our flex container has height, there is vertical space for justify content to work. So let's play around with this inside VS Code. So I'm back inside this file, and the first thing I want to do is uncomment out the height. This will give our flex container a height of 800 pixels. I'm also just going to remove the align items property. So I'll refresh, and let's discuss what's happening. We have our main axis running from top to bottom, which is being set by flex direction column. Our flex container now has a fixed height of 800 pixels, which means you can see there's now space between our last flex item and the bottom of the container. And by default, we know that our flex items are going to stretch. And because we've shifted the main axis, our cross axis is now running left to right, so our flex items are stretching from left to right. Let me just explicitly add that, align items stretch. You'll see there are no changes. But now, because we have height on our container, we can add a justify content value like center, and you'll see our flex items will center inside our container. And once again, that's because we now have a height on our flex container, and our main axis runs from top to bottom. So justify content is aligning our items along the main axis. So it's centering our items from top to bottom. Let's change align items to flex start. So you can see our flex items are now positioned on the left. That is the start of the cross axis, which is currently running from left to right, and they're vertically centered along our main axis. Let's change this to flex end. And you'll see that moves our flex items to the right. That is the end of our cross axis. And finally, let's change this to center. So now our flex items are both being centered vertically, which in this case is along our main axis. To justify content center is centering them vertically, and also centered horizontally, which is along our cross axis. So that's being centered by the align item center. So as always, I've gone into a lot of detail between when a container has height, doesn't have height, as well as shifting main axis, as I really want you to understand the details of what's happening. The good news is application in the real world is fairly simple. So let's now take a look at some align items guidance. Align items is commonly used on navigation menus and footers. Looking at this page over here, I'm going to zoom into the navigation bar. The navigation bar is a flex container. The logo on the left is a flex item. The anchor tags in the center are also flex items, and the anchor tag and button on the right are also flex items. We have our main axis running from left to right, our cross axis running from top to bottom. Along the main axis, we would be using justify content with a value like space between to set the horizontal alignment, but we'd also want these items to be vertically aligned, that is, along the cross axis. And in this case, we would want them to be centered. If we didn't do this, the different flex items would just be positioned very weirdly vertically. So I'm on the web page we just looked at. Let's go open up DevTools. We'll select the navigation bar, which you can see is a flex container. We can see we have justify content space between. If I turn that off, you'll see the flex items all just appear next to each other, whereas justify content space between nicely spaces them out. You can see the align items value is set to center. If I turn this off, you can see our logo and anchor tags move to the top, and it just looks very strange, not having all of these items vertically aligned. For the next piece of guidance, align items is often used for positioning items inside a component in a flex row. Looking at this page over here, we have a component like this, which is inside a flex container. Our text is a flex item, and our button is also a flex item. Our main axis is running from left to right. So in a row, our cross axis is running from top to bottom, and you can see that our items are positioned at the bottom of the flex container. That is, we'd be using a value like align items flex end. Another example of this is on this page over here, where we have this icon and text component at the top of the page. This would be inside a flex container. The icon would be a flex item. The text would be a flex item. Our main axis is running from left to right. Our cross axis is running from top to bottom. And we'd be using a value like align items center. So I'm on this page. Let's open up DevTools. You can see this container is a flex container, and align items is set to center. If I remove this, you'll see that they move to the top. So you'll see our flex items are no longer vertically centered, and they're just going back to the default value, which is stretch. Now, it's actually quite hard to see the stretch here because there's no background color. But if I hover over this blue, you can see the blue box is not just the height of the text, it's stretching below. Whereas when I hover over the magnifying glass, because this element is an SVG with a fixed height, which you can see in the box model here as 20 pixels, we're not going to see the effect of stretch there, like we discussed earlier, and it's just going to the start of the cross axis. So let's wrap this chapter up by adding to our summary card, justify content and align items. In this chapter, we looked at align items, which positions flex items along the cross axis. We saw there were 5 values. Align item stretch, which was the default value. We have our container, our main axis running from left to right, which means our cross axis is running from top to bottom. If our flex items are just content, like text, with no fixed height, the default behavior is that they'll stretch along the cross axis. The next value was flex start. We have our flex container, our main axis running left to right, our cross axis running top to bottom, and our flex items are now positioned at the start of the cross axis, that is, at the top. The next value was flex end. We have our container, our main axis left to right, our cross axis top to bottom, which means that our flex items are now positioned at the end of the cross axis, that is, at the bottom. The next value was align item center. We have our flex container, our main axis left to right, our cross axis top to bottom, and our flex items are now positioned in the center of the cross axis. The last value we saw was align items baseline. We have our flex container, our main axis left to right, our cross axis top to bottom. Our flex items had text, which in this case are different sizes, and they'll move up and down on the baseline of the largest piece of text, that is, the letter B. Now, I know this was a lot to take in, and there's so many different circumstances of when your container has height, of when it has no height, when your main axis is shifted, when it's not shifted. There's just a lot going on. The truth is, in practice, it is fairly simple. There's just some common values we're going to be reaching for a lot of the time. As we've just seen in the guidance, align item center is a very common value we want to use to vertically center our flex items. So let's now go and add the align items property onto our Quill homepage. There's 2 parts of the homepage so far we've added Flexbox. The first is on the navigation bar. We have our flex container and our flex items, which is the Quill logo and our 2 buttons. Our main axis is in row, running from left to right, and we have our cross axis running from top to bottom. Just like in the guidance we saw earlier, we want to vertically center our flex items. So let's go add this inside VS Code. So I'm back inside the app.css file. I'm going to scroll down to our navbar. We currently have display flex and justify content space between. Now, something really important I want to highlight before I go add align items is that our navigation bar has a fixed height, which we're currently defined with the variable nav height. That height is currently set to 300 pixels. And I have a comment here, update the value in the Flexbox topic. Now, I'm not going to update it just yet. We will be changing this value in a few chapters' time when we discuss nested Flexbox. So let me scroll back down. Let's go add align item center. I'll refresh, and you'll see that our logo and buttons are now vertically centered inside the Flex container. Let's open up DevTools to see that. If I scroll down to the box model, you can see the Flex container, the navbar, has a height of 300 pixels, which I just showed you earlier. And align items is centering the logo and the grouped buttons vertically. Now, as you can see, this does look a bit weird with such a large height and these buttons on top of each other, and we will be sorting this out soon. But we definitely want these flex items centered vertically like they are here. The next location on our page we're currently using Flexbox is in the footer. We've converted this into a flex container. We have our flex items, which is the logo, our social media icons, our anchor text, and our small text at the bottom. These are our flex items. For the footer, if you recall, we've shifted our main axis. So our main axis is running from top to bottom, which means that our cross axis is running from left to right. At the moment, our flex items are positioned on the far left, but we want to center them along our cross axis. So we're going to be using the align items value center. So let's go add this inside our project. So as I mentioned in our footer down here, our flex items are all the way on the left. Now, because we've shifted the main axis, we know it's going from top to bottom, and our cross axis is going from left to right. As we've discussed earlier, the default value of align items is stretch. Now, we can't really see that going on, but if I go and select temporarily all paragraphs and give it a background color of red, you'll see that this flex item is stretching along the cross axis. And we discussed earlier that this wouldn't happen for values with fixed height and width, like our logo over here. All right, so let me just remove that. And as discussed, we want to center all these flex items. So I'm going to go grab align items and set the value to center. So this is looking great. Just a small note, our footer links, home, login, and register are still stacked vertically and are aligned left at the moment. Soon we will be correcting this and getting them into a single row. Let's continue to add to our Flexbox knowledge and learn about how to add consistent spacing between flex items using gap. We'll be discussing Flexbox and the box model and the gap property. So let's start by looking at Flexbox and the box model. Box model properties can still be used in a Flexbox layout to control spacing. We have our flex container, our main axis currently in row running from left to right, and our cross axis running from top to bottom. And we have the following flex items in our flex container. Margin can be used to space items, and padding can be used in flex items. So using the box model properties of margin and padding can still be applied to flex items in a flex container. Let's check this out in VS Code. So I'm where we left off in the app.css file in the previous chapter. As a reminder, we have these 4 flex items, we have our flex container, and our 4 flex items over here. At the moment, the flex direction is set to column. I just want to remove that now, so our main axis defaults to row. And I'll just keep justify content center, which as we know, centers our flex items along the main axis, which currently runs left to right, and align item center, which centers our items along the cross axis, which is currently running from top to bottom. So let's go play around with some different box model properties on our different flex items. On flex item 1, let's go add a margin right of 50 pixels. So as expected, this creates 50 pixels space between 1 and 2. Let's go to flex item 3 and add a margin to all 4 sides of 100 pixels. So you'll see on the left and right, 100 pixel margin. And if we open up DevTools, we can see top and bottom has also had 100 pixels of margin applied to it. Let's go to flex item 2 and let's add a padding of 40 pixels all the way around. I'll refresh, and you'll see padding has been successfully applied. So you can still apply box model properties to your flex items. Okay, I'm just going to quickly go remove the box model properties I added. Okay, so I'm back to where I'm started. Now, something which is fairly common to do is use align items and/or justify content to align your flex items, but then you still want to create even space between each flex item. So to achieve this, we'd have to do something like add margin right of 50 pixels to our flex item 1, copy this, add it to flex item 2, and add it to flex item 3. So this would create equal space between our flex items that are centered horizontally and vertically. Luckily, Flexbox gives us a much easier way of doing this. And that's where the gap property comes in. Gap sets uniform spacing between flex items on the main axis. The property looks like this: gap and then a unit value. Importantly, gap is set on the flex container. In the demonstration earlier, we had to set margin right on each flex item. It's important to note that gap is set on the flex container, not the flex items. So the way it works is we have our flex container, our main axis running left to right, our cross axis, and applying gap 24 pixels on the container will space our flex items horizontally 24 pixels apart. So instead of applying multiple margin properties on flex items, we can just apply a single property, gap, on the flex container. And we can also do this when the main axis is shifted. So for example, we'll shift our main axis, so it's in column. Our cross axis now runs left to right, and our flex items will now have a gap between them of 24 pixels. Because again, gap sets the spacing between flex items on the main axis. So let's play around with this inside VS Code. So I'm back inside the file we were working on just earlier. I'm going to go remove margin right from each flex item. Okay, so we're back to where we started now, with our flex items all butt up next to each other. All we're going to do is get the gap property, add a value of say 50 pixels, and voila, we have equal spacing of 50 pixels between each flex item. And of course, we can change the direction of our main axis. So we'll do flex direction column. So our main axis is now running from top to bottom, and our cross axis is running from left to right. And you can still see gap 50 pixels has been applied between each flex item. And remember, gap is equal spacing of your flex items along the main axis. So let's now take a look at some margin and gap guidance. Margin is used when you want different spacing values between flex items. On this page here, we have these two cards. Let's focus on the card on the left. This is all inside a flex container. Our main axis is in column running from top to bottom. And we have 4 flex items: this icon, the heading, paragraph, and anchor tag. Each of these flex items have different spacing values between them. So we can use margin on the flex items to achieve this desired effect of different spacing values between the flex items. All right, so I'm on the page here. Let's open up DevTools. I've clicked on the card, which is the main flex container. You can see there's no gap property applied. But if I click on each flex item, each of these divs, you'll see this first div has a margin bottom of 32 pixels. Let's turn that off, and you'll see the spacing disappears between the icon and the heading. You'll see this piece of text here has a margin top of 8 pixels, so a different margin value than what we just saw. And finally, this anchor tag has a margin top of 32 pixels. So if I turn that off, you'll see the spacing between the text above and the anchor tag disappears. So you can use margin on each flex item if you want different spacing between your flex items. Now, gap is used when you want uniform spacing values between your flex items. For example, in the footer on this page, each column of the footer links lives inside a flex container, where each anchor tag is a flex item. We have our main axis running from top to bottom in column, and for equal spacing of say 12 pixels between each flex item, we can just use the gap property. Now, in all honesty, because of the power of the gap property, it is a lot more commonly used than using different margin values. Let's check out this application again, and I'm going to show you multiple places gap is used. I'm going to open up DevTools. I'm going to select this hero section. You can see it's a flex container, and you can see over here the gap property of 28 pixels is being applied to achieve equal spacing between all the flex items. Let's go find some more. This card over here is also a flex container. And in this case, there's only 2 flex items. We have this item here and this item here. and you'll see gap is being used at 8 pixels. Now this is actually very common, to only have 2 flex items and then apply a gap property to space them out. Let's go look for more examples. You can see on this card over here, again it's a flex container, and again gap is being used to separate the 3 different flex items. Even on this major section over here, Flexbox is used to nicely align these 2 large flex items next to each other, and to create some extra space, a gap of 32 pixels is being used. And of course, like I showed in the demonstration, if I go and select the footer, you can see we have a gap of 12 pixels being used between each of the anchor tags. So it's common to use gap to create spacing between your flex items. So let's start building out our next summary card. Gap, nested flexbox, and centering. In this chapter, we looked at gap. We saw the property looked like this. Gap is applied on our flex container, and it creates spacing along our main axis. So a gap of 20 pixels applied to our flex items would look like this, where the space between each flex items is 20 pixels. So let's go ahead and add the gap property inside our Quill project. As a reminder, we're currently using Flexbox in 2 places. The first is on the navigation bar, where we have a flex container. We have our 2 flex items, the logo in the left, and the grouped anchor tags on the right. Our main axis is in row, running from left to right, and we're using the justify content space between property to space the flex items along the main axis. We have our cross axis, and we're using align item center to space the flex items vertically along the cross axis. Now gap is used to space items along the main axis, and because these are spaced how we want them to already, that is the logo on the left and the grouped anchor tags on the right, there's no gap or margin required on this flex container. The second place we're using Flexbox is on our footer down here. Our entire footer is a flex container, and we have 4 different flex items: the logo, our social media icons, our anchor tags, and the small text. In this layout, our main axis is in column, running from top to bottom, with our cross axis running from left to right. Now this is a great place to use gap. We want equal spacing between each of our flex items along the main axis. So let's go add this to our project. So I'm back inside our app.css file of our Quill project. I've scrolled down to the footer, and all we need to do is add the gap property, and I'm just going to give it a gap of 1 rem, which from the unit section of the course we know is 10 pixels. So I'll refresh the page, and this creates a small gap of 10 pixels between each flex item. And again, just remember, the gap property is applied on the flex container, which is our footer over here. Next up, we'll explore how to create more complex layouts by combining multiple containers with nested Flexbox. We'll be discussing what is nested Flexbox and nested Flexbox guidance. So what is nested Flexbox? It is common to have a Flexbox layout inside another Flexbox layout. So looking at this page over here, this entire hero section is inside a flex container, and the 2 buttons are also inside a flex container. Because this flex container is inside the other flex container, we would call this a nested flex container. It's nested within another flex container. Let's check out this page in DevTools. I'll grab the hero section, and as you can see, this is a flex container. If I expand this div, you'll see that this div down here, which is nested inside this div, is also a flex container. So we have a flex container inside another flex container. So the interesting thing happening here is that for this flex container, each of these are flex items. And this last flex item is also now a flex container. So a flex item within a flex container can also function as a flex container itself, allowing for multi-level flex layouts. So looking at this in diagram form, we have our first flex container, we have our different flex items. We can then make one of our flex items a flex container. And because this flex container is within another flex container, we would call it a nested flex container. And of course, this nested flex container will have its own flex items, shown in blue here, which we could call nested flex items. So let's go play around with this inside VS Code. Alright, we're making great progress so far in this topic. I now want to step up our coding exercises a bit and build this simple layout using nested Flexbox, which could appear on an About Us section of a web page. Alright, so I've gone ahead and set up an index.html file with the boilerplate code and linked a style sheet called app.css, which is currently empty. Let's first go add the main blue background container. I'm going to add the div and give it a class of main container. Inside the div, I want to add our 3 different profile cards. So I'm going to do div times 3, and I'm going to give it a class of profile card. And I'll just copy this class onto the other 2 divs. So we're just going to start off nice and slow by getting our profile cards inside our main container. Let's head over to app.css. I'm going to select the main container. I'm going to give it a height of 800 pixels and a background color of light blue. So let's open up the browser and see what we have. Okay, nothing spectacular. We just have our main container with a height of 800 pixels and a light blue background. Let's now go add those 3 profile cards. I'm going to select the profile card. I'm going to give it a width of 300 pixels. I'm going to give it a height of 400 pixels. And just note, we'll later be removing this height and adding in actual content. But for now, because there is no content, we need to go and explicitly define a height so we can see our profile card. And let's give it a background color of white. I'll refresh, and our cards are now just stacked vertically on the left. I'll open up DevTools, and you can see we have our 3 cards running down the left here. So let's now go and align them using Flexbox inside our main container. All I'm going to do is come to the main container, grab the display property, and make this a flex container. I'll refresh, and our cards are now stacked next to each other inside the main container. If I inspect this in DevTools, you can see our 3 cards over here. Now by default, we know that the main axis runs from left to right in row, and the cross axis will run top to bottom. You can also see there's space horizontally along the main axis and space vertically along the cross axis, because we've defined a fixed height on this container. So let's first go and space our profile cards along our main axis. I want even space between this, and we know that the property to use for alignment and spacing along the main axis is justify content. And I'm going to set its value to space evenly. I'll refresh, and you can see our cards are now spaced evenly along the main axis. Next up, I want these cards to be vertically centered inside our container. We know that to space flex items along the cross axis, which is running from top to bottom, we use the property align items. And to vertically center it, I'm going to use the value center. Okay, great. This is starting to take some form. Before we start adding the content into our cards, I just want to slightly improve this by adding a border radius and giving a value of 10 pixels. So our corners are now nicely rounded. All right, I'm going to head back to index.html, and I now want to go add content inside our profile cards. The first piece of content we had was that emoji. I've just grabbed it off the web, and it's an SVG currently sitting in my clipboard. I'm just going to paste here. So that's the profile emoji. The next element I'm going to add is an H2, which is the name of the person. The first person we had was Jane Doe. Next up, I'm going to add a paragraph tag and add their job title, which was software engineer. And then below this, we had those 3 social media icons. For now, I'm just going to add a placeholder paragraph and write the word social media icons, which we're going to come and update a bit later. So I'm now just going to copy this div and delete these 2 others and paste it once and twice. So we now have 3 cards with the same structure. Just to keep them unique, I'm going to go update this SVG to another one I have sitting in my clipboard. The second person was John Smith. Their job title was product designer. And I'm just going to leave the placeholder social media icons paragraph for now. Now to avoid boring you, I'm just going to go update the content on our 3rd profile card. All right, so our 3 profile cards are now inside our main container. We have our first one over here, our second one over here, and our 3rd one over here. So let's check this out in the browser. Okay, great. Our profile cards are looking a lot better with the content in. Let's head over to app.css and now work on the profile card. The first thing you'll see is that the content is actually overflowing the card. And that's because we previously set a fixed height on the card, as we had no content. Let's now remove this, as we do have content, which will give our card height. I'll refresh, and you'll see the height of the profile card is now being set by the sum of the heights of the different elements. So let's now use Flexbox inside each profile card to better space and align the content inside here. So essentially what we're going to be doing is now making our profile card a flex container. Looking back at our HTML, currently our main container is a flex container, which means that each of these divs is a flex item. But now these flex items are also going to become their own flex containers, where the content inside these divs, that is the SVG, H2, and 2 paragraphs, will now become the flex items. So just to really highlight this main div, wrapping all the content, is a flex container. These 3 divs are each flex items of this main container, but now they're also going to become their own flex container, where the content inside of them will become flex items. We have 3 flex containers, 1, 2, and 3, inside another flex container. So all we're going to do on our profile card is add display flex. I'll refresh. Now, because the default value of flex direction is row, it now moves our flex items inside the card, which is the different pieces of content, into a row along the main axis. We don't want them positioned like this. We want them going vertically. So we need to shift the main axis by grabbing the flex direction property and adding the value column. I'll refresh, and we're kind of back to where we were before. But now our profile card is a flex container, and each of these elements is a flex item. Let's check this in DevTools. You can see this profile card is flex, and you can see those purple dashed lines appearing, signifying that this is a flex container. And once again, the main container over here is also a flex container. So our profile card is a nested flex container, because it's a flex container inside another flex container. Let's now go better align and space the content inside the profile card. Now, the spacing we see between the different elements is currently being set by default margin in the browser. If I open this up, you can see in the box model, there's default margin being applied to each of these text elements. So I'm just going to go do our mini CSS reset. I'll use the Universal Selector to select every element, and I'm going to go remove any default padding and any default margin. Okay, so all margin and padding has been removed from the page. Now, because our main axis inside the profile card is running from top to bottom, and I'd like to achieve equal spacing between each of these elements, I'm going to use the gap property, and I'll set its value to 20 pixels. If you recall from earlier, the gap property sets equal spacing between flex items along the main axis. And once again, in our profile card, the main axis is running from top to bottom. So we get equal vertical spacing between each of our elements. Let's check this out in DevTools. You can see that hatched purple is an equal spacing of 20 pixels. The last thing I want to do is horizontally center each of our elements. Now, once again, our main axis is running from top to bottom, which means our cross axis is running from left to right. And we know for spacing and alignment along the cross axis, we use the align items property. So I'm going to grab align items. I'm going to set its value to center. And this will nicely center all our content. Now, before we handle our social media icons, I want to just go add a bit of padding to our card. As it's looking a bit cramped, let's give it a value of 20 pixels. Okay, that just creates a bit of extra space inside our card. So let's now go tackle the social media icons. I'm back inside the index.html file. I'm now going to go replace this paragraph with a div. And inside the div, I'm going to add 3 SVGs that are currently sitting in my clipboard and I've just grabbed from the web. Okay, so we have our 3 social media icons here, which are contained within a div. Now, these icons are identical for the other cards. So I'm just going to go remove the paragraph here, add in the content there, remove the paragraph here, and add in the content here. All right, so let's check this out in the browser. All right, this is looking pretty good as it is. The SVGs appear nicely next to each other like this because by default, they're inline elements. And inline elements do not start on a new line. Now, what I would like to do though, is have better control of spacing and alignment of these SVGs by converting this div container into a flex container. So effectively, we're now going to have 3 levels of Flexbox. Our first level is the main container, which contains 3 flex items, the 3 different profile cards, this one here, this one here, and this one here. We know that our profile card are also flex containers, where the flex items are the SVG, the H2, the paragraph, and now this div. And we're now going to go convert this flex item, this div, into its own flex container, which means that each of these SVGs will be flex items of this flex container. Now I need to add a class to this div, and I'm going to call it social icons. I'm going to copy this and just add it to our other div containers for the social media icons. In app.css, I'm now going to go select the social icons, and we're going to convert this into a flex container by adding display flex. I'll refresh, and you'll see not much changes. Our SVGs are still positioned horizontally next to each other because by default, our flex items, that is the SVGs, are in row because the main axis runs from left to right by default. But just to show you that this now is a flex container, if I go add flex direction and set this to column, you'll see our social media icons will appear one below each other. Okay, I'm just going to remove this. And the only thing I actually want to do on the social media icons is create equal spacing between them. I'm going to use the gap property, which we know sets equal spacing between flex items along the main axis. And I'm just going to set this value to 10 pixels. All right, before we check out our masterwork and expand the browser full screen, I've realized this emoji isn't correct. I'm going to go just update that in the HTML. All right, great. I've just updated that emoji. So let's go check out our beautiful work. All right, this looks fantastic. We've now built a simple section of a web page, and we've used 3 different levels of Flexbox. Opening up DevTools, we have our main container, which is a flex container. Each of these profile cards are flex items of this main container. We then made these profile cards their own flex containers to space and align the content inside the card. Inside the profile card, it has the flex items of an SVG, an H2, a paragraph, and a div. And then this flex item, the div, we also converted to a flex container, which has 3 SVGs. So in this demonstration, we've nested Flexbox twice. Anyways, I hope this was a bit of fun and is able to also help consolidate a lot of the other properties we've been learning about so far. So let's now take a look at some nested Flexbox guidance. Nested Flexbox is commonly used on navigation menus and footers. Looking at this page over here, I'm going to zoom into the navigation bar. All of the content in the navigation bar is inside a flex container in purple. We have 2 flex items. On the left, we have our logo, which is a flex item, and all the anchor tags on the right are also grouped as a flex item. We would then use a property like justify content space between to space these 2 flex items. I'm now going to zoom in on the flex item on the right. This flex item would also become a flex container. So this is now a nested flex container. And we then have our different flex items inside this nested flex container. So let's check this out in the browser. So I'm on this page. I'm going to open up DevTools. I'm going to select the navigation bar. You can see that this is a flex container. I'm going to expand the HTML. You can see we have a div on the left and a div on the right, our 2 flex items. You can see this flex item on the right is also a flex container and contains these flex items over here. So a navigation bar is a very common use case of using nested Flexbox. Looking at the next piece of guidance, nested Flexbox is also commonly used in sections and components. Looking at this page over here, the entire hero section would be a flex container. The heading, paragraph text, and buttons are our flex items. I'm going to zoom in on the buttons. This would now be a nested flex container, and our 2 buttons would be the nested flex items. So let's check this out in DevTools. You can see we have our flex container here. If I expand it out, we have a div with our buttons, which is also a flex container. So nesting flex containers inside other flex containers is very common. So let's wrap up by adding to our summary card, gap, nested Flexbox, and centering. In this chapter, we looked at nested Flexbox. We saw that we can have a flex container with flex items, and that we can convert flex items into their own flex containers, which is known as a nested flex container. The nested flex container has its own flex items, which we can refer to as nested flex items. So let's go and use nested Flexbox on our Quill homepage. If you recall, we're currently using Flexbox in 2 locations. We have a flex container around our navigation bar, which currently has 2 flex items, the logo on the left and the anchor tags on the right. And we're using the justify content space between value to create space between these 2 flex items. We're now going to go add Flexbox onto the flex item on the right. I'm going to zoom in on our anchor tags. This will now become a nested flex container, which will contain the flex items, the 2 anchor tags, which we can refer to as nested flex items. So let's go code this up. So just a reminder of what our navbar currently looks like. The navbar over here is a Flexbox. And if we go look at the HTML markup, this flex container has two flex items. The logo on the left and the unordered list contains two list items, which are the two anchor tags. We're going to go convert this flex item, so we'll end up with a nested flex container. To do this, we need to go add a class, which I'm going to call nav button container. Back inside app.css, I'm going to select this class, nav button container, and let's go convert this into a flex container by changing the display property to flex. I'll refresh, and finally, we have our anchor tags next to each other. Now, because by default, we know that our main axis is running from left to right in row, we can add a small gap value to create space between our flex items, the anchor tags. I'm going to add a value of 2 rem. All right, so this navigation bar is looking a lot better. Now, something we did earlier on in the course was actually add temporarily quite a high height value onto the navigation bar. It's being controlled by this variable nav height. And if we scroll up, we can see that's currently set at 300 pixels. If I open up DevTools and select the nav container, you can see it's quite big. Now that we've aligned our buttons next to each other, we can go reduce the height of this. I'm going to go change this to 100 pixels. Now, this looks pretty bad. Let's open up DevTools and see what's going on. Because previously the height was 300 pixels, it was creating a lot of white space between the navigation bar and the hero section below it. Now, earlier on in the course, we actually had some margin bottom applied to our navigation bar to create some white space between it and the hero section. However, I'm not going to go add that on because in the next chapter, we're actually going to use Flexbox to center this entire hero section. So we're just going to have to live with this for a little bit longer. But this has been very successful. Our navigation bar is complete and looking really great. And you can see the power of using nested Flexbox. Now I'm going to scroll down the page. And the next location we're using Flexbox is on our footer over here, where at the moment our social media icons and anchor tags are being stacked vertically. So we're now going to be using nested Flexbox to correct this. Our entire footer is a flex container. We have the logo, the group social media icons, the grouped anchor tags, and the small text as flex items inside the flex container. I'm going to zoom in to the social media icons and anchor text. The anchor text is now going to become a flex container. And because this is inside another flex container, we can call it a nested flex container. Each anchor tag will be a flex item, so we can refer to these as nested flex items. And for the social media icons, and because this is inside the parent flex container, it too is a nested flex container. The flex items of this container are each social media icon, which again we can refer to as nested flex items. So let's go code this up. Okay, so I've scrolled down to the footer class, where we're displaying Flexbox. Let's go look at the HTML markup. I'll scroll down to the footer. Here's that class. The footer semantic HTML element is the flex container, and the flex items inside this container are the logo, the social media icons, which live inside an unordered list, the anchor tags, which also live inside an unordered list, and the paragraph, which is the small text. So we're now going to convert this unordered list to become its own flex container, and this unordered list to also be its own flex container. To do this, we need to go add a class here. I'm going to call this social icons container. And for the anchor tags, I'm going to add a class and call it footer links container. All right, let's head to app.css. In the footer section of the CSS, underneath the footer class, I'm going to first go select the social icons container. We're going to set the display property to flex. I'll refresh. And you can see these icons now nicely appear next to each other in a row. As our main axis is running from left to right, we can use the gap property to create some space between our flex items. I'm going to set a gap value of 1.5 rem. Now for our anchor tags, we'll go and grab that container, which was footer links container. We're going to change this to a flex container by adding the display flex property. I'll refresh, and you can see our anchor tags now appear next to each other. And again, because the main axis is in row, we can use the gap property to create some space, which I'm going to just set as 1 rem. I'll refresh, and voila, our footer is now looking beautiful. And once again, this is a nested flex container. Opening up DevTools, I'll select the footer, which you can see is a flex container. I'll expand the footer. You can see the 4 different flex items, the anchor tag, the unordered list, the unordered list and the paragraph. And for 2 of these flex items, the 2 unordered lists, we've converted those to become their own flex containers. The CSS course has been split into 2 parts because YouTube has recently enforced a 12-hour upload limit. So as much as I wanted the course to be in a single video, I've been forced to split it. Part 2 is available here, and I'd really appreciate it if you could please subscribe to the channel and drop a comment below about what you think of the course so far. I'll see you in part 2, where we'll keep the party going.